through geometry, which makes a distinction between it and geometry. It can't be both.
It is reality. We can understand reality using this special type of geometry. And this special type of geometry that we call general relativity gives us the best explanation and understanding of the real physical, tangible reality around us.
Okay, so let me give an
But
actual summary.
you're telling me something that it's an incoherent statement. If it is real, if this effect is real because of space and time being curved by mass, then it would affect everything, including the macroscopic level, the microscopic level. Go ahead, Austin.
Okay, so here's a couple of things I'm going to read. They're not very long. And it's going to summarize everything for everyone. Okay, so quantum mechanics is incompatible with general relativity because in quantum field theory, forces act locally through the exchange of well-defined quanta. Secondly, relativity gives nonsensical answers when you try to scale it down to the quantum size. Everything are eventually descending to infinite values in its description of gravity. Likewise, quantum mechanics runs into serious trouble when you blow it up to the cosmic dimensions.
It's all true.
I agree.
That's right.
Yeah, it goes both ways. When you try and shrink down relativity, it stops working. When you try and expand or blow up quantum mechanics, it stops working. Both of them are not complete theories. Even quantum mechanics, there's something wrong about it.
Yeah, so there is a different option, right? So, the reason that quantum doesn't work when you blow it up to the cosmic scale is because your presuppositions of the cosmic scale are wrong, right? And so then when you take that presupposed cosmic scale with the presupposed theory of relativity, you bring it down here to the real world where we actually test things, it doesn't work, and the evidence directly contradicts it. So you guys are going to act like you have no idea that the other option is that it's your assumptions are just wrong.
But what is the other option, Woodson? I mean, any real physicist, scientist, cosmologist worth a pinch of salt will tell you that we know we don't have all the answers. We know, a lot of our ideas and theories are not complete. There are a lot of things out there that we just can't explain. But hopefully, if we keep, I'm not done, Gregory. Hopefully, if we keep trying at it, if we keep making honest attempts at it, we might get close to what's going on. We might never get there, but that doesn't mean we shouldn't try. But if you feel like because we don't have all the answers and we know we don't have all the answers, we should stop trying, then what else should we do? Like, is there something else you propose?
No, that's not the point. The point is, whatever the alternative is, what you are saying now is wrong. But instead of conceding that it's wrong, that it's false, you want to say it's not complete, so as to maintain that it's even viable or plausible.
Correct.
Instead of just conceding.
Do you have an alternate?
That's
whether
irrelevant.
I do or don't have an alternate, whether we do or don't have an alternate, that does not negate the fact that it's false. You can't just use this rhetoric where you maintain, oh, it's not complete, so as to refuse to concede that it's been debunked.
And there are numerous alternates, by the way.
Such as?
Within your own paradigm, I already read them off. Biometric gravity, entropic gravity. There's all kinds, like a neo-Newtonian dynamic theory. There's multiple things. There's two different versions, primary versions of biometric gravity, one in which with immense energies, the speed of light is variable and not constant. And in fact, the speed of light, things can go much faster than that. There are numerous theories.
So why are those not generally accepted? Is there a reason?
Because for over a century, everyone just ran with relativity to explain everything. And we're just now actually looking at evidence that just disproves relativity. So it's just everyone's going to hold on to what they've rocked with so far until we can agree on something else.
When we have these discussions, we need to stop pretending like the academics in academia are just so pious and objective and have no biases, that they don't have any controlling presuppositions which they protect at all costs. Like they aren't religious. Like, they don't abandon logical consistency in preference for the presuppositions and customs and doctrines and whatever else they value. You need to stop playing that childish, naive game.
Theories of large-scale variations in the matter density of the universe, scale invariance of empty space, decaying dark matter. I mean, the list goes on and on. So,
Like, just like you people in this room, the people in academia don't want whatever doctrines they don't want to be false. Whatever they don't want to be false, they don't want to be false, and they will resist any and all critique.
Aren't all these alternate theories evidence that they are exploring alternate theories? I don't understand what the problem here with this is.
Oh, maybe you should listen carefully. So the Globers are claiming that
No,
relativity.
what's it? Don't backslap me, okay? Just answer my question.
Well, listen carefully then. So
no, just answer the question.
I'm trying to.
Will you let him?
Well, don't
You
backslap
have to let him, Steel City.
Okay, so the Globers have been claiming that relativity hasn't been falsified, and they keep on just saying the word incomplete. Okay, yeah, the reason that there are so many alternatives is because it has to be replaced because it has been falsified. That's the point.
If something is wrong in certain extremes, it doesn't mean that you throw it out completely. But you are correct. You keep exploring alternate theories, and that's exactly what science is doing.
It's not that it's wrong in certain extremes. It's wrong on every scale.
Yeah, but I mean that's where no one will ever agree with you. When you guys make like absolute statements like that it's wrong in its whole entirety, it's wrong on every scale. No, because they are things that it's right about. A lot of things that it's
I'm
right
talking about
about.
the
That's
scales.
why all I'll ever give you, all I'll ever concede to is that it's not a complete theory, but it's not
I'm
wrong.
talking about the scales, man. The scales. I'm going to say that you can't use relativity and it works with some things. Duh, that's why it was proposed. Bacon, you are hot. Mike and my man, your dogs are hungry. So
they are mine, but sorry.
Yeah,
like
feed
you guys,
your dog.
it's like very simple, right? So it doesn't work on the quantum, the local, nor the cosmic scale. So when I mean it's wrong on all scales, I mean it doesn't adequately explain what is observed on all scales. So it isn't. He said if it just doesn't work in a few extreme situations. No. It's from top to bottom. Like just that you have a few things in there that aren't wrong doesn't mean anything.
That's not the nature of the
Quantized gravity.
situation. Right?
Quantized gravity, entropic gravity, neo-Newtonian dynamics. I mean, it's on and on. My point is that you guys pretend you know that GR is right, and ironically, it is well known for many years now that it cannot be right. So just say it.
So
Just
it's
be real.
not right at all? Or are you saying it's 40% right, 60%? Or it's like a
He
big
can't make
fat.
it any more simple. He said this multiple times. It's wrong on all scales.
So it's like zero. Wow.
Yeah, because it makes basic claims, right? You do know that relativity isn't like a list of why do apples fall? Well, why does the banana fall? What about steel? It doesn't try to answer every question in the world. It makes general assessment claims, right? It's general relativity. It is effectively a claim to explain
But
all
you
of it.
can solve for Einstein's equation to figure out the geodesic along which an apple would fall as it
You could
falls
create
from a tree.
100 different equations to do that.
Yeah, then that shows it's right. I don't understand.
I derived it. I could post it for you.
You could do it with
ask
a million different claims of causes, though. So that's a non sequitur.
Let me ask Clark a question. Clark, you said something's going to be incomplete but not wrong. At what point is it incomplete and then becomes completely wrong? Okay, is there a percentage? Like it could be 50% right but 50% wrong, or 30% right and 70% wrong? At what point does it become wrong?
I mean, that's the thing with science. We say things are falsified. You know, we just say that. Trying to think of an example, man. You know, it's just basically it's the best idea we have. That's the best way to see it. We know it's not 100% correct, you know, but it answers a lot of things, and it answers a lot of things pretty well, you know.
But Kaloi,
So,
this is just obviously a resistance, a refusal to concede, to speak the sentence, it is wrong. That's all this is. So that's
but
why
what is it
Larry
wrong about
asked
Gregory?
you the
If you
question.
guys want to say it's wrong, fine. What is it wrong about Gregory? Tell me.
No. Listen. This is rhetoric to avoid saying the sentence, it is wrong. That's why Paul asked you the question.
But you
Let,
gotta convince me
let me
why it's
finish the
wrong. I'm not
sentence.
just
Let
gonna
me
say it's
finish the
wrong.
sentence. Let me finish the sentence. This is why Paul is asking you at what point you say it's not wrong, it's just incomplete. So at what point in the answer to the question, to the problem, does it become wrong, false? When you say this is false, at what point do you say that?
All right, I would say it becomes wrong when um, all predictions it makes are falsified. Now, if you feel it is wrong, Gregory, can you give me a specific situation in which general relativity is wrong? I've answered your
It,
question. Please answer.
it doesn't make sense in the first place.
No,
Like
come
on
on.
the
I answered
piece
your
of the
question.
theory.
Please answer my question, Gregory.
But you don't have to.
The
You don't
curvature of space and
have to
time.
tell me- hold
Okay, that's a
on a
But
second.
reification
answer my
fallacy
question,
that
Gregory. You
no
can't
one's
just say it
listening.
doesn't make
No one's listening. General relativity, the curvature of space and time because of mass. So I'm existing in my very existence, in the substance of my being is curving space and time.
Yes,
Yeah.
To
there is
cause
an
things to fall.
interplay. There's a very deep fundamental underlying connection between you and the fabric of reality around us, Gregory. That is what it's telling us. Now,
Yeah, that's a
please answer my
reification
question.
fallacy. This
And
is
please
the answer,
answer my
Caloric.
question.
This is the
You
answer.
can't. No, no, no. This is
Stop
not
with this
fair, Gregory.
nonsense. Grown
This is
men.
not
I'm
fair.
answering your question.
I
You keep
can't be
demanding
answering
that I answer.
your
I'm in the
question.
middle of answering
You
it.
don't want
Stop
to answer a
talking and
single
listen.
question. That's not fair, Gregory. Come on.
Stop talking and listen.
Then
Grown
answer the
ass
question.
man. It's ridiculous. Grown ass men coming onto a forum talking like this. I told you the answer. It's absurd on its face. The reification of space and time. That's
Your
nonsense.
answer,
But you
your
just
answer,
refuse to concede to that. That's ontological
Gregory,
nonsense.
you're claiming something. You're making a positive claim, and you're not backing it up. You're just
I
basically,
already
saying it
said
doesn't
it.
work.
The theory of of general relativity. This is a theory. Okay.
Yeah,
Stop
you're not
presuming that this
saying.
is actually real. Okay.
I
This is
already
an a
explained why
priori
it's
theory
wrong.
against. Be quiet and
Greg,
listen. Be
like, why do
quiet
you
and
guys?
listen. Be quiet and listen.
That's Whitson.
Wow.
Come on.
you know that's Witsit, right?
No, I didn't know
Yeah,
that.
sorry. I'm just trying. I'm not understanding why it is that we go over what's wrong with it, and then you guys loop back to saying, "Well, just tell me what's wrong with it then."
I mean, really. So here's the answer that I'm trying to give. Excuse me, Austin. That was my apologies. General relativity, mass, objects existing, curving space and time. That's a reification of space and time. It's ontologically absurd.
So that's why it's wrong.
Yes, it's ontologically absurd. It doesn't even get basic ontology correct.
So that basically sounds like nuh-uh to me.
You can interpret it that way. You can deliberately interpret it falsely, but that's not the correct interpretation of what I said. So address the critique instead of just trying to reduce it to, again, people always do this to me, always reducing what I'm saying, always reducing my critiques to just a mere opinion, so as to discredit what I just said, so you don't have to actually give an argument against what I said.
But that's the problem. It is an opinion.
It's not a mere opinion. Just retorting
It
to
is.
me that it's a mere opinion does not debunk what
Yeah.
I just said. Give an
Yeah, all you're
argument.
giving is an opinion,
Hey,
Gregory. All you're giving is an opinion.
Left lane. Why would you jump in here? Because now you're going to be added to the list of who gets exposed here. So,
Yeah, because I can answer if I want to because it's a public forum. Thank you.
okay, but I'm explaining now you're on the list. Okay, so you guys are pretending nothing's wrong with it again. You're going to make me thoroughly expose you with specificity. You guys are going to pretend relativity doesn't get anything wrong. Relativity can't even mathematically work out black holes. It can't even solve for singularity.
By the way, he did say that earlier about it being incomplete. We already admitted all that stuff. So
No, it's not that it's incomplete. No.
We accept that, admit it, and move on.
No, it's not that it's incomplete. It literally cannot do it. It doesn't work.
That's the point of it being incomplete. It doesn't work in high gravity situations or very near the speed of light. It's incomplete. We said that.
Well, maybe
we conceded it. We admit it. We accept it.
It's not
Well,
incomplete.
maybe extremists can answer my question then. Well, let extremists answer my question. How much of it has it got to be wrong before it's completely wrong? How much? What's your percentage?
Like you want a percentage?
Yeah.
I'm going to go with 95%.
So if I have 95% of the solution is poison, is that solution good for me?
It could be incomplete. The other 5% may be a lack of understanding, a lack of utility. Maybe you don't have the technology to test that. That actually, the perfect example of that would be the Higgs boson, where we mathematically predicted it, but it took us 50 or 60 years to actually develop the technology to confirm it was correct. So there's those possibilities, but we just might not have the technology, and we don't have the mathematical know-how to do some of these things. So it is incomplete and not necessarily wrong. There is a difference between those two statements.
So no. Hang on, Paul. When they say the sentence, when they retort saying it's incomplete, that presupposes that they know the entirety of the theory, but have yet to say it. What's the rest of the theory?
That's actually opposite of what it is. We don't know the whole theory. We know this is part of the whole theory. Therefore, it's incomplete.
No, because
so
the part you're claiming that you
if you don't know the rest of the theory.
But the part that you're claiming
it doesn't work
just
in certain circumstances, therefore it's not complete. I mean, it's not.
No. Wait.
That it's 100%. You don't have to know the whole thing to know it's not complete. I mean, that's
yes, you do. How do you know it's incomplete if you don't know the whole theory? How do you know the pizza is incomplete if you haven't seen the whole pizza?
Actually, that's a good point, extremist. If you can say it's incomplete, but if you don't know the whole thing, you can't say that. You can't say that. He's right.
So what you are saying is
what's
theory and it's wrong.
ontologically absurd about it, Gregor?
I'm sorry, say again.
What's ontologically absurd about general relativity?
Space and time is not concrete. They're not concrete, and so they don't have extension in spaces, so they can't be curved. Or they can't be traveled upon.
What we misunderstood here, like it's a philosophical just like bankruptcy, right? It's like incomplete's not synonymous with wrong. Okay, so if I say this ice cube maker makes 10 ice cubes in an hour, every hour, and then I go over there and I say, oh look, there's a pizza on the counter. Well, my theory didn't talk about pizzas. That's incomplete, right? Because it didn't address pizzas. But if I then open up the ice maker and it only makes 9 ice cubes instead of 10, my theory that it made 10 was wrong, not incomplete.
So, Gregory, general relativity is ontologically absurd because space and time are not concrete. Yo, who's coughing?
Somebody is dying. God bless you.
Yeah, okay. Well,
Abdul, hey man, I don't want you dead.
So no one's broken yet. What's up with that? I gave you an example. I gave you an analogy of ice cubes. What happened?
The analogy of ice. Yeah,
I mean, I'm miking with a lot of noise in the background.
The original was a lot of background noise. Did somebody mute him?
I did.
There we go.
There you go.
So you guys heard the analogy though, right? So there's a difference in, oh look, there's a pizza on the counter. Well, my theory was about ice cubes, not pizza, so it's incomplete because we don't know why the pizza's there. That's incomplete, right? It doesn't address that. But if it's talking about how there's going to be 10 ice cubes in an hour and there's always only 9, my theory that there were going to be 10 ice cubes is wrong. It cannot be right.
But what are you equating that to? General relativity?
Yes.
When any of you say, no, it's not wrong, it's incomplete, that answer, quote, it's incomplete, presupposes that you know the entirety of the theory, so tell it to us. And then you say, no, there is no more theory to be told, that's the entirety of the theory. So if it is the entirety of the theory and it's wrong, then it's wrong, not incomplete. It's complete and it's wrong.
Yeah,
Well,
but Gregory,
the other side of the coin on that too. If I say the answer to the math problem is it's 100 or 100, but I say 99, well, I'm 99% correct, but there's one digit off. Am I right or wrong? I'm wrong.
Right. You're wrong. And you know that, and you know the entirety of the answer, that it's not 99, it's 100. Not being ignorant that it's 100 and you only know 99.
well, this is the best analogy I can give you, right? You have a special technique that helps you find things in the dark, all right? And there's 10 objects you got to find in a dark room, and you use your special technique, but your special technique no, sorry, your special technique only allows you to find 10 objects. There's actually 11 objects in the dark room. You can only find 10. You haven't learned the super grand master technique to find the 11th object. That's all. We just don't know
That's not
how to
what's going
find that
on.
11th. I'm not done
That's
with it.
not.
Come on. I'm
the
not
problem
done
is
talking.
that,
We just don't. Please, guys. Please. We just
oh, I
don't
thought
know
you were
how to
done.
find that 11th object. So to give you to show how that analogy applies to relativity, we know how to answer most things using relativity. We just don't know how to combine it with quantum mechanics. When we start trying to use it within the quantum realm, our equations like speed off to infinity and we get weird answers, which just tells us that our equations are not complete.
And it
But
doesn't
for
work
the
on the
most
An
part,
cosmic
instance of
scale either.
incompletion. Caloric, in your analogy, you said we found 9, but there's really 11. In
we
that
found 10.
analogy, you just demonstrated that you know that there's 11. You know the complete thing. You know the complete theory. So that's not analogous to you saying it's incomplete. When you
No,
say
we
it's
don't
incomplete,
know.
that means you don't know the entire theory. So say the rest of the theory. When you say that we know that there's 11, but we only found 9, you're saying that you know the entire theory. It's antithetical. It's not analogous at
No,
all.
but I wasn't done. So we have a special technique to find 10 of the 11. And then my homie Gregory has this unknown super secret technique where he can just find that 11th piece only. He can't find the other 10. He can only find the 11. So Gregory and I have two incomplete theories, and we can't put our theories together so that we have one theory that helps us find all 11 in one go. What we have is two incomplete theories. They're not
But in your
compatible, and we
analogy,
have to
these are not
find a way.
incomplete theories. In your analogy, these
Why are
aren't
they not?
incomplete theories. These are entire theories that don't account for everything. Instead
Yeah,
of saying
so
that
they're not
the entire
complete.
theory
They
doesn't
don't
account for
account for
everything,
everything.
so instead of saying that it doesn't account for everything, therefore the entire theory is wrong, the theory is wrong.
No,
It isn't that
it's
it's
incomplete.
missing some theory. In your
It's just
analogy, there
simply
are entire theories. It's not a partial theory. It's not part of a theory. In your analogy, it's this theory, your theory, and my theory, two whole entire theories that aren't accounting for everything. They fail
but
to account for everything.
if my theory can find 10 of the 11 objects in this dark room, how are you just going to say it's wrong? It's just not complete, Gregory.
It's not an instance of the theory being incomplete. Let go of that. This is just rhetoric that you're making in your mind so as to refuse
No.
to say it's wrong. It's just a
Yeah,
commitment
listen.
to this notion,
If you
to
want
the
to say
rhetoric.
it's wrong, go ahead and say it's wrong. It really makes no difference at the end of the day, Gregory.
It does make a difference. The rhetoric is wrong. You rather choose the rhetoric
Cool.
saying it's incomplete rather than saying it's wrong. When you say my
All right,
theory doesn't
cool.
account for everything, that's not an instance of it being an incomplete theory. That's an instance of it
Okay.
being a failed theory.
Can I just say this
Yeah, all
though?
right, Gregory.
What it
All right.
is, he's right though. It's just a talking point, and the truth of the matter is, it doesn't work on the quantum or the cosmological scale. And it's like, for example, if relativity is correct, so relativity says that for this motion to happen in the galaxies, there must be this amount of mass. That mass displaces the space-time and causes this motion. Okay, so relativity says that. Now we see this motion, but only 3% of the mass that would be needed for that motion if relativity was correct. Meaning, if the mechanism of relativity actually were happening in reality, then it would require this much mass for this motion. Yet we have this motion observed, and we do not have that mass. Therefore, relativity is wrong because the actual observational data directly contradicts its claim.
An entire theory debunked, falsified. Not part of a theory that's yet to be said.
Cool. We're wrong, but yeah. Kosho did have he posed a very good question. I don't know, Gregory Whitson, could you guys give us an instance where general relativity made an incorrect prediction on something?
I just did.
In all instances, when you make the ontological blunder where you reify space and time, in all instances, you're going to be wrong.
In all
Falsehood
instances.
implies falsehood.
So it's wrong all the time, everywhere. Like it's just never been right on one itsy bitsy little thing.
Not even once.
Yeah, who cares?
No,
Who
that's
cares,
not
though?
a straw man. That's exactly what Gregory's saying.
Yeah, it was
Well,
fair
I'm
enough,
not
but
strong.
that's not what the actual. Who cares? Like, why can't you address the point? I just gave you an example of what's wrong with it. Why is it that you're pretending relativity's never gotten anything wrong?
What did he get wrong? Sorry, I didn't hear that part.
It was supposed to have, yeah. It's supposed we have way too little of mass in the galaxies that we observe.
What's that got to do with general relativity?
Okay, well, relativity claims that based on a certain amount of mass, there's a certain displacement in space-time which causes a gravity well, giving you a certain motion or curvature. So if we see that curvature, but it doesn't have the mass needed for said curvature rate based on relativity, that means relativity is wrong. And that's what we observe. And we observed that as early as 1933.
That's a particular instance, which is one of all instances where it cannot be right. If you tell me a reification fallacy of space and time, and everything you described, every event, every motion, every change you describe presupposes the reification of space and time, you're going to be wrong. That which implies falsehood is false. That which is a reification fallacy cannot be correspondent to reality.
Yeah, Whitson, I don't fully understand what you said. I think what you're alluding to is that, the cold dark matter model we use now for our known observable universe doesn't correctly predict the mass to energy ratio we have. Maybe I'm not sure, but maybe you could also post a link to where you're getting this from so that I have more clarity on the point you're trying to make.
Galaxy rotations and dark matter.
Dark matter. All right.
Correct.
So I was right.
And I'll show you Stanford saying that I'll show you Stanford saying that our dependence on dark matter is an embarrassment.
So you saying because of dark matter, relativity is wrong?
Objectively,
you have to
relativity
show
is wrong.
that dark matter is incorrect. So
can't say
for that to
dark
be
matter hasn't been shown to be real. So
you can't show it to be incorrect when it's not even a claim yet.
Yes, it's not a claim.
Yeah, it's literally undefined embarrassment. That's actually Caltech that said that. It's a Caltech paper. Yeah, it's an
But we
embarrassment.
know that dark matter, like has gravity. We know it's made of matter. That's why we call it dark matter, because we see the gravitational effects it has on things around it. We see how it gravitationally lenses light as light passes through it from distant stars and galaxies. Like,
where have you seen dark matter?
We've seen the effects it has, Gregory. Like
where have you seen the dark matter to cause the effect that you supposedly observed?
We see the effects it has on things around it. We don't see dark matter itself. That's why we call it dark. It doesn't interact with light or any sort of electromagnetic radiation. So we call it dark.
How do you know it caused the effect that you say it caused?
Because we see how it causes things to move around it.
But you haven't seen it do it. You haven't seen it cause the effect. So how do you know it is the thing causing the effect?
Because we see the effects of things around it. So there must be something there causing that effect.
Okay, but how do you know it is dark matter as opposed to just matter?
Dark matter is just a name we gave to it, Gregory. We just call it dark.
Dark matter is a name you gave to a hypothetical thing that you have never had any empirical sense of.
It's real. It's there. and we see how it
You
affects
haven't
things
had any
around.
empirical experience of it.
We do have an experience of it because we see how it affects things around it.
How do you know
No.
it's causing that effect?
Wow.
Assuming relativity, you have to that has to exist. That's what you should be. If we assume relativity, if relativity is correct, dark matter has to exist.
That's
So
a
you
more
just don't look
correct
at it with the
statement. There
right.
you go.
Yeah, you just never look at it from the right perspective. And here again, I just dropped Caltech literally saying like our reliance on hypothetical dark matter is an embarrassment. So you're saying it's not hypothetical, but Caltech disagrees with you. It just objectively is. It's not even defined yet. Our reliance on hypothetical dark matter is an embarrassment.
Yeah, let me read what you posted.
This is science falsely so-called, knowledge falsely so-called. Pseudonomondiosus.
I guess my point is when we say it's an embarrassment, you don't have a position to act like we're crazy people. Just wanted to make the point.
Here's a question. Why, this is for everyone to consider. I mean, whoever wants to answer me, that's fine. Why such a dedicated commitment to these doctrines of academia?
It would require humility to
Yeah,
reset.
I'm reading this, and this is just agreeing in lockstep with the general prevalent idea. It talks about the cold dark matter model, the CDM, Einstein lambda model. It talks about how we have good reason to think structural formation on the scale of galaxies and larger as a result of the gravitational growth of small primeval departures from homogeneity. So that's dark matter, as described by general relativity in linear perturbation theory. Yeah, I mean, bro, this is talking about dark matter. Like,
wow.
Okay, this is the end of it. I read the whole thing.
I'll read what it actually says.
Yeah,
so
which
the
part was I
model for
supposed
the model for the light element seems to require that the mass density in baryons is less than that needed to account for the peculiar motions of the galaxies. It is usually assumed that the remainder is non-baryonic or acts that way. Our reliance on hypothetical dark matter is an embarrassment. A laboratory detection would be exceedingly welcome.
There is no empirical experience of this dark matter.
Yeah. And that's because it's not like that. It's not someone just came up with this theory or something. It's like, damn, we have to address this. Relativity doesn't work. Yeah, it's whatever. It's exhausting. It's like it just absorb your religion for what it is.
But you actually have to provide evidence for the contrary.
I have to provide evidence that dark matter is not real.
How about you provide evidence first that exists, though?
Oh yeah,
Jace,
I already posted one.
Let me ask you this. Are you telling me that I have to provide evidence that dark matter is not real?
Yes, if you're going to claim that dark matter isn't real, then you need to provide evidence.
Do you even know what you're saying?
Prevailing scientific evidence is against
you. Evidence that unicorns don't exist, buddy.
The prevailing
Jace,
scientific evidence that the prevailing scientific evidence that you just invoked literally is our point, which is that dark matter has to exist if we assume relativity.
Jace, when you make that demand to us, what do you mean by evidence?
Measurements, data, observations that are positively indicative of and or exclusively concordant with one hypothesis above all others.
So you want me to measure or quantify that which has no existence?
No, you can use your hypothesis and provide measurements and data for it that is against the dark matter hypothesis.
Jace, what's my hypothesis? What's my assertion that you want me to provide evidence for?
You don't even have one. That's the hilarious thing. You're trying to tell
us. What is my assertion that you want me to provide evidence for?
And you
I think
won't
what
even
he's
stand behind a concrete
Jace, what
alternative.
is my
And we're
assertion
supposed
you
to
want
take
me to
that
provide
seriously.
evidence for?
I already told you, you don't have one. And that's the hilarious part.
So why are you demanding that I provide evidence for an assertion that you say I don't
Because you're
have?
saying that the overall scientific hypothesis is incorrect.
So when I say dark matter
So
isn't
that's a
real, you demand that I
baseless
provide
claim.
evidence that
That's
substantiates
what a
that assertion.
baseless claim
And
is
you're still
defined
talking
as.
through me, not actually conversing with me. You want to give your religious fundamental apologetic demanding evidence for my assertion
Ooh,
when I
you
say
quote Pete
that there is
Gregory.
no dark matter. And you want me to provide evidence
I
for that?
don't accept your projection. Sorry, bro.
Yes, you gotta let him speak though, because keep interrupting him.
Yeah, I wasn't done talking yet, and then he started talking. Sorry.
Jace, you want me to provide evidence that substantiates the assertion there is no dark matter. Is that what you're asking
Gregory,
me?
if you were to say, hey, I have idea A with evidence B, C, D, E, F, and I say, oh no, that's not real, you're going to be like, well, how do you know that my idea and my evidence isn't real? And if I can't produce anything for it, then that is the definition of a baseless claim. And that's exactly what you're doing. I'm sorry
So
you
did
don't
you
like
hear what
that.
Austin just said several minutes ago?
Yeah, and Caloric read the rest of it.
Uh-huh. And what was said?
Yeah, they apparently don't agree with what Witsit's trying to say.
It
No?
literally does.
So when you heard
Well,
when
what
you
about the part I read with it? Doesn't that part matter, or it's only the part you read that matters?
Well, I was
hold
invoking it to
on,
make my point, wasn't I?
wait.
But
So when Austin read the sentence, the model for the light element seems to require that the mass density of baryons is less than that needed to account for the peculiar motions of the galaxies. It is usually assumed that the remainder is non-baryonic or acts that way. Our reliance on hypothetical dark matter is an embarrassment. A laboratory detection would be exceedingly welcome. Did you hear
All
that,
right,
Jace?
now would you read the part I read, Gregory? If you just scroll down a bit, do we have good reason to think?
We have good reason to think
Right.
structure formation on the scale of galaxies and larger was a result of the gravitational growth of small primeval departures from homogeneity, as described by general relativity in linear perturbation theory.
okay, so the good
Check this
reason they
out. I
have
left a
is
link. I
this:
left a link
it
for you
doesn't.
guys. It helps Gregory's idea here in a way in which this dark matter idea is absolutely debunked in every single way. And there's also an alternative that has been seen, and it's the dark web, and those are cosmic galactic filaments that connect nearly, if not all, galaxies. And this is a big deal. And this is what we're talking about. Those missing baryons that you were talking about. They found a bunch of baryons. They actually light up. They're in partial in gases, and those gases are ionized. And the ionized gas is a plasma, and a plasma is a perfect conductor of electricity, and so on and so forth. There's no need for dark matter at all whatsoever, except to substantiate dogmatic theories that want to prevail because of the funding that's involved. Guaranteed. Go ahead.
Pretty correct.
So Jace, the nature of my assertion, there is no dark matter, does not require a posteriori empirical data to substantiate it, because it is the negation that there is this empirical thing in the world. If I attempt to give you empirical data to substantiate an assertion that negates the empirical existence of a thing, then I've just contradicted my assertion. So the nature of my assertion does not require empirical data. It's your assertion that is the antithesis of mine that requires empirical data to be substantiated and justified.
Right. It's very disingenuous to ask someone to prove something doesn't exist. And I think that's something Don Scott touches on in that video that I posted as well. It was only made a month ago. It's very detailed. Don Scott's retired professor of electric engineering, electric universe proponent, and they do a lot of work on this very topic. So it'd be interesting to see what your takeaway would be if you believed in dark matter before you watched this video.
Now,
maybe
you
you guys will
can
actually watch.
prove the inexistence of things For example, I can prove that I'm the only human in my house right now. You take you to my house. You don't step inside the house. I'm the only one in here, etc., etc. Here, come look over here. See, there's nothing there. That what you said is there is not there. So where can you take me in the universe to show me dark matter?
Right? I mean, it should be everywhere, right? If it's what they say it is.
You know full and well that the reversal of the burden of proof fallacy was in full effect just now. That's where I've become indignant. People act like they're so smart and then do things like that.
I missed the first part of the conversation. I only heard you ending it basically, and then I shorted up with the link and some other discussion, but I didn't hear like that the first part, whatever it was.
Yeah, Jace demanded that I provide evidence to substantiate my assertion dark matter isn't real.
Oh, right, yeah. That because they did that. NASA just did that, or sorry, whatever the challenge was, a challenge put out by some of the main dark matter proponents, and the challenge was prove it doesn't exist. It was funny because it's like that was the most disingenuous shit. It's a swindler, snake oil salesman. That's what Don Scott said. Called him a snake oil salesman for saying that shit. So, you're right. Proving the negation of a thing is like asking someone to do that is a disingenuous position, I think.
Fallacious retort. The argument from ignorance. This is true because you haven't proved it's false.
Right. Well, I'm glad we can align on something, Gregory. How you doing today, man?
I'm well, and you?
We were having such a hard time yesterday linking up, man. I didn't know what it was. I think it was the religious stuff. I don't really get into that too much. People get emotional.
Well, the fact of the matter is everyone is religious, but we're not going to get into that right now.
Thank you. Yeah, you handled yourself well on that one. I appreciate that.
Yeah, I mean, we're all just wrong, Gregory knows we're wrong, so what's the point?
All he says, "You guys just wrong." Crying in his beard.
About personal. Yeah, sorry.
Yeah, we're just wrong. I mean, yeah, we're wrong.
If it's personal, like it's not you that created this theory. You're just adhering to a side. So you're not right or wrong. You're just watching, just like the rest of us. We're pointing at the architects of this information and trying to, philosophically digest what it is that's happening. We're all, we're not all right or wrong because none of us created any of these ideas that we're bouncing around off each other. So we're just, are you on a winning or losing team? I mean, you're not supposed to think of it like that in life, are you? It's just, we just, sometimes people get opposed to personalities and shit like that too. And you be trying to say the same thing, But I think tagging your self-identity onto somebody else's theory, though, that could be dangerous because then you're like, that's a lot of shit you're not in control of. Then you're not in control of yourself then because the theory can change, and then you're not going to want to change with it. You're going to be stuck on stupid.
Yeah, but I mean, at the end of the day, Gregory says we're wrong, so we're wrong, because Gregory says it. So I mean, I don't know what else.
Focusing on that shit, but I'm not.
Yeah. He doesn't have to refute anything.
But that's the truth.
He can just say no.
That's literally what happened. Gregory just said we were. I asked him to. I asked Gregory to explain how we were wrong, and he said that we're just being ontologically absurd. Everything is wrong on all scales. When I asked him to give one example,
let me try to simplify it.
we're just wrong.
He's covered you guys conversationally. Sorry, cornered you guys conversationally, and that's fine. You can move on, make it simpler. How do you think dark matter exists? Where can I go and see it, touch it, experience it, eat it, taste it, fuck it? Where can I go and do that? Please.
So because you can't have sex with dark matter if it don't exist,
So
like
I'm just asking where I can go get some. Where's it going to be
in a
tangible?
galaxy far, far away or within our solar system, there's dark matter, but because it's not made of normal barrier. Yo, come on, I'm answering your question. I'm answering your question, bro. Can you let me answer your question? Dark matter is all around us. It's everywhere. But because it's not made of baryonic matter like us, it has a very weak interaction with us. You won't touch it.
Okay. Okay. So
you
do
won't
you think
touch
that's
it.
something like
Sorry.
when people say, when people say ether, do you think it's similar to that? I don't believe in that shit either, but is that what you think?
On its face, maybe, but then I would ask a question. What evidence is there for dark matter and what evidence is there for ether? And I'll let the evidence speak for itself.
See, I have to dig in.
evidence,
Bro,
though.
I gotta go study this shit before I can even make a claim like that because it's only a hypothesis. I can go eat a carrot. Where can I touch dark matter to actually prove that it exists instead of under a microscope, bro? I don't believe under the microscope.
Not even under a
You gotta do better
microscope.
than that. You gotta do better than that, bro.
Right. Let's back up our energy, though. It's
that's not me, but okay.
Well, the
you
whole
came
room
in ready.
fired up.
Goddamn.
Crazy.
Oh,
but
gosh.
I agree
I didn't
with
mean
you.
to
I'm
hurt
not
your
telling
feelings.
you you're wrong.
I'll shut up now.
No,
I
I agree with you. I agree with you. I'm just saying keep your control so we have the
I'll control myself just for you, Nancy. Thanks.
Man. Anyway, so it's hard to even agree with somebody in these days, isn't it?
If you were in a virtual reality world playing a virtual reality game, would you say that that virtual reality environment is there or it is not there?
I left a link that it talks about the cosmic web and the Birkeland currents and all of the things that are needed to replace the idea of dark matter, and they all exist and they're all in place. So let's keep ignoring them because that makes a lot of sense. Now, does anybody else want to jump on that virtual reality discussion?
I have to pull a line from the Matrix. What is real? So what do you mean by real?
Right.
Is it there? What do you mean by there?
Vat. We're just going to assume we're not brains in a vat for the sake of progress.
Well, even if your brain's in the vat, your experience is real, right? Even if it's all computer generated.
Right. That's why I'm going to assume I'm not that, because you can't know, but you have to start with a premise for your own reality, and my own reality assumes that that's not the case. I'm not going to say prove me wrong, because that would be a disingenuous position for me to take. That's why I'm just going to assert that that's not the case. I don't see any evidence for that.
Isn't it this dark matter would be in the realm of virtual reality?
No, that's just...
It's not something.
It's real, Carlos.
Not that far away, dude.
It's as real as you and me.
It's right there in electricity, and it's in the material that's actually present there. We haven't been very good at seeing these things because we're assuming the wrong shit all the time. But we're getting closer and further out there into the regions, and they can detect that this shit is real. These are plasma densities that they had no idea were that dense. They thought it was vacuum space, like not a shit, like they didn't realize that there was a cosmic web that ties all the galaxies together in a big plasma filament, and all these millions of filaments connect all these galaxies together, and the rotational velocities of galaxies drop over at the 1/r rate of the plasma rotation, and the whole thing is set up in the Bessel function of the Birkeland current. And Donald Scott wrote papers on it, and the whole thing is right there for everybody to see. And it's just that that's the answer. And then no more research money comes in after that. I mean, all you can do now is just keep on, adding to your, what you already know. You're not going to keep looking for some missing thing anymore that costs billions and billions and billions of dollars every year. I mean, that's
Seems
going to
like
hurt a lot of people's feelings.
all of these equations and suppositions would be the same parameters that a virtual reality programmer would use to install this paradigm. I doubt that, if there's nothing tangible there, then it's all virtual reality.
What's virtual reality, Carlos?
Well, just throwing out the words that people get, just for no reason, just detracting from the actual conversation.
Well, all of the
It's not a
measurements and the
computer-generated
suppositions
thing.
about distance to stars, the mass of planets, and all of these suppositions are all based from measurements down here on Earth. You haven't been able to touch any of this stuff to measure it.
So the Cassini mission didn't crash into Saturn?
There's too many holes that can be poked into this dynamic just lie of what they're feeding you. Half of the photos that came back from the James Webb Telescope have already been shown that the metadata is all created in Photoshop. There's too many holes like this.
So, Carlos, like, how do you discern truth? Like, when you see James Webb and then you see a YouTube video of flat Earth is made, like, how do you know, like, which one's real and which one isn't? Do you just believe the YouTube video?
I see the real person on the other end of the channel, so that's real. But there's deep fake as well. So I take it all with a grain of salt. It's all virtual reality until I can see something tangible.
Just a
So
little
when
less
is
salt.
it? When
Just a
is
little
it
less
tangible
salt on
for
the
you?
things that fit your bias,
Is it?
and more salt on things that don't.
So, I mean, is it more tangible for you when you can experience it for yourself, Carlos? Like, if someone shows you a video, you're not going to trust it because of deep fake, right? So, how do you know when to trust something?
I'm going to watch the video and soak up the information, and then I'm going to have my discernment, and then I'm going to walk away from that video and probably forget it, but I'll keep some of that information back up reserved for my next conversation. I'm not going to take it all as gospel.
So
if
you
it confirms his bias, he accepts it, Nate.
Yeah, it sounds like. Yeah, I mean, I was going to ask Carlos, like, aren't you going to take some sort of steps to verify?
Calling out bias is not an argument, though. We all have them.
Oh,
yeah,
he discerns truth. The easy answer. The answer staring you in the face is he accepts what confirms his bias.
Yeah, recognizing confirmation bias is important.
I think the only way you're going to find out the truth is when you're dead.
The thing is, I think what's his name is right though. We all have biases. We all recognize it. And the other thing is, we all take things on faith, whether you acknowledge it or not. You trust the information coming out of NASA. Other people may trust a YouTube video. We all trust somebody, something for what we think we know and believe. So to reject that that's a bias in and of itself, right? Did I come through?
Yeah,
I agree. I'm waiting for the Glovers to answer you.
So
you came through, Paul, 100%.
So yeah, definitely, we all have biases, but I would love to believe that all of us here are independent thinking, open-minded truth seekers, right? And even though we know we have biases, we're all out here for the truth, and we all accept that facts don't care about feelings. And if the evidence goes against our bias, we're going to follow the evidence, right? Because we're truth seekers. So, Carlos, you with your bias, even though you're a truth seeker, when you watch a YouTube video that you might have a bias for, because you're a truth seeker, don't you take steps to try and verify the information in that YouTube video, or you just walk away from it?
I see it like a blanket of lies, and every time you knock down a lie, you're one step closer to the truth. Like you can pick holes in NASA, the ISS. You can pick holes everywhere. Once you've washed away those lies, you're one step closer to the truth.
But what about the YouTube videos that flat earthers make? Like, they could be lies in those as well, right? So what do you do to verify they're not lying? Since you can't trust anything because deep fakery and whatnot, you literally can't trust both sides, right?
Well, I want to jump in on this because I think there's something to what you're saying. If a flat earther let's say, does a video of him on a lake or an ocean and he's doing measurements or whatever he's doing, I can actually go to that location and validate what he's saying personally. Okay, so then me validating that personally, I can say, well, that information coming from that flat earther is valid. But how do you validate something that's shot into space, that you can't validate? You have to trust the chain of custody from the source all the way down to you're getting it in the news or wherever you're going to get it from. You have to trust everybody along the way that they've done everything ethical. Which do you think is more valid? I'm asking you now.
I could go to space, or I could go to these observatories where they have these, really expensive, sensitive, big instruments that are used to make these long, deep space observations, right? The same way you could go out to the beach, to the water, and make your measurements. I could also just go and do what other people did.
But when you were talking about the images, though, something that's from a James Webb telescope, whatever it was. I mean, if I don't have access to that telescope, I don't have access to the data. How can I validate it?
And what if I don't have access to a passport and I can't, or I don't have access to an ID, I can't cross state lines, I can't go to the beach you're at, Like, whatever you throw at me, I can throw it back at you. The point is...
That's my point, though. That's my point.
Yeah, and I get your point. That's what I'm saying. Whatever you throw at me, I can throw back at you. If you can say you can't validate something on my side, I could just say I can't validate something on your side. But the point is, Carlos is saying that he doesn't trust either side because of things like, deep fakery and whatnot,
Well,
So my question, if it's impossible...
Sorry,
Chase?
sorry. Go ahead, finish,
No, go ahead.
sorry.
Okay, so I was just gonna say, if it's impossible for Carlos to trust anything on both sides, how does he find truth?
No,
And I was just gonna add, it leads to the crazy situation where the people who have verified these things, the people who use the instruments, so it's real for them, but it's not real for those who haven't verified it, and that's just not how reality works. It's an insane way to go about things.
Yeah, Silent, you're very quiet.
Can you hear me now?
Yeah, you're muffled.
Hey, it's not coming through good?
You're really
Silent, I can hear you.
Yeah, you just low volume.
Really?
Mm-hmm. Shit, really?
Well, I think the argument is an epistemological argument. How do you know what true knowledge is? Is it someone telling you and you trust in them that they are telling you the truth and that's true knowledge? Is it your experiential component of it? Like I've experienced this for myself. Then it comes down to what are you going to, who are you going to trust? What are you going to trust? So what is true knowledge?
There's a point where our empirical knowledge ends. So we don't have an empirical experience of everything. But there are things that we do know that we don't have an empirical experience of. And so we justify that with argumentation.
How about now? Can you hear me now?
Yep, you're good.
A little better.
All right. I just want to challenge what he said about he compare people going to other countries to people going into space. And I just want to say, like, it's not equal, right? Because millions of people can go to one place and they corroborate, even if you don't have a passport or whatever. And to go to space is actually a very strict thing, and only a few people have gone. So yeah, you shouldn't be comparing those two things.
And even more basic than that, space is a location where it cannot be traveled to. Outer space, the sky vacuum.
I agree with that, but
another claim. There's another claim.
Yeah, and so is the sky vacuum, which is yet to be substantiated.
Well, actually, wait a minute. Hold on a second. NASA themselves actually admits you can't get above low Earth orbit. So what are we talking about here? NASA themselves said that.
Yeah. So Silent Zero. So you saying that it's not a fair argument to make because it's harder to do one thing compared to the other. I don't see why that matters. You know, going to space is something that's possible to do. It's difficult. I'll give you that, but you can do it. You know, what's even harder than going to space though is going to the bottom of the Mariana Trench. More people. Please, I'm not done, bro. I didn't interrupt you. More people have gone to space than have gone to the Mariana Trench to its bottom. But I don't hear anyone here saying, yo, bro, please. But I don't hear anyone here saying that the bottom of the Mariana Trench is not a real place, you know? So
because it is. I don't the sky vacuum is not. And we keep presupposing the sky vacuum is real. It's not.
Why is it not real, Gregory? Like, why do you keep making that claim?
Because you can't have gas pressure without a container.
Yeah, that's not true.
What does gas pressure have to do? Man. What does gas pressure have to do with our atmosphere? The atmosphere is atmospheric pressure, and atmospheric pressure, within its definition, there's nothing about a container. There's nothing about containment. Atmospheric pressure is just caused by the weight of the atmosphere.
So you think the gas?
What does that have to do?
Gas has you think the gas has a natural tendency to a downward vector, pressing on itself?
Yes, with that, and I also think that the atmosphere isn't just made of gas. I think the atmosphere is a fluid that is gas, solids, liquids, a lot of things in it. So it's not just the gas. So this whole gas pressure without a container doesn't apply to our atmosphere.
Okay, so you believe that gas. So you believe gas behaves contrary to the way it actually behaves. It behaves expanding in all directions, omnidirectionally, filling the space.
I never said that. I never said gas doesn't act that way.
You said gas presses in on itself and goes down in a downward vector, which is contrary to the way gas behaves.
I said, that's not what I said. What I said is...
You did say that to me. Please stop double speaking. Stop making conversation impossible.
That was left lane that said that. What I said was atmospheric pressure speaks to the weight of the atmosphere. Atmospheric pressure has nothing to do with gas pressure, which speaks to containment of gas. So when you guys keep saying gases need to be contained, I don't know what that has to do with the atmosphere.
Okay, when we talk about gas pressure in the container, we're talking about the natural behavior in which the gas moves. We're not talking about the weight of the molecules of the gas. It's irrelevant.
All right.
Okay. So
would you agree with
go down, go boom, boom. Gas doesn't go down, go boom, boom.
Yes, it does.
Expands and fills the space.
Why? Go ahead, Nate. I'll let you finish your thing. Then I've something to add after.
If it expanded to fill the space equally, we would not have a pressure gradient because all of the pressure would be equal everywhere at all altitudes.
No.
Also, there's multiple gases like CO2, SF6, NO2, on and on, that are asphyxiation risks to researchers in the lab because they don't expand in all directions. They go downwards and displace the oxygen and pose a risk to the researcher for asphyxiating.
Yeah, and is that happening in a container?
Yeah, halide fire extinguishers do that very same thing.
You can't have it
happening
both ways.
In a container?
You can't have it expanding in all directions in a container and then also not expanding in all directions in a container.
Is that happening in a container?
Yeah, you can't have it both ways. Do you
Yes
not
or no?
understand that?
Stop with the sophistry.
Yes,
Answer it
it
directly.
does.
Okay,
Yeah,
so
so it
that's an instance of
expands in all
gas behaving in a
directions in a
container,
container,
not in
and
a
it doesn't
vacuum.
expand in all directions in
So
a
it's
container.
not behaving in an open system. It's in a container. You just give me an instance of gas
It's in
behaving the
a
way it does
room.
in a container. You're giving me an instance of gas behaving in a container to substantiate the notion that it behaves that way without a container.
It's in a room.
You're giving
If you
me an
consider
empirical
that
instance
container.
that's the very antithesis of your hypothesis.
No,
Yeah,
you
No,
started
that's not
out
true.
saying gas expands in all directions in a container. Now you're saying, oh, no. It both expands in all directions in the container and it doesn't expand in all directions
No,
in the
that's not what I'm saying. Did say that once.
That's what you're saying, man.
It's not.
Either it does or it doesn't. Pick
It's
one.
not.
Yeah,
That is not
Gregory.
arguing against straw men.
Gregory, that GIF that's in chat is a good visual representation of gas going down.
And I wouldn't. A room is not a container in the same way that a gas canister or cylinder. So they're two. The gases are going to act in two different ways in those situations.
So you believe that we're flying around in a vacuum and gas is sticking to a ball?
Do you have any details of this container? Altitude, makeup,
It's
opacity.
irrelevant.
Why? I mean, if it
It's not
exists,
irrelevant.
It's not important. There is a container,
It is
regardless of its
important. You're
dimensions,
asserting
regardless of its
something that
height,
no one's ever
regardless
seen.
of any
You
of
can't.
any of
You
this.
can't talk.
There is
You
a
can't
container.
give any
Solid. It contains
representation
gas.
of it. You can't prove it. You just say it's there.
You can't give me any instance of gas sticking to a ball in a vacuum.
Yeah, that's an absurd request. If it worked
That's
that
what you
way,
believe.
physics does. Yeah, physics
That's what
doesn't
you
work the way
believe.
that we think it does. If you could do that, that's an absurd
That's what you
request.
believe. So
Well, that's
what you
what I
believe
know.
is absurd by your own admission.
It's what I know.
You don't know falsehood to be true. You don't know absurdities to be true.
Yeah, you're just running off the rails now.
Yeah, this is going way off the deep end.
Yeah, you can't show me any instance of gas sticking to a ball in a vacuum.
What about the Earth? Why can't we just say the Earth is the example? What's wrong? Because you can't
it's
prove
not
the
the
container. So your
Because
counterexample to the Earth
that's why.
would be to demonstrate where the container is, and you can't do that. So why doesn't my statement stand?
Because that is not the case. You try to appeal to the earth. That is not what's happening.
So
That's not what
again,
you see.
nuh-uh is your answer. Nuh-uh.
No, that's the argument. It's not just nuh-uh. When you appeal to the earth, that is not what's happening. That's not what you see. That's not what you see.
We
That's not what you see.
exactly what I described.
You go outside.
Sticking to the ball without a container.
Outside, you go outside. You don't see what you think you see.
Oh, so my senses don't work. We see gases.
No, you're denying what you do see.
There is
You
no
deny
container
what
that
you
we
do
can
see. That's the
perceive,
point.
and therefore, my example is wrong. Is that what you're saying?
Right. You go outside, and your belief about what you see is not what you see. You see what you do see, and you deny what you do see in preference for what you don't see that you believe you see.
So this whole thing about flat Earth trusting our
Gibberish.
senses that flat earthers repeat ad nauseum. We can't do that now.
No, we do that. That's why we don't believe we're living on a ball flying in a vacuum with gas and liquid sticking to it.
Wait a minute. Did anybody else think you just said two exact opposite things?
Yep.
Okay, just making sure it wasn't just me that he just said.
What are the two opposite things I said?
Point out what was that he said?
We can't trust our senses, but we can trust our senses.
No, I never asserted you can't trust your senses. Never once did I say that. That's the problem with you globalists.
Did you hear that?
This is the problem with people like you in the world. We're trying to reason with you. We're saying exactly what we mean and meaning exactly what we say, and you hear the very antithesis of what we actually said and meant.
Okay, let's
This is
do this again.
asinine.
Hold on 1 second. Let me do this again. So my senses, I go outside, I see gas sticking to the earth without a container. My senses do not see any of this that you describe, but you still say it's there.
That's not what you observe. Your description of what you observe is not what you observe. When you go outside, you see gas in a container. You see gas above you, above the earth, out in the air, up in the world.
Container.
And it's
So why is it
contained.
there?
And you see up in the air, you go outside, you see gas all around you. There's gas all around you. You don't see that you live on a ball, flying and moving through a vacuum and sticking to a ball. That's not what you observe.
None of my senses indicate there is container. No sense.
You don't observe that because it's not there.
None of my senses tell me there's a container.
Hey,
You
Gregory,
don't observe
you're
that.
not allowing him to. You're not allowing response. You're clipping every single time. So could we get it back and forth instead of clipping everything?
I think it's part of it's me. I apologize. But again, my senses say I go outside. There is pressure sticking to the earth with more at the bottom than at the top or higher up. Therefore, there is a downward vector, by the way. And also, I do not see a container. So why should I trust something that I cannot sense that should exist? So you're telling me I should trust my senses. My
trust your
senses do not
senses.
tell me there's a container.
You shouldn't believe that you experience something that you don't experience. What you describe that you experience is not what you experience.
Wait, what? What I experience is not what I experience?
What you describe. You can hear me.
What I describe is not what I experience.
Wow. Your description of what you experience is not correct.
Okay, so I'm going to say what I want you to tell me where it's wrong. I'm going to try it again because I don't see a difference. But I'm going to say I go outside. I see pressure on the earth greater at the bottom than at altitude, and I do not see or experience or in any way detect a container.
Yes, you do.
Now, what part of that is not correct?
You do see a container.
How?
I would agree with Extremistus. Where do you have proof of a large container that you're within?
Look
How
up.
do I see a container other than...
That's not a container, though. That's just up.
No, look up. That's where it is, all around you.
Yeah, but how do you know that's a container if you haven't gone up there to verify that or validate it?
Well, number one, the gas pressure. The gas is pressing on the container, and revelation from the God.
All right. Well, if you're going to go with spiritual or religious viewpoint, I hear you on that. But I just think that even if you have pressure, like the idea of a propane tank, you need pressure, et cetera, that's fine that happens here. But you still don't, anyone who makes that argument doesn't have proof or validation that it's happening up in the sky or around us.
Why not?
Because it's just an assumption. It's just a lead.
Why is it just an assumption? Why not, when I say look up, you are looking at the container? What's wrong with that?
What's the difference between you're assuming the container and we're not assuming it? Because there's no evidence that it exists.
The difference you just said.
That it does not exist. Wrong.
But you assume the vacuum.
Like when you look up, you think you're looking at a vacuum.
You're inferring a vacuum because you see less pressure over altitude. We are inferring a container because that's what we experience in our daily life.
But the thing is, this less pressure is less and less and less and less. It never ends. There's not a hard, fast, less pressure, bam, container. It's less pressure here, little less, little less, little less, and on and on and on. Therefore, if it's on and on and on, there's no need for a container because it just keeps getting closer and closer to a vacuum as opposed to a little bit of pressure and then bam, a container.
No, you
and what you're describing is gas filling the space.
You can only have a gradient of gases within a container. You cannot have a gradient without a container.
Why? Like you just described a gradient.
Well, that's the nature
with the gas
of things.
it's filling the space.
Ask God.
Why do you think that?
Here's the thing.
Listen. What you just described.
You're asking me why the sky is blue.
No, I'm asking why you think that. I'm asking why you think a gradient.
Let me say this because the point needs to be emphasized. The extremist just described the gradient of the gas filling the space. The only way you can detect the gradient, how higher up you go, is because the gas is filling the space in the first place. Emphasize that, appreciate that fact. Okay?
So you can have, to answer his question about gradient in container, you can have it in a container, that's fine, but it doesn't have to be a closed container. If I have a container and I exert some sort of force on it, there will be a gradient without a lid on it, so to speak.
All right, then, extremisist, then do you have any experimental proof or validation of a gradient pressure system that goes to a vacuum?
Outside of a container?
I mean, my example would be the Earth. I mean, I said that earlier.
I'm begging the question.
Right, so just begging the question. I mean, it's fine if you don't. I'm just saying if this was like a court of law and you had to prove something tangibly, I mean, you don't have that.
If it was a court of law, I'm pretty sure they would actually take that as an example, but we will not go there. I don't think they would count that as begging the question.
Extremistus, what I would say, just in response, is that I understand your position, but the only reason you have to think what you think is because somebody told you that that's what it is, and you've chosen to believe it. You can't demonstrate it.
Not true at all.
You can't duplicate it. You can't ever do anything to justify that position, and that's fine. But you just need to be honest enough to admit someone told you that's what it is, and you choose to believe it.
No, that's actually completely not true, because you want to know how I came to that conclusion is that there's 14.7 psi at sea level. There's about 5 psi at 30,000 feet. There is about 0.1 psi at 120,000 feet where Felix Baumgartner jumped. So that to me tells me that, first of all, there's no container obviously between 0 and 120,000 feet. And second of all, it also tells me that there is a gradient going to 0. And if you just keep going further, it will keep going to 0 without a container needed.
No, okay, so
it's
no,
not the implication of those premises.
Until you can get to
That's
the
how
place
it is.
where
All
it
implications.
where it is 0. Is there proof that there's somewhere where it is 0? All you're telling me is that there's a gradient. You haven't shown me a 0 anywhere, a vacuum.
That's just what you assume after you appeal to the fact that there is a gradient. But you're ignoring the fact that the only way there could be a gradient to detect is because the gas is filling the space, not going down, go boom, boom.
Now, as I said earlier,
It's a big assumption.
You can actually demonstrate, and it's demonstratable, that you can have an open container, like a pot or a lid or anything. You can put a gas in it. You can accelerate this object, and there will be a measurable gradient within that container without a lid that's under acceleration. That force will cause a measurable gradient without it needing to be a closed container.
Yeah, in a world where you're in a closed system, you don't live in a vacuum. You have never seen the vacuum. You never had any vacuum that you believe you live in.
Are you talking about a centrifuge when you're talking about this rotating gradient?
No, I can put this thing on one of those giant rocket sleds and have it moving, accelerating in one direction.
Isn't the rocket a container, buddy? Isn't the rocket a container?
That was not, I've said that. I mean, it's a container, but it's not closed. It doesn't have to be closed. It can be open on one end, and you accelerate it in whatever direction, and there is a gradient from the open end with less pressure to the closed end, so to speak, with higher pressure, without the one end being closed. Now, once that acceleration stops, then yes, it equalizes. That gradient will disappear, so to speak, and then you don't. But under a force, under an acceleration, you do have that gradient without a container needed.
In a cosmos where you don't live in a vacuum, you live in a closed system. You have never had an empirical experience of the vacuum.
That doesn't change what I just said.
I wanted to ask something.
PO fails. That's only possible in a contained system.
Where does the claim that we need a container to pressurize gas come from exactly?
So what's the gas pressing on if it's not a container?
Where does the claim that gas pressure required container comes from?
The word
it's a rhetorical
pressure
question, Bacon.
It means pressing on something.
No,
The word pressure means pressing on something, bro.
Pressure means force over area, right?
Yeah, what area?
Yeah.
Oh my
So,
God.
for example, if you're using
it was a rhetorical question.
one
It
second.
was a rhetorical
Let me
question.
address
What is the
silent.
gas pressing on, Bacon?
Let me address silent. So, for example, if you're measuring pressure with a barometer, the pressure is pressing on your barometer, right? It's not pressing. You're not measuring it pressing anywhere else but your barometer.
What
Right?
is the barometer? It's pressing on the area that needs to be pressed, right? To have a reading. Otherwise, you don't have a pressure.
Yeah, but that's the reading, right?
It's any hypothetical area.
Man.
Yeah, you're explaining me.
Red herring.
All you have so far with that example is that you need some surface area to read the pressure, right? I'm asking.
Yeah. So the point
to
is, what
have
is the gas
the
pressing on, Bacon?
I can get to a sentence. Well, I'm asking to get pressure. I'm asking to get pressure at all. There seems to be some universal rule that tells you you need a container for it. And I wanted to know the justification for this universal.
So answer the question: what is the gas pressing on, if not a solid container?
What do you mean?
What is the gas pressing on, if not a solid container?
On whatever you're using to measure the pressure.
The gas.
So
We're talking about the air, buddy.
Okay.
Air, what is pressing on to have that pressure?
Yeah, it doesn't have to be pressing on anything. For example, if I want to know the air pressure inside of a certain area where there's no walls, pressure still exists inside of the area. I mean, inside of the volume, right?
No, you cannot generate a pressure if you don't have the walls. You don't get it.
Bacon, we didn't.
No, I'm specifically. You're not getting my. You didn't get my.
With the barometer of a
No,
tire
you missed.
without the tire. You cannot have.
You missed my. What I meant there. Suppose I'm referring to just a volume, a random volume in the atmosphere. For example, take a cubic meter above your house. Just think about that cubic meter that sits above your house. The gas inside of that volume that we are thinking of has pressure, right? There's no walls on that volume, but there's pressure there. If you put a barometer inside of that volume, you're going to read the pressure. But if you don't put anything there, it still has pressure, right?
Bacon, we're not asking you about the method to detect gas pressure.
Didn't get a yes or no. I didn't get a yes or no, and I wasn't asking you.
Yeah, could y'all? Yeah, hold on.
This is a red herring.
I think Matthew was responding.
Y'all are failing to answer the question.
Yeah.
Go ahead, Effie.
That cubic meter is part of
he's making a question about.
Go ahead. Wait.
We're not talking about.
Let him
That's the
go.
problem.
Hang on. Go ahead, Bandit.
Just going to say that cubic meter above my house is part of, it's a subset of a greater volume of air, or atmosphere as you call it, which is pressurized. You can't just take that little slab in isolation. Where does the greater volume of pressure come from?
I didn't understand anything you said.
Oh my God.
The cubic meter that you are referring to above my house, that is a part of a much greater volume of pressurized air. You can't just take it in isolation. The greater volume, where does that get its pressure from?
In other words,
that's what I'm asking.
In other words, you can't pretend that this fraction of all the gas above your house is not a fraction of all the gas everywhere.
I'm not pretending that.
Okay,
but,
so it's not,
for example,
how gas itself, it's a fraction of all the gas.
How do we know the atmosphere has pressure? How do we know the atmosphere? You can pick up a barometer and read it, right? You're in an open field, no walls. You pick up a barometer, you read around 1 atmosphere. So you know there's pressure in the atmosphere, and it's around 1 atmosphere. How do you know that?
Correct.
Because there's a force being created at the barometer. So you know there's a force over an area, which is the area of the barometer. And the barometer itself is going to do the math for you and tell you what's the pressure.
This is a red herring.
Am I correct? Am I correct?
You must be trolling. Honestly.
Am I correct?
A genuine argument.
You're so determined to go on red herring.
So you want to avoid? I mean, if you want to avoid answering the questions,
it's not me
and pretend it's not related.
It's you going on with the red herring.
But if I want to make an argument and I want to find common ground, I have to ask some questions to establish the common ground first.
Like that's not the point. The whole beginning of this line of dialogue. Too bad. That's you're red herring. You're not talking about what we were talking about.
We're talking about gas pressure.
He is talking exactly. There's no red herring here. Quit calling red herring.
This is a red herring. Do you know why it's a red herring?
No, it's not.
Because you don't want to answer it.
No. Do you know why? Because we're not talking about how do you detect gas pressure.
No,
we're talking about the necessary antecedents
it's a counter argument
to occur.
Yeah, I'm trying to get how you got there, and apparently you're implying that. Therefore, just because
we're talking about.
Let me explain.
One second.
If you have a balloon, which is 2 feet in diameter, and you pump it up to 50 psi, and you have a barometer inside the balloon, it will read 50 psi. How do you get the 50 psi? It has to be inside the balloon. It's pressing on the barometer, but it has to be within the container.
Of course, in the balloon example, we know there are walls around the pressurized gas, but I'm not asking for examples in which you can. I'm asking for justification for this universal rule that every time you find pressure, it means there is a container. Showing me examples of containers with gas pressure inside doesn't prove that.
There is no justification for the antithesis of that universal. In every instance where you detect gas pressure, it's contained.
I'm not claiming the antithesis. I'm asking you to justify the claim.
Listen to what I just said to you. You're claiming the antithesis of the universal.
I'm not. I'm asking you to justify your claim. I'm not claiming the opposite.
You're not saying that. Fine. You're not saying that. There is
I'm not saying that.
Container.
I'm asking you to justify your claim.
Every instance you detect gas pressure, the gas is contained. You don't have any instance where you detect gas pressure with gas that is not in the container.
There is your answer. That's the answer I was expecting. So the claim that every time we want to pressurize gas, we use containers. We have no instance in which we can pressurize gas without a container. And this seems to be where this universal rule comes from, right?
Yeah, it's called inductive reasoning, which is what you do in science.
Yeah, but you cannot extrapolate those to situations where you haven't tested before. So, for example, you cannot extrapolate those experiences to situations that would be very different from where you test those. So, for example, you can test gas law in small containers, and it's going to work very well. As you use bigger containers, the ideal gas law doesn't work very well, right? Because it's a law meant for the scale that it was tested for. So this claim that every time we find a pressurized gas, we do that with a container. I mean, there's a certain scale we're referring to. We're not talking about Earth-size scale things.
That's what he's saying.
Yeah,
it doesn't scale.
We're not talking about things of the scale of the Earth. All of what we're saying is like things are at a human scale. So now you're using experience of things that comes from a human scale and try to apply that to Earth-size scale without giving any thoughts on without giving any extra thought on anything that could be different at that scale.
So
this is why I don't think you're not justified. This is why I don't think you're justified. This is why. Let me just conclude. This is why I think we are not justified.
Why can't you end? I get the point.
I'm about to.
Let him finish.
Let me just finish. Okay, this is why I don't think you can justify using an experience with human scale containers to make claims about the whole atmosphere. Because clearly we're not talking about something that is similar to the experiences that led us to that general rule. This is my argument.
Okay, finally. So that's a special pleading fallacy. So this gas law is a law that's universal but not universal, and it doesn't apply to the macroscopic scale of the
No,
Earth.
I never claimed it was
applies everywhere
universal.
except the Earth.
If he's got something to say.
It applies everywhere except the Earth overall. It's special pleading fallacy.
No,
Okay,
wasn't my
Gregory,
claim.
if he's got something to say.
What is the demarcation line between where it applies and it doesn't apply? Like, what's the scale? Have you got any idea when that law stops applying?
Well, I'm not claiming that law stops applying. You guys are just using it without any restriction. We ignoring the fact that you're taking something that works in a very specific scale and trying to use it to something that is many orders of magnitude bigger than what led to this.
But it's not always the law. It's only a law when it suits us to be a law. And then
Thank you.
it's
It's special pleading fallacy. It's a law, but it's not universal when applied to the macroscopic scale of the Earth.
Yeah,
it's
laws
special pleading
aren't.
fallacy.
The laws aren't. This is not a fallacy. Laws aren't always universal. Laws are meant for what where they're tested for. Like the ideal gas law. The ideal gas law. The ideal gas law.
You don't have an instance where you detect gas pressure of gas outside of a container. So you can't substantiate that assertion.
I'm not asserting.
You detect gas pressure
What
with
assertion?
gas that is contained. So
What
to say it
assertion?
doesn't apply to the Earth is an unsubstantiated assertion.
I'm not saying it
It's
doesn't
special
apply
pleading
to the Earth.
fallacy.
I'm not saying it doesn't apply to the Earth. I'm saying you're not justified trying to apply that to the Earth because you're talking about something very different.
The law is not only talking about human level scale. That's not what the law.
This is what
That's
led to the
relative.
law.
That's a description of a relative instance. It's not a description. Bacon. A law is not describing a particular set of instances. It's a general universal. It applies at all times, at all places, to all things. That's what a law is.
The law,
It's universal.
Not really.
law is very
It's
specific.
universal and not universal.
Not really.
Law.
That's actually not true. The many laws you're gonna find in the own definition of the laws that there are certain parameters in which they apply, which is the parameters in which the law came from. So, for example, the ideal gas law, it comes from experimentation in small containers, so it applies very well on small containers.
So the law,
the ideal gas law,
the ideal gas law, is talking about small instances done by experiment. That's not what the law is talking about. The law is the necessary antecedent to gas pressure is a container. That's the law.
Yeah, but if the law comes from experiences with small containers, it wouldn't make sense to believe it would apply to containers that we haven't tested it for, right?
Dude, seriously?
It would be a logical fallacy, wouldn't it?
It's implicit.
Yeah, answer that question.
It's implicit by the law that we see. There's no justification to include the antithesis.
No, you called it a law, but it doesn't matter if you're calling it a law or not. The reason why this law exists.
All instances to establish a law. That's why it's inductive reasoning.
Yeah, of course not.
Gas law isn't valid at low temperatures or high pressure.
That's an example. Yeah, so laws can have limitations, and usually those limitations come from the parameters in which the law was tested for. So
this
if
isn't
we
making any
test,
sense. So are there
What do you mean?
instances? Are there instances? It's very simple. You're saying that it's not universal, that it's not always the case that you need a container to have gas pressure. So what instance can you appeal to where you have gas pressure of gas without a container, outside of a container?
this is an inverse of burden of proof. I'm not saying it's not universal. I'm saying I didn't get to the middle of my sentence. I didn't get to the middle of my sentence. Let me finish, please. I'm not making the claim that I can justify this rule not being universal. You are claiming it is universal, and I'm asking for your justification. And I think you're not justified by making this an universal law.
That's your critique of my position. Your critique can only stand if you can provide an instance where there is gas pressure outside of a container.
This is what the inverse of burden of proof is. I don't have to prove you wrong.
Your critique hinges on.
I'm not
going to
have
allow this
to.
obscurantism.
I'm not have to prove you wrong to prove you're not justified.
Your critique can only stand if it's substantiated by an instance where you have gas pressure without a container.
Unsubstantiated by showing that you are not justified, because that is what my claim is. My claim is that you're not justified in
You
using
asserting
the.
the claim does not substantiate it.
No, I'm not claiming otherwise. I can try to justify otherwise. I
Did
can
you hear
try to
that, Bandit?
justify.
So his assertion is substantiated because he said so.
No, you're strawmanning me. My claim was never that that this rule is not universal. My claim is that you don't have justification to treat it as universal. You can only use the law. You can only use the law in the you can only use the law in the parameters it was tested for.
Double speak.
How is that double speak?
It's universal. It's not universal.
I never said it's not universal.
Yes, you are. That's what you're arguing. So you people
No,
can't make
Mark,
up your mind on what your argument is.
Well, apparently you don't hear very well, because what I'm saying is you are not justified in treating it as universal. This has always been my point. I never claimed it is not universal.
Why am I not justified?
I already explained that, because the laws you're referring to were tested in a specific scale, and many of gas related laws only work for those scales. So we know in extreme cases they don't hold. Now you're picking a specific law about gases that comes from our experience, human scale experience, and trying to use to.
All right, so Bacon, you're saying that laws are not universal, that they're specific depending.
Not necessarily. Yeah, they're not necessarily universal. They have limitations. Many laws have limitations.
So the law, gas pressure, the necessary antecedent to gas pressure is a container that doesn't apply universally.
Where's your citation that says that a container?
Just follow the argument. I'm not bothering with citations right now.
Tell me his citation. Well,
just follow the argument. I'm not bothering with citations right now.
Why do you say that?
That might be the case, right?
So substantiate that.
I'm saying that might be the case because
of gas pressure without a container.
He won't give substantiation, and he immediately asks for substantiation.
Yeah. So my first argument against you, or ask for you to substantiate, how can you use why are you using this law universally, right? And your answer is asking me to substantiate otherwise.
Because there's no substantiation for the antithesis.
And neither for the claim.
There is. In all instances, in every instance where you detect gas pressure, the gas was contained.
Yeah, all of those are human scale containers, right?
Right. So that you can inductively reason to a universal general based on those particular instances. So for you to then say to me, the law is not universal, that implies that there are instances of gas pressure without a container. Show it me.
No, you cannot generalize beyond things you haven't tested. So you haven't tested.
So then science is impossible then, given what you just said. You can't generalize from particular instances. You can't, so we don't know any laws at all, according to what you just said.
Of course not. So for example,
we have no scientific knowledge according to you.
No, of course not. Laws can work with specific parameters and scales.
Bacon,
Can I address what?
Well, Bacon, not to change the topic entirely, but we don't have to. But I was just thinking how spectroscopy, that experiments done on Earth, then claimed that it's happening in outer space, and that.
Thank you.
So why is that not the case there? Why is all of a sudden that on that scale it just is equal, but on this other one it's not?
Yeah, that's a good point.
Mechanism. It's because of the mechanism.
I mean, appreciate what Bacon is saying right now.
But you're making a leap. You're making a leap that spectroscopy works on that scale, and then assumptions based upon that's happening
due to the
vastness of outer space, even though you've only tested it on Earth on this scale.
Yeah,
because
I never
we
claimed
can show that the mechanism of atomic emission and absorption doesn't change regardless. And show that the behavior of gas does change as scale increases.
Tell me an instance where you have gas pressure without a container.
The atmosphere.
Begging the question. It's not what you observe.
Yeah, we're not going to get all of this.
It is actually what we observe. We notice
it's not what you observe.
Yeah,
in all gases, whether or not there's a container around it, or if it's just sitting in the air, all of those gases exhibit pressure gradient, which is a differential in pressure without a barrier in between those differences in pressure.
Yeah, okay. You explain a gradient of gas pressure, which necessitates there be a container for there to be gas pressure. You don't have
No.
any instance of there being gas pressure without a container.
The only thing that would
appeal to the sky vacuum. You appeal to the sky vacuum, which you have never had any empirical experience of.
Can
the
you
only thing that would
substantiate
the only thing that would necessitate it to have a container is the first thing, the very thing we're making a critiquing of, and we have the fact that we have a gradient is what is suggesting that this might actually not apply to Earth-like scales, right? Because if we keep going up, that pressure is going to keep going down.
But you have no empirical experience of.
By the same standards, by the exact same standards, we could say by the fact that we have pressure in the first place, we could say that that's evidence of the container. You can't prove it's wrong either.
Yeah, but the only reason why the only reason why that would be an evidence is if we are using this rule universally. But if you just notice that the gases are forming a gradient and the pressure is dropping as you go high, if you just extend that reasoning, the more you go, the higher you go, the less you need a container to contain that pressure, because the less pressure have to be contained, right?
You don't have any
so
evidence
this
of
is
gas pressure without a container.
so this suggests that at a very big scale it might not be needed, right? We have a suggestion for that. You're just parroting our argument. You're not supporting it.
Test for that. How do you
Because
test
people
for that to see
have
if you're
sent
right?
balloons up to like people have sent balloons up to like 0.003 and lower atmospheric pressure.
Yeah,
Flat
filled
earthers
with
included.
pressure. You're not in a vacuum.
Yeah, but the less. Yeah, but this suggests that the higher you go, the less.
In a vacuum.
Most people can obtain on
yeah,
Earth.
Hey, real quick, please. So fast. This is what I'm going to make sure that I understand. I've never been to where the supposed gas pressure runs out and turns into vacuum, so I don't know what the fuck's happening that far up. Thanks.
Okay, make measurements then. You can take you can join in on somebody taking taking measurements with a you can join in on somebody taking Okay, I'll try and get it out anyway. Even if you don't want me to say it, I'll still say it. You can join in on somebody taking measurements with a weather balloon. You can monitor the pressure on that system because you and that team built that system. You know what it's capable of registering. It's registering pressure. Now, as it gains altitude, now, if you want to keep interrupting, we can keep doing this. We can keep doing this if you want to keep interrupting.
Please, both of you, please calm down. He did ask specifically where the actual pressure ends and the vacuum begins, is what he specifically said.
Okay, I will get to it if he doesn't interrupt. I can get to it if he doesn't interrupt, correct?
Go ahead, just finish your point, Doofus.
Jeez. All right. So you and your team, being purveyors of this piece of equipment that's going up in the atmosphere, it's registering that pressure decrease to well below 0.1 psi. If there's a container up there, what is it doing?
Okay, so are you done?
Yeah, what is the necessary? What's the necessity for that container?
You just asked a question. That's weird that you would answer a question with a question, but anyway, what I'm saying is, you have to go with the balloon, or you don't really know, do you?
Oh
yes,
my God!
because you can take the the equipment that you put on the balloon. Yes, because you can take.
Go up and touch it.
Yes, because you can take. Yes, because you can take the. You can take the. Yes, because you can take the equipment that you sent up there, and you can apply all the kinds of tests you want to as to whether or not I get that your butt hurt, but let's finish it anyway. As to whether or not the equipment is capable, as to whether or not the equipment is capable of measuring pressure accurately, you can test that with a vacuum chamber here down on Earth. If the equipment was faulty, you would know.
Okay, I'm not buying it, so whatever. Cool. Moving on.
That's your opinion.
Yeah, you
An
don't have to
opinion
buy
based
it.
on
But
lack
here's
of
the
evidence.
problem, though, is that you can't also prove it. That's the other problem, though, because the only
Yes,
other
you
proof is to
can.
point at other
That's what I
places.
just said.
I was still talking about it, though, but the only way that you can prove it is to point at different things that you think are an atmosphere next to a vacuum.
No, because what you're doing is you're removing the air from a contained enclosure that contains your device that you're using to measure pressure. With that reduction in the amount of air that's within that space, the device registers less pressure. Now you know, because there's less air in there, that you measured less pressure, that the device functions. And then when you put it up there in the atmosphere, you're sure that what it registers up there is the same kind of thing that it registers down here.
Assuming
Lots
the
of
device
empty,
pressure, not a
empty
vacuum.
space, lots of empty space with no air in it.
No, still pressure, not a vacuum.
Exactly. Like
It never
there
goes
is
to
still
zero.
an
God
amount.
damn.
There's still an amount of pressure in there. And here's the other thing too: is that again, we're talking about proof of the claim of all of this stuff. Like this is a claim that's not testable. I mean, you can go up and just see that there is in fact still pressure, but you can't go and test that there's the vacuum there. Like that's the part of the problem is that it's an unfalsifiable situation.
No, that's not true. We do use
Yeah, what are you
instrumentation.
testing? Yeah, what are you measuring up there? You're measuring something that is classified as a vacuum, correct?
It's classified as a vacuum. It's not really a vacuum. There's still pressure.
Okay, cool. The actual globe model says that it's not a lack of matter entirely. It says that there's still pressure out there in interstellar space. It's just very,
Right.
very, very
You're
low.
contradicting yourself. You're not in a vacuum.
No, I'm not actually.
In your
'Cause if
own
you're
paradigm,
asking-
you're not in a
If
vacuum.
you're asking for validation of the globe model claim, the globe model claim is that there's very, very little pressure up there, and we can measure that directly.
Right. There's still pressure contained.
Right, but that doesn't mean that you
Right,
know
so then
what's
we've
beyond
validated
that.
the
I
globe
mean,
model.
all you can do is make a claim, but you can't test beyond that. And all you're saying is
Yes,
that you're
actually, we
assuming
definitely
a
can
vacuum
test
beyond.
for the claims of the globe model because the globe model claims that there's very little pressure up there, and we can measure that.
Right, but that's kind of begging the question. And the
No, it's validation. It's not begging the question.
say, well, are there any? Oh,
I'd like to ask just a quick question.
not really.
Statement was
It
made.
really is unfalsifiable.
What's the difference between validation and begging the question? What
Right,
test
so
do you
a-
do to
so a-
determine what's?
So a model, when it makes a claim that there would be very little pressure and that there's almost no matter whatsoever up there, when you validate it, you measure the thing that the claim stated to be true to actually be true.
I got you.
Right. So you should not be detecting any pressure.
So check it out real quick. So I'm going to make a model that predicts that chickens
Hold on.
cause the sun to come up in the morning, and I'll
Effie,
measure
you're on
the noise of the chickens every morning, and that is validation of my model, correct?
Now, Fe has got a question. He's been trying to get in for a minute. What you got, Fe?
Yeah.
But is
Thanks.
that validation
Thanks,
of
Howard.
my model?
Oh, jeez.
I just
Yeah.
Just quickly, you made a
Validation
statement.
that someone else wants to speak.
So
Yeah,
just
Doofus,
ignore that you're begging the question. All right.
Just shut up for a second, man.
Dude, we'll come back to you, I promise. All right, just a quick one. Doofus, you made this statement in part of what you were saying that in interstellar space there's very little matter. Yeah, that you just brushed over that like it was fact. How is that not just making shit up? How on earth would you justify knowing what exists in interstellar space?
Gotta take that one over.
Yeah, there's a bit quiet there. It's a bit quiet. I'm just waiting. Hello.
Yeah, you're there. I don't know what happened.
Thanks, Howard. Yeah.
You know, you'd have to
Anyone-
actually
anyone-
go there
can
and experience it.
anyone offer how we would claim or even be ballsy enough to say we know what exists in interstellar space, allegedly?
Yeah, go up there and experience it. Yet to be done.
But Doofus just made the statement like it was known.
Hey, hold on. Okay, I had something else going on here. Thanks.
Okay, sorry.
What was the question?
Okay, the question was, in your little dialogue a second ago, you said, just brushed over the fact, in interstellar space, there's very little matter. It's not a vacuum, there's very little matter. So my response to that is, how on earth would you have the vaguest idea what exists in interstellar space, and how does that not qualify as just making shit up?
All right. Well, that's the information we have to go on. The data we have presently available is that the matter that we can observe to be up there is very spread out in between each of these objects that we can observe to be up there.
Up where?
Data gotten from who and how? Data gotten from who and how?
Yeah.
From observations of the sky. What do you mean? From who and how?
So you just stand up and you can see that it's very
interstellar space, bro. Let's be specific.
Yeah, we looked at it. That's how we know more about it, is we looked at it.
Okay. So you're standing here on the ground. Doofus, you're standing out here on the ground. You stare up and you say, there's billions and billions and billions of light years of distance between all this other stuff up there. And just because I'm looking up there, therefore I know that there's very, 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 very little matter between all those things.
You know that's not right.
Right. It seems like you think that all astronomers use only their eyes. And they look at any moment. They don't look at it over time. The only way that they can come to these conclusions is through careful measurement with powerful optics, devices, spectroscopy, over time. Centuries of observations put together over time is how we got to where we are now.
So what about those observations and all their tools that they're using informs them?
Observations with your eyes. That's all you.
That's what he said, right? Looking up at the sky.
Yeah.
Okay. So let me just over
the course of the past hundreds of years, astronomers just stood on the surface of the Earth, looked at the sky with their human eyes, and said, "That's what that must be." No, of course they didn't do that. Why would you suggest that?
Okay, so supposedly they have these instruments. Supposedly they have these high-tech instruments staring up at the sky. Explain the process of inquiry and who did it.
All right, so you want me to teach you all of astronomy here in Discord?
No, I've got one question.
Quit acting like me. Demanding justification for your position is ridiculous. Explain.
He's trying to get you to talk about the satellites and NASA. Is what he's trying to get you to say.
Explain the difference between astronomy and looking into the sky and guessing.
You want me to justify my claims? How dare you ask such a thing?
Right. What I have to do is I have to teach you all of the centuries worth of information that has been collected up until this point. You want me to do this in a Discord conversation where you reject said information without having looked any of it up, right?
So instead of actually just giving me a concise and cogent explanation to justify your position, you want to reduce my argument, my demand to absurdity, driving it into a wall. Obviously, I'm asking you to put in a paragraph or so. I'm asking you to put in. I'm asking you.
If you haven't looked any of it up, why does me telling you now change anything?
Wow.
All right. That was chaos. You guys are talking at the same time, so I muted both of you.
Yeah.
I don't know who was talking first, but maybe Gregory. Gregory, try to make a concise point, and then Doofus can respond.
It's very simple. Very simple. I'm asking you to put in a paragraph or two or more, not a whole entire semester, explain how they did what they did and who.
Beyond looking at the sky.
That's what I'm asking.
Well, I mean, Doofus, you should probably just admit you're just believing government space agencies. Just leave it at that.
Right. No, that's not true, because I do know some astronomers, some amateur astronomers, admittedly. But the problem is
the only people that
in this conversation. The problem is that if you're into the problem is
hold on, dude.
The problem is that
hold on a second. I'm just saying the only people that have claimed to be in interstellar space or send devices to interstellar space are government space agencies, which is why I said that.
All right. So you can interrupt me. That's fine. You're allowed to do that. Great. Now, space agencies.
No, I wasn't finished speaking. And just bowling
space agencies are not. Space agencies are not who I'm basing my information off of. As I just said before you interrupted me, I have people that are amateur astronomers that I know So don't change my position for me and say I'm using government space agencies to come to my conclusions.
So those amateurs were in interstellar space. Those amateurs, that's where they went, to interstellar space, or was it only a government agency that's gone to interstellar space allegedly?
Nobody has been to interstellar space themselves.
So here's the thing. Here's the thing, Doofus. So there's no perfect vacuum. There's just really, 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 really low pressure, right? Is that
good? Because the globe model doesn't say there should be a perfect vacuum.
Cool. Okay. Cool. So if we go out 20 light years out into interstellar space, where there's really, 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 really hardly any matter at all, it's really low pressure. In between those places of matter, what is it? Is it a perfect vacuum or not?
It's
because there's virtually nothing there.
If you want to start getting into the random appearance and disappearance of particles, we can get into particle accelerators and how we know that stuff happens and all that jazz. What I'm talking about,
so there would be a perfect vacuum then,
what I'm talking about is our observations of the matter that we can see. We know that the stuff that we can see is very spread out, and the stuff that's in between, we can't see.
Instead of repeating the claims over and over again, we need to move forward in the conversation and answer my question. Who and how did they detect this? Explain the method of inquiry.
Right. As was mentioned in this conversation and several conversations you have been a part of several times before, spectroscopy and astronomy together, we're looking at the stuff that we can see. We know what matter does under excitation. We know how it should come back to us as light. So we see that, we measure it, and we map it out.
Explain more. So you're just saying, observe and measure, explain more.
If at this point you're in the conversation and you haven't looked up how astronomy works, how is me telling you right now going to change anything?
Explain more. If you explain more, I will get more information. Don't you know how communication works?
That's the thing. You don't do your research. If you want me to do your research for you, you can take your time and do that.
Red herring. Red herring. I'm not talking about doing research. Explain yourself.
If you want to argue about astronomy and the particulars of it and how it functions, how the devices work, what we record, and what that all tells us, you have to do something on your own. You can't just say, I need somebody else to tell me.
Red herring. I'm not talking about research. Explain yourself.
I already did.
Explain more.
Don't need to. We're looking at the matter, and we're looking
so you just
at what
refuse
light
to
it emits,
adequately
and what
justify your
light is
position.
reflected off of it. The information that we gain from that tells us what's going on up there.
All the time that you spend running your mouth in these forums, and you don't take the time to explain more information to adequately inform the person you think you're schooling.
Right.
You have not adequately justified yourself. You just say the word spectroscopy and astronomy and observation and measurement. Explain more. No, I don't want to. Fine. You have failed to justify yourself.
That's also your opinion.
Yeah, you've also failed to justify yourself a time or two today.
Is that actually other people who are not fundamentalist religious apologists for the globe model? Am I making sense? To just invoke the words astronomy, spectroscopy, observation, measurement, is that an adequate and satisfactory, informative, contentful answer to the question?
Well, there's a certain reasonable amount of information that you should expect to gain on the Discord server.
So if there's so much information, explain it now.
Go look it up.
Right. You're just asking other people to do your work for you.
You know, you keep zipping to a red herring, trying to ridicule me for being lazy, even though I'm asking you questions, and you claim to know so much. You claim to know so much. Explain.
Right. We know how the matter responds to excitation. We know what light comes back from it. We know what stuff is made of and what it does up there. So now, what else? You can go ahead and you can go look further on your own into how that happens.
But you know so much, so why aren't you telling me what you know? You know how they did it, you suppose. So explain. How did they do it?
Right.
Yeah, this is obviously not going anywhere.
Right, because you refuse to explain. You act like you know so much.
He didn't explain it. It's only your opinion at this point.
Yeah.
You haven't explained. You said we know. How? You know so much. Explain how.
He gave you the amount of information he's willing to give. If you want to know more about it, it's out there on Google.
So that's your answer. Your answer to the question how is go research it. That doesn't demonstrate that
there's
you
some
know
base
what you claim to
level of effort
know.
required of the person's taking part in this conversation.
Your answer to the question how is go research it. That does not demonstrate you know what you claim to know. You failed.
Right. We know down here when we have this matter and we excite it in different ways, it responds in different ways. We know how that response, those responses come back as light.
How?
Okay. Now we get into how do we excite things?
How did you detect this? How did you gain this knowledge?
Gregory, you have to learn the ways.
Go ahead and look it up.
You have to learn the ways of being a Google Earther.
It's not even about being a Google Earther. All it is knowing the terms. If you don't want to go out and look what those terms mean or how they're employed in reality, that's your problem.
But he's not, that's the thing. He's not really asking for you just to go find something on Google. He's asking how you know it and for you to validate it yourself. If you can't and you just have to defer to Google, fair enough. But I mean, that's what he's asking.
All right.
Thank you, Joe.
So if I excite some gas, how do you think I go about doing that?
I don't know.
All right, we can.
I really have no. I've not the slightest
make
idea.
any
That was just a
guesses?
lazy answer. I don't have the slightest idea.
Start
I
with
guess you increase the heat.
He's just trying to take advantage of where you're not, pretend about his world. Reality
Cut out for some of it.
independent of
Yeah,
what
Jace, you've been
Doofus-
cutting out whatever your insults were. We didn't hear him.
Yeah, he's just trying to pretend that he can keep his word. Once your knowledge ends, he's looking for where your knowledge ends, so he can use that as justification to keep his worldview, when reality is independent of how well Doofus can explain something to you.
Okay, so your anticipation was wrong. Be quiet, Doofus.
I mean, that's
No, that's
entirely
what you're
accurate.
doing. It's very
Not what I'm
easy
doing.
to see,
It's
dude.
not what I'm doing.
You're not hiding it.
It's not what I'm doing. G, are you going to allow this strawman fallacy to continue? It's not what I'm doing.
All right, well then let's investigate why you stopped asking about how we can measure there to be near perfect vacuum up there in the atmosphere. And you can independently, well, at least you and a team of people that put up a weather balloon, you can verify that that's up there. We moved away from that part of the conversation. Why?
We didn't move away from it. I've been asking you how. You just research it.
Okay, right. And in this conversation, I came up with a mechanism that you guys could go about determining whether or not the measurement that device makes sense.
Did you know?
Right?
What was it?
Right. You can test the device that's on that balloon here on Earth, down here at the ground, by applying a vacuum, right? By pulling some air out of something to make sure that the device is registering what is told to be what you are told it is measuring.
So there's a device on a balloon. You send it up to the up. You send it up, and it detects what?
Very, very, very low pressure.
Very, 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 very low pressure. How high did it go?
Mm-hmm. Well, it depends on each balloon. I mean, you have to have a pretty
What's the
decent
highest?
team in order. The highest?
What's the
I don't know. You can easily expect one that you put together with a competent team to go 120,000 feet. That's not a problem.
Can it get to interstellar space?
110,000.
Did it get to interstellar space? Is there a device you send up there just hundreds of thousands, if not millions of miles and above, up in the air? Up.
What? Why? We're already measuring
Because
far less than 0.1 psi.
that's not interstellar space, is it? Interstellar is several hundred thousand and above. Is it not?
It's classed as a vacuum. Anything less than that is a vacuum. There's
Classed
already a vacuum
or
up
shown
there.
classed as or shown to be a
shown to be
or close to.
Right.
Like if I class you as a woman, that doesn't make you a woman.
Well, it's a great
Thanks
great
for that
example of
randomness.
demonstrating
the
that the
classification-
atmospheric pressure approaches zero.
Right.
I class myself as a millionaire, but I'm not a millionaire.
Classifications,
Just because you
you're
class it
aware
as something
under
doesn't make
your-
it that's what it is.
Right. Hold on just a second. Because you should be aware at this point through many years of being in flat Earth that vacuums fall under different classifications. There's different strengths of vacuum.
Define vacuum.
A vacuum is, I mean, we have to go with a classification system for vacuums, do we not?
Define vacuum. What is this vacuum you speak of? What is that?
The fuck? It's an area of extremely low pressure. In this case, we have various. In this case, we have various classifications for the strength of vacuum. They do exist. Here, you want me to go ahead and post that for you since you're about to Google something?
Several different kinds of vacuums, supposedly. Okay. The very first definition Google pulls up is space entirely devoid of matter. So not a very small amount of matter, devoid of matter. There is no matter.
So why are there different levels of vacuum classification?
It's an excellent question. You mind answering that for me?
Right. It's because there are vacuum classification levels because there isn't a perfect vacuum in reality in massive planetary scale space.
Oh, so there is a vacuum and there isn't a vacuum. There is a place where there's an entire deprivation of matter, and there is no place where there's an entire deprivation of matter. Self-contradictory.
It's not contradictory. Here you go. I'll paste it for you. I know you don't like classification systems. It's arbitrary, and philosophy doesn't like things that are classified. That's fine. But here's the classifications.
So you want to keep appealing to there's these different kinds of classifications of vacuum, but not actually define the category of which these different kinds of vacuums are. So you have this class called vacuum. You have these different kinds of a vacuum, but these different supposed kinds of vacuum are not intelligible until you define the class that they're supposedly a member of.
Yeah, I already defined that. It's an area of very, very little matter.
So just very little matter. That's okay. So that's obviously what you want to stick with, because if it really is, there is no matter at all, then all these supposed kinds of vacuums aren't vacuums.
I mean, is that a scientific term?
It's not just. It's not. Hold on a second, because it's not just my classifications, is it? I've posted something that very clearly lays out the classifications for vacuum of very varying strengths. Why do you assert then that it's just me who's saying this?
Well, I'm curious, where on the thing you posted does it say
very
little amount? Does it say very little somewhere, or are you making that up?
Well, 10 to the negative 3 torr is a very small pressure. The only way to have such low pressure is to have very little matter.
At the very top of this list, 0 torr, theoretically impossible.
Mm-hmm. Yeah. So what? But let me ask you a very simple question.
That's why I asked you to define vacuum.
So let me ask you a very simple question. Just as a question of logic. If I increase in altitude and I notice that the pressure drops, and I go higher and the pressure continues to drop, would it be logical to conclude that as the higher I go, the lower it gets, approaching 0 at some point? Is that not logical?
Depends on the cosmic paradigm you live in. If you believe you live in a vacuum, then you think that. Listen to the answer. Ow!
Yeah, it doesn't.
Depending on the cosmic paradigm you believe you live in, if you believe you live in a vacuum, that would follow. If you don't believe you live in a vacuum, if you don't stipulate, that's not one of your premises, that you don't live in a vacuum, it wouldn't follow.
We stipulate specifically that we don't live in a perfect vacuum.
Yeah, in my paradigm,
so that you make your position absurd.
Yeah, so
you don't have any justification for your classes of vacuum. You see, there's these different kinds of vacuums. There's not perfect vacuums, and there is no instance of a perfect vacuum. So you don't live in a vacuum.
Oh, okay, but there's classifications for vacuums. It's there, I posted it.
Right, there's assertions about the different kinds of vacuums that is based on the class of there being an absolute perfect vacuum devoid of matter. But you say there is no perfect vacuum, so you don't live in a vacuum.
Yeah.
So this is non-productive.
Wouldn't it be better to say low pressure systems than instead of vacuums, and instead of classifying vacuums, just say low pressure systems?
That's what low pressure system is a vacuum.
Right. If we want to get into the absurd topic, sure, we can say all vacuum chambers are not vacuum chambers. But why? What would be the point of saying that all vacuum chambers are not
Logical
vacuum
Call it
chambers?
a low
consistency.
pressure system. We call it a low pressure system at this value.
You know,
Yeah, but
logical
we call
consistency,
them
not
vacuum
contradicting yourself, adhering
chambers.
to the law of identity. This is this, and this is not what it is not.
Okay, that's why they specified perfect vacuum at the top of the chart.
Right, and it's impossible. According to you, according to this chart you just posted, you don't live in a vacuum. It's not possible.
We don't say we do.
No one lives in a perfect vacuum.
That's what it says right here on the chart. 24 minutes past the hour.
What's the
That's
difference
just by
between a
definition.
vacuum and a perfect vacuum? Why did so you
That's where the classification comes in.
vacuum. You can't say near perfect and impossible vacuum. You can't use the same word vacuum. Either a vacuum exists or it doesn't exist.
Or it doesn't. It's an absolute.
Yeah, this black and white bull crap makes you where you can't know anything.
Right.
Words
But
were
there'd be no
specific.
point in having things
that's where
called
we ran
vacuum
into the
chambers.
problem. He asked, and we said, how little? And you said, very little. That's not the scientific very little? Is that a specific measurement or a...
Yeah, less than 1,000 parts of the atmosphere. You know, like if you have an atmosphere, 1,000 times less of that, that's very little, I would imagine, because the air is already very little matter in a given space.
So there is no vacuum, according to you. You don't live in a vacuum. You don't have any evidence of a vacuum. Regardless of you insisting calling it a vacuum, it's not a vacuum.
Oh, okay. It's classified as a vacuum. It's fine.
Yeah, it's not a vacuum.
It's classified as a vacuum.
And it's not a vacuum.
It is.
It's classified as. Classified as.
Yeah.
You're just going to keep insisting your pseudoscience like I'm the one that's being ridiculous when a vacuum is the
you're
absolute
wrong.
deprivation
You're
of
wrong,
matter.
Gregory.
And according to
You're
your
just fucking
paradigm,
wrong.
there is no absolute vacuum, and so you don't live in a vacuum.
We don't say it is an
Well,
absolute vacuum. It is classified as a very low vacuum.
Right, and if the classification is wrong, which is what you refuse to concede to because you
That's
are
what you
religiously
say. That's
devoted
your
to
opinion,
your
and that's
paradigm.
Yeah,
Hey,
that's
you
your
want to hear
opinion.
a funny
That's-
joke?
We're
Just
trying-
a
no, but
shorthand.
that's what this whole
It's
debate is about.
easier
is
to call
the
it.
classifications.
It's just
I
a
know, that's the
shorthand,
point, but
guys.
they have made it easy.
It's easier to
for
just
people
say
to do that.
vacuum than say a
Yeah, of course,
low
it's easy to just make
density
assertions that
That's
aren't
what we are
X
substantiated.
value.
That's
Do you
what we're
not
trying to
understand
contend
that
here.
people shorthand
And do you not
during
understand that you are just
communication?
making an assertion that is not substantiated?
No,
Do
it's
you
just
understand
a
that?
shorthand.
the
It's
assertion
just
made
a
was that there's
shorthand.
very little pressure
It's
up there.
easier to just say vacuum than to say a
Yeah,
low
of course, it's
matter
easier to just say
density
vacuum. It's easy to
of
say it has
X
to substantiate
value. You
unjustified
have to
claim. Yes,
keep
I understand.
constantly
It's wrong.
interrupting.
Yes, you're right.
It's easier
You
to
you
say
you continuing to
vacuum.
condescendingly
damn it.
talk slow to me is not going to
Easier
make me
to
concede to your
say
pseudoscience.
vacuum. It's easier to say vacuum in a conversation than to say a low density system at X value.
Oh,
every
it's so
time you
difficult to
talk
say low
about
density, low pressure system. Oh, it's
unless
so
we're
burden
trying to
shaped.
be
Easier
scientific,
to
are we
shorthand
trying to
it
be
to
scientific,
vacuum
or are
because
we trying to
people
be
over the age of
pseudoscientific?
6 understand what you mean.
Right.
Maybe
So
they're
you
not
don't live in a
supposed to be
vacuum.
talking about it. So the
Do I hear a
destruction
joke?
of language, right? You ever 1984, the
well-
destruction of language? Do you remember that part?
I'm sorry you don't get short.
That is exactly the
Fuzzy
point,
Ewok.
though. Right? That's precisely
not,
what we're
because
trying to contend. Right? The fact that all of these things are classified and all of these different government agencies have told us different things and made different classifications to make our life easier
I've
and
posted
to
like
destroy our
20
language
different
and to
measurements.
lead us down a path mentally and
I've
verbally
posted like
so that it
20
makes the
different
pseudoscience
measurements from
I'm just
non-government
gonna
agencies. I did overtalk you, I apologize. But I did post like 20 non-government agencies measurements.
That's
so what you're
great.
saying
So-
isn't relevant.
You want to hear a joke?
seriously, so you're gonna ignore everything else I said if you even fucking heard it because you can't just shut up?
Yeah, you just going
Well, I
over and
heard
over
it.
and over again saying the same thing.
Right,
That's
I
my
heard it,
point.
and
we are
it's not,
trying to contend. That is the point. That the
All right, here's
world
the
has
big
given
straw
us
man.
a language.
it's not about the destruction of language. That's ridiculous. What it's
It
about
certainly
is
is.
that
It absolutely is.
It's a vacuum. It's not a vacuum.
That's exactly what's
Hold
happening.
on. Hold on.
Hold it. Ho.
All right. It's not about the destruction of language. When I post to you,
It certainly is.
Jesus fucking Christ, dude. So
But
when I
when
post
you
to you
say
what
that, you're
the
missing our
oh
point.
my god, we'll just keep doing
No,
this.
really, like, but
We'll just keep talking until
Well, you guys, hold on. Doofus had the floor. At least give him his
me to
30
be muted.
seconds. Yeah, I'm trying to give you the floor, Doofus. Just go ahead.
All right. So what I've posted is what people have agreed, in a group together, what the classification system for the word vacuum means. Now, language is what the group of people agree to each other, what the definition of words mean. Now, this group of people has agreed to classify a very low pressure area as a strong vacuum. So here you go.
Yeah, it's doublespeak. It's a
No, I
vacuum,
understand
absolutely
it.
devoid of
I
matter,
understand it
and
just
there's
fine.
matter there.
Yeah, I understand the classification system.
Yeah, it's doublespeak.
No, it's
Many people
not.
subscribe to doublespeak.
So it's
No,
partially
it's in black and
devoid of
white.
matter. So it's partly devoid of matter, but also partly containing matter.
It's very specific in how much matter. Really specifically how much pressure.
Yeah, that which is not a vacuum is a vacuum. Yeah, you're calling that which is not a vacuum a vacuum.
Right,
It's
that's
wrong.
your opinion again. Right, but
It's your
as we've
opinion that a
already gone
vacuum.
through,
It's your opinion that which is not a vacuum is a vacuum.
But as we've already gone through, the words mean what the collective agrees they mean.
No, appeal to majority
Classifications for
fallacy.
vacuum, classification for vacuums. No, you don't get to call language a fucking fallacy. That's not
They didn't
something
call
you're
language a
allowed to
fallacy.
do.
You're appealing to the majority
That's what
because they
you did.
erroneously
What you
defined
did
this
was
word
you
this way.
said-
Therefore, it's correct. It's wrong.
No. What you said was we can't classify that as a vacuum. Now, of course, we collectively can because the collective determines what words mean. That's the idea
you
of language.
you can make assertions as a group and it's still false.
That's your opinion.
The group says so, therefore it's true. No, the group says so and it's
determines
wrong.
what the words mean. That's the
Not in the
entire
slightest.
basis of language.
Not
Language
in the
does not
slightest.
exist. Language does not exist without the people that made it and agree upon
Well,
its meaning.
there's your anthropological presupposition concerning language. That's your problem.
I think the vacuum argument sucks.
Yeah, I do
If
too. I
I-
think it
if-
sucks.
can I-
This
if
semantic
I've made
bullshit.
if I earned over $1 million in my entire life, but not in 1 year, am I still a millionaire?
Earned? What about net?
What?
Well,
Yeah.
this is language. I mean, the word millionaire means that you've met, that you got $1 million. Well, over the
More.
lifetime, I've probably gotten $1 million. But does that mean I'm a millionaire?
Right.
Or does that only
No,
because you have to have
you've
it.
got to have it at one time for X amount in one lump? Is that what I don't know?
No, you can be a millionaire for a second if you had to. It just has to be that you had $1 million. Not that you had made $1 million in your lifetime, but that you actually have it.
Right. But so $1 million. But I got $1 million. But I had $1 million. So I over my lifetime, I've had $1 million.
They are not going to follow the logic that you're going down,
Yeah.
Fuzzy. That's why I'm just asserting the
doesn't
very.
make any sense.
We're, at this point, we're
Because it's not
arguing over
logical. The word is
had.
defined to mean you have $1 million, like you have in your possession.
So if J.K. Rowling gave away all her money, she would never be she wouldn't be a millionaire anymore. She would be.
Did you have $1 million at one point in time, all at the same time?
Did she also sign away all rights to every book to Harry Potter and everything
This is
else?
stupid,
So she's
man.
Literally,
It
I
is.
don't know. We're arguing about language.
It's ridiculous.
We're talking about language and the ways that society is structured and the way that the certain groups and organizations have structured that language.
The definition.
Everybody knows what a millionaire is.
Well, this says a person whose assets are worth $1 million or more. So I guess that would mean that you don't have to have the cash in the bank of $1 million, but if you have houses and whatever, your assets in total.
Who determines what those are worth? How much is your house worth?
The market. What do you mean?
Yeah, but
the
who
market determines that.
Well, I know, but who determines
The
market?
market.
It's what
The
people are willing to give for it. Yeah.
This other definition says your net worth is 1 million or more, excluding the value of a primary residence. That's what this one says.
Now, they could be specific definitions for specific legal cases. But yeah.
Yeah, so anyway, you're calling that which is not a vacuum a vacuum. It's doublespeak.
So let's get away
What's your
from
opinion?
it. Yeah, let's just get away from it. I'm not going to agree on it.
So you see how the human mind works. When we are devoted to something, we will protect it at all costs. So when it's obviously contradicting logical consistency, even within their own paradigm, they will defend whatever premise they hold, no matter what is said against it.
The way you just said
Not
that,
a vacuum.
maybe we were talking earlier about why they do all these lies and why they do all this stuff, and what you just said is a big one. If they can get people to believe something, they get people. They then get people to defend it. So not only do they have believers, but they now have people defending and rooting them on.
Apologists.
Yep.
All right, but we should be able to acknowledge that as many times as has been posted in this chat today, that the agreed upon definition for vacuum includes a classification system for different levels of pressure, right?
That's wrong.
That's your opinion.
That's according to you.
Well, but hold on, but we all here can agree that I think we can agree, all of us, all countries in the world agree that the same amount of reindeer are in front of Santa's sleigh, right? Collectively, we can all agree to that.
God damn, man.
All right, so then when I ask somebody, any random person, how many reindeer are in front of Santa's sleigh, they'll give a number, and that number will agree with the most people. So that's part of the vernacular. Now, if I ask,
therefore, that really is the case.
What is a classification? What if I ask, what is a classification system for vacuum? And they post something like I just posted, a list of different pressures at which different vacuum levels are classified. Then what?
Right, including that which is not a vacuum into the category of vacuum.
That's your opinion.
I'm not going to concede to this bullshit.
The thing is, you're talking about a perfect vacuum, and there are classifications. All vacuums are not perfect.
And then that which is not a perfect vacuum is a vacuum, but it has matter in it. A vacuum with matter in it. A vacuum with something in it.
According to the
classification.
classification. According to the classification.
And according to the classification.
Language,
so it is true because they say so. That's the ultimate authority, because the professionals say this double speaking nonsense. Therefore, it is the case.
Makes sense
no.
to me.
The classification system is agreed upon. Nobody says any particular thing about it is true in any particular place. It is simply a classification system.
Cycle standards.
It's stipulated by who?
All standards basically are just agreed upon definitions. So I work with a standard called ITIL, and that was just really to create a common language between sort of technical people like me and business people who have to give me money to do technical things, so we can all understand what we're talking about. That's all that is.
The problem isn't the standard. The problem isn't that there are standards. The problem is that the standard is absurd.
That's your opinion.
Why would you say it's absurd? If it's agreed upon that we can use these definitions in a scientific context, and all the people in that context understand the meaning of those terms used, then it's not absurd. It's just a standardized use of language.
In your own paradigm, according to that chart.
Very fuzzy.
Name all the reindeer standard. Every country could standardize the name of each reindeer, so we could all be on the same page.
Okay.
Yeah, according to the chart that was posted in the live stream, according to the chart that was posted in the live stream voice text, the perfect vacuum, a vacuum, is impossible. By your own standard, by your own position, you're not in a vacuum.
We don't say
we're not in a perfect vacuum.
You're not in a vacuum.
Not in a perfect
vacuum.
You don't have to prefix vacuum with the word perfect. It's just redundant. You're not in a vacuum.
Set of standards,
the classification system exists.
Yeah, by that classification system, we're not in a perfect vacuum.
You're not in a vacuum. You're prefixing vacuum with the word perfect. Prefixing vacuum with the word perfect is just redundant.
No, because that's just the standard that's been created so everybody knows what they're fucking talking about.
Right. Prefixing the word vacuum with the word perfect is redundant.
Well, prefixing the word diamond with the word flawless would not have any value either, and we know that's not true.
Diamond flawless.
I said prefixing the word diamond. I said prefixing the word diamond with flawless. Okay. You didn't listen. Thank you.
No, I was seeing if you were paying attention.
You did say prefixing the word.
flawless with diamond. So
No, he said
No,
prefixing the
so we
word
can
diamond was
rewind the stream
flawless.
though, because every time you guys do this, we can always rewind the
all
stream.
right, calm down, calm your tits,
Correct.
calm your
Every
tits. It's all
single
right.
time.
Go for it.
What I don't understand is why is this such a problem for you, Gregory? Why do you care?
Because you're saying that which is not a vacuum is a vacuum. It's nonsense.
your opinion.
No.
But
Sorry.
you people devote yourself to believing that it is true and that it's not nonsense. So that's the
No,
problem.
it's just agreed upon standards. That's all it is.
Right, what you agreed upon is absurd. It's false.
Who cares what the label is? We've given it a label.
Right, what you agreed upon is wrong.
What's your
You
opinion?
can make that point. It can't be wrong because it's agreed upon within that community.
Okay, so let me ask you this.
Let me
ask you, if the entire population, where are you, if you would like to say?
I'm in the UK.
If everyone in the UK agreed that it's okay, it's justified, if not even beneficial, to torture you for fun, would that make it okay?
That's not it. That's a red herring.
That's a complete category error. Let's just say that everybody in the UK. Wait 1 second. I'd like to make a quick response. He asked me a question. Let me respond.
No, but
Let him respond. Go ahead. After Skeptic Fuzzy, go ahead, talk. Skeptic.
Go for it. Go.
So if everybody in the UK understands that we change the name of cucumber to zucchini, and everybody in the UK understands that for some reason we're going to use this ridiculously stupid word of zucchini, but we all know that it means cucumber.
Mm-hmm.
Is that a problem?
So my question. So my question. Right. Go ahead, answer my question.
This is about meaning. This isn't about action.
No, the point is, if the majority says it's okay, if the majority says A, then it is A. So if the majority of the UK said it's okay to torture Skeptic for fun, would that make it okay?
Again, you're creating a moral action with an understanding of meaning of a label.
No,
that
you're
is a
saying
red
that the
herring.
majority determines A is A.
No,
Whatever the majority says, it is the case. So if the majority of the UK said, it's okay to torture Skeptic for fun, would that be true?
How about you tie it to an
torture? They
analogy
actually
of the
meant
same
tickle. They
kind
all
of
agreed on tickle before that.
Cacophony. I can't see
right.
anything.
Well, if you would take the time to tie your argument to something that's actually being discussed, the meanings of words, not the moral implications of actions, then it would go so much more smoothly.
You don't understand.
All right, I got you real quick. I got you. No, they don't. But the majority of that group that believes in Santa Claus being all the children will all agree that the names of the reindeer. I mean, a case can be made for the red-nosed one. But just because they all believe it and all agree upon it doesn't make it reality, guys.
It makes it the definitions
doesn't
of
make it
words.
real. It doesn't make it true.
We're not talking about the classification system being evidence for something in reality. We're just talking about the classification system itself at this point. So if you want to say,
so let me ask you this. Your critique is fair. Let me ask you this.
We're not saying that the classification itself we're not saying the classification system itself is justification for the heliocentric model. We are just agreeing to the classification system all on its own.
So let me ask you this. If the majority, I think you're in the United States, Doofus, if the majority of the people in the United States, or even if all the people in the United States, excluding you, said that we classify Doofus as a rapist, would that make it so? Would that be true?
There again, it's a red herring.
Another red herring.
It's a classification issue. If the majority classifies you
as a
rapist, would that make you a rapist?
Another red herring.
No.
Jesus Christ.
Okay, I'll try another example then. If the majority of the United States, go ahead, Fuzzy. Go ahead, Fuzzy.
Moral implication is just a classification.
Thank you. It's like I just said it. Classification.
Oh, sorry. No, I'm breaking up. But all he's saying, it's a
Fuzzy.
If you want to give the word rapist a classification of the word, what it means, and then we apply that to it. So, for instance, they say ultra high vacuum is 10 to the -11 torr. Okay, so that's classed as an ultra high vacuum. So, if under that definition, I've got something that's atmospheric pressure. It is, by that definition, not an ultra-high vacuum, is it not?
How about this? How about this? I understand what you just said.
Why don't you answer the question rather than sort of pose?
Oh, that was a question? I'm sorry. What was the question?
Yeah.
He asked if you agreed.
Would you not agree that if we've defined an ultra-high vacuum, I'm just using Doofus table, I'm actually going to expand it because I haven't got my glasses on, is 10 to the negative 11 to 10 to the, 10 to the negative 10 to 10 to the negative 11 torr, and we measure something of 760 torr, that wouldn't be, under that definition, an ultra-high vacuum, would it?
I don't understand the question.
Oh my gosh.
I mean, just simplify the question.
Okay, I'll use your example. If being a rapist is forcing someone to have sex against their will, and Doofus didn't do that, he would not be, under that definition, a rapist, would he?
But that's not the point. Your
that is the
appeal,
exact points.
Your appeal is to the majority. The group said
my
so.
God.
No, it's not.
You getting
It's
excited?
not.
You getting excited?
Fucking
It's
double
not
speaking
to the
nonsense
majority,
sophist.
it's to
This
the
is so
definition.
irritating. This is nonsense.
It's not to the majority. That's the
So
whole
what
point
is
here,
it
Gregory.
then? So what is it then?
It is just a standard set of non-clementia.
Set by who?
Words. Set by the
Set
people
by who?
set by
The
the
majority, right? The people.
No,
The people who
not by
use
the
it.
people.
Double speaking nonsense.
The people
Set
who
by
use it.
Use it. Exactly.
Yeah.
Wow. Ridiculous. So who said it? The people, right? The people? The people?
The people that use it, the people that need to describe different levels of pressure
Right,
at
the
very
group?
low pressures to each other. So what they need to do is come up with some kind of standard. ISO
Yeah, the
has
group.
one.
So when
ST has
I
one
contradict
before
the group's word trumps my word, correct?
That's how language works. You already know
You
this.
see? So that's
You
your
know-
argument. Stop moving the
You already
goalpost.
know for a fact that
Double
that's how
speaking
words.
sophist.
You already know for a fact that's how language works. When we have a definition for a
Okay,
word,
so
it's
that's what
because
you're saying. So that's what you're
when
saying.
we have a definition for a word, it's
So that's what
because
you're
the
saying.
people-
Yes,
when
I
we
got
have
it.
a definition, when we have a definition for a word that everybody agreed upon, that's how the word gets used.
Right.
When we have
Okay.
a classification system, which
Yes.
because the people who use it that need to describe certain things to other people have agreed they will classify it as.
Okay. Are you done rambling? So that's your argument.
Was that rambling,
My
really?
critique of the argument is just because the majority say so doesn't make it so.
That's how language works.
It's not how language works.
It is. It is precisely how language works. If everybody started using a word in a certain way, like selfie, it becomes part of the language, doesn't it?
No. If someone says the word the is a, does that make it so? Does the majority, if the majority said that, does it make it so? If someone says elephant is tiger, does that make it so?
That's not what he said.
If someone says up is down, does that make it so?
It's not what he said.
Gregory,
That's not what I'm saying.
Here's a
You
very
just-
simple example. In my world, we use a term called.
You see, you just
man-
trample on my examples.
second.
You just whistle past them.
It's a red herring. It's a red herring.
Yeah,
It's not a red herring. If the majority says the elephant is a tiger, does that make it so?
If the majority says, if the majority has defined the animal that you see, you associated with the word elephant, but the majority says that the animal that you see is associated with the word tiger, the majority would win because they're all talking to each other about this thing that they all recognize and they already have a word for. You can't come along and have your own personal definition for words.
Okay, so when we know that a vacuum is devoid of matter, and then someone says this, which is not devoid of matter, that has the presence of matter, is a vacuum, I'm supposed to agree to that?
You're supposed to agree to the standards by which the people communicate these things to each other, because
Right,
that's
so I'm
why
supposed
the
to agree to
standards-
self-contradictory
because that's why-
assertions.
because
Absolutely
that's
not.
Because that's why the standards exist in the first place. What you're
Yeah,
arguing
I'm not
is
agreeing to
things like-
self-contradictory assertions.
you're
A vacuum
arguing-
is
what you're
devoid of matter.
arguing is
That which
things-
is the presence of
what
matter is not a
you're arguing
vacuum.
is things. What you're arguing is things like standardized definitions for categorizations of things has no meaning, which is not correct.
Yeah, what you don't understand is that it's an absolute dichotomy between there is matter, there is no matter. That's what you don't appreciate. If it's a
That's
vacuum,
your
there is
use
no
of the
matter.
word. That's your
that's your definition.
That's how you.
It's not just my use of the word. It's the historic use of the word by the majority.
Yes, and
But you people come along and contradict yourself.
Gregory, I kind of agree with you on that. If you want to talk about a vacuum in its truest sense of the word, you are right. But what people have done in science, and in my industry, especially IT, is we have terms that all the IT people understand. So I was going to use in cyber, we have what's called a man-in-the-middle attack. That has a meaning between me and any other technical person I'm talking to about the type of attack that's being done and the meaning of how that attack is being enacted.
Okay, there's nothing self-contradictory about that. The self-contradictory to call that which is not a vacuum a vacuum.
There is no man in the middle.
Involved. Yeah, there's no man.
There's no human in the middle.
Great. Okay, so that calling that which is not a vacuum is self-contradictory.
Then calling the man in the middle
does not involve a man.
And just retorting that it's retorting to me that it's my opinion doesn't. Retorting to me that it's my opinion does not debunk my
define these words. Use them.
Okay, so that's my critique of this idiotic, imbecilic categorization.
That's your
retorting
opinion.
to me. Retorting to me that it's my opinion doesn't debunk it.
It does. If we see something like a man in the middle attack doesn't have to include a man, you would also say that that is self-contradictory. But we know in technical fields that we have to use terms that everybody already agrees have a meaning.
Okay, so refute what I just said.
I did.
Or
the man in the middle.
Just concede. Or just be quiet.
No, he just
Gregory,
did.
Actually, let me ask you this very simple question. If you were using that table that Doofus posted, and you know that the person you're talking to who's in the same field understands that table, if you said medium or intermediate vacuum to that person, would they understand what you meant?
Sure.
Let me ask you this, Dress.
Doesn't matter. It's beside my point. That's a red herring. To my point.
Let me ask
calling that which is not a vacuum is self-contradictory. It's wrong.
Yeah, let me ask Dress a question. Hey, Dress, I need you to manufacture me a set of glass tubes under vacuum. Could you do that for me?
No.
I know somebody.
What, do I need to give you more information about that or something?
No, I just don't know how to do it.
Okay.
That's the honor. If you want me to extract copper from malachite, I can
make
do
this
that.
linguistic anthropological argument in defense of this self-contradictory nonsense.
Yeah, again, that's
Self-contradictory.
fine. If you could hold that position, and in colloquial English, I would kind of agree with you. But when you're talking about technical language in itself has meaning between technical people.
Yeah, so you people agree that that which is not a vacuum is a vacuum. That's what you've done.
No, it's nothing to do with that. It's a classification.
So you don't agree that that which is not a vacuum is a vacuum?
It's a classification of vacuum, and I've already gone over this.
Right, so you agree that that which is not a vacuum is a vacuum.
Under that standard, yeah.
Yeah, self-contradictory. People are ridiculous.
That's fine. You can hold that opinion. But if it conveys meaning in a conversation or in a technical document, then nobody else gives a shit because the people involved understand the meaning of the term used. And that's
my critique is true regardless of them not caring.
That's all fucking language is about.
Yeah, my critique is correct regardless of them not caring about it.
Correct to you.
Yeah.
No, correct. It's correct. Not toss out to you.
If you entered it, to my point was, if I asked someone to make me some glass tubes that were under vacuum, their question to me would be, what degree of vacuum do you need? Because there ain't no such thing as an absolute vacuum.
Because you're using the word vacuum in the sense of low pressure system. It's not a vacuum.
Yeah,
You're using the word vacuum in the sense of low pressure system.
Varying degrees
you're calling that which is not a vacuum a vacuum.
Hey Howard, it might interest you to note that the varying degrees of vacuums, there's a reason to do that. Even like if you have a light bulb, that's under more of a vacuum than your typical, say, Crookes radiometer.
Yeah.
So it has real world benefit to us.
In the nature of the case of vacuum, it's absolute dichotomy. Either there is or isn't matter. There's no degrees, no spectrum.
We have a real world use case. We have a real world use case where different classifications of vacuum are very much used.
Yeah, your classification calls that which is not a vacuum a vacuum. It's self-contradictory. It's nonsense, regardless if you don't care.
Right, that's your
You say
opinion.
there's a real world use case for a radiometer?
The Crookes radiometer specifically, there's a real world use case for specifying the amount of vacuum necessary because a Crookes radiometer does not function under strong ultra high vacuum.
Does that thing actually
high
do
vacuum.
anything though? Do we actually use that thing for anything?
It's a radiometer. Yeah, it's a tool.
You're talking about the thing where sunlight hits it and it spins?
Yeah.
Okay. I thought that was like a toy or something they sell at the museum. All right.
Okay. People have opinions, as we found out today.
I know. I just didn't know they used that for.
And some people have logically consistent, non-self-contradictory opinions. Some people do. It's a shame.
When they limit you, you should really consider that.
Yeah, when they limit me from falling into absurdity, yeah, I very much consider that. I don't want to fall into absurdity.
Gregory will never be ISO 8001 certified.
What the hell did you just say?
It's called standard of operations.
Which is supposed to mean what?
Everyone has to be on the same page.
Mm-hmm. Still doesn't mean anything to me.
I'm not surprised.
So this is the problem with the human race. We just are dedicated to that which is not true, that which is not good, that which is not logical. And any critique of the error, of the fallacy, of the ridiculousness is defended instead of just forsaken.
Okay, so why is Rhode Island called an island?
I don't know.
Exactly. Doesn't have to make sense. Words have meaning.
What is the point? Is that a refutation?
The point is, we have already names for things. If you don't like the names for things, you have to get everyone else to agree to change those names. It can't just be your own opinion.
That doesn't follow. If I don't like the name, I don't like the name. I don't have to get everyone else to disagree with me. It's just that my critique still stands.
Then you'll end up falling into the situation where you end up using words like globalist that already have meanings that everybody else says, why is he using that word in that way? It sounds ridiculous.
And then I explain myself, and then they're like, oh, interesting. Yeah, I see what you mean.
Nobody says that. Not outside of this venue.
False absolute statement. You don't know what you're talking about.
Oh, I do. I typically have conversations.
Not in the slightest.
Not even a single iota. Not a single modicum. That's really adult behavior. I typically do have conversations amongst people outside of this community about the things that occur inside this community. And yes, redefining the word globalist is objectively ridiculous.
And why is that?
Because it doesn't mean that. Everybody already has an agreed upon meaning for the word globalist.
Says who?
It doesn't mean somebody who has the opinion that the Earth is spherical.
And according to who?
According to everybody who uses the word globalist.
Not me. Other persons like me. So that's another false absolute statement.
It's objectively ridiculous for you to have your own personal definition of the word.
No, but it's not just me that has it, and it's not the case that everyone believes what you just said.
Yeah, you and Crit can share bunks.
Yeah, and a number of other persons too. So your false absolute statement is false, demonstrating you don't have knowledge. There's no truth in you.
I think he has a reason to define it differently, though, right?
Yes, I have a reason. Yeah.
You could
globalist.
Say no.
People who believe that you live on a globe.
Oh, you don't think so? I heard a very decent argument that All right.
Right, but then that's a word that already has a definition that most of the planet's population.
Yeah, a lot of words have other senses, not just one.
Yeah,
like most words.
Nobody in the general population uses globalist in that way.
Yeah, but that includes me, so that's another false absolute statement.
Right, in the general population. I said outside this.
In the general population. I'm one of the general population. I'm a member of the public.
How about this?
In more general, outside the community that we happen to be in a conversation in a more general sense than this conversation.
His false absolute statement is false. He's still defending it. Like, it's so patently false. He's still defending that.
How about this definition? How about this definition of globalist? This is on Urban Dictionary. It says a person who is behind a shadow world government, usually a person in a powerful position and who practices eugenics and Satanism.
That works.
Yeah,
that's an Urban
yeah,
Dictionary definition.
Yeah, the general population isn't quite hip on that one either.
Does that fit your definition of a globalist?
I think it's funny
Nope.
to use globalist as somebody who believes in the globe, though, because it fits. Like
it fits. It fucking fits.
Got the word global in it. Globalists are the ones who made up the globe lie, and they're the ones pushing all the economic globe BS. And then people who want to defend the globe, like a defense agent for the globe, are a globalist. It makes sense in that way.
Globalism, globalist. The belief
you have
that
to,
the Earth is a globe.
You have to acknowledge, however, that it's your opinion that people fabricated the globe.
It's your opinion that it's true.
It's my opinion that I've personally verified it. We've had this conversation.
It's my opinion
before.
also that I've debunked it.
Yes.
Do you want to keep exchanging opinions?
Very nice. Thank you. Yes, it is your opinion that you've debunked it.
And it's your opinion that it's real.
It's my opinion that I've measured it. It's your opinion.
Yeah, that's your opinion. It's my opinion that you didn't.
Yeah, it's your opinion that I didn't make measurements.
But Doofus, if you're so confident and you measured it and all that, why are you hanging out with people who severely deny that the globe exists? Why would you like hang out with them and like scream and yell?
That's an excellent question.
Doing that if you're so confident that you found some wonderful truth that the Earth is a spinning globe.
Right, because you guys ask questions. I try to answer them. What's interesting to me, and the reason why I stick around, is what you have to do in order to reject the answers you asked for.
No,
I've never asked you a question, so I don't know. I just did, but I'm not asking you. I've never asked you a question about the Earth, but I just asked you a question why you want to discuss this if you think that you've already found the answer.
Well, you did ask me questions about optics. Not very many, of course, but you did ask me a couple.
Maybe way long ago when you first joined the server, and I quickly found out how completely uninteresting it is to discuss things with you. So I've up on that.
Right, which is your opinion.
And it's your opinion that his opinion is wrong. So you can stay all day. What is your point?
No, I'm just saying. Hold on. So your reason for being in these discussions is that people ask you questions and then they don't listen to your answers, and that makes you want to stay.
It's not just the not listening to answers part, because
that included and more. Oh,
yeah, it's the fact that the amount of justifications necessary to try and make the answers no longer true.
And that makes you want to stay? That makes it worthwhile participating in the discussion?
It makes it more interesting to find out what lengths people are willing to go through in order to deny certain things that they can verify on their own.
Oh, so you did a sociological study just for yourself?
Yeah, I guess basically that's how most people who come into Flat Earth are looking at it, as though it's some sort of weird psychological issue. That's most people that come into this.
It really is. I mean, that's kind of what you'll get a consensus among all the globe earthers, as you call them, that we come here because it's a spectacle.
I think it's a very small portion of flat Earth denialists, global enthusiasts, whatever, that have some kind of twisted mentality of their own that may have that, but that's definitely only the very few that are in this position of being involved in years and years and years, just fixating over something that you have cognitive dissonance over.
Everybody but Geo, though.
You're not here to learn.
There's nothing weird psychologically about thinking the Earth is exactly what it looks and measures and appears to be, meaning a stationary surface that you're standing on, and that up is up and down is down, and that the sky, sun, and stars are moving. There's nothing weird, bizarre,
that's a coherent,
wonky about that. It's much more
Gio, that's right.
weird and wonky to just believe blindly that you're on a spinning, whirling globe trillions of miles an hour through a vast vacuum.
Gio, that's an intelligent conversation with you. You're one of the very few that can actually say, "Look, no." Let me finish with Gio. Gio has observed a flat and motionless Earth that does not rotate, does not move, and is observably flat. And he's doing it from what he's actually seen. The problem I have, and the reason we're here, not because of Geo, but because of other people who argue that things when we do our tests and we show the math behind what we've done in our tests and our observations, that it does point to something other than flat. And those discussions are the ones.
But it don't.
we're entertained by, because we show things that are blatantly obvious to you, for example, Gregory, about a higher horizon that drops with.
I have the same opinion. I have the same opinion as Geo. Why is his opinion
No,
the
we don't
same
have
and
the
mine
same
isn't?
discussion. Gio and I do not have the same discussions. His are based on his observations, and mine are based on mine. And we don't
And what are
see eye to
mine?
eye. We don't. Yours, I
And
told
mine
you.
aren't?
Well, let's do this. Let's go through this then. When I see the horizon drop with altitude, that is giving me proof and evidence that the Earth is round. What do you
But
have
you
to
don't
that?
say that.
No, we do. Show me a
You
picture. Any
don't.
picture. Show me any picture where you see the horizon at or above level.
What the hell is at or above level?
As measured, anyway. Not just
Okay,
eyeballing it.
Any picture besides at sea level, something at some altitude above. Something above
Zanik, the horizon isn't a tangible point on your globe.
Hello.
It's not
a mountain or
tangible.
a building or anything. Just show me one picture where you see the horizon that is anywhere near level.
I have what you're asking for. George Hanna took a picture, measured. He actually measured it. Remember, he was doing those measurements? He measured the horizon above eye level. Your own boy.
Yeah, and the horizon is not a physical tangible point on your globe. It's not a tangible object.
Now what, Zanuck? Now what? We have the horizon over level. Well, now what?
What you got to say to that, Zanik? Come on. Quick snap. Quick.
Wait, are you talking about the back shore? Where the back shore was
George
above
Hanna took
level?
measured the horizon above level.
Right, the back shore, the topography.
No, the horizon.
Well, topographical horizon.
He was not ice.
Yes, he was on ice.
Show me the picture. Show me this picture you talk about.
I'll have to dig it up. You haven't seen it?
There's no pictures ever recorded throughout history of level being anywhere other than above the horizon at any kind of high.
Except for the one George took.
No,
where it's
I'm talking about an altitude picture. Anything above like 1,000 feet. It has to be above 1,000 feet or so.
What the hell are you even asking, Zanik?
It can be above.
I'm saying that
30 feet.
if you measure level at anything above 1,000 feet, I'm not just picking arbitrarily. Why not be safe? Anything above 1,000 feet, you'll never see level match up with the horizon. The horizon will always be lower than level. Always. If you can show me some picture that doesn't, you convert.
What do you think horizon is?
You never will.
What do you think horizon is?
I don't know. It's where we see it, and it's always below eye level.
The point where objects are obscured from your vision.
Oh. Didn't you know the horizon isn't physical?
Pardon me?
Didn't you know the horizon isn't physical?
Not invisible. You can see the horizon.
Yeah, you can see the horizon. You can see the meeting point between the floor and the sky, but it's not a physical, tangible thing.
Yeah, it is actually.
Zanuck, you guys call the horizon refracted and this and that, depending
it can move. Yes, it can move.
Hold on.
It can move, can it?
Yeah, so hang on.
Only a very small 0.02 degrees, 0.04 degrees at sea level. That's nothing.
All right.
We see a 3 degree. Hold on.
Trying to speak.
My evidence shows a 3 degree movement, and your evidence shows a 0.02 degree movement. That's our evidence is a little stronger than yours.
My question is, how are you using the horizon quote unquote drop as proof of the shape of the Earth when at the other side you'll double speak, as it were, and say that the horizon is moving and it's not geometric, it's not because of the curve of the Earth, it's actually just an apparent thing and it moves and bends depending on all these things. How do you hold that and then also hold, hey, look, here's this thing of the horizon, it shows the geometric Earth curve.
Okay.
Before you answer, you have something called a dialectical tension in your worldview.
Oh God!
Hold on. We don't say that the horizon is not because of geometric Earth curve. It's just one of the many factors.
One of the many factors, huh? How many factors are there?
Well, the simplest explanation is geometry and refraction. We can get more technical.
So is the horizon the tangible Earth curve?
The horizon tangible Earth curve? No, the horizon is a result of curvature.
Okay, then when we see boats being cut off from the bottom up, that's not Earth curve, right? Because you just said that the horizon is not Earth curve. It has to do with refraction. So when the boats are being cut off, we can just put a stamp in it. 100%, that's not Earth curve, right?
But we're inside.
I like how you changed my position for me. Thank you.
Okay, make it clear.
Let's use my actual position, which is that
Let's use your actual position.
The shape. Let's use my actual position, which is that the shape of the Earth and refraction together can cause where the horizon is to be where we see it.
Interesting.
Yeah, nowhere did I say it's not because of the curvature of the Earth.
And we can measure this.
When people change my position for me.
Right, but you understand the
Can I make a point here? I've got a quick point just to augment what he had just said, what Doofus has said. If we now take multiple measurements, changes independent variables you like to talk about in the scientific method, we can then actually narrow down what that refractive value is, and it's very small. So it's a rounding error in most cases.
Yeah, but when we see hundreds of miles across a planar surface, and you guys want to say that the Earth is actually curving, then that's not just a little bit, is it? That's a lot.
No, it is a little bit. We're not talking about small angles. We're talking about 0.02 degrees at sea level, more than you should. You should see a 0.02 degree drop just based on if it was a flat surface, but because it's curving 0.04 degrees. So only 0.02 degrees deviation. And then we can see massive amounts of this refractive effects by the Earth. By the sun and the moon, which are up to 0.5 degree. But we see 3 degrees when we see the Earth from an airplane, or 1 degree from a tall building. So our evidence is much stronger than the refractive cause of why the horizon is below level.
How are you affecting a curve?
And you can again, the key thing is you can then take multiple measurements. Wait, let me close with this. You can take multiple measurements and then determine what that refractive value is, because it goes down. That refraction value goes down as you go higher.
How's the curvature of a shape being refracted?
Because optics.
Optics do not change where the horizon is.
No, I understand the idea of your calculations. The thing that seems like a contradiction is the flip between claims of like, why do we see too far? Oh, it's because there's all this refraction happening. Why are the boats being cut off? Oh, that's the actual curve of the Earth. And then the other one where Zanuck, where you're saying that the horizon at these long distances you claim is fitting a globe calculations. Those aren't consistent. Like in one way you're trying to, it's a double speak thing. Like in one way you're trying to say, hey, here's the curve of the Earth. This is a geometric physical curve. There it is. Haha, there it is. In another scenarios, you're saying, no, that doesn't exist at all. It's actually bending and warping and refracting to make the planar Earth look like a sphere. Or vice versa.
We have measurements such as
one second, Zanuck, real quick. In this exact conversation that we're having right now, I already laid out that it's not just geometry in any specific situation. I've already explained why would you attribute to globe earthers that the position is that it's only geometry that has something to do with it, when I just explained that it wasn't. That isn't what I said. Let's rewind the stream. Every fucking time you guys do this, it's
you say this. Hilarious. You've been saying this for years.
Turns out I'm right, and you guys are making shit up.
You've been saying this for years.
He said that exactly. He said it's made up of a couple of factors.
Yeah, you say it's both. There's a dialectical tension in your worldview. You're
insane. There's no dielectric tension. Stop using words you don't understand.
Do you understand what I'm saying?
You do. It's not. You don't even know what dielectric tension is, even in your.
I'm not talking about dielectric tension. You didn't hear correctly. Dialectical tension. You didn't hear correctly.
The problem is that the existence of two factors does not immediately become a contradiction. Two factors can independently exist.
The two factors are contrary to one another.
They're not.
Either the horizon is a tangible physical object, or it's not.
It can't be both. You cannot say that geometry and refraction are contradictory. There's no world in which that makes sense. There's no world in which that makes sense to say that geometry and refraction are two things that are contradictory to one another.
What is the horizon?
The horizon is the last part of the surface that we can see.
Before
so it's not really a tangible object, is it?
Before things. Okay, let me give you another example real quick. We also are at 35,000 feet.
Trample on my question,
Gregory, I give you the floor.
Why do you trample on my question?
No, you trample on me. You were done. It was my turn real quick.
No, I wasn't done. I asked you, why do you trample on my question?
Stop talking for a second. Gregory, please. So at
I'm the one talking to
30,000 feet, we see things that are 200 miles away that only should be 100 miles away if the Earth is flat. There's more evidence that the Earth is not flat. That can't happen on a flat Earth. You cannot see things that are too. So seeing too far, we're admitting you can see too far on a round Earth. And the reason you see things further on a round Earth is because it's round.
So if the Earth was flat, it would be 100 miles away, not 200 miles away? How does that make any sense?
Yes, exactly.
The angular measure at which he's observing.
I know, because you don't understand geometry.
Right, the angular
What are you
measure at
talking
which
about?
he's
Something is
Let me
100
put a
miles away on
drawing
a
so you can
flat
understand
plane,
what I'm
but
saying.
you say if it was flat, it should be 200 miles away? Why? How
Yeah,
does the
Right, can I
no,
flatness of the
100 miles
thing,
away if it's
how does the
flat.
flatness of the thing the object is
can I go ahead and
existing on
explain it
make it
though?
be
Let
two
me be
times
clear. Let
further
me be
distance?
clear one more time. At 30,000 feet, you should see that object that is 100 miles away. Excuse me, it's 200 miles away, only 100 miles away. It's a 3-degree drop
What?
to that object. We're looking at something 200
What did you
miles
say?
away. We're at 30,000 feet. We're looking at something 200 miles away. We see a 3-degree drop. That 3-degree drop should correspond with a 100-mile away object, not a 200 miles away object. Please try to think about this before you respond.
3-degree drop.
Yes, from level.
Right. The
But if
part
we're
of
on
the
a flat
surface
plane,
that we
though.
can see, the
If you're
part
on a
of the
flat plane,
surface,
it would only be 100 miles away.
the part of the
What?
surface
How,
that
how does that work? If it's 200 miles away, it's 200
Dude,
miles
you're laughing
away.
because you're mocking what you don't understand.
Well, Xander,
If it's 200 miles away, how does it all of a sudden become 100 miles away? How does that
30,000.
work?
Well, listen again. 30,000 feet up, and a 3-degree
Uh-huh.
drop. It makes it stop talking, and you might learn. Because now I'm the 4th time now. Gregory, you're being obstinate.
All right,
Just
hold on.
stop it.
Well, don't force him to learn, but yeah, Gregory, don't interrupt him. At least let him speak.
So we have a 3-degree drop for an observation of an object we know is 200 miles away.
Down there, okay.
If we have used trigonometry at 35,000 feet and 200 miles away, that 3-degree drop would correspond with a 100-mile away object if the Earth was flat. So we know it's not flat because we couldn't see 200 miles if the Earth was flat.
Am I just slow? Gio, does that make sense?
God, I'm trying to be as slowly.
Hold on, Zanuck.
What'd you say, Gio?
You're approaching it in an
No, it
inverse
did not
way.
make sense. What he said. No.
Like, I don't understand. How does a 200 mile away object become 100 miles away? All of a sudden, because I raised 35,000
Hold on,
feet.
Zanuck. Zanuck, hold on just 1 second. If you're looking down at 3 degrees from level, from a horizontal reference at your location, if you're looking down 3 degrees, your line of sight should intersect something 100 miles away. But what we see at that location is 200 miles away, not 100 miles away.
You got the distance wrong. What the fuck? How does what?
Because you can observe the surface details, landmarks, and whatnot, and find out what you're looking at.
Uh-huh.
We can see a landing site, which a green and white. If you're an aviator, you understand this. A green and white flashing light means the airport's open, and you can just barely see this light. Let's say it's Reading when from San Francisco. It's 200 miles away. You see it. You see that flashing light. It's 3-degree drop from horizon because you know this too by simple measurements. Yet, if it's flat as a baseline, because we have the rise over run inverse tangent, which tells us what that degree would be. And if it's 3 degrees, we take the tangent of that, and we should see a 100-mile distance to that object, not a 200-mile. It's twice off. The error is twice what it should be if the Earth is flat.
Doesn't make sense. I don't know what you're saying.
You have to understand trigonometry is based on these angles that all add up to 180 and trigonometric functions, which are relationship and ratios of those sides of a right triangle. We're establishing a right triangle, 35,000 feet above, and 3 degrees drop, meaning there's a 90, and then what? 90, and then a 3, and then what would the last angle be? Anyone want to guess? 44. So you have a 44-degree angle, and a 3-degree angle, and the 90-degree angle.
No.
No?
No. Somebody disagrees.
What?
A 42. 42-degree angle, a 30-degree angle, and a 90-degree angle.
Still incorrect.
I thought a triangle was 180 degrees.
You're right. Sorry, I was trying to. I'm trying to do this picture and also talk at the same time. Yeah, it has to end up to 180 degrees. Correct. Triangle. So we have 90, and the other ones we have a 3-degree, and we have an 87-degree angle.
Right. The one at your location is the 87-degree angle.
Right. So we have 87-degree angle and that 3-degree angle and the 90. And if you do the basic trigon on that, you can understand the relationships between those sides. If one base, that one leg, is going to be 35,000 feet or 5 or 6 miles, then we know by the distance to the object, which is 200, that can't be 3 degrees. It can't be. It doesn't work.
So you got the
No, it's not
distance wrong.
refraction.
So you got the distance wrong in this hypothetical. With all these premises that you
Because I
set
just
up, how
took
do
off
you
from
go
an
to
airport and known. I
the?
know
Oh my God! Can I finish? Can I finish?
Well, you had a question.
Can I
Quick
finish?
question. We know how
Can I
we know
finish?
it's 200
Can I
miles away. We
finish
know
the
how far
sentence?
the cities are
You
from each
stop
other.
talking. You stop talking, and as soon as I try to respond, you interrupt.
Well, because you asked a question about the distance. We know the distance. You don't think we know
I
distances.
wasn't done though. I wasn't done.
Sure, go ahead.
So
Then.
with
Sorry.
all the premises that you set up, how do you support the concluding premise if the Earth was flat, therefore it should be at this distance? What's
Because of
the
trigonometry.
connection?
We know the distance of the object. We know it.
It's the connection.
We know we've driven it. We know the distance of the object. We know the height of the airplane. That's all known. And we know we have a 90-degree angle up below us. So that way we know we cannot have a 3-degree drop to that object in the distance and have it be a right triangle and have the base leg be 200 miles. It'd have to be 100 miles. That's twice, a factor of 2 off as an error. So it can't be flat. The base leg cannot be 200 miles. It has to be 100 miles if the Earth is flat.
Doesn't make sense. So the
I
Earth
know it
is
doesn't make
flat.
sense to you, Gregory, because you never took math.
So the Earth is flat.
No, Earth can't be flat.
It can't be flat.
It can't be flat because you cannot have a 3-degree drop for 100 miles.
You don't know what kind of assertion that is. Do you know what kind of assertion that is?
Yes, an educated one.
No.
Yeah.
That's a metaphysical assertion.
No, it's an educated one. You don't understand.
You made an assertion about can't. You made an assertion about what can or cannot happen. That's an issue of metaphysics, possibility.
No, it's not a metaphysical. Can is not mathematically possible.
Well, the other thing that's
understanding mathematics. It's understanding angles.
I get that you're calculating it. The other thing that's essential is that this 3 degrees. So you're up at some 30,000 foot in an airplane, and there's a light that's 200 miles away, and you're claiming that you have a device that's getting you an exact 3-degree measurement.
That's not hard to do, Gio. A HUD display is the easy way to do it. But
3-degree drop.
You can use a bottle of water. You could easily calculate 3 degrees.
HUD display thing.
Plus or minus a degree. You're so far off, Gio, that it's not even funny. You cannot be 1. You know what 1 degree would have to require? What kind of dip?
I'm not saying the measure is or is not correct. I'm just saying
it would be 3 degrees.
You're looking out of a heads-up display at 200 miles and claiming that you're getting an accuracy of 3 degrees. This is a bit absurd.
That's not hard to do.
An opinion. What? The devices are capable.
Let me put the drawing in the chat so you can see what we're talking about visually.
And there's a reason in celestial navigation that you don't sight stars down at the horizon. There's a reason for that because of refraction and because of the
non-sequitur. It has nothing to do with what we're saying.
In the environment that don't allow you to get an accurate read.
I want this 3-degree drop to be explained to me. Is the 3-degree drop the drop behind the Earth curve? Is that what it is?
No, it's just below horizontal reference. That's where you see the thing in the distance.
Xandic, post your little heads-up display thing. You've posted it probably 18 million times.
So with all those premises being set up,
heads-up display, and I'll post the kind of graphical depiction of what we're talking about here. I'll do both. Hold on.
I still don't see the connection between the premises and the concluding premise.
All right. So if you have an Earth with no curvature, we'll say it that way, and off in the distance there is something. Okay, I'll do it from the observer's point of view. You're looking down 3 degrees from a horizontal reference. Where your line of sight should intersect is on the level of the ground that you're overhead of, in the distance, should be only 100 miles away from that point. But we see that the object that is at 3 degrees down is 200 miles away, not 100 miles away.
How do you know the horizon should be 100 miles away?
We're not talking about the horizon. We're talking about an object we can directly observe.
Wait, what should be where?
If you're looking down at 3 degrees, your line of sight should intersect the surface of the Earth 100 miles away, not 200.
How did you come to that conclusion?
If the Earth had no curvature, that's what it would have to do. That follows from basic trigonometry.
Would you not need to know the length and width of the Earth first?
No, you just need to know your height above the ground.
But how do you know you should be seeing it? 200 miles away and not 100 miles away? If you don't know the size of the Earth.
Okay, if you've got a 90-degree angle from your vertical down to the ground, right? That's one angle, and you know that your height is a side length. And you know the angle at which you're looking down at, so you know that angle is 87 degrees. You have 2 angles and 1 side length. You can use that information to derive the other 2 sides and the other 1 angle. Do you follow?
It's in the chat. There's a nice drawing of this concept in the chat. So Gio, try to look. Gregory, look at that.
Okay, so let's say the ship. We call it a ship. The ship should be 100 miles away.
Look at the picture. Look at the picture I showed you.
I'm
There's a little
looking.
guy flying an airplane, right? The horizon's at 200, but we also see, I should put a little lighthouse there. That's the airport I see as well. That's at the horizon as well. Little airport on the coast, 200 miles away. I see it. I see the blinking light. It's very clear. The airport's open. I know it's 200 miles away as well. I look down. It's exactly 3 degrees to that particular airport. But we should only see 114 miles if we have a 3 degree drop from level. Yeah, if you're looking level and if you're in a triangle and you look down 3 degrees and you're above a 90, and we know the height above the ground. That's the only variable that you could be questioning. If we're 35,000 feet, we should see only 114 miles.
Yeah, but you need 2 90-degree angles. You need one 90 degree. Yeah, you need the 90 degree where the altitude of the plane is, and you also need another 90 degree for your baseline.
Yeah, and that's done very easily in an aviation sextant. Great application. I'm glad you gave me the segue to that, because we have the vertical, because it's a plumb bob, and we just do a 90-degree opposition to that. So it's very, very simple to find the level line. And by the way, the most expensive level in the world is one I've just posted from. These are HUD displays. These are very expensive level systems. Has a level line on it, as one of many functions, one of which is to show level. And the level line is a number of degrees marked on the HUD display of below level. And you can't have something that's 200 miles away be 3 degrees in dip. It can't work trigonometrically. It'd have to be 100 if it was flat. So
you're claiming that this heads-up display gets as accurate as a level as an auto level when you're bouncing around with air currents in an airplane. So how are you claiming? I mean, you're basically claiming that you're measuring the shape of the Earth with a heads-up display, which is
correct,
in my opinion, very
simple. These are very accurate vertical plane measuring devices. And because what it does, it takes vertical and does a 90-degree opposition to vertical and gives you a line that's on the head-up display. That's very accurate.
Right. The difference between maintaining level flight and descending is 1 degree. Those, it's even less than that. But the devices have to be accurate enough to be able to determine what direction the plane is pointing, obviously.
And whether it's gaining altitude or losing altitude. And there's actually how it's even pitched. This shows where the nose is, where it's pointed. That W is like where it is where it's pointed to. So in this one case, with the sun setting, the plane is pointing downward, still levels above the sun, and then still above the horizon. And then above it, it's pointed a little bit above level, yet the moon is still below level. And the horizon is far below level as well.
So
these are if you dispute these very accurate devices, you're kind of kidding yourself, because if they weren't accurate, it'd be dangerous.
I'm not necessarily disputing the purpose of a heads-up display and how they work. What I'm talking about is trying to use it at a 200-mile distance to measure a degree accurately, to then claim that you're measuring the entire surface of the Earth that way.
Well, you could see things in that one picture, for example, even the one where it's at night using infrared, which basically reduces the refractive effects too. We see kind of a grayed horizon and then more of a distinct green versus blackish border. We can see things that are flashing distance that we know are more than 190, 180 miles away. If we're seeing a 3 degree drop to those objects at 35,000 feet, we know that the surface cannot be curved. It has to be, it cannot be flat. It has to be curved. Because if it's flat, it'd be much closer than where where that spot is in the background. It'd be in the foreground, much further in the foreground.
I need to highlight something real quick. An angular measure does not become less accurate the farther away something is. Angles don't care about distance themselves.
Correct.
Well, this goes back to you guys were talking about how when we see too far, the horizon's changing, and actually it's a sphere, but it's allowing you to see further because it's refracting and allowing you to see around the corner. So with all that, and then even like that Skunk Bay footage, and it's showing all the horizon wavering, going up and down, but you're somehow sticking to that, but then also claiming that now, this is the double speak thing, now at this distance, all of a sudden it's accurate to a pin drop, to where now you're measuring 3 degrees and then claiming that the Earth is a globe. So in this scenario, there's no refraction, everything's perfect. But in all the other ones, when we see too far and it doesn't fit a globe, you guys have to then say that the horizon's moving all around and things are bending and warping and you're seeing around corners. So again, it's not consistent.
But how much is that horizon dipping up and down? by angle, not by linear distance, but by angle.
A lot.
How do you know? You don't have any measurements for that.
Yeah, the Skunk Bay footage. There's a lot of others that show how much the horizon moves.
What is the FOV of that particular camera?
Even those like ones that people call the black swan, those oil rigs, and how on different days it changes dramatically.
Right. What is the FOV of those shots? I can tell you it's definitely about a degree. So, I mean, we can just sidestep that whole thing. The amount that the horizon moves, that's actually less than a degree, that FOV. But the amount the horizon moves by angle, that amount is very small. Very, very small by an angular measure. You see vastly different effects on things that are very far off in the distance because those objects have a small angular size.
And the truth of the matter is, if the Earth was a globe at 200 miles, you wouldn't even be able to see that airport. It would be behind curvature.
Not at 35,000 feet.
So how is it? Oh, even at 35,000 feet, I'm sure. I mean, do the calculations on that even.
Well, how are you sure if you didn't do the calculations?
Well, how, I guess, Zanuck, how I'm looking at that first one. What, that little light, is that the airport?
What the fuck, Geo?
I was asking, Zanuck would have to tell us how tall the airport is, that light, if he knows.
Oh, it could be at the surface, but it's generally, 100 feet high.
All right, so the light's 100 feet tall. Okay, light's 100 feet high. How tall is what altitude do you claim this airplane is at?
35,000 feet.
Okay, and how far?
214 miles is the direct calculation. No, 210 miles, I think it is. I can go back and see the calculation, but generally 200 miles. Anything in that range still blows out the assertion that the Earth is flat, because you can't have a 3-degree angle drop to that airport, which is for an object that's 100 feet off the ground, and flashing green and white lights that you can see clearly at that altitude in the darkness. And as you approach it, if the angles all match up as well, it's not like it has some distortion at the edge where the horizon is. As you approach it, that angle still follows to the trigonometry of the spherical Earth, not the linear, not the a planar or a flat Earth. Like I said, it should be at 100 miles if you're looking 3 degrees down, and you don't.
How do you come to that conclusion that it should be 100 degrees away?
100 miles away? Because if you're 35,000 feet, I just told you, you do the angle 3 degrees, do the tangent of that. That's the opposite of adjacent, right?
Okay.
And you do that tangent of that. That gives you a ratio of those two sides, and it can't be 100 miles. It has to be it can't be 200 miles. It has to be 100 miles.
But how do you know?
If you thought the Earth was flat and you were going, how far is that airport? You would dip down. Oh, I got a 3-degree measurement. And your buddy goes, well, how far away? Well, if we use basic trigonometry, it's 100 miles away. And I don't have enough gas for 100 miles, pal. Well, we're just barely make it. No, you're going to run out of gas 100 miles. You're another 100 miles to go. You're going to be
okay. But how do you know it should be 100 miles away if you don't know how big the Earth is?
You don't need to know. I'm just telling you by angles, just by the streams.
Doesn't make any sense.
Angles. If it's flat,
why can't the airport just be 100 miles away?
Flat, Gregory, if the Earth is flat, it should be 100 miles away. You don't need to know anything else other than the angle and how high you are. Don't you get it?
How about it really just is 200 miles away? Like, what about that?
Yeah. But what would the explanation be?
It all depends on his 3-degree claim. His 3-degree claim would have you looking into the ground on a planar surface, is what he's saying.
No, the pictures I show you show 3 degrees. Those marks on there show 5 and 10 degree segments. You can see there's a 3-degree, that W is at a 3-degree angle. And it'd be accurate. Anything over 2 or 3 degrees is plenty accurate for this.
Isn't this little bullseye not pointing to the horizon?
Right, it's trying to descend
right now.
Is
the circle. The bullseye is the direction of travel. The W is the angle where the nose is pointed. The line is the level line.
Okay, what if you point the nose up?
I got that.
And line this up with the horizon.
Go to the picture. Go to the picture above it. The nose is pointed up. and the level line is still above the moon and the horizon, and the direction of travel is right at the line. That means we're not losing or gaining altitude.
How does it dictate the distance of the airport? It don't make sense. Because I'm looking down at this. I mean, the airport is 200 miles away. Period.
Conversation with me right now.
This don't make no damn sense.
You're just fighting me.
Like your perspective of where you're looking does not determine the distance of the object.
It's not perspective.
Hold on.
For Christ's sake.
Hold on a second. Gregory, if you have a triangle where you know two of the angles and one of the sides, can you agree that you can find out what the other two side lengths are and the other angle are?
The point is this: your perspective doesn't determine what the distance.
You don't even want to. You don't want to do it.
Because I'm looking down at this angle, therefore it should be at that distance. No,
what we're talking about here.
Yeah, because basic trigonometry. Yeah.
I'm not the only one here thinking this. Like, so because I'm looking at this angle, therefore the object on the Earth should be at this distance?
Yes, because trigonometry.
Your perspective doesn't dictate the distance of objects.
It can if you know two angles and one side length. It most definitely can tell you. Oh, well, that's your opinion. But unfortunately, we have trigonometry.
Because I'm looking at this angle, therefore the airport should be this distance away. That makes sense.
Yes, because we have trigonometry and we can use trigonometry.
It's religious apologetic fundamentalism.
No, it's trigonometry. It's not religious apology.
It's not trigonometry. You're not measuring. You're not measuring things. You're not measuring where you are and where you're above, and the measure in the length of the Earth and the distance of the object. You're saying because I'm looking at this object at this angle, and the angle of my perspective is somehow dictating the distance of the object that I'm looking at. That's fucking retarded.
Right. So here's where the earlier conversation comes in. We have trigonometry, and we can use two angles and a side.
Condescending to me. I really tried my best to understand. Condescending to me with nonsense.
Thank you for cutting in. So when we have two angles and a side length, we can determine the lengths of the other two sides. This is something that we can all agree on that trigonometry allows us to do. However, you have to presume trigonometry does not work specifically because we show you an observation where it doesn't match what trigonometry says should happen.
How'd you measure the length of your perspective?
The length of your perspective. You really said that,
Gregory.
Because that's what you're talking about.
No.
You're looking down at the object, and that line between your eyesight
we can
to
see
the
objects
object.
that are in the distance that are right at the horizon, maybe right below, maybe right even closer to the horizon. Let's say it's not 210 miles like it should be, it's 200 miles or 190 miles. Gregory, at a 3-degree drop, between below level, and I gave a good picture of at 45,000 feet. I can't really read. I think it's 35.
This is confusion.
Anyway, stop talking. I'm trying to explain to you.
This is confusion.
That even we see things that are not even as far as the horizon, we know they're not. We know they're 200 miles an hour or 190 miles away. They're not 100 miles away. They're not 100 miles away. They need to be 100 miles before you can have the Earth or the shape of the surface be flat. That's what we're trying to explain to you and try to help you understand.
How did you measure the length of your perspective?
It's not a distance of the object, you mean? Dude, we have radar. We have radar
between you and your eyes.
So when you're an aviator, you have
between you and your eyes.
The object and
oh
your
my
eyes.
God! You asked the question I'm trying to answer, and you just talk over me.
You're probably not answering the question at all right now.
I am. We know how far. You don't think when I take off from SFO that I don't know how far Reading is?
How far from what?
From me.
From you.
From your eyes. So how did you measure the length between
God, from your eyes? Of course, from your
eyes?
goddamn eyes. Yes.
So how did you measure the length between?
Because I'm over the fucking Golden Gate Bridge, and I look out there 200 miles, and I see an airport that's flashing green and white. It's 200 miles away.
Okay, so it's 200 miles away.
And I see it.
End of sentence.
And
so when you're on a flat plane and you're 35,000 feet up in the air and you're looking at an object 200 miles away, it's 200 miles away.
Right, and you can't look down 3 degrees to see it on a flat surface. That's the point we're trying to make.
But you can.
Well, yeah, that's the thing.
You're 35,000 feet above the surface of the Earth, which is flat, and the object is 200 miles away. You look down at it, and you can see it.
Down 3 degrees.
Right, but the problem is that you're trying to take the observation that it is 3 degrees down and it is 200 miles away and say, well, the Earth must be flat, so that's how it works on a flat Earth. No, that's not how we.
You're making this implication argument to try to give another reductio ad absurdum argument, but you can go up 30,000 feet, look at the object 200 miles away, and you can see it. End of story.
And you presume the Earth is flat, which doesn't agree with the observation.
And you presume the Earth is a globe.
Well, the observations seem to match it every single time we take
The observations is that you see an object 200 miles away, 30,000 feet up in the air.
Yep, at 3 degrees down, which does
Right.
not work.
So none of those premises necessitate the conclusion that it would be 100 miles away if you want a flat Earth.
Yes, because a flat Earth would,
no.
Your line of sight would intersect the surface of the Earth at 100 miles away. Yes.
It's non sequitur conclusion.
Simple geometry.
It's not a non sequitur conclusion. Trigonometry itself is not a non sequitur. You have to try and justify your
don't
position.
support the conclusion.
You have to justify your position by calling trigonometry a non sequitur.
The premises are simply a non sequitur conclusion. You can be 30,000 feet up in the air, look at the object 200 miles away, and boom, there you go.
But you can't look
at a 3 degree. It's 3 degrees below a horizontal reference, which doesn't make sense.
The horizon is where it is, and the airport is 200 miles away. It's not where the horizon is. It's closer to you than the horizon is. You look down at the airport 200 miles away. There you go.
Right, but it's not about the horizon, is it? We see the object.
So what's your point?
Is 200 miles away, and it's at an angle which doesn't make sense for a flat surface.
It's non sequitur. So I'm looking 3 degrees down.
Trigonometry is not a non sequitur.
From the horizon. I'm looking 3 degrees down from the horizon, correct? My eyesight is 3 degrees below
3 degrees
horizon.
down from a local horizontal reference.
So
there's a distinction there.
That doesn't. Important. So I'm looking 3 degrees down below horizon. Therefore, what?
No, you're not looking 3 degrees down below the horizon. You are looking 3 degrees down below a local horizontal reference.
Okay, so therefore what?
It's not in a place where it should be if the Earth has no curvature.
How do you know it shouldn't be there?
Because trigonometry. We've been through this.
That doesn't mean anything. Elaborate.
It does. Because
it doesn't.
If the Earth had no curvature, a 3 degree down from horizontal reference angle and something that's in the distance, your line of sight should intersect the surface of the Earth at about 100 miles away, not 200 miles away.
Yeah, I mean, in a nutshell, it's almost like they're claiming that these heads-up displays are like shooting off the sphere into outer space. Essentially, the 3 degree sort of drop, they're claiming that that's the actual drop of the curvature.
Right. That's what I said in the first place several minutes ago. I said, is the 3 degree drop the curvature of the Earth? You said no.
Right, the 3 degree drop is where the object is located in your line of sight.
Right, but it's under what you think is the horizontal. Therefore, that is the 3 degree curvature of the Earth.
No, it's where we see it is 3 degrees down from a local horizontal reference. Where
so it has nothing to do with the distance of the object on the surface of the Earth.
Surface with no curvature.
So it has nothing to do with the distance of the object on the surface of the Earth.
It does. The distance definitely matters.
You looking 3 degrees down before the local horizontal reference doesn't make the object further or closer. It's non sequitur.
Right. The distance of the object observed at the angle we observe it at is very. Thank you for interrupting yet again. The distance at which we observe the. Thank you for interrupting one more time.
I'm starting to think
distance at which
you sound exactly like Biodual, but go ahead.
I don't. The
Especially
distance
in this
at which
argument,
the
you're
object.
like super Biodual right now.
Okay. The distance at which the object is observed at the angle it is observed at. Both of those two things together are part of the argument. You can't just look
what
at
about
one
the Earth? You're missing the Earth. You talk about trigonometry.
Isolation.
What about the
You
Earth?
need to have both of them together.
Okay, what about the Earth? You're missing the bottom of the triangle.
Right. So the object is clearly on the surface of the Earth.
So what's the distance? You're saying it's 200 miles away from your eyes. What about the distance between the airport and the point on the ground below you, 30,000 feet in the air?
Yeah, on a sphere, that should be curved, and now you don't have any trigonometry because you don't have angles and you don't have a triangle.
Like you don't have the bottom of the triangle.
But if you assume, for instance, that the Earth has no curvature, then you're free to use that triangle. However, when you do use that triangle, you find that the thing that you're looking at is not where it should be.
How do you know that if you don't know the bottom of the triangle? What's the length of that?
Trigonometry.
Right, we're getting that from trigonometry. You are at an altitude. You have an angle to the object.
Okay, so it's 200 miles away.
You have an angle to the surface below you. That's the direction of plumb. You have two angles. You have one side length. On any triangle on a plane, you can figure out what the other two side lengths are That's trigonometry.
Okay,
You're
so it's
allowed to
200
do
miles
that.
away. End of conclusion. End of matter.
Right. It's not just that it's 200 miles away, but it's also 200 miles away, and we see it at 3 degrees below a horizontal reference.
Okay, so
it's not where it's supposed to be if we assume the Earth has no curvature.
Where's it supposed to be?
It's supposed to be higher up, less of a drop from horizontal.
What the hell is higher up?
Less of a drop from horizontal. I specified that.
It doesn't make sense. Where should the airport be?
A shallower angle. It should be a shallower angle.
You think your answers make sense because you just don't want to make a complete sentence.
No,
Say a complete sentence. Where should the airport be? It's 200 miles away. Where should it be?
I can see the profile of this whole setup in my head. I mean, I don't have to draw it on paper. I assume that you could do the same.
Where should it be? It's 200 miles away. Where should it be?
All right. So since I have a calculator, I'm going to go ahead and figure that out for you, I guess, since you don't seem to own a calculator.
Angle below the horizontal reference frame. Height of the person below above the surface of the Earth. It's 200 miles away. You say it shouldn't be there. It should be where?
Looks like 6.66 miles. Like roughly 6 miles high.
What?
Take 6 miles divided by 200.
I'm doing it in feet because I'm crazy.
Okay, so we get that's 0.03. We take inverse tangent of that. It should be 1.7 degrees.
I got 1.9.
I'm being told it's 200 miles away, but it shouldn't be there. Where should it be?
1.9 degrees.
So now we're at a difference of 1.9 and 3. So now you're claiming that a 1.1 degree on a shaky, shifty heads-up display at 200 miles
it's not shaky and shifty. The angles are easy
Earth's the globe. Zanuck, this is just even if
That's
I
why
was
they have
fucking retarded.
The angles are very easy. The angles are very easy to figure out or use a sextant for, and this is what was basically a aviation sextant. That angle is even if the reason we don't have an accurate. I put 1.7 and he said 1.9 is I rounded the mileage to 6 miles rather than 6.6. So I do 6.6 miles.
You're not answering the question.
Hold on, divided by 200 miles, and I get 0.033, and I do inverse tangent, and that gives me the 1.9.
Thereabouts.
Okay, that's not a location of the fucking airport. That's the angle of your perspective.
No,
that's the angle it should be.
It's where it should be.
You asked me. Hold on.
1.9.
That's not a goddamn location. 1.9 is not a location. You're telling me it should be. So you're telling me it is 200 miles away. It should be somewhere else. Where should it be?
Gregory, you asked me after I said it's at 3 degrees. So where should it be if it's 200 miles away for an Earth with no curvature? You asked that. Now I answer 1.9 degrees drop from.
That's not a location.
It is a location.
It is. It's a location relative to your local horizontal reference.
So where's the location relative to this
in the original? I understand that you want to just keep ignoring me, just to try and get a rise out of me, instead of actually listening to the conversation. All right, so now let's try this one more time. 3 degrees in the original proposition is below. Okay, 3 degrees below horizontal reference is the original observation. 1.9 degrees is where it would have to be if we assume the Earth had no curvature. So instead
That's
of 3
not a
degrees,
location. You're talking about your angular perspective.
Okay.
3 degrees to 1.9 degrees. Those are the difference between the angles of your perspective in your explanation. You haven't told me the distance where it should be, supposedly. Not once.
Okay. Let's go over it again. We have something in the distance that's 200 miles away. We know that that's 200 miles away. Now, we look at it, and it's 3 degrees below a horizontal reference. Now, your question was, where should it be if we assume a flat Earth? Well, the answer is it should be 1.9 degrees below a horizontal reference, not 3 degrees. We observe it somewhere where it shouldn't be.
You're an idiot. Just point your eyes down or up.
Okay, thank you. That was really constructive.
It's ridiculous.
Really good response.
So it shouldn't be at 3 degrees. It should be at 1.9 degrees. But what's the distance between you and the object?
200 miles.
So what distance should it be?
What's
if you were looking down at 3 degrees, that distance should be 100 miles.
That's
You can keep asking the questions over and over again and get the same answers and still throw your hands up like a child. That's good. Very constructive.
so. Finally, you told me it should be 100 miles away.
I said that from the beginning. Zanuck
Okay,
said it
so
from the beginning.
we should be seeing the airport 100 miles away at a 1.9 degree angle below the horizontal reference.
No, you combined two different things together again.
So
I'm
what the
not
fuck are
actually
you talking
surprised.
about then?
On a flat surface at 3 degrees, it should be 100 miles away.
And if it was a flat surface and it was 200 miles away, it should be at 1.9 degrees, not 3 degrees.
What is making the difference?
See,
What's making the
not
difference?
that
That's a
hard.
good question.
The curve
What is
surface.
making it not be where it's supposed to be?
What? Tell it.
Well, I don't know. The only thing that I
surface.
have at my disposal is either refraction or curvature. And it turns out that in the atmosphere at that altitude, the highest density of the atmosphere is below, not above, which causes light to bend downward, which makes distant objects appear higher than their actual position, which makes it.
So then you haven't
even
measured
worse
the
for
actual
you.
distance of the object then. If you talk about
Yeah, we do know
refraction.
the actual distance to the object. It's 200 miles.
If the difference is caused by refraction, you haven't measured the actual location of the actual distance between you and the object. It isn't really where it appears to be.
Yes, you have actually measured the distance to you between
You
you and the
haven't.
object. Because as Zanuck has pointed out in this very same conversation,
You
he
haven't.
observed the Golden Gate Bridge, and then he also observed the airport. So he knows where he is.
If
and he
it
knows
is where
what
it
the
is, where you see it
object
is,
he's
and it's not
looking at. He
refracted.
knows
It's
the
refracted,
distance
it isn't
between
where you
those
see it
two.
is. If it's
I'll try
refracted,
again.
then it isn't where it appears
It
to
seems you
be.
were talking through the middle of that. He knows where he is. He knows
If
what
it's
he's looking
refracted,
at.
it isn't where it appears to be. You can ignore everything I'm saying, so you can keep condescending to me. But if it's refracted, it isn't where it appears to be.
Okay, it's
So you
still
haven't
200
actually
miles away
measured
from his
its
location.
actual distance.
Yeah, actually, because the thing that he's looking at is a recognizable landmark. The thing that he's over top of is also a recognizable landmark. So unless you
Just
want to
keep
call the
whistling past what
distance
I'm just
between,
saying.
so if you're calling into question the distance between those two known landmarks, I will call you out for it.
Okay, so you're just gonna whistle past what I said. You know, I actually want to have a conversation.
Oh, I did definitely have a conversation. We do know the distance to the object that he's looking at because
If
we have
the
two
difference
landmarks
is
to go
caused by
by.
refraction,
and we know the distance
object is not
between
where it
those
appears
two
to be.
objects, then we know the distance to the thing that we're looking at.
If it is caused by refraction, it isn't where it appears to be.
Then we still know the distance.
You don't know the distance.
That's what the
That's
argument should be.
your
Gregory,
opinion.
is refraction, because they use refraction when it comes to observations on land through a similar type density of medium. So when you go up higher in elevation and you're looking down and viewing towards a much larger disparity in the density of the medium, you're certainly going to have refraction. So refraction perfectly explains Zanuck's little.
No. Refraction would, if you introduce refraction into what they're saying and the way we know refraction operates, it would make it look worse for flat Earth.
So
if it's
explain to me how refraction works and the bending. So we're talking about densities.
Yep.
Mm-hmm.
And
light
the coefficient of refractive index.
Light bends towards the denser medium, correct?
Mm-hmm.
Yes.
So if we're looking out over something and we expect the angle to be 1.9 degrees down from level, but it's actually further down from level, that means light would be bending further down towards the denser medium. So how is this?
That's actually backwards. Well, that's actually backwards. If the light was bending upward, the distant objects would appear downward. If the light was bending downward, the distant objects would appear higher.
No, that's not how that works.
That is.
So,
I can show you verification
exactly
of that.
how it works.
So you're telling me refraction bends downward when we're viewing something like the black swan, but then refraction bends upward when we're talking about this example that Zanuck has provided.
No, and nobody
Actually,
nobody said that.
Yeah, in both cases, the black swan is an example of looming, which is caused by light bending downward, causing the distant objects to appear higher. In the case of a high altitude observation, that gradient is in a stable configuration such that the highest density is always below, and that means the light must bend downward and distant objects appear higher.
Okay, so when I'm viewing something from above my swimming pool, is the refraction going to show me the fish further away from me or closer to me?
Neither. It will move it up and down.
So will it move the fish up or down?
The fish will appear higher because the light is taking a downward bend.
That's where you got to shoot below the fish to hit it.
Actually, yeah, that's a perfect example, Howard. Spearfishers and bowfishers know that they have to aim low because the fish is higher than where it actually is. It appears higher than where it actually is. I hope I said it that way. In fact, let me get a diagram. That might help.
I thought you had to shoot slightly higher. Maybe I'm incorrect in that assessment. I'm working, so I can't really look.
Yeah, but even using that analysis, doesn't that fit that the 3 degrees versus the 1.9 that's appearing lower and it's actually higher? Like it fits that general analysis that would.
Well, if we're seeing the light, the airport at 3 degrees,
exactly,
and it's appearing higher, then its actual location is lower, which would actually be more detrimental to the flat Earth.
No, its actual location is higher than it's appearing.
Geo's correct. So if we were trying to shoot that airport, right, and it's being refracted, we'd want to shoot higher because it should be at 1.9 degrees, but we're seeing it at 3 degrees below.
Right.
No.
Perfect.
Okay, that's your
good call, Geo. Exactly.
All right.
Right, but you're making an assumption based on the surface of the Earth. Here, let me show you this diagram that I just posted. Think about that fish example. Right, but I'm showing you this fish example here, just like you called out to me just a moment ago. That fish, the fish is appearing higher, the light is bending downward. And ordinarily that
you haven't substantiated that concluding premise that the airport should be 100 miles away.
So you have to shoot lower, not
because that's
higher.
trigonometry.
You guys said earlier that you had to shoot higher, but you actually have to shoot lower.
No, I said lower. You have to shoot
you aim
under the
low.
fish.
I said you aim low too. Who said you aim high?
So supposedly, curvature or refraction is causing the difference in the next example.
I've shot a few
Which one
fish
is it?
in my day.
Well,
Okay,
what if we?
As I explained just a moment ago, Gregory, the light that passes through a density gradient where the highest density is below bends downward, causes distant objects to appear higher. So
Okay,
no,
so
it does not help
isn't where it
explain
appears
Xander.
to be located.
And it should be located even, it appears higher than where it actually is. So when we observe it at 3 degrees, it's actually in a slightly lower angular position.
Non sequitur. That premise does not support your concluding premise. You're telling me that it should be 100 miles away. I asked you what is making the difference. You said curvature or refraction. If it's refraction, the object isn't where it appears to be.
Yeah, and it appears to be higher
So
than
your
where it
point is
actually
moot.
is. Right, that's your opinion.
That's the point. Your point is moot.
If the object,
You're talking about where it should be. The difference is caused by refraction. So where it is just an illusion.
If the object is in
Where it
a
appears to
higher
be is just an
position,
illusion in your example.
Gregory, if the object is in a higher position than where it actually is geometrically, we're looking at an angle that is less than it should be.
Excellent. So the object isn't where it appears to be. Your point is moot.
Then the object is actually even further from where it should be, assuming no curvature.
And the thing is, there's no refraction.
Why are you looking through this vast difference of just noise to try and make a measurement? This is so ridiculous. You're like, oh, let's look super far away, and then the point where it gets so hazy, we don't really know what's going on. That's what we're going to use our conclusions. That's ridiculous.
Thank you.
Yeah, that's what I said originally in this. It's a heads-up display. They're claiming that they're getting as accurate as a horizontal as an auto level does in a bouncy airplane with a heads-up display that Zanuck or whoever took this shot with their camera trying to take a photo of a heads-up display. They're claiming they're measuring the shape of the Earth over 200 miles. It's absurd.
You're assuming it's bouncy at 30,000 feet.
As I mentioned in this very same conversation, the angular measure does not lose accuracy over distance. If we can clearly see where the object is in our vertical, if we can clearly see where the object is vertically, if we can clearly see where the object is vertically, then we can make a determination.
A determination is not a measurement, okay? And this is your problem. You're not measuring.
It is
You're
a measurement.
determining based on beliefs.
Oh,
whatever you believe refraction to be is what is causing you to not be able to make a measurement. So whenever you go to make a measurement, you can't because refraction. So stop saying you're making a measurement. Stop going off into the distance to the point where you can't even see anything and you see a little boat and going, there, we did it. We measured the ball. We
shouldn't even be talking about refraction in this observation because it's at 30,000 feet.
Well, refraction.
Okay, so the two options that were supposed to me was that refraction is causing the difference or curvature is causing the difference.
Yeah,
it's at 200 miles away. They tell me that it should be 100 miles away. Refraction distorts the perspective, so it isn't where it appears to be. So how is curvature making the difference?
If you introduce refraction into this observation, it will look worse for the flat Earth.
Right.
No, it's
not worse for the flat Earth. It's worse for your claim. It's worse for your claim that it should be 100 miles away.
No, it's not.
The difference, it looks 100 miles away because of refraction,
it's not.
so it isn't really where it appears to be located. That undermines your
It would
point.
actually be further away. It would be further away.
It isn't where it appears to be. It undermines your point.
No, I would like to point out that if it's called into question what I believe refraction to do to the nature of light, what is interesting to note is that the only way that I can get long distance observations done is if I know what's going on in the atmosphere. Okay, so you can claim.
Keep whistling past my point. Keep talking about the nature of refraction. It isn't where it appears to be if it's caused by refraction in your example. Shut up about refraction.
Okay, I can continue to talk about refraction regardless of your opinion. In our atmosphere, we have a stable gradient at that altitude,
moot.
which causes the distant object to appear higher, and it's too low already. So it's even lower than that in reality.
What does that mean? Too low? What do you mean?
It doesn't mean anything. His point is moot.
It's at a 3-degree drop below horizontal.
And why is that too low? But what is that too low?
It should be, because where it should be, assuming an Earth with no curvature, is 1.9 degrees.
What do you mean where it should be? You're saying where something should be. What
where it should be if you stop interrupting.
How do you know where it should be?
All right, so I'm about to explain where it should be if you stop interrupting. It should be for something 200 miles away from an altitude of 35,000 feet. It should be 1.9 degrees below a horizontal reference.
So refraction isn't making that difference.
So hold on. Why do you think that's something? First, is reality what should be, or is reality what is? Let's just go to that real quick.
Well, if we go with that line of argumentation, then reality should not be a flat Earth since it didn't agree with what it should be.
Okay, so reality is what is, right? Not what should be.
Okay. Well, it's not where it should be.
But that's not reality. So you're bringing forth from not reality your imaginatory argument of where something should be to justify your beliefs. That's crazy.
Welcome to the globe. Thank you.
If that's how you get to the globe, all right, man.
His point is idiotic. He appeals to refraction to substantiate the conclusion that the airport should be 100 miles away. If it's because of refraction, the airport is not where it appears to be. Your point is moot.
Okay, I didn't ever say that the airport should be 100 miles away. Not that that's where it is or what we should. Just hold on. Write the hand.
When you can't use imagination,
write the hand. When you said, hold on, I like that both of you wanted to get in before I finished. Write the hand. If you want to say we shouldn't use what should be, we shouldn't use an assumption that the Earth is flat then, because what I did was I assumed that the Earth had no curvature in order to come to a measurement that it should be for a distance.
Your argument is moot every time you appeal to refraction. The object is not where it appears to be. Your argument is moot. Stop appealing to refraction. Your argument is moot.
Right, you can just claim that refraction makes things unknowable. However, I work in a field
You tell me that's where it should be, as though that's where it really is. But if it really is appearing to be there because of refraction, it isn't really there.
Okay,
so it's not because of refraction. If we're looking at refraction, it isn't where it really is. It isn't where it really. It isn't where it appears to be. It's somewhere else.
Okay, I'll start over since you interrupted. If you go into the line of argumentation that refraction makes things unknowable, or that refraction itself makes a position unknowable, I will remind you that the people that make these observations do so using cameras. Optics is not some unknowable thing. We know how optics works.
No, you see, right? We all can see. Nobody can see how we see. So that's such a ridiculous statement to say we know how optics works. The only information you have for optics is your vision. Now, do you know how your vision works?
No, that's not true.
No. You don't get to see how vision works.
We don't make glasses.
He's telling me that the airport should be 100 miles away from me, the observer. And he's saying what's causing that is refraction. So then the appearance that it's 100 miles away is just a refraction. It isn't really located 100 miles away. Your point is moot.
Gregory, thank you for changing my position into something that it wasn't. You did it again.
Double speaking sophist.
Right, but nowhere did I say that it is 100 miles away because of refraction. That was never my argument.
That's what I asked you. What is causing the difference? I asked you, what is causing the difference? You said curvature over refraction.
Yeah, thanks.
I asked you earlier, what is causing the difference then? You said curvature over refraction. If you go with refraction, then it isn't where it appears to be. Your point is moot.
So here in reality, if we establish a density gradient where the highest density is below, we observe that the light through that density gradient bends downward and distant objects through it appear higher than their actual
incantation is
position.
Going to work.
I'll go ahead and finish what I'm saying. I'll go ahead and finish. I'll go ahead and finish.
This assertion will be justified if I repeat it just 100 more times.
What I'm saying. I'll go ahead and finish what I'm saying. Here in reality, when we have a density gradient where the highest density is below, light bends downward through it, and we observe objects through it to appear higher than their actual location. This is effectively the chanting tactic. I'll go ahead and keep going. Let's just keep it going. All right.
Yeah, go ahead.
So we observe those distant objects appear higher through such a density gradient where the highest density is below. Now, when we measure the atmosphere, the density is arranged that way, such that the highest density is below. When we looked at that airport, we looked through that kind of gradient. It's appearing to us in a higher position than where it actually is. Since it's already too low to fit the prediction for a flat Earth, it's even lower than that, which makes it even worse.
And you're saying that the difference is caused by refraction or curvature. You say refraction. If refraction, then it isn't where it appears to be. It isn't located where it appears to be located. Your point is moot.
All right.
So now you have to find where it actually is.
So you said my position is that its location from being too low is based on refraction. No, that's not my position.
That's what you told me.
Refraction and curvature collectively cause objects in the distance to appear different vertically than where we expect them to be. Collectively, yes. Don't say nah.
Wouldn't they cancel each other out?
Well, the thing that is most important to take away from this is that one of those two effects, refraction, causes the object to appear higher than where it is. The other effect that I mentioned, curvature, causes it to appear lower.
On a flat Earth.
Why?
The curvature on the flat Earth is causing it to appear. It should be 100 miles away.
The curvature is causing the object that is verifiably 200 miles. The object that is verifiably 200 miles away, we can observe that it is already at an angle that is too low to make sense for a flat Earth.
So the airport should be 100 miles away on a flat Earth because of curvature.
If you try to rearrange my argument for me, you can turn it into something that is absurd because that's not what I said.
Do you expect them to relay everything you said, though? He's trying to sum it up.
Yeah, he's trying to sum it up by changing the argument.
Well, I kind of
his argument is it's too low. Now, when he says it's too low or it's any of that, that's just his personal beliefs of where something should be on another personal belief. He goes, if I believe the Earth was flat and I believe this thing was here, it should be over there. It's not over there. So clearly what I believe is correct. It's you have to break down what they're saying. It's just so ridiculous.
I actually agree with him. I actually agree with. Hold on, Doofus. You do say a lot of things like you do say things like should a lot, and you keep asserting that. Remember, these debates are with the models that are in conflict, and you keep asserting that your position is the correct. You keep saying that and saying that.
That's what happens in a debate.
All I'm saying is the whole purpose of don't pretend that these debates are not talking about the shape of the Earth. So when you have an opinion and you say should, and if it's don't matter, we've already calculated. You've asserting that everything that you think is true, which is what we are in contention of, which is probably why we don't agree.
Well,
so
the thing is, if we use trigonometry,
that it should be 100 miles away on a flat Earth because of curvature.
Thanks.
That's not what he said, Gregory.
That's what I asked him. I asked him what is causing it to be 100 miles away rather than 200 miles away on a flat Earth.
It's not. It's not 100
miles away. He tells me. I said, what's causing the difference? He says curvature.
Yeah, that's why I said this earlier.
Was very clear.
They're trying to claim that the reason it's 3 degrees is because what they're claiming is the horizontal HUD display is actually essentially shooting out into space, out of the sphere into space, and that the curvature is what causes it to be 3 degrees, and then they're claiming that it should be 1.9 if the Earth was a planar surface. So they're claiming there's that 1.1 degree difference of this thing shooting off into space and so they're claiming that little bit of position is what this argument is.
All right, I wanted to respond to Matrix real quick though. What I based my conclusion of that it's too low, that it should be at 1.9 degrees, is trigonometry. If I know 2 angles and 1 side length of a triangle, then I should be able to determine the side lengths, the other 2 that I don't know. Do you agree?
Yeah, refraction kills trigonometry. So that's done.
No, it doesn't.
Honestly, you just claimed to know something was 200 miles away before you measured it.
Refraction and curvature kill trigonometry.
Well, this is why you don't sight stars down at the horizon for celestial navigation, because of refraction. And they're claiming...
Yeah, we're not looking at a star.
They're now doing it... Well, you're looking at an airport, which is a light on the horizon.
Yeah, 200 miles away, not as far as you think stars are, whatever that may be, because you don't want to give a distance.
Yeah, my point is that you don't sight stars down anywhere of 15 degrees or lower because of refraction. And you guys are then using an observation like this to claim this level of a 1 degree difference.
Actually, we can sight stars below 15 degrees. We're allowed to, because there's a table that allows us to correct for that. The amount of correction is less than 37 arc minutes typically.
So once again, we're on a flat Earth. The airport is 200 miles away with 30,000 feet in the air, 3 degrees below the horizontal reference frame. And then I'm being told that it should be 100 miles away on a flat Earth. Why do you say that?
Because trigonometry.
Oh, damn, that's like an hour ago.
It's a meaningless content.
That was answered. That was answered an hour ago.
That image I just reposted of Xanax kind of shows that. They're claiming that 3 degrees. You have a 90 from the airplane down. They're claiming the 87 because they're getting the 3 degrees. Therefore, that last angle would have you looking into the ground at 100 miles is what they're claiming.
That's where your line of sight would intersect, yeah.
Hmm.
So this whole argument just presupposes that you live on a ball.
No, presupposes a flat Earth. That's what the example in the illustration is.
No, you're saying it should be 100 miles away
for a flat Earth,
but it isn't. Therefore, it's a ball.
That's really not a preposition that has to be in it.
Right, because what we presupposed was that the Earth had no curvature. That was our presupposition.
Right, and then you do the trigonometry on the flat Earth.
It turns out that our observation didn't match our presupposition.
Right, and you did the trigonometry on the flat Earth, and the airport is located 200 miles away, so there's no justification to say it should be 100 miles away, period.
Yeah, the line of sight should be 100 miles away. Trigonometry.
It shouldn't.
Yeah.
There's no justification for that assertion, none. And your justification is
you don't have any justification
trigonometry. That's your justification. Invoke the word trigonometry, therefore the assertion it should be 100 miles away is justified. No, it's not.
Yeah, you never did anything in reality.
Justification. So what is your justification that it should not be 100 miles away?
Because you did the trigonometry on the flat Earth and you calculated the distance and it was 200 miles. Boom.
We're not saying it should be anything.
Why don't you go ahead and do that math for me, Gregory? How about you go ahead and back up that assertion?
This is your example.
No one here said it should be anywhere, right? We're not the ones saying, "Oh, that thing that we see, where we
did
see
see
it,
that. You said that.
Else." Hold on, Gregory. Try not to interrupt him, bro.
Bro, no, it's such
I was
a ridiculous.
co-signing him. Go ahead, Ghost.
Just for me, I think it's a ridiculous argument to look at something super far away and go, you know what? It should be over there. It's not over there. It's where it is. Therefore, like to make any type of conclusion from what isn't happening is like it's like you're making a conclusion based on not reality.
What is the justification to say it should be 100 miles away? You did the trigonometry on a flat Earth. You said now you got the conclusion it's 200 miles away. That's it. So to then continue to say it should be 100 miles away is unjustified. To invoke the word trigonometry and answer to that question is nonsense.
So if you constrain your observations to your backyard, you will never know anything.
What the hell was that?
Bro, but
he said you can't look at something 200 miles away. He said you can't look at something 200 miles away.
That's not what I said. I said you're not even using what's 200 miles away. That's the point I made that you missed. You're not using what's 200 miles away. What you're using is what you believe should be somewhere else.
No, according to the DME, it was 200 miles away. It's called distance measuring equipment that's on airplanes. You can select an airport off in your distance, select it, and it'll tell you exactly how far away you are from it.
Okay, but
just give up. Like, just let go. You have no justification for the assertion it should be 100 miles away on the flat Earth when you got the conclusion 200 miles away doing the trigonometry on a flat Earth in your example.
But that's not what the trigonometry says.
The distance is not a shape. It's just a distance.
Yep, and it's in a place where we shouldn't see it.
Well, right there, what do you think? What do you think of long distance observations that show a planar, like a lack of curvature and a planar? Like, do you stand by those as being valid or partially valid, or would you also say that those are not valuable or not useful?
I mean, it's a picture, right? It shows what it shows. Now, if you're going to say that, like, oh well, it only looks flat because, that's what I would have contention with. If you're going to say it looks exactly like it is, I have no problems. It's once you leave the reality of what we have and say, well, it should look like this. That's where I'm like, well, what do I do with that? I can't argue a should.
Well, I guess what I was asking, like, if you were walking down the street and you struck up a conversation with a random person, you're talking about the shape of the Earth. I mean, would you bring up long distance observations? We see too far. There's no curvature. Like, would you bring those up as being an indication that the Earth isn't a sphere? I'm saying for yourself, or would you not even go there?
Nah, I don't like, because of the whole refraction thing you get, because you like, I like to stay very close to where I am, like the orientation of people, like how we're all upright on top of an object. Like, to me, that these are more like, when you start getting far away, you can invoke things like refraction and bending of light that can help or hurt you.
But Gio, with your question, when you have these high altitude photos and you don't see curvature 120,000 feet or higher, right? That's just looking all around and seeing that you don't see curvature of the Earth, as opposed to having a long distance photo trying to ascertain the location of a particular object on the face of the Earth. That's the difference.
Well, we also never see curvature. It's always just we only see like half of an object. That's what they'll say curvature is, right? Like, to see the curved ground would be a hill. So all of their quote unquote curvature is something behind a flat horizon. That's another pretty crucial point for me.
And their example, the airport is 200 miles away on a flat Earth. You're 30,000 feet in the air, 3 degrees below the horizontal reference frame. There's your conclusion. 200 miles away. Then they continue talking about it should be 100 miles away. What is the justification for that? Trigonometry. That is not an answer.
It is. What is your justification that it should not be there?
What about trigonometry justifies that claim? You already did the trigonometry in your example on a flat Earth, and it's 200 miles away.
Okay, that's not what the trigonometry says. Thanks. If we do if we have a triangle and we know one side length and we know 2 angles of that triangle, we can determine the side lengths of the other 2 sides that we don't know.
That's what the trigonometry says. That's what you did in your example. Thanks.
Right. No, at 3 degrees down, it shouldn't be 200 miles away.
Yeah,
that's not what trigonometry.
What justifies that conclusion?
Because trigonometry.
What are
Do
the
the trigonometry.
What are the lines of the triangle that you just used to do this measurement? Are these invisible imaginary lines you're just proposing?
Your altitude is 35,000 feet. Okay.
That's not a line. That's a position. A position at a height is not a line.
I mean, they are essentially drawing imaginary lines.
Hold on, Gio. We have to come to an agreement. Is height a line? Yes or no?
No.
Oh, Jesus Christ, dude.
A line is a line. Height is not a line.
Uh-huh.
Well, the line between the height of the object and the surface of the earth.
Yeah, I mean, they're using
obviously it's a line.
Like if you were to drop a fishing line from an airplane or whatever, like a line directly down to the ground, and then they're using a line across the earth, and then
the
site to make the three angles, the three lines.
You can't have it yet.
I was going to say that this whole argument is kind of a recycle of. I just posted that thing when Ruhif and Ranty, and he was going to go up the hill and do the auto level thing, because this is the one that I just posted it that Ruhif had. He was claiming that this is his prediction that the auto level was going to be looking off into space, and then that's why the Earth is curved or whatever. So this one that Xanax has is kind of like just a recycle of that, or maybe this was a recycle of Xanax. I don't know, but whatever this Global Earth Society meetings are, where they're just coming up with these things, and it's like it's like the same version of that. It's like an incredibly long distance with a tool that's not designed to measure that distance whatsoever, removing refraction and then making assumptions about the conclusion to then claim that that's somehow indicating the shape of the Earth.
But the tool creates a horizontal reference, and the ground always drops below that.
So what's causing the difference? The airport's 100 miles away. You're looking 1.9 degrees below the horizontal reference frame. What's your height?
You got the numbers wrong again. I'm not surprised. The airport is 200 miles away.
You're saying that it should be 100 miles away.
No, I said that where the angle that your line of sight follows should intersect is 100 miles away. The airport is 200 miles away. I didn't say the airport should be 100 miles away. Never once in this conversation have I said that.
It doesn't make sense anymore.
It didn't make sense in the first place when you said the airport should be 100 miles away.
That's what you said. I didn't say that.
Nobody in this conversation ever said that the airport should be 100 miles away.
Okay, so I got your argument wrong again. What the fuck are you saying?
What was actually said in this conversation was that a 3-degree drop below horizontal should intersect the surface of the Earth at about 100 miles away. That's what was said in this conversation.
Okay, so what?
The airport
does that have to do with the distance of the airport?
The airport is 200 miles away, and we see
on the flat Earth.
You're assuming that, but we should see the airport at a different angle than we see it at.
So then you did say that it should be 100 miles away.
No, I said the surface of the Earth intersects that line of sight. The intersection for that line of sight.
I'm trying to get his argument right. He just won't let me.
Right, but you keep changing. You keep changing what I'm saying. The intersection of the line of sight. The intersection of the line of sight should be 100 miles away. The airport is 200 miles away.
Intersection of the line of sight to the airport. Yes.
No, the line of sight is to the airport. But if that line of sight was over a flat Earth, it should intersect the surface of the Earth at 100 miles away.
So what about the airport?
The airport is 200 miles away.
Okay, on a flat Earth.
That's what you're assuming.
Oh, what the fuck are you talking about? That's what I'm assuming.
It can't be 200 miles away on a flat Earth. Jay Greg, it cannot be 200 miles away. What part of that don't you understand?
What are you talking about? It's on your example.
Work out that way. With refraction.
What the hell is this bullshit? You're telling me in your example the airport is 200 miles away on a flat Earth. You're 30,000 feet above the air, looking at a 3-degree angle under the horizontal reference frame. That's what you're telling me. And then you tell me it should be 100 miles away on a flat Earth.
Right. What we're saying is that the triangle that's constructed from those specifics, a 3-degree below horizontal and a 200-mile distance to the airport, do not match.
Yeah, they're just claiming that the degree should be 1.9 instead of 3.
So how far away should the airport be then?
The airport is 200 miles away. Nobody is making Nobody is making a claim as to how far away the airport should be. The airport is 200 miles away.
They're just saying, Gregory, that on a flat Earth,
110 or 114 miles away.
Yeah, with the 3 degrees, they're just claiming that you'd be looking into the ground, which is kind of absurd because if you're looking out over the Earth, it like that difference in 1 degree is it's beyond it's not even something you would move your eye for because you're just seeing the whole field of view. So it's not even, but of course they're then claiming that it's not just your eye. They're claiming that the heads up display is working sort of like an eyeball, let's say, that has a horizontal line through the middle. And then that is what they're claiming is accurate enough over this distance to get that tiny little bit of 1 degree difference to claim that that's the difference between a curved spherical Earth and a planar extended Earth.
This is about the 5th time I've had to correct you on this. Hold on a second. This is about the 5th time I've had to correct you on this, Gio. Do not say that the angle over that distance is absurd because the distance does not matter. An angular measure cares nothing about distance.
But you're saying that the airport should be at a certain distance. So that's the entire crux of your argument.
No, the airport is. Again, the airport is, one more time, the airport is at 200 miles.
But yeah, you're telling me, so you have
keep on getting the argument wrong, Gregory. We're not saying it should be there. We know where it is.
You were telling me
200 miles away.
Should be. That's what you were telling me.
If the Earth was flat,
no.
maybe we should word it differently.
I'm not telling you where the airport should be. I'm telling you where your line of sight should intersect with the surface of the Earth.
What is that? What does it matter?
Oh, it matters very much because where we
my eyes should intersect with the Earth
to see something that's 100 miles away. We instead see something
I'm on a flat Earth. I'm 35,000 feet in the air. The object is 200 miles away.
Mm-hmm. At an angle that doesn't fit a flat Earth.
How did you come to that conclusion?
That's the problem. Geometry, man.
Trigonometry.
Yeah.
So it shouldn't be. It shouldn't be at 3 degrees angle. It should be at 1.9.
Yes.
Yeah.
It shouldn't be at 100 miles, and it's not. How about that?
Just about that conclusion. And don't just say the word trigonometry. That's not informative. That wouldn't work in with your colleagues. That wouldn't work in your classrooms. That wouldn't work in anywhere in your professional arena. So don't give me that shit to me.
Hold on. Classrooms is where it came from.
The word trigonometry. Sir, how did you come to that conclusion? Trigonometry. Okay, can you explain further, please? You idiot.
I think that
it does actually work with my colleagues because my colleagues know trigonometry. If I give them a side length of 200 miles and another side length of 35,000 feet, they can for themselves calculate what that angle should be. 1.9. You can't seem to do that.
You don't have any of that in reality. In reality, you have to use imaginary lines that you cannot verify the length of. This is why this argument is just so fucking ridiculous. You're going, oh, I'm going to go up on a ladder. I'm going to look at a tree. I'm going to imagine lines. I'm going to do trigonometry. Earth is a ball.
The lines that you imagine we do not. The lines that you imagine we do not have is the length from the observer to the object that we're observing in the distance, and the height the observer is above the height of the observer above the ground. We know both of those side lengths for that triangle. If you want to assume the Earth has no curvature.
Okay, so which one is the case?
Wait.
Hold on, because I didn't quite finish. Don't tell me that I don't know those lengths.
So which one is the case, though, doofus? If you tell me it is the case that the airport's 200 miles away, you're 30,000 feet in the air, your perspective is 3 degrees below horizontal, then that's the case.
Right. So it doesn't fit the presumption that the Earth is flat.
Why do you say that?
Because the trigonometry doesn't match.
Match with what?
Do the math on it. Try to make a 3-degree angle.
Is that really supposed to be a satisfactory, meaningful answer? People in the room.
Hey, try to make a 3-degree angle, a 200-mile distance, and a 35,000-mile altitude work. Please do that now.
On a flat Earth, right?
Try to make it work in trigonometry.
On a flat Earth, correct?
If that's what you want to go with.
Okay, so what should it be on a globe?
Dude, they've already gone through this like 20 times.
This doesn't make any sense. It just jumped to this conclusion.
I think it makes sense in terms of the basic idea that they're laying out. So that part,
well, I mean, we have level.
There's a big problem here. Hold on. There's a problem because what first he said when he was looking, you have looming or whatever where it would appear higher because of the curvature of light, right? But then he's going to say you're going to use the perfectly straight line of sight, which is actually the same line that, remember, that curves up and down. So that line that curves up and down, he will then invoke that it's a perfectly direct line of sight. But if you go back to where it curves and have it be a direct line of sight, the Earth can't be a ball because you would see too far. So then we go refraction, but then you go back to the direct line of sight, no refraction, so you can make your proper measurements. Double standard.
Exactly. We were talking about this double standard earlier. They do it frequently. At times, they need all kinds of a dramatic 7/6R. They need to plug in R radius values for all kinds of refraction. Then other times, they need it to be exactly straight lines.
First of all, 7/6 is not dramatic. It's just a little over 1. Second, when we apply the way we know refraction to exist through a density gradient where the highest density is below to the flat Earth example, we find that it's even further off from the position that it should be in.
There you go. Should be. There it is. Invoke your imagination of where reality should be.
When did you do this comparison? That's what I'm getting at.
No, refraction makes your refraction makes your problem worse. Not better.
When did you do this comparison? That's what I'm getting at. So is this 200 miles away, 30,000 feet, 3-degree angle on the horizontal frame? Is that on a flat Earth or a globe Earth?
Now, the assumption when I brought up trigonometry was that the Earth had no curvature, and it didn't.
Which one is it on?
Assumption. That's what I'm getting at, Gregory. The triangle that we constructed with a 200-mile long baseline and a 35,000 foot height, the angle didn't match what was observed.
On which one?
A flat baseline, dude. Come on, keep
so
up.
This is on a flat Earth.
Right, the angle doesn't match.
Did you do this? Is this in real life or is this just your hypothetical?
This is basic trigonometry.
Is this your real life? Did this happen in real life or is this hypothetical?
Trigonometry is used in real life. I hope you know that.
Doofus is backing this as if he was even the guy in the airplane doing the heads-up display. He's backing it like a defense agent, like he absolutely just has to, and he's somehow saying that he knows all these distances. But Zanuck is the one that brought this up. So I was going to ask Zanuck, are these your heads-up displays in an airplane, or is it something you pulled off?
That's not my heads-up. I've done this measurement myself while flying many times. You want to correlate
it in real life?
No, I'm just saying I'm just asking. You posted 3 of these, and then
I didn't do those because they're the most dramatic. The ones that are closer.
Let me just finish what I'm asking. You posted 3 of them. Doofus is defending it as if he has to, no matter what. And he's just going with it. He's going with the numbers you're saying. And he's pushing it and all that. It makes a little more sense that you're pushing it because you are the source of the photo. So I'm just asking, outside of Doofus's commitment to do that for some unknown reason, your pictures of these HUDs, I'm just asking, where did they come from? And that's what I'm asking.
Many different aircraft, all sorts of videos of HUD displays in action. I have had many myself, but these are the better than I've ever taken of my own.
But specifically, you were bringing up this one SFO to Reading, this airport 200 miles. That's the one we're talking about.
I've done something equivalent to that. It was actually
so none of these are that at all.
No,
so we're literally.
I don't have SFO.
Doofus is just arguing an imaginary thing, and you're pushing an imaginary thing.
Hold on, you're claiming that it's imaginary. Now you're making a claim that it's fake.
Well, none of these heads-up displays are even the one we're talking about, right? Zanuck, is that what you're telling me?
Well, we're using the example of an airport which I've seen.
So you're just assuming an example from things you found off of Google.
You asked me a question. Let me finish. So I've done it myself to Sacramento, but it's not as dramatic because it's only 100 miles away. But what we're saying here is these pictures are real. They do show the horizon 3 degrees below level. They show the sun and the moon below level as well. And any looming would make your problem worse.
Okay, be quiet and listen. Is the 200 miles, 30,000 feet, 3-degree angle in real life, which we're talking about, is that in real life?
I mean, that's what we've been discussing. That's what we've been discussing. And this whole difference was this 1.1 degree difference.
In a light
plane, just saying, we don't even have the heads-up display to even back that.
I've been Palo Alto to Sacramento. I think it's about 120 miles, and that's what I've done personally. And it was the same type of calculation. But this
then we're not talking about something that was in real life.
I was trying to make a visual graphic for you so you can understand it conceptually, that if you are at 35,000 feet, which I haven't been in a light plane, it's an airliner. My dad is, he's been flying for 25, 30 years. they would be able to measure that. And they have heads-up display pictures that we're showing you here that show the horizon at 3 degrees below level. Now you can argue
like
that
you were
they're
just
fake,
saying,
but at least you know. Hold on. I'm almost done. I let you finish.
You're
I
rumbling
let you finish.
on.
Let me finish. I let you finish.
Yo, he's
I
rumbling
let you
on.
finish.
I
Let
just
me
asked a
finish.
simple
I have
question. Is it real or not?
last 3 words to say. So, God,
fucking annoying. Hurry up.
You're annoying. So we have level, and we have the horizon, which is 3 degrees below level on many of these captures of actual video. They are real. They're not fake. They're not CGI. You have to then toy with why you think that is, because it's the same concept as we're talking about as an airport with a green flashing light at 200 miles away that you can see from 200 miles at 35,000 feet. There. Thank you.
So, is it real or not? Yes or no?
They're real.
So the whole thing we've been discussing, the 200 miles, 30,000 feet, 3 degree angle, it's real, yes?
Real. Is real.
So then that's the reality then. So which cosmic paradigm are you doing this in? You believe you're doing this on a globe.
No, I don't believe anything. I'm giving you that it can't be on a flat surface.
When did you do this on a flat surface to make the comparison?
Because we understand trigonometry.
Yeah, the presupposition of the argument
fictitious, supposed fictitious trigonometry you did on the flat Earth that isn't real?
Fictitious?
So the presupposition in the argument itself is that the surface of the Earth has no curvature. Using that presupposition, we then construct a triangle because no curvature, right?
If you got this in real life and the Earth is really flat, then that's that.
That triangle, we then find out the particulars of it don't make sense in reality.
If you got this triangle in real life and it's on a flat Earth, then that's that.
All right, but it's not because
what the angles talking
don't
about?
Match. Right, the angles don't match though.
Let me
don't
just
match what?
Hang on, let me say one thing real quick. Just to Zanek's point, the horizon being 3 degrees below level, quote unquote, that is not Earth as a ball.
Yeah, I would agree. I mean, the reason the horizon exists is because of the visual meeting point of the ground in the sky, and that can change distance depending. It might be 5 miles out, 20, 30, depending on the cloud layer and depending on the atmospheric conditions. And so if it's only 10 miles away versus 80 miles away, that position will be different.
Well, yeah, so that's where we see.
You find out that when you gain altitude, that you get less of a variation. The more altitude you have, the more altitude you have, the more altitude you have, the less variation you have. And in conjunction with that, not only are you looking at the angle down to the horizon, but you're also looking at surface features that you know their distance from you.
And in real life, which you'd say you did, and you're on the flat Earth, then that's that.
And all of the
parts you're presuming the Earth is flat, Gregory.
All of the
okay, you say it's done on a globe. Okay, you say it's done on a globe. So when did you do this on a flat Earth to make the comparison?
Right. The presumption in the argument is that the Earth has no curvature. That's what we're using to start.
Okay, so you're comparing these real figures to a fiction.
Okay, flat Earth is fiction. Thank you.
Your argument is stupid. You act as though it would really be the case that it really is this on a real flat Earth. But you haven't done this on a real flat Earth, according to you.
Okay. Yeah,
you're comparing your real figures to a fiction.
Right. Trigonometry
presupposes that yours is real.
Gregory, I'm going to mute you for a few minutes, man. You're just screaming and interrupting people. Just take a break for a second, but go ahead, Doofus.
Right. So we know here, I guess I've said it enough times to Gregory. I don't need to say it again. We can use trigonometry in real life to measure real life angles and real life distances. It works fine.
Yeah, but that's when you actually have like a physical measurement. Like, and this is why I'm like, you don't actually measure it, right? You have your height, okay. Then you have the distance to the place, okay. You've done those measurements in straight lines, okay. Then you get up on that ladder and look, and then there's no more measurements, right? No measurements happen at this point. Then all of your conclusions, all of your proof, all of everything that you say, yup, this is it, comes from the one part where you didn't actually do any physical measurements. You were just looking off into the distance and going, yeah, it looks like it's about kind of there, right? Kind of about there.
No. Theodolite is not the theodolite and a theodolite app together, both of those things. Those are actual measurements, and your altitude is a measurement.
No, well, the theodolite's a scope, so you're not measuring a distance in feet and inches. You're just looking.
Okay,
That's
theodolite is not built to do that.
Well, but then this is the problem. You can't verify the length of that line. You're going, I look, if this line should be 1,500 meters, you've never hang on. You've never actually physically measured it to make sure it is, right? You could have magnification because of the atmosphere. You could have any of these effects that could change where it looks like it is, which you admit that it does. So this is why you'll never double check that line. But anyway, so you have this third line that you've never double checked the measurement, never verified the measurement, and then you're going to use the unverified measurement to base all of your conclusions on.
Thank you. They're comparing it to a fiction.
So
in their argument, they haven't actually done the measurement. They haven't actually done the other triangle on the flat Earth that they say is not real. They say they did the triangle in the globe, and then they want to compare it to the triangle on the flat Earth. But they haven't done the real triangle on the real flat Earth so as to make a real comparison. They're comparing what is supposedly real with what is supposedly fiction.
Okay, thanks, Gregory. So I'll say it to you one more time, right the hand, since Gregory seems to not be able to get it. If we have two angles and we have one of the side lengths, we can calculate the lengths of the other two sides of a triangle.
On paper,
we can do this in reality anywhere. No. This is something we can actually do. Now,
you're not doing it in reality.
The altitude is an actual measurement. The distance to the airport is an actual measurement. And the angle that is below horizontal is also an actual measurement. We know all three of those things.
You don't the line to make the triangle, right? You have your height, then that hypotenuse, is it? The long one from the top of your height to your location. You with me? That line?
All right, say that one more time. Sorry. My daughter decided to do something weird.
So you have your height at A, right?
You have your height. That is your closest side. Yep.
Yeah. Then you go to the location on the ground is your flat line, right?
Well, yeah. Okay. Go down to the ground and then out to the thing that you're looking at. Yeah.
Yeah. And then to close it off, you go from the top to the ground.
The top to you mean the top where you are to the object you're observing.
From the heads-up display to the airport or whatever. Yeah.
Yeah. From your height. That's to close the triangle. So you have your height, which is whatever, 10,000 feet. Then you have the distance to the airport, 100 feet. Then you have to close the triangle with that last one. My argument is you never do that sufficiently because the only way you do it is by looking. And looking is not really a measurement. And you're going to say, well, we know the distance of here and we know the distance of here, then it should be this. But then I would say, well, that isn't reality. And if you would want to say conclusively what it is, you would have to physically measure from your eye with a string to a location on the airport, measure the string, and then make sure it all works out.
Not necessarily. If we're 200 miles away from something and we're 6.6 miles in altitude, we can come to a conclusion necessarily that the hypotenuse is not going to be much larger than 200 miles, a very small amount greater than 200 miles. It's going to be pretty much close to 200 miles.
Yeah, but that's
this is how triangles work in reality, though.
But so the whole problem is you might not be looking, quote, at a triangle because you might be missing the point where your distance is from. So where you took your distance from, that's where you have to look exactly. And I'm saying for you to look exactly at the inch spot where they started to take that distance from is damn near impossible, right? You're at a big cone. So your measurement needs to be verified because you're saying this hypotenuse should be 165. What about if you measured it and it was a completely different fucking length? You'd be like, holy shit, we have something wrong here. And this is what you've never done.
Right. And it's a 1 degree thing that they're claiming. So it's like the auto level. Trying to use an auto level at 200 miles. This is trying to use a heads up display in an airplane at 200 miles.
At 200 miles, 1 degree, 200 miles.
As I've mentioned several times, is not less accurate because it's at a longer distance.
It's not that the degree is accurate or less accurate. It's the accuracy of how that degree matches with the ground.
Geo,
your unjustified opinion.
Can you please just hold on? Geo, can you please stop saying the distance somehow calls into question the angular measure?
Of course it does.
Of course it does. It's a part of the triangle.
Exactly how does the distance make the angle less accurate?
Well, there's a reason that auto levels are spec'd at a particular distance because they've been proven in physical reality to be accurate at 300 yards or something like that. Whereas to just take it at 200 miles, it's not that you're not getting some degree out of the sight. It has to do with whether that degree is actually accurate to what the Earth is at 200 miles versus 300 yards.
You could be off by dozens of miles at least.
What is the reason for the maximum distance recommendation for an auto level?
Because that's what it's been spec'd and designed and tested to be valid at.
Because it works on vision. Because you have to see
there's an
your
actual
target. Because
Gio,
if you
there's an
don't see
actual reason that's published, widely known, why there's a maximum recommended distance to use an auto level. It has to do with stadia tachyometry, specifically stadia tachyometry.
It has to do with you spotting the stick, right? So you have a height stick that you use with your auto level. This is how you know that you're not just pointing off into the distance. Like you have to check these things. So if you can't see the stick to know what your height is, you can't check your auto level. This is why you don't just send the stick guy 200 miles down the road and barely look at the stick and go, yup, we're level. They have to keep it so they can see the millimeter readings on that bar.
So Doofus is sitting here just trying to eyeball it instead of actually having a device to measure the accuracy.
Exactly. That stick is part of the device. If you don't use that stick, the device is useless. So, and this is what he's doing. He's not using a part of the fucking device and saying I've used it's like, it'd be like playing chess with only the white pieces.
Yes,
right? Like, oh,
that's just not true. That's not true.
Yeah, that's incorrect because the stadia the stadia hairs on the auto level are at a particular angular separation. You can use those to determine where in your field of view objects are relative.
Yeah, so what? You can use it. It's not accurate. I can use a pillow to bang in a hammer. That doesn't mean it's effective.
I remember there was a time
using it as should be aware. The auto level definitely establishes a horizontal reference. Correct?
Yeah. Of course it does.
You sitting here trying to talk about
it accurate. Only when you use the measuring rod and actually validate it.
Yeah, exactly. You have to use the measuring rod, or else it doesn't. You don't connect it back.
The center crosshair, that is definitely a horizontal reference, whether or not you have a stick in your hand.
No, that you have to verify.
Here trying to eyeball it is not accurate. Period.
Because it needs to be calibrated.
We determined then that something in the distance using that horizontal reference is not where it should be.
Well, it needs to be calibrated, which is why you use the stick, because the stick is like, it's almost like the equivalent of using a string in the other example. Like the stick is actually a physical thing. So then when you can calibrate that, then you have it calibrated at that distance, and then now you have a working tool. To just take that and start shooting it hundreds of miles over the earth, you don't have an accurate tool anymore. You just have a tool misuse that you're just
a high power optic, that shoots a horizontal line.
It's not shooting a line. You're just looking.
The stick does not.
You think like are you Superman? Do you have a laser beaming out your eyes to the object in the distance?
It's creating a horizontal reference. Gio, the stick is not the sufficient equipment necessary for calibrating the auto level. There's more to it.
Stupid.
Do you know what the rest of that procedure is?
Bro, do you need the stick? Because vision, there's a quote, drop to vision. So that line, that horizontal, you have to make
drop to vision? Well, here's a nice
guys, just let people finish speaking. Let him finish what he's saying instead of just clipping him.
I'm sorry.
It's like a power lines, right? Like you have to look almost directly up at the power line that you're right under, but you can look straight out and see the power line that's like 100 feet away, right? That if there's a level across the top, the level line doesn't go in a downward diagonal because you're looking that way. No, you got to line it up, man. That's what the rod does. It lines it up. And what you're doing is you're creating this horizontal line, but it's actually on a diagonal down, and it's not a horizontal.
It's actually a horizontal, but you see drop due to distance. So the line is separating from the surface of the Earth upward. So you've got it backwards.
You see drop due to distance?
Yes.
What's causing that drop?
Hold on. Back to right the hands power line example. Fortunately for everyone else that works with perspective, including myself, The definition of perspective does not allow something that is above your altitude to ever appear below your eye level.
Answer my question.
Okay. After, Right the Hand acknowledges that the perspective definition doesn't follow his definition of perspective.
Yeah, it's the exact. What you're trying to do, right, with the auto level would be line up those the power lines. You would somehow, but you would never be able to do it, right? Just because the way vision works. So you have to do it very close, because the further away stuff gets, it doesn't line up like that. It doesn't line up horizontally, visually. It lines up in a downward diagonal.
Right, but what you mean by, quote, the way vision works is perspective.
No, well, you could call it whatever you call it. It's when you look at stuff that's far away, it starts looking like it's down and smaller. That's why you can't, if you would try to make a horizontal line based on that, it wouldn't be horizontal, it would be on a decline.
Okay, but the way vision works, as you put it, anything that is above your altitude on a flat surface should never appear below your eye level in the distance.
Why are you saying that?
Because it shouldn't.
Okay, so what does that have to do with what he's saying to you?
Defined.
What does that have to do with what he's saying to you?
Well, because the high object, right? He's saying it drops as it goes further into the distance. That's wonderful. However, if we observe something in the distance that is at a higher altitude than us from the surface of the Earth, then we know it's not due to perspective. Or if we see it at a higher altitude and we see it below our eye level, we know that's not due to perspective.
Yeah, but the eye level that, see, again, the eye level that you're using is straight or curved depending on how you need it to be.
Oh, jeez. Okay.
Why is the eye level the standard? All you have to do is look down.
Because we want to base it off of some measurement, ideally.
Like, if you're looking at whatever you're looking at, like, what the hell is this? I'm 35,000 feet in the air. I'm looking at the object in the distance. Either I'm looking at the object or I'm not.
Okay. Eye level is at a 0 degree horizontal, or at a 0 degree vertical angle, or horizontal, as it were. So when we say something is at eye level, we're specifically meaning that it is at a local horizontal reference, 0 degree vertical angle, a 90 degree zenith angle, however you wanted to define it.
Okay, and so what about the object I'm looking at?
Right, the object you're looking at is in a place where it shouldn't be, assuming the Earth has no curvature.
But you haven't done the triangle on a real flat Earth in your argument. You're comparing it to a fiction. So you don't have a real comparison. You don't have a real comparison in your argument.
Trigonometry to figure out what I'm trying to do, where I'm trying to aim, and all that stuff. Although I have to actually add in other factors because I know there's drop due to distance.
Am I making sense?
No.
Not really.
Someone else speak, other than the anti-flat earther. Supposedly you did the triangle in real life. You say the flat earth isn't real, but if we did do this on the flat earth, then it would be this. It's contrary to what we have in reality. But you haven't done the comparison on the real flat earth to make a real comparison.
Right, because we don't have a real flat earth.
So then your comparison argument is false.
Okay. Trigonometry, we use that here in reality to do actual useful work with it. What you're saying is the thing that I explained earlier with trigonometry about the 3 degree angle and the 200-mile distant object, that's not reality. You're saying that for some reason, for just
no, I'm not saying the triangle is not reality. I conceded that triangle is real.
That the trigonometry for some reason doesn't apply in that specific
I conceded the triangle is real. Shut up and listen. I've been saying this the entire time. I conceded already the triangle is real. You believe that you're doing it on a globe, and you believe you're comparing it to this supposed triangle on a flat earth. But it's not. But in your argument, the flat earth isn't real. So you're comparing what is supposedly real with that which is fake, that which is not real. It's not a real comparison. If I have an apple and I want to compare it to some other hypothetical fruit, how can I compare it to the other hypothetical fruit? It's not real. That's not a real comparison.
I'll say this one last time because you just made the same mistake in my position. Yet again, you changed my position for me. No, I'm not presuming a globe Earth in the argument. The argument is presuming a flat Earth. You're saying
so then that's what it is on the flat Earth. Then
I am doing this on a globe Earth. No, that is incorrect. Do not tell me I am doing this on a globe Earth. The real triangle is on the flat Earth. What I'm doing is I'm constructing a triangle on what I assume is a flat Earth. I am assuming for you that the Earth has no curvature.
Okay, so then that's what it is. The real triangle is on the real flat Earth.
Yeah.
Doofus, are you assuming that how we measure it is exactly how we see it?
We see it where we see it. What do you mean?
In your argument, like Matrix is on the right track. So the real triangle is on the real flat Earth. Gregory, I did this on a flat Earth. I did the triangle on a flat Earth. The triangle is real. So then the real triangle is on the flat Earth then.
No. The presumption in the argument was that the Earth had no curvature. The angle and the distance, though two distances, were applied to the triangle I presumed was on a flat Earth. Now, in that presumption of a flat Earth and the specifics of that triangle, it didn't match a right triangle.
This doesn't follow.
I think the answer to Matrix's question is yes. They're just assuming that they're dead straight lines at 200 miles. They're all perfect straight lines. That's what they're assuming.
No.
Mm-hmm.
That is
Howard
incorrect.
says yes. Doofus says no. So how does that work?
Right. Well, and any particular observation done optically through the atmosphere, at least for me, I apply both geometry and refraction as the two mitigating factors for a change in horizontal or a vertical position.
But at a certain point, wouldn't these two cancel each other out? The refraction and the curvature?
Only if the refraction was stronger than it typically is.
So what would be the difference between a globe Earth, right, and a flat Earth with refraction? Wouldn't it, hypothetically, in a flat Earth refraction, wouldn't it appear to curve?
Be in the opposite direction. Yeah, we would observe
just entertain my hypothetical.
An Earth with no curvature.
Hypothetical. Don't switch. Hypothetically, on a flat Earth, right? Let's just say we know these things are flat, and we have refraction. Could it be misconstrued that this refraction on a known flat Earth it is curvature? I'm just saying hypothetically.
That's what they do.
Let me finish what I was answering with. If we presume the Earth has no curvature, it doesn't even matter about the surface of the Earth in this particular case. We can measure the specifics of the atmosphere to see which direction light should bend. And the atmosphere has, above 20 feet above ground level or higher, a stable gradient such that the highest density is below, causing light to bend downward and distant objects to appear higher. An Earth with no curvature should appear as though it is concave.
Doofus tells Gregory the triangle is real, and I did it on a flat Earth. Gregory says to Doofus, so then the triangle is on the flat Earth then, not the globe.
The triangle that I constructed was on a flat Earth.
Yeah.
Yeah,
and the triangle is real, and so it's on the flat Earth then, not the globe.
Yeah, it didn't match reality. That's the problem.
But the triangle is real, and you did it on the globe. Therefore, it's on the flat Earth. You did it on the flat Earth. Therefore, it's on the flat Earth, not the globe.
You've confused yourself. Just take a nap.
It's ridiculous. It's double speak.
It's not double speak if you don't get it.
You already told me the triangle's real, and you did it on the flat Earth. Therefore, the real triangle's on the flat Earth, not the globe.
Right. The triangle has real-world distances in it. I'll say it as clearly as I can. The triangle has real-world distances.
See, every time I try to argue with him, he just repeats his argument.
And then I used.
It never gives a rebuttal to what I'm saying to him.
Hey. And then I use those real-world.
You've been doing this for 30 minutes.
Jesus Christ, dude.
Oh, hold on, Gregory. You don't answer
Gregory. Distances. Hold on, Branch. I use those real-world distances and assumed I was going to construct this triangle on a flat Earth. This triangle does not match reality.
Hey, let me ask a question, Doofus. When you say you're talking about
triangle, doesn't match reality.
Gregory, let me get in just a second. Sorry, bro. I've been operating loud machinery, so I've been listening, but I haven't been able to get in.
Go ahead.
Doofus, so you say that what you're observing doesn't match reality. Is that your claim, right?
That's what he just said, yes.
So
no, that's not what I'm saying. No.
So
you don't
what
get
you're
to go. No, you don't get to continue on from there. That's not what I'm saying. What
Hold on
I'm
a second.
saying is that the measurements for that triangle do not match the presumption of a flat Earth.
Can you provide me the evidence for this claim of
right
what you're talking about, right? Because I've been listening for the last 2 hours to people talking basically about a hypothetical because there's no actual real world evidence for what Zanuck claims this 3-degree drop, this 200-mile distance, this specific airport. All he does is he shows a few HUD displays that you could find off fucking Google, and there's no information at all. He has no flight data, no pictures showing exactly.
Yes, you have all the things you need.
Where the is located.
You don't need to know where it is. All you need to know is that it's an infrared camera. Let me finish. You have an infrared camera. You can see the horizon. You can see the moon and the sun and many other things below level. You're just gonna talk over it.
Like Napalm was in the middle of the sentence. He gonna complain to Napalm that he's getting interrupted.
Yeah, Xanax. So this claim about this 3-degree drop, it should be 1.9 if the Earth was flat, based on some airport that you're spotting the lights. Do you have any evidence whatsoever for this claim observation?
The horizon.
The horizon. Okay. Well, I can say that the Earth is flat based on 16 million different numbers that I want to provide to you, and I won't give you any evidence. I'll just say
the horizon. Like just invoke words.
Give me a picture.
I can easily explain why he said that.
Horizon.
I was trying to
you just stop and listen for a second. It'll make sense. We have the horizon below level. We have the sun and the moon below level.
Can I get
How is that possible on a flat Earth?
So is this this is what you are claiming is this 3-degree drop to an airport and a light at an airport?
That is a different observation.
So you
the
have
you
no
need,
actual evidence.
I'm still talking. I'll let you talk. Let me talk.
You've been arguing
all
about
you
for
need
2 hours.
Is a level line
snake oil salesman
that shows that the horizon is below level. That right there will tell you the circumference of the sphere that you're taking the measurement from, because you cannot have a horizon below level if you're on a flat plane.
Okay, you know what, guys, I gotta get this out, guys.
When you gain elevation,
you guys are talking about all this
you're
bullshit,
going to have your horizon.
Wait, not even with refraction can that happen?
No, because refraction makes it worse.
Listen, doofus tried to explain
You've seen it. You've seen it silent. It makes the horizon go above level.
Hold on, I'm talking. Doofus tried to explain all this shit to you guys a second ago, and now you want to fucking listen to a less coherent fucking explanation of it. Why? When Doofus gave you the best one.
Give us a damn.
I was giving you the same one that Doofus was.
No, you guys didn't fucking want to listen to Doofus.
Perfectly.
I would say, you know what? Instead of going down this path of a fucking subservient explanation of it, listen back to what Doofus just said. His explanation was the best.
What explanation was that?
His explanation was an unsubstantiated comparison.
Ask Doofus.
No, Branch, we think it was more coherent.
Thank you, Branch.
You tell me why it was more coherent. I've said the exact same thing he did, just using different words.
Take credit for what he said.
No, I'm just saying why do you think it's better? Why do you think it's better?
Why,
they're just different.
Yeah, listen, the only reason you guys got off of Doofus's fucking explanation was because because of hearsay chat. You guys were going in the flow of chat instead of the flow of fucking ideologies and fucking understanding.
Okay, Branch, you're just talking words now.
Branch,
Look,
the reason
both
that
Doofus and I
Xanax
gave you
started
the
to
same
speak
argument.
is
We started
because
out
I
with
actually
an
called
airport,
out the
3
bullshit
degrees below,
that
being
he's
200 miles away. They
3
can't be
degrees.
200 miles away.
Show the
If
evidence
it's
for the
flat.
3
And number
degrees,
2, I
Xanax.
said horizon,
Show
just
the
by the
evidence.
mere fact that it's
Show the
below
evidence.
level,
Show
means
the
that the
evidence.
surface has to be curved.
Show the
How did
evidence.
you measure it? How did you measure that?
You're going to be talking over me the entire time. Everybody,
Show
thank
the
you.
evidence.
Just
You
continue
don't
to
have
blab
it.
over me.
You don't
Just
have it.
words, Sanic, all day long. Words and
Yeah,
more
there's
words
actual
without
evidence
any
posted for the
evidence.
horizon
And
being
you
below
guys
3
show
degrees.
How you
that
measure the
all
angle.
the evidence in the world. You guys don't
Right, with a
show
heads-up
any
display.
evidence at
Easy.
all.
Show how you
words.
measure the angles, Anik.
Let's just not listen to what Doofus said. Nobody listened to it. It was obviously bullshit, wasn't it?
Hey Xanac, if I take a picture of a HUD display, but I'm below the eye level of the pilot, would it show things below the horizon and the
Absolutely
HUD
not, because that's
line
how the
being higher?
HUD display is so useful. It can counteract the ability to ever try to fool it by what you're saying. That's a common response for flat earthers, but it's only because they don't understand how they are calibrated, how they operate.
So if I took a picture from the floor of the airplane, it would give me the horizon.
You can't. You have to be within a degree or a degree and a half of the actual screen, and it will move within that range. So within a certain range of about a degree, you can see it. If you get out of that range, it goes blank. Are you listening? Because I heard people talking in the background.
So do you have any examples?
So in other words, it does not work if you are not in the place where it can work. Why are you talking over me? I just don't get it.
Because
Branch, just stop it. It's so fucking annoying.
Doofus was trying to make a point. And
no, it was asked to me.
Listen,
about,
even if I'm overtalking
Branch,
you right now, the whole
Branch,
point you're making is
shut the fuck
overtalking
up.
Doofus's.
Gio, please, would you moderate Branch? He's out of control.
Xanac, Branch just wants to see the
there's one
picture
other
of the
thing.
airport lights that you're talking about. He wants to see the airport lights at 200 miles away. He just wants to see that picture, bro. That's all he wants to see.
All right, there's one other thing worth
two
mentioning.
comments that I'm trying to address.
I
if I address any of them, I'm sure he'll talk over me even more, like you are now.
Well, that's your claim. That's your claim.
No, the claim is
airport lights.
I can show you how the HUDs work. I can show you the diagrams and all the rules and
the picture of
the
the
information.
Claim that we've been
Why are
arguing
you
for
talking
the last
over me?
2 hours?
I don't understand it.
Freaking idiot, bro.
I'm giving you an explanation of how the HUD works. And no, you cannot go to the floor and see the level.
I don't care.
Just fucking stop talking over me. Even now, you're doing it.
About how you
unbelievable. Now you asked the question because you're so ignorant. How
guys, the only way out.
I just want you to provide.
I'm trying to help you understand. And he wants to
provide
evidence. Finish.
I have told you so many times, Sanic, you don't need to help nobody understand. Everybody understand what you're saying. They just
if he did, he wouldn't be asking it, looking at the HUD from the floor. It doesn't work by working on the floor. What's wrong with you,
buddy? I was in the
It
middle of a
doesn't
sentence.
work working on the floor.
Let me just finish and I'll be done.
It doesn't work looking at it from the floor. Silent, talking over me even still.
You keep interrupting me. I don't know. It's the first time I talk to Sanic.
We gotta stop talking over each other one day.
Yeah, Sanic, they do understand what you're saying.
They don't understand.
Holy shit.
Given by the question.
All right, I can
If they
explain
understood, they wouldn't have asked a stupid question like that.
Hey, Xanac, the only thing I don't understand is why you haven't given us the picture.
You gotta stop talking over each other eventually.
Silent Zero.
It's not going to happen, Gregory.
Talking. Guys, let one mic at a time. Silent. Were you done speaking?
I was done, Dyslo. Thank you, my man.
Okay, go ahead. Go ahead, Gregory.
It's just an unsubstantiated comparison. The triangle is real. It was done, presumed on the flat Earth, so it's done on the flat Earth, not the globe.
Thanks for that wonderful input. Silent, what were you actually saying?
So in other words, it's an unsubstantiated comparison. Until you actually you presume you did this you presume these distances, this triangle is really on a globe. You have to really do it on the flat Earth to make a real comparison. You can't.
Okay. Xanac, I want to mention something to you real quick. Yeah, your position to the HUD projection surface itself can be off by as much as 1.5 degrees or whatever. But the amount that changes the position of the HUD relative to the distant objects is considerably less than the amount of that angle.
Oh, yeah, I was trying to make that point as well, but I was continually being spoken over. But yes, so finish that point. Thank you, Doofus, for saying that. The level line still remains near perfectly accurate to where it is in your field of view. As long as you can see the HUDs, it is accurate.
I mean,
I can show you a dynamic. I can show you a dynamic response of what happens when you move around a cockpit and how it follows you like a shadow. So you cannot look at it and have it not be accurate.
Right. It's a rear
so they're going
projection.
to keep pressing this premise.
projection.
They have to hold this premise. If this premise fails, then their whole argument fails. If it's not effective to just eyeball it through the HUD, then their whole argument fails. Of course, they're going to religiously devoutly defend it.
Okay, because we can
show you a picture of how you can move around and how the HUD level stays at a certain position above the horizon.
Right.
Doesn't move.
I was about to finish saying the HUD is a rear projection system. That light that you're seeing on the screen is coming in at an angle such that when you are able to see the HUD itself, that the light is coming from a direction that it is going to correspond with something in the distance very accurately. You can see in several videos, in fact, Wolfie's got a pretty awesome one, where if you go in and out of the range that you can see the HUD, the lines correspond with things in the distance. They don't change as you move around.
You are extremely likely to be inaccurate with that eyeballing, and 1 degree difference could be a difference of dozens of miles.
All right,
You're not getting it. You're saying it doesn't change
Gregory,
at all.
in this conversation, what I said was that the angle doesn't change by the amount that you can see the HUD by. That was in this same conversation.
That has nothing to do with what I just said. So every time I give an argument to what you say, you never just argue against what I said. You just repeat your argument like I'm just so fucking dumb.
Gregory, it won't be 1 degree off. It's not possible. It's not possible.
I just posted graphics of how it's actually constructed and how it functions. There's a field of view. There's a colorimeter aperture, which tells you how far away from this screen you can actually be before you don't see it. And when you see it, you are looking at it and looking at an accurate representation of what you're seeing in your field of view. If you're out of its range, you won't see anything. It'll go blank. So if you're 1 degree off, you will still see it, but the net output is perfectly accurate.
Yeah, we get that, but that's not the argument. We're trying to argue this 3 degree drop to a airport that has lights in a distance of 200 miles away, which it should be 1.9 degrees on a flat Earth.
The horizon being 3 degrees below level, that would be sufficient for you.
Did you hear what Napalm said?
That's the argument.
He wants to see the green and white flashing light at 200 miles away at Reading Airport when I took off from San Francisco, or from Palo Alto. And I don't have a picture of that. We have things that represent what we see. But we see that all the time. We know how far they are, and we can see it's more than a 1 or 1.5 degree drop. It's 3 degrees at a high altitude.
As per usual, Zanuck is the citation. He has no actual evidence to support his claim except for he saw it. So
I show you of that. I show you a 3 degree drop from level from 47,000 feet, 3.5 degrees, almost 4 degrees actually, to the horizon, and other pictures showing the moon and the sun below level. That cannot happen on a flat Earth.
Certainly can. So what was the visibility on that day when that picture was taken with that HUD?
93 million miles.
At least you can
93 million miles is your visibility. So when I'm leaving and the airport and I'm in an airplane,
that's tremendous.
And the pilot comes on and says, our visibility today is 10 miles.
Unlimited.
It's clear. We'll be traveling, blah, blah, blah. No, he doesn't.
Yeah.
Your visibility is not 10 miles. I mean, unless you're in the cloud or coming up to a cloud.
So now we can see forever. That's cool. So can we see forever across?
Yes,
of course you can. You can see trillions of miles away from you. Don't you know that?
You can see stars that are trillion miles away. Trillions of miles away.
The past, right? When you look
at
the
stars that are trillions of miles away. Yes.
That argument doesn't really. That argument doesn't really help you when you say that argument doesn't really help you when you say you can see forever. You have to have justification for exactly how far you can see. If you want to come up with a number, that would be helpful.
What do you mean? Our perspective is limited. In your everyday human experience, you don't see forever.
Yep, and if you're especially if you're at 30,000 feet and you're looking down towards the atmosphere, you're looking through a thick part of atmosphere. So you presume that you're going to be able to see through that thick part of the atmosphere forever. I think visibility.
What we see in the distance is the surface of the Earth. We're not seeing the atmosphere getting in the way. We see the surface of the Earth getting in the way.
And there's something else called the attenuation of light, meaning that the light reflecting off objects more than 200 miles away is going to attenuate at a rate that is not going to be able to hit your eye. So you will have visibility limitations.
What is that
No,
rate?
but I've seen flashing lights at 200 miles. That's not that hard.
Depends on the
Just like you can see things at 100 miles. Go to a mountaintop near you, and you can, with a pair of binoculars, you can see over 100 miles. No problem.
What is the rate that it attenuates at? You said it can't make to your eye from 200 miles away. Why do you say that?
Depends on the thickness of the atmosphere.
Because he's making things up.
What is the rate? You said it's at a rate that can't reach our eye. What's the rate?
I don't recall exactly, but you can see a candle light.
There you go. This is what you do now. You bring up things that you say. You have nothing to back it up with.
So there is an attenuation of light, meaning that the candle will still be visible. It's high enough to be visible, but you actually can't see the light because the light.
Who says you can't see napalm? With a pair of binoculars or a telescope?
I'll pull up a citation. Unlike you, I'll provide evidence.
Oh, that's not evidence.
Right, but what is that rate, though?
Everything is evidence.
It's not going to be evidence. No, it won't be. I can tell you it won't be evidence because no one's ever said that in the history of optics.
He's about to show you.
No one's ever said that.
Why you don't want to see it? He's about to show you why you don't want to see it.
Okay.
You're dismissing. Hold on. You're dismissing his evidence before he even show it.
Even presents it.
Right, but
he's saying we can't see things at 200
people,
miles.
myself included, who have used optics for a living.
Your comparison is unsubstantiated. You haven't done the triangle.
I've seen airplanes from the ground that are 200 miles away. We see the ISS that is over 200 miles away.
When I took the floor, there was no one talking.
Gregory, we see the ISS.
When I took the floor, when there was no one talking, so you trample on my words. So I just trample on my words. I'm not going to allow you to talk. You just going to trample on my words. You keep calling my name if you want to. You're going to trample on me when I'm talking when the whole floor was empty. What I was saying was, you have never done the comparison. You've never done the triangle on the globe. You've never done the triangle on the flat Earth. I made the comparison. Your comparison is unsubstantiated.
Not so. We see the ISS over 200 miles away. We see airplanes. Gregory, whoever else, napalm. We see airplanes that are over 200 miles away that are transiting the moon, just like the ISS. And you know what? We see exactly how far they are away. You know how we know this? Because we know the angle to them, and we know their angular size, and we know their size. So we know they're 250 miles away when we see them transit the moon. Happens occasionally. It is measurable.
So again, my point still stands. You haven't made. You don't think we can see
a mile away airplane?
You haven't done the triangles in the two different cosmoses.
Yes, I have done the triangles.
You don't have a good comparison.
The triangles are easy to do. Trigonometry is this is about the 5th grade level we're doing triangles.
So you went to a flat Earth realm and you went to a globe Earth realm and you did the triangles
that are at the 5th grade level.
So you went to the flat Earth realm and you went to the globe Earth realm and done the triangle in both realms and made the comparison?
I've done triangles in reality, and it seems that the ones that we observed didn't match.
But did you do the triangle in the flat Earth realm as you did in the globe Earth realm and made the comparison? No.
Any planar triangle we can successfully use trigonometry on, and if we presume
again, my point still stands. You're repeating your argument every time I give you a critique is not going to substantiate your argument.
So I guess it's my turn to repeat myself.
All the time. That's how you argue with me every single time. I give a critique and he repeats his argument, which I'm critiquing.
You get to repeat yourself, so I get to repeat myself. So, when we presume that
repeating your argument, which I'm critiquing, doesn't justify your argument.
You're still talking. Come on. You're still talking, dude. Jesus fucking Christ. All right. So, when the surface of the Earth, when we presume that it has no curvature, we have construct a planar triangle that contains those measurements, and we find out that what we measured in reality does not match.
Right, so you're comparing reality with the fiction that you know is a fiction that you made, a fiction that you made, and then saying it's not real.
Right, I assumed the Earth had no curvature, and it
so you're
turned
repeating
out
the argument
that my assumption
instead of
was
giving an argument to my critique.
It is because what I assumed, what my fiction was, that the Earth had no curvature, and it turned out reality doesn't match that.
That's your non sequitur conclusion from the two premises. The triangle's real, you told me. You did this, you assumed this on a flat Earth. Okay? So these two premises don't support the conclusion that it's not possible on the flat Earth. It's non sequitur.
It does. If I try to construct a triangle with that distance.
You haven't done the comparison between the two cosmoses.
when I try to construct a triangle with that distance, 200 miles, and that angle, 3 degrees, turns out that doesn't work.
How do you know that?
Oh yeah, and the height of 35,000 feet.
Because triangles are real.
So you
trigonometry is real.
reality, and you say we're on a flat Earth.
And Napalm, you just made my point too by your little article. Yes, with binoculars, things come into view. We can't see with the naked eye. I never said we did things with the naked eye. That would make any difference.
Is the
We're not looking at a candle. We're not looking at a candle. I'm looking at a lighthouse 200 miles away with a, I don't know the candle power of this lighthouse. I could find that out for you, but it's incredibly bright. And you don't need a set of binoculars. Although I have binoculars to look at things at those altitudes and distances.
So again,
so it's not the attenuation of light because you can still see it. So you're wrong.
You're wrong.
Not wrong. You just got done saying if you have a set of binoculars, you can see it. So it's not attenuation of light. It's basically your angular resolution. It's at the diffractive limit.
A bit more nuanced.
So again, you have not done the real comparison between the flat Earth cosmos and the globe Earth cosmos. You haven't done a comparison between two real cosmoses and two real triangles. Your comparison is unsubstantiated.
Oh my God! Seriously, how do you function as an adult?
This kind of logic. 35,000 feet, when you're viewing something 200 miles away, what is the diffraction limit?
0.02 degrees is the diffraction limit, but you see point sources of light that are much smaller because point sources of light act differently than just angular resolution. You know this, right?
Is the horizon a point source of light?
Is the horizon a point source of light? It acts as though it is, yes, because it follows the entire width of your field of view.
Can we address the fact that the question was asked at what distance and at what altitude the diffraction limit is?
Yeah,
Does anybody know what that actually means?
He's just making up things now.
Please elucidate to me how a distance and an altitude gives you a diffraction limit.
Is the horizon longer or wider than 0.02 degrees in your field of view? I rest my case because that's a silly.
We're still disputing the reliability of making the observation and the measurement angle between the HUD display. This granting them too much.
Can you explain to me why your boy said, what's the diffraction limit at that altitude and distance?
Dewis made a claim. He said he knows the size.
It should be the same no matter what.
What do you mean?
Okay, the diffraction limit for your eye is the same no matter what you're looking at and no matter how far away it is and no matter how high you are. So yes, thank you.
Thank you.
Unless you have a set of binoculars.
Say that.
I already said that. I agreed with you. There's a diffractive limit, 0.02 degrees.
Okay, y'all agree. Move on.
You couldn't answer it.
0.02 degrees.
It was a bad question. Yep.
Y'all agree. Move on.
Doofus claims he knows the size of ISS. How is it that he knows the size of ISS?
You're talking about Zanuck since he said that, but
sorry.
We know how far away it is.
Zanuck.
We know how far away it is.
At the size.
A simple parallax
you know the size of the ISS. How is it that you know that?
By
because NASA
angular size of it and its distance from you. It's not a hard calculation.
Okay, wait a minute. Hang on. How do you jump to the distance? How do you know the distance?
You can measure it.
You measure it.
How do you do that?
Two observers on the ground can measure a transit across the moon, for example.
How do you measure it?
Very easy to do. Should I put the description in the chat? Would that help you?
I want you to show me how to measure
Scott Manley's is really good.
Okay, let me put it. That's a good question.
6 7 times.
You don't
how do you
know
measure it?
I'll
So you
show you how
finally
you
answer
do
the
it.
question.
Right. If you
chat.
keep talking over the answer, it won't make it any.
No, he didn't give it to the first time the question was asked to him. How do you measure it?
Hold on.
All right. So you take two observers and you measure the angles to the transit as it transits something. Scott Manley did it with the sun. What is it? Astronomy Live did it with the moon with Red's Rhetoric, I believe. That's what the two observers were in his case.
Quick question:
just take two people on the ground.
Why do you need two observers if you can observe something from an airplane with one observer and make an angle measurement? Why do you need two observers when you're referring to the ISS?
My God. Hey, Palm, you can't be this silly. Seriously? Do you know what we're trying to explain here?
You're trying to measure the distance to something. You need a distance, which means you need two people that are separated by some amount.
So why is that possible with only one person then?
One person, you're just looking at a thing. You know its angular size. You don't know anything else.
All right then. So then this pilot in the cockpit looking the distance and 200 miles away, the airport, it can't get the angle then.
No, that's incorrect.
No, you're just missing the point altogether. I mean, seriously,
Christ,
you got to be trolling, or you got to be like
This
on drugs
doofus
right now.
character,
You're
this
saying
doofus
nonsense.
who's living up to his name, just told me that if one person is doing this, then he can't accomplish the task.
Because we're looking for a distance to. We already know the distance to the.
Hold on a
We
second,
already.
Zanuck.
Oh my god.
What I said specifically was that you cannot use one observer to determine the distance to something. In the other case, we're measuring an angle. You can, with one observer, measure an angle. That's easy to do. The two are not the same. Measuring a distance and measuring an angle have different requirements.
So you can use one person to measure the angular size, though, right? You can use one person to measure the angular size.
One person can measure the angular size, yes.
So if we take an ISS transit picture, we can measure the angular size, right?
Yep.
You see his two pictures in the chat I just posted?
Would that give us a distance if we know the actual size of the ISS?
Yes.
Well, you'd have to use the published figures that you're not willing to use, but
Well,
you
no,
can.
I got a jet in there, so we can figure it out by these two
the published
observations. Hey, Napalm,
published
listen
figures
to
are
me.
that it's slightly larger than about a 747, right?
Well, Napalm, if you hear me, I got a picture of two objects transiting the moon. We know, because we have a discerning eye, about why these two pictures are different. This is a flat Earth of response to the ISS versus a jetliner. And they talk about the altitude that these airliners fly at. And I think that's like some kind of case against the ISS. But we'll go into why that's totally wrong in a moment. The point here is that we can see a jet transit the moon. We know the angular size of the jet. If we know the angular size of the jet, and we know the size of the jet, we can then determine the distance to the jet. And in this case, it'd be roughly 200 miles away.
Yeah, well, about 150 probably. So the thing is, you're looking at this aircraft, the profile or the silhouette of it that you see, you clearly don't see the wings out to the side. So it's not overhead. It's near the horizon. It cannot be its altitude away from you.
And the yellowing of the moon showing you're going through atmosphere, meaning it's probably at the horizon.
Yeah.
How does the angular size and size of the jet inform you the distance from you?
That's trigonometry. More trigonometry for you.
Yeah. Yeah, if you know the size of the
invoking
jet,
the word trigonometry does not inform me of anything.
It
well,
does.
If you can just say I don't know trigonometry, Zanuck, help me, and I will definitely comply because I'm trying to help you understand, Gregor.
So rather than just invoking the word trigonometry, actually explain it in multiple sentences.
Yeah, I was about to.
I shouldn't have to tell you that, grown-ass man.
Yeah, I was about to when everything started going.
I wasn't talking to you. I was talking to Zanuck.
But you can use. He actually did this already for you. Thank you. The angular size and the published actual size. You compare those two, then you can find out what the distance is from you. He said that already.
Wait, say that again.
You take the angular size that you measured and the published figures. You get those two to compared. You compare those two together. You can figure out how far away it is.
That doesn't make sense. It doesn't follow.
It does. All right. So say I have an object that is 1 foot wide. We'll use freedom units, and it is in my field of view a 45-degree angle. Now it's 1 foot wide, and it's 45 degrees of my field of view. Can you figure out how far away it is from my eye?
Sure, there's your hypothetical. How'd you do this in real life? How did you get the angle?
Oh, dude.
And the distance.
How do you measure
in real life?
2022.
So explain how you got the angle measurement.
A camera.
You can't just make up a fictitious angle.
No, you can measure the angular size of the sun or the moon, and then you can if you want to take a picture of it like we did this transit, you know the moon is a certain angular size. Count pixels and see how many pixels. Because
you would have to get the distance. You would have to get the distance between you and the sun or whatever
object. You already get
object.
done to explaining to you. You can trigonometrically calculate this by the angular
it's not
size.
Required.
That's nonsense.
It's not required that you know the distance beforehand before you calculate the distance to it. That's
correct.
silly.
He already told you. Let's say we got 145
You're just
feet.
asserting that you can get the. You're just asserting that you can.
What
get
is the length of the airplane?
From invoking these two premises: the
Can you tell me
angular
the length
size
of
of
the
the
airplane
object
from that
and the
drawing?
size of the object, and you just assert that it can inform you. It doesn't actually make sense.
Gregory,
See the
Gregory, we know the angular size of the moon. If we take a picture, of something in front of the moon, and we know that the moon takes up so much size of the field of view, then we know that comparing the known angular size of the moon to the aircraft that's crossing in front of it, we can figure out what its angular size is.
How do you get the
then
angular
using
size?
the published figures for that aircraft, then we can
God,
figure out
Gregory,
how far
seriously?
away it is.
How do you get the angular size?
Oh, we just kept telling you
So
this.
we have the moon. It has a certain angular size, okay? You can come up with a measurement of the angular size of the moon independently if you would like to.
How did you
However,
get the
knowing
angular
that
size?
angular size of the moon,
again?
However, when we know the angular size of the moon and we take a picture of something in front of it, we can use the moon as a reference to figure out. We can use the moon as a reference. We can use the moon. We can use the moon as a reference to figure out what the actual angular size.
Buddy.
Jesus fucking Christ, dude!
Yeah, he asked you how you get the angular size.
It's got to be like Troll Central or something.
Okay. So when we get the angular size of the moon,
how you get it?
When we have something in front of it, we can use the moon as a reference to figure out the angular
did you
size
get the
of
angular
that
size
something
of the
that
moon?
crossed in front of it.
How
Put your
did you get
thumb
the
up.
angular size of the moon?
Oh, for fuck's sake!
Oh God, I have to substantiate my claims. Oh my God, I can't just take the angular size for granted. I have to demonstrate how I know.
All right. So you are aware that it's common. It's a common shorthand that the moon is roughly half a degree in angular size. Correct?
That's a
Are
shorthand.
you at least aware
What's
of
the
that
shorthand?
much?
I measured it.
That the
What the hell
moon
is
is
that noise?
typically about half a degree in angular size. You're aware of that, correct?
No.
No, you're not aware that the moon is usually about half a degree in angular size.
No.
Yeah, everybody knows that.
Oh my God, dude.
You do now.
All right. So now we know. Now if we use that shorthand in this particular example, we can come to some sort of distance for that aircraft, and it sure as shit is not 6 miles.
So then, how did you come to the conclusion that the moon is the angular size?
Well, I can measure it because I know at a certain
there's
distance.
ways you could do it yourself, like in your backyard or whatever.
Yeah, I measured it.
How? We know that 747 is 231 feet long. So we get the number of pixels across the moon in the picture. If we know the moon is a half a degree in angular size, we can then figure out what that airplane is in that picture. And then determine how far it is away based on the fact we know that the length of the airplane is 231 feet. It's not that hard. If you put your mind to it, Gregory, you can do this.
If you do know the angular size of the moon,
No, we do know the angular size of the moon.
Yeah,
we can't just start calling the angular size of the moon fake just because.
There's a lot of ways you can.
Yeah, have a look at the picture I put up.
Figuring it out.
Yeah, how do you know a 12-foot board is 12 feet long? You measure it.
It's worse than that, left.
How did you measure the 12-foot board? You took a ruler, you put it up on the board.
What angle in your field of view does it represent? For example, if something is a 45-degree angle above you, and all the way down to the ground, like a pole is looking at you. You're looking at a pole, like a light pole, and it was a 45-degree angle from the top of the pole to the bottom of the pole. You would say that thing had an angular size of 45 degrees, would you not?
How did you measure the angular size of the moon?
A protractor. I have a protractor right next to me, and I'm looking at the angle, and I'm sighting it to the top of the light pole. Or I could look straight up and then take a divide it in half and know that whatever halfway between straight up and the light pole, that'd be 45 degrees. Does everyone agree follow me now? So it's easy to find a 45-degree angle. And that angular size of that light pole at that point will be 45 degrees in angular size.
It's not an angular size. It's what it looks like.
No, it's an angular size.
That's what it looks like, dude.
What it looks like, really? Look at the peanut gallery.
Angular size.
The angular size would be 45 degrees.
Angular size is known as a parent size. It's how it looks. It's literally what it is.
You're talking about how it looks from a certain distance, right?
Angular size will increase and decrease as you approach and back away from something. Sure.
He tries to use these magic words like angular size. When
really, angular size is a magic word.
When really,
it's just what it represents in your field of view. It's what it represents in your field of view.
Let me quit panic. Okay.
Hello.
Okay.
Zanuck, you're just interrupting. You're just interrupting. Let someone speak.
So when we get down to it, right, we're like, well, what do you mean when you say angular size? And they'll say, well, how that looks out there.
No, what it represents in your field of view.
Yeah, it's an angle.
Everything represents itself in my field of view.
It doesn't represent itself. It represents an angle in your field of view.
Oh, okay. So I don't see the object. I see an angle. All right, here we go.
Please
you see the object in the angle in your field of view.
Can we just... Guys, can we put Write the Hand in a timeout for a moment? This is not helping.
I made a picture that hopefully should get everybody beyond this point. Okay? Here's an image. You know you have a 60-degree field of view. You know that the object takes up a fourth of the image. Okay? So what does it tell you? It tells you it has a 15, it's an angular size of 15 degrees from left to right.
It looks like that much over there. Yeah, that's all he's doing.
How do you know that the picture is representative of your perspective?
Oh my God, Gregory! And Write the Hand. My God,
that's a good question, Gregory. So it's not actually based on your vision. It's based on the sunrise to sunset. Say if you were on the equator and the moon or the sun actually passed directly over your head, it's treating the sky, the visible sky until it touches the ground, as a 180-degree protractor. And so from one horizon to the other, crossing right over your head, you can fit 180 moons across the sky if they're touching shoulder to shoulder. You know what I mean?
360.
Yeah.
360.
No, I said across the sky, not around a circle.
Yeah,
right?
180 degrees. 160.
No, you're right. Yeah. Sure.
Imagine there's 300 moons in the sky. Just imagine there's 360 moons in the sky. One of them would be
horizon to horizon. 360 moons in the sky, horizon to horizon.
Yeah. And then the one you see would be the one.
Why is this a mental block?
It's just I understand what you guys are trying to say.
I don't think you understand. You're not showing that you understand.
Okay. I just disagree with everything you're.
You can't disagree because it's basic physics. I mean, basic math.
We don't see in pixels, right? You're looking.
You're not talking in pixels, or we wouldn't.
You're looking at the moon, and you're going. Let's apply some kind of number to the moon that it's there.
We're talking an angle.
We measure. We actually measure it.
Angle,
right
bro.
hand.
You can.
Angle is what represents your field of view.
Aren't angles?
You can see 180 degrees from one horizon to the other, right hand?
No, what does that
mean? Take a picture of the moon.
That means if I look to the horizon and I look to the other horizon over water, I see 180.
No, I don't see 180. I just look around and I can see.
Oh my God, dude, you're hopeless.
Okay, but see, this is the problem. Hang on. Hang on. Let me just speak without interruption, please. The problem is, in reality, what we're doing is just looking, right? That's what we're doing. Now, he's going to try and quantify that looking with some kind of angular size mathematical equation, right? But you'll never do anything in reality. The only thing you've actually done in reality is look.
Or measure. We actually measure, too.
So you stretch the ruler from you to the moon.
Yeah, in reality, show me where you
need a ruler to the moon.
Oh my God! We can measure in rulers, or we can measure in angles. Do you know the difference between an angular measurement and a linear measurement?
You told me you weren't just looking at the moon. You said you did a measurement. Okay, so don't just look at the moon. Demonstrate the device you used to measure and how far you measured, verified with a measurement device.
How far you measured? That's not how angles work. Write the hand.
So what? Okay, so so what are you measuring then? What did you measure,
Chris? The angle is what I'm measuring.
But what angle? You're looking at the moon. Where's this angle?
You don't need a distance to measure fucking angle, Chris.
Oh, I'm asking you what you measured.
Hold on. The object changed depending on the distance.
You're looking at the moon,
right? But an angle does not depend on distance.
When did you measure this angle when you were looking at the moon?
All right, so we know from trigonometry that we can take a 1 foot object that we can take a, thanks for that. We can take, say, a 1 foot wide object. Thank you for that again. We can take a 1 foot wide object and measure the angles that it makes at certain distances. And we can use that to figure out how far away I need to be from that 1 foot object in order to have something be half a degree in my field of view. Then, once I have that figured out, I can use that as a comparison object against the moon. It turns out I've done something like that. The moon is about half a degree in angular size. You can verify this.
Okay, I got it. So that was pointless because we're just going to go right back to what you say when you went, we know. Okay, so when you start your when you start your entire argument with, well, we know, when I'm asking for a measurement, hang on. If I was going, I'd let you get all your bullshit out, right? So now we're going to go back to measurements, right? If I was going to measure my table, I wouldn't go, well, we know the table is 48 inches, so I don't need to measure it. No, we would take a ruler or a yardstick or some kind of standardized device, and we would make a measurement. Now, you need to show me where you did that and with what type of thing you measured, not just looking at the
you. Right ahead. They put their 2 fingers and then they measure the distance between the 2 fingers.
That's what it sounded like. That's what it's like.
Squish. So I'll go through the part that I said we know. What I said we know, I excluded you, I suppose, and maybe even Gregory. We know trigonometry does exist, and we can use it in the real world to determine what angles are to things in the distance. In fact, that's what, when you do roofing, 12/4, or 12/4, that's a rise over run, or 4/12. That gives you an angle at which the roof needs to be.
The roof itself is what you would measure, okay? Right? So the roof is tiles and shingles, and you would measure that. Now, when you looked at the moon, what is the roof that you measured?
Oh, my God. Can we please just skip
I know. Your entire argument is hinged.
Oh, my God. It's hard now. A real question that I need to answer. Oh, my God.
Guys, can
no, it's not a real question.
You measure the roof
it's
of the
not
moon?
A real question. Okay,
what kind of question is that?
Don't worry about the roof that he never measured in the moon analogy or what he's saying he did. But we'll just move on. So we're just going to accept with blind faith, like a religious fundamentalist, what you say. And oh my God, I can't believe he asked me to prove it. No, we don't do this. We just accept it on faith.
No, actually, what the entire argument about the 12/4 or the 4/12 roof is about is, you know, that at a distance, the 12, a certain size of something, 4, will give you a certain angle. That is what I'm talking about. Trigonometry is something we use in everyday life to figure out what the angle of things are in the distance.
Okay, so still, what was the roof that you measured? Because all I'm hearing from you is...
I just told you 12/4.
No, that was all imagination. You didn't mention anything in reality. You talked about trigonometry, and trigonometry is reality. It's not what, it's just the word you say. It sounds. Okay, so what did you... Hang on. What did you tell me very specifically? In reality, I took this device and measured this thing. This is what I measured. Don't just say trigonometry.
Right, I took a 1 foot comparison object and gave it an amount of distance between me and that object, which would represent half of a degree in angular size, because I know trigonometry works.
So you held up a quarter.
The distance is required for the trigonometry.
Don't you need the distance exactly?
I used a comparison object I knew the size of and knew the distance to in order to come up with a known angle.
Hold on. So
you don't need the distance to the moon in order to make the comparison that I'm making.
But you need the distance, exactly.
See, but guys,
no, you don't.
It works with the inverse square law, guys. So
he's using angular size on the side.
It has nothing to do with the inverse square law. Thank you.
We asked him. I asked him what he did in reality.
The degree that something shrinks in your vision and the distance as it goes away doesn't have to do with the inverse square law.
It's not an inverse. No, it's not the inverse square law.
Yeah. No, it had nothing to do with the inverse square law.
Bro, what did he do in reality? He held up something, and he held a quarter in his hand. Because I was like, don't give me this word jargon. What did you do? He goes, I took a comparison object. Yeah, that means he took a baseball in his hand. And then he's like, I held it up. So he takes a baseball, he holds it up, He looks at the
Why
baseball.
not use the comparison object I actually used?
Well, okay, what was the comparison object?
My comparison object was a 1 foot length of wood.
Well, you can't just use a length. You had a wood. So it was a wood block?
Yeah.
Okay, so he cuts 1 foot off of a 2x4. He holds it up to above his head. He looks at it. Then he looks at the moon, and this is his measurement. This is what he did.
No.
This is ridiculous, bro. When you act out, when you verbalize,
yeah, what you're saying is ridiculous.
When you verbalize,
it's not what I said.
Wait, I wanna explain how it does have to do with the inverse square law. So if you have a square piece of wood that's colored into 4 sections, right? A red, blue, green, and yellow section. Just 4 squares making up this square, and then it takes up a certain size in your view, and then you double the distance that thing is from you. That the new size of it in your vision will be the same as how much size one of the corners, just the red square of that original one, took up in the first sight.
Okay, that's not the inverse square law. It's half its angular size, not a quarter.
You think if you double, it's half the size? Double the distance? Half the
Double
size?
the distance, half the size, yes.
Yeah, half the angular size. Angular size is not square area.
Now you're talking about just one dimension.
I'm always talking about one dimension when I'm talking about angular size, because that's what it is.
I'm talking about the overall size of it taking up in your vision.
Okay,
not just
that is not
height
angular
changing.
size. Thank you.
I mean, that is angular size.
It's not. Angular size
I'm looking
is
at this article
one-dimensional.
right
It is
now.
not two-dimensional.
I'm looking at this article right now, lonewolfonline.net. I'm looking at the sentences. The angular size of an object is determined by its actual size and its distance from the observer. For an object
You
of
can
fixed
calculate it
size, the
that way.
larger the distance, the smaller the angular size. For objects at a fixed distance, the larger the actual size of an object, the larger its angular size.
where's the part where you hold up the piece of wood? Did you skip that part?
Right, you can calculate the angular size of something knowing its size and its distance, which is the thing that I mentioned.
So how did you
about
get the
my
distance?
comparison? Thank you for interrupting before I was finished.
Like,
So
that's
that's
the
what I
crux
was
of the
mentioning
issue,
when I
you keep avoiding
thank
it.
you for interrupting yet again. Thank you. So when you take a known object with a known size and a known distance, you can calculate the angular size. When you have the angular
Yes,
size
that's my point.
and the
But you don't
distance
know.
to an object, you can then calculate its actual size.
But
And when you
Right, so how
have
did you get
Sort
the
of size of
distance?
and when you
nobody.
have
You
and
see
when
how
you
you keep repeating
have
yourself every time I
and
ask him the
when
question,
you
how did you get the
have
distance?
and when you have hey Jesus
dang.
fucking Christ, Gregory.
Buddy, stop cursing.
Like, if you have the distance, if you have the angular size, then you can calculate the angular size. How did you get the distance?
Did I get to finish what I was saying, or did you cut in before I finished?
Well, he did interrupt you, but I always wonder, Doofus, when you yell like that, is there anyone in your house that's like, what is he doing up there in his room, just shouting into his mic at the top of his lungs?
Well, they recognize that the people I'm talking to are too
Answer the
arrogant
question.
to allow me to finish what I'm saying. Look, he did it again.
All right, I'll temporarily mute him so you can speak. He is interrupting, so go ahead.
All right. So there are 3 things. You can have the size of the object, the distance to the object, and the angular size. Given any 2 of those, you can find out the third. If you have the actual size of the object and the distance to the object, you can figure out the angular size. If you have the angular size and the distance to the object, you can find out the actual size. If you have the actual size and the angular size, you can find out the distance to the object. You don't have to have the distance.
So how do you get the distance or the size of the moon?
But the
All right,
article just
so
said the
when
angular
I
size
when
of
I
an
make
object.
Question was posted, Gregory. Hold on.
I can tell you about techniques.
Okay, when I make an object of a known size, and then I get myself a certain amount of distance away from it,
Don't
then
give
I
a
know.
shit about your object. I ask you about the moon. I don't give a shit about anything about here in the earth. I asked you
Okay.
about the moon.
Will you allow me to finish talking this time? Let's see how long this works.
Stop this.
Let me go ahead and see how long this works until I get an opportunity to finish. Let me go ahead and see how long it takes for me to get an opportunity to finish.
If you don't
Let me see how long this takes. Let me see how long this takes until I get an opportunity to finish talking. Let me see how long this will take until I get an opportunity.
All right. Until you start answering what I ask you, then you can go ahead. I'll be quiet.
Thank you.
Now.
I will answer the question as completely as I can so that you can't confuse it later. So let's start from the beginning. If I have an object with a known size, known distance from me, I can calculate its angular size. I need to get as far away from that object so that it is half a degree in angular size. Now, using that comparison object, which I know to be half a degree in angular size, I can put it next to the moon to see if the moon is the same angular size, thereby confirming that the moon is half a degree in angular size.
All right, stop there. Let me answer to that so far. Okay. So you're comparing the angular size, but at this point, you don't know if the moon can be closer to you and smaller or farther and bigger.
Closer and bigger, farther and smaller.
It will make no difference to where you are. So at this point, all this process that you have done is crap.
That's your opinion.
Yeah, the article says right here, the angular size of an object
the process that I went, thanks, Gregory,
and its distance.
Yeah, but it's
the process that I went through was to come to a conclusion.
You're assuming.
Jesus fucking Christ.
Guy,
Sorry to interrupt you, but you're assuming everything. It's assumptions.
Hold on.
Start
Gene,
to finish.
can you hear me talking? Guys, you've got to start giving each other a bit of room. It's getting audio chaos. So just give each other a bit of room and let people finish and then carry on. Cheers.
All right. The
can we get to the crux of the matter?
The comparison object was only used to determine what the angular size of the moon is. I'm not caring about the distance to the moon in this particular example because the question was, what is its angular size? I can measure its angular size with this comparison object and have done so. Therefore, the moon is about half a degree in angular size. You can call it useless to say that, but it's not.
Can I ask you if the medium is fairly consistent between you and the object in comparison to what you're contrasting to the moon, and if the medium is consistent between you and the moon? Like, you would have to go through all these variables in order to like gather accurate, information rather than just biased one.
No, the information I need is that the moon takes up a certain amount of my field of view, and that angular size is what I'm measuring.
I understand.
I don't give a shit about what medium it's going through.
Well, the problem is light mixed with an atmosphere has a lensing effect, and when you have the lack of an atmosphere or a minimal atmosphere, then it's going to obscure the overall size of the moon or the object, depending if it's celestial or terrestrial observation.
Well, could we just stick with the angular size measurement, and then we can address the refractive effects?
But even worse than that, he's trying to get the angular size without the distance. But it says right here, the angular size of an object is determined by its actual size and distance.
Did you see what I typed out?
Yeah, Gregory, it seems that you aren't listening to the conversation again. I said you can have three things, and you can determine one of them given the other two. You don't need the distance if you have the angular size and the actual size of the object. You can calculate.
But you can't get the angular size without knowing the distance.
So
That's not true, Gregory.
Rube, you're not meeting Gregory where he's at.
It's not double speak, you dumb fuck.
Oh wow, taking too far there, man.
Yeah, we don't need.
No, he's being really stupid. Seriously, you find the angular size by finding the angular size. There's a lot of ways to do that. If you know the angular size and you know the actual size of the object in real life, you can determine the distance. Why is this so hard to understand?
Yeah, if you do know the angular size, but you can't know the angular size without knowing the distance.
You can figure it out. You can measure it. You can, for example,
in order to get the angular size, you need the distance and the actual size of the object.
For example, you can measure your thumb, arm's length from your eyes. That's roughly a half a degree.
Let somebody else help Gregory out. He's really got this confused.
Gregory, take it from me, man. you're misunderstanding what you're reading, and it's a simple mistake that you're making. And so the factors that will affect how large something appears to you in your vision are distance and its size.
Yes.
But that's what determines how much of your field of view it takes up. But you can take a direct measurement of how large something appears in your vision, because all you're doing is just measuring how much something takes up in your vision. That is the angular size. Now, the factors that affect, angular size is how close or how distant that object is. That's one of the factors, but you're misunderstanding what you were reading there.
This doesn't make sense. How do you get the angular size? How do you get the angular size without the distance?
Yeah, I can tell you. Yeah, I can tell you. Okay, so check this out, Gregory.
He holds that piece of wood up.
Gregory. Okay, so you plant your feet firmly in one position. Then you take a rope of any length, okay? And then you get someone, you stand on one end of the rope, someone takes the other end of the rope and traces a circle around your body that you stand in the center of, right? So now you got a perfect circle around you. Now you drill 360 holes in the perimeter, the circumference of that circle traced around you, and you find 360 really long, tall metal beams that will fit into every single one of those slots, all right? When you insert one metal beam into any one of those 360 holes around the circle around you that you're staying in the center of, that pole will take up 1 degree of your vision. And you can get a friend, if you're looking at something in the distance and you want to see how much of your field of view it takes up, you ask them to work with you and put beams in front of the thing you're looking at, and for every beam they place down in order to cover up that thing and obscure it in your vision will be 1 degree of angular size that thing is in your vision. And you can measure it that way 1 degree at a time for each metal bar needed to be put in front of it to completely obscure it.
That was very nice.
So you do this in real life?
Well done.
Yeah, you can do that. You can absolutely do that. You don't need holes. You just need something that can be placed in a circle around you, tall enough to get in the way of whatever you're trying to look at.
So you surround yourself with 2x4s, you drill holes in the 2x4s, and then you start spinning in a circle, and that's how you measure.
Oh my gosh! Leave it to right to hand to really fuck up a beautiful.
Left the nuts, got it figured out.
Hang on. So this circle is standing vertically around me, Ghost. It's standing up vertically around me. And there's 360 holes around the perimeter of the circle, and then you stick humongous long
just
rods.
Tall. They're very thin, but
long rods in the holes. And then you got something away from you, stretching from you on a rope, and it's standing away from you at a certain distance. And someone gets a wooden beam and puts it in front of the object.
What?
Yeah, you know if you put 360 like things that are standing side by side to each other in a perfect circle distance away, an equal radius around you in all the directions, you know that thing takes up 1% of your, 1 degree of your vision. Another way you could do it is if you built a perfectly circular cylinder around you, made of any material you want. Let's say it's wood, like you make a wooden yurt or just a circular wooden structure around you, and then you drill 360 windows in it. They're probably going to be small, depending on how big the structure you make is. But you drill 360 peepholes in a circle around you at eye level, and then you can just mark them off with numbers above it and say, how many windows does this thing is visible from until I'm looking to the left or the right of that object through these holes. It takes up, 5 of those holes. That thing is 5 degrees wide of my vision.
Is this whole elaborate hypothetical done in real life?
Yes. Yeah. Everyone. Yeah. This is how you do it. I mean, there's better ways that don't require
around
giant
themselves.
structures.
People set up a humongous circle around themselves and stick long rods in these
See,
circles.
this means You gotta be a troll. These are the questions you cannot be asking if you have an IQ above 10.
So it doesn't.
Okay, so how do you do it in real life?
Yeah, it doesn't actually have to be a humongous structure. The circle around you can be as the radius of the circle can be as short or as long as you want. All that matters is getting objects that can be placed around you that can fit 360 of these objects on that circle. So the shorter the circumference, the skinnier each beam has to be.
But what am I doing in real life when I'm looking at the moon?
You got to build the wall of beams around you first.
You could honestly do it with a sombrero, right? You take a sombrero and then you glue 360. You take a sombrero and then you glue 360 chopsticks hanging plumb from that sombrero.
Are you trolling us? If a flat earther told you this, if a flat earther had 360 chopsticks on a sombrero and he was telling you about the thing, you would take him serious?
That's how you can measure angular size.
I'm saying Geo puts the sombrero on.
Yeah, I have to come in.
You take him serious?
Yeah,
you would take me serious?
Fundamental.
So fundamental chopsticks hanging from a sombrero. This is fundamental.
Yeah, Fundy's is demonstrating a great knowledge of how to measure angular size. I have to commend him on that. Yes, he's doing a good job.
360 chopsticks on a sombrero. If that's your
height of knowledge,
I'm just saying, if
not
that's
these
your
hypotheticals.
We're being so harsh, bro.
Height of knowledge,
like this is legit stuff, okay?
No, I know. 360 chopsticks hanging from a sombrero. Can you do a cowboy hat? Does it have to be a sombrero?
Hold on, guys. It is possible to do that. It doesn't mean that you can tell the size or the distance of an object based on that.
No, you can't tell the distance, but you can tell the angular size. But what you can't tell is the true size.
The angular size, it may be a false size in reality.
I mean, you may do that method. So you do this series of actions. You do this series of actions like you described. Wait. I'm trying to get to the bottom of the matter instead of repeating ourselves. So you do these series of actions. Okay, you do what you described. And then you can assert that you got the angular size. But that's not how the angular size is derived. I'm reading it.
See, you're misunderstanding what you're reading, Gregory. Trust me. It's what it said. So when you read it out loud, you said the angular size is. Hold on, please. What you read out loud is that the angular size is determined, not discerned. And when it says determined, it doesn't mean how you come to determine angular size. It means the things that play a part in how big something appears in your vision are its distance and the actual legitimate real size that the object is.
Fundy, distinction without a difference. What? It's distinction without a difference. What? No, how you ascertain knowledge of the angular size of the object is taking into account the actual size and the distance of the object.
Fundy and Gregory, it's derived. The word they use is derived, which means
they got to put chopsticks and sombreros in there. They got it wrong. It's not distance.
That's how you get the angular size. You're telling me that you don't need the distance to get the angular size, but these people, these experts, are saying otherwise. And you saying to me you can do this elaborate process with a sombrero, a humongous circle around you, with long rods stretching out into the distance, and then slapping digits and objects on the objects in the distance. And I have the angular size, but that's not accurate.
One more comment, and this is my final attempt, or just final point. There is no such thing as a false angular size. An angular size is just what something looks like. It's an apparent thing, not an actual.
That's 25 fucking minutes ago. Jesus fuck.
So sorry to interrupt. It's an assumption. It's an assumed. You're assuming.
No. Oh my god, we listened to all of that bullshit just so you can be like, really, all it really is going, that's what that thing looks like. Yeah, I know.
That. But it's also a standardized unit.
Yeah, it's calculable. So you calculate this angular size with the actual size and the distance.
No, you just observe.
You can calculate it that way, but you can also measure it directly.
I know it's apparent. I know the nature of the calculation. I know the nature of the thing that I'm trying to calculate, but it is a calculation. And the way you calculate the angular size, the size that it appears to appear, is with the actual size and distance.
Right, and his fundamental was going through. He painstakingly detailed how you can measure it directly without knowing the distance.
But that's not accurate. Your method is wrong.
All right, check this out.
That's your opinion.
One more thing, Greg.
fact.
So
Hold the brick up while wearing a
If you
sombrero
close your
using
eyes.
chopsticks.
No, hold on. Okay, if you close your eyes, all right, you just close your eyes, and someone just describes something to you that somehow they have insight on. If you close your eyes and someone says there is an object this big and it is this far away from you and it appears as a circle, then you can do the math in your head to understand it. When you open your eyes, you can guess how much of your vision it'll take up. If you have those two things, you can do the math in your head, and without even looking, you'll know how it will look to you before you open your eyes. But you only.
But it's not accurate, though. That's not going to be accurate, is it? Unless you measure it. So that's another assumption.
That's where Daislow's
Can
involvement
I
of the
get this point
medium
across?
comes in.
But we
I need
can't
to get this
talk to each
point
other.
across that everything you've said is one massive assumption. Because unless you know the actual size of that moon and the distance, you will never get the exact size. You never will.
The angular
Never.
size.
No, yeah, you're right about the actual size, but angular size is just how much of your vision it takes up from where you're
Still
standing and
requires
looking
a
at
size.
it.
That's not the mere nature of angular size.
Guys, that is true. I don't know why you guys keep arguing about it. It is true, but it doesn't mean that they can know the distance or the size of objects.
That's right.
We
That's
keep
what I
listening
just
to the
said.
point. You can't get the angular size without the actual size and the distance.
Yeah, exactly.
That's what we're
It's
saying.
not just it's not just a mere speculation.
Hold on, the real angular size you're talking about, right? Because they can have an angular size, but it's not gonna be.
It's not the real one.
Like, it's not gonna tell you a real distance or size.
But it's not accurate.
There's
Exactly,
no
it's
such
not
thing.
accurate. Yeah.
There's no
The angular
such thing
size
as
you
a
measured
real
was the real
versus
angular size.
There's no such thing as a fake versus real angular size.
But that's
yes,
not
there is.
the point, Funky.
Yes,
You're whistling past the point. We know it's an angular size. We know the angular size is not the actual size. We know. You can't get the angular size without the actual size in distance. If you don't have the distance, you can't get the angular size.
You can't calculate with your
Gregory.
eyes closed. No, your point is that you can't calculate the angular size with your eyes closed. That's fine.
No, that's not the point. No, that's not the point. No. Your eyes being closed is not equivalent to what I just said. Your eyes being closed is not equivalent to what I just said. If you don't have the distance, the calculated distance, and the calculated actual size, you can't get the angular size.
Yeah, and how did they get that off the moon? How did they get the
measure
angular size
it.
of the moon and the distance?
You can measure it.
How?
You can measure.
How did you measure the distance and the actual size of the moon to get the angular size of the moon?
Hanging along the rim.
The sombrero, bro. You're forgetting about the sombrero.
I mean, that's literally the easiest way you could do it for yourself. It doesn't have to be a sombrero. Just literally anything
Cowboy
that will.
Well, what he's
Literally
essentially done, write the hand in Gregory. What he's essentially done is he's constructed a protractor around your head. Only like two.
But hasn't calculated the actual size of the moon and the distance thereof.
Thanks for cutting in like that. So when you have a protractor and you have two references on that protractor, you can measure an angle. And now what he's doing is he's put all these references around you, so you can use any two of those to find out what the angular size of the thing in the distance is.
No, it's still not right. Still not right. I wouldn't bet my life.
You can say no,
I
but
would not bet my life on your method. I would not bet my life or my family's life on your method. No
I mean,
way.
who in the world did this method? What professional in the world did this method to get the angular size of anything? Who?
Literally all of our ancestors.
So, bro, get out.
Your ancestors, hey, they weren't putting sombreros on and walking around. That's not how you, bro.
I gave three options. They
that's not a dude. When you put freaking chopsticks from a cowboy hat and look around, that if that is your standard of a measurement, I'm like, bro, that's not a measurement, man.
So I'm curious. I'm curious, Fundy. Is there any specifics as far as like how big the platform or cylinder would have to be, or the thickness of the rods or
Well, one thing,
there is.
One thing you could do, you could measure the circumference of that circle, divide by 360, and that would be the dimension of each rod.
So, Dicelo, the circle around you can be as big or small as you want. All that is necessary is to be able to put 360 demarcators along the circumference of whatever you're putting yourself in the circle of. So you could use something very small, like chopsticks hanging from a sombrero, or you could use giant logs a mile away from you, or flagpoles. Just as long as you can fit 360.
I would assume there would be
accurate readings.
I would assume there would be some ratio as to the distance from the object obscuring your view versus the thickness of that object, and there's got to be some sort of a proportionality.
Yeah,
right?
yeah, it's a consistent give and take for the width of the markers versus the
Totally
length of the
inaccurate.
radius. For sure.
Totally inaccurate. It's inaccurate. You're not going to get precise dimensions and distances because they had to go to the moon. Remember, they had to know the exact distance there and back, so they had the right amount of fuel and everything else. Bullshit. You can't.
I don't have to go to the moon to know how much of my field of view something takes up in my vision.
But we're not talking about field of view, though.
Would this be comparable to
protractor?
Angular size is field of view.
I got another question real quick.
That value without the actual size and distance.
Angular size is rooted 100% just in how much of something it takes up in your field of view.
So how do you know your makeshift protractor is accurate?
I got a quick question. Snipers will essentially look through their scope and determine the distance of the target because they can already determine an average size of a human chest. So that's kind of like dead center mass of what they're always aiming for. So yeah, they'd say about 17 inches, right? And depending on how much 17 inches of circumference fits within the parameters already marked out on that scope, kind of helps them determine the distance of the target. Would this kind of like be analogous to angular size and?
Yeah, it's a very dark and very correct example of angular size, and using that to figure out distance.
And the only guesswork comes in is dealing with something like a human body that you can make an estimate for to get like kind of a good guess, right, or a pretty accurate guess.
So without the distance, you just have an observation of the object in the distance, maybe also the actual size.
Well, I can tell you something where you wouldn't need any guesswork, and that would be like the moon, for instance, because all you would need is the time it takes for the moon to go around in one night, then pick up and come back in the same place, which would be 360 degrees. So you take the amount of time that is, about 1,480 minutes, and then you could take the amount of time it takes for the moon to completely pass some object from bottom to top, like the horizon, for example. And if you time,
you're a little lost in the conversation.
If you time the time it takes for the moon to pass the horizon from bottom to top, about 2 minutes, and you divide that into the amount of time it takes to do 360 degrees, you can get the exact angular size of the moon.
Let him finish.
You're a little lost in the conversation, bro. We weren't talking about techniques.
That's exactly how you measure the angular size of them. That's how they make
I already gave 4 versions that don't require guesswork and are much more simple than what you laid out. We moved past that. When we were talking about guesswork, you're just a little lost in yours not needing guesswork versus the type of guesswork we were laying out in the other example.
But I'm giving you an example of an angular size where you wouldn't require guesswork.
No, yeah, that's not what we're talking about. I already laid out 4 different versions of the system that requires no guesswork.
That doesn't mean anything, buddy. The moon can go either go faster and be farther away, can be going slower and be closer to you, can be bigger. Like there's so many variables that you're just making assertions. So
none of those angles matter.
A lot of people are having different conversations.
It does matter. I mean, you can keep saying that it's okay. Right.
Yeah, angles don't care about distance.
Well, if you're gonna put a number on how much that moon travel on that through that angle, yeah, it does matter.
No, an angle does not care about distance. If you observe if you observe the moon to be making a 360-degree cycle over a certain period of time,
yeah,
and that you measure that period of time, and you take the amount of time it takes for the moon to be from beginning to end obscured by the surface of the earth, that amount of time out of that circuit gives you the proportion of that circle that it took for it to be obscured, which gives you the angular size of the moon as well. It's just not a very clean example like the sombrero was.
Listen.
Yeah, the sombrero is much better, but that is another
1,000
viable
miles
technique.
an hour, whatever, 1,000 miles an hour, and can be really far away. It can be going like 50 miles, and can be like it can be closer to you. And it's gonna take the same time. It's gonna take the same time to go around.
Right. So angles don't matter, or distances don't matter to angles. Thank you.
They do.
I just telling you how they do matter, and you just, man.
Right. So if I have an object that is 1 mile away from me and it's moving at 50 miles per hour, and then I have an object that's 2 miles away from me going 100 miles.
Hold on,
Thank you for
caveat right there, because you already told me the distance and the speed, buddy.
Thank you for allowing me to finish.
See,
Thank
here,
you for allowing me to finish talking. Thank you for allowing me to finish talking. Thank you for allowing me to finish talking.
You just gave us the distance. Thank you.
You keep doing this shit. We're trying to figure out the distance and the size, and you just give me the distance and the speed. You give me those two things, which are the things that we're trying to figure out. Damn.
Well,
Thank you for allowing me to finish talking. Let me go ahead and finish. If you have an object that's 1 mile away from you, moving at 50 miles per hour, and you have another object that's 2 miles away from you, moving at 100 miles per hour, the angle at which those two objects appear to change in your field of view will be the same. The distance does not matter.
No, the further away something is, the smaller it appears. The closer it is, the bigger it appears.
Exactly.
That is
true.
true.
For fuck's sake.
No, for fuck's sake.
Check this out.
Right, so
Greg.
if I move something that's 50 miles away or 1 mile away from me, a certain distance, and then 2 miles away from me, double that distance that it moves, the angle at which it changed in my field of view will be the same, correct or no?
Correct.
We're not talking about how it appears to you subjectively. We're talking about the calculable angular size.
It's not subjective, that's objective.
About angular size.
We are talking about angular size.
It's the same kind of thing because you got an
jumped
object
in
that has
3
a
minutes
certain
ago,
amount of
Brenda. You don't
size
know
that
what
it
we're talking about.
I wanna say another thing to you, Gregory. I can take a direct observation of something's angular size with my chopstick sombrero. However, once I've determined the angular size just through direct observation, that gives me absolutely no insight onto the thing's distance or actual size. Okay,
right.
I can directly
That's right.
observe something's angular size, but that has no bearing and offers me no understanding on its actual distance or actual size. But what it does is provides an infinite sliding scale where that thing could be enormous and far away, or small and right in front of my face and close. I can't tell just by angular size, but what I can do is take a direct observation of angular size. So if you want to take a direct observation of angular size, which you can do with my sombrero chopsticks, and you happen to know what you're working with, what you're looking at, like a person who you like have measured them yourself and then they walk away, you can tell how far they've walked away from you with my sombrero hat and an understanding of their physical height that you verified yourself while they were in front of you. And as they walk away...
Your sombrero hat is not standing the right way. It's supposed to be vertical, not horizontal. And you're just measuring the angle between the protractor and the object.
They shrink widthwise in the distance as well. So it doesn't matter.
But your makeshift protractor, which should be standing vertically, is just measuring the angle that the object is from the surface.
No, I can measure how much they shrink widthwise instead of turning my head sideways and doing them heightwise. If I measure like the breadth of their shoulders, I can apply the same thing with my sombrero
No, this
hat.
is wrong. This is wrong. Your makeshift protractor, standing vertically as it should, is only going to measure the angle of the object relative to the surface.
Why does it have
not
to
the
be
angular
vertical? Why are you
size
making that
of the object
stipulation?
in your perspective?
But why are you making the stipulation that it has to be vertical?
Because I mean, hello. If it's horizontal, then you're not measuring. I mean, I guess you're measuring. If you hold it horizontal, if you hold it horizontal, then it would just be measuring the angle relative to the bottom of the protractor, which is not informative of the angular size.
Instead of a person, to make it more reasonable with my sombrero hat that I don't need to tilt my head sideways, let's just make it a ball that I know the diameter of. A big giant ball
Well,
that
that means
rolls
you
away.
know the diameter.
Yeah, you would have to know the diameter. But yeah, you would have to measure that with your own tape measure or whatever. Yeah, you'd have to do that in person for yourself to know the size of the ball. But if you do have direct experience and knowledge on the size of the ball, and you're wearing the sombrero hat, then you can know at any moment how far away it is from you. As long as you can still see it.
Yeah, but you don't know that about the moon. The moon is, you don't know that about the moon. Highly irregular, not precise.
Yeah, you can't do that with the moon. Yeah, we don't know how big the moon is, legitimately, and we don't know how far away it is. All we can do is take a direct observation of the angular size with my sombrero.
That does not inform you of its angular size.
That's highly irregular.
That doesn't inform you of its angular size. That method is wrong.
That's a direct observation of angular size.
Highly irregular.
No, it's not. You have not calculated anything.
It is.
You don't need to calculate angular size. You can measure it directly.
Yeah.
Don't have this man
You have not accurately calculated the angular size of the object.
You don't have
It's
to calculate
wrong.
it, though. You can measure it
Every
directly.
article that I'm reading here is telling you that you're wrong. You can't just take a protractor and point it at something and say you've gotten the angular size of the object. You don't have its actual size. You don't have its distance. So you can't calculate its angular size.
You can if you put markers in a perfect circle around you.
No, the more you say you can't do it, the more you say you can do it, the more wrong it is. You can't. It's not going to become
You won't
true.
know the depth, the diameter.
If Gregory
You won't
had his
know
way,
it.
you
can't
cannot
know.
make measurements of angles at distances.
Yeah.
Unknown distances, even.
Yeah. Sorry, that's absolutely highly
Hey,
irregular.
Gregory.
But the question still stands.
The
How
angular,
did they
the
know the
angular
distance
size.
to the moon and the size of the moon? How did they work that out?
I
That's still on
posted
the
2
table.
articles in the text chat.
The angular size is correct, but it's an apparent angular size, isn't it, Van?
That's redundant. It's angular size.
And that's all it will ever be. Angular size
Exactly.
is yeah.
Exactly, which is what you said at the very start, pretty much.
Yep, and you can measure it.
Yeah, you guys are killing me, Gregory.
I know,
Man,
I know.
you're killing me, man.
No, that's
How don't you measure angular size?
that's a perfectly reasonable measurement. But what you're saying, Gregory, is correct. But it's reversible as well. That's so what you're saying. The equation you're talking about.
What? Would be reversible?
The equation you're talking about the distance.
It's not. It's
and
not
actual
reversible.
size.
You have to know two.
It is reverse. It is indeed in reverse. Any algebraic equation is reversible.
No, you can't know one and calculate the other two. You need two known for certain to calculate the missing third, which doesn't make it inverse. It means it has 3 different positions it can occupy, not one or the other. It's this, that, or the third.
Thank you for interrupting me, dude. But that's my point. Of course, you need 2. The point is that if you have, you can use the equation you just described to find out what the angular size is, but you can use the angular size and one of the other 2 variables to determine the third one. And then in the case of the moon, that's how it was originally done.
That's not coherent. It can't simultaneously be the case. You can get the angular size with the actual size and distance, and you can get the angular size with the actual size and without the distance.
Yeah, he messed up. He messed up by saying you can do the opposite of your equation. What he meant is you can shift it 1 position over, but regardless, if you want to calculate the third, you have to know for certain what the other 2 factors are.
Yeah, saying you can do the equation in reverse is just saying I can switch the digits to the other side of the page.
I'm telling you that you can find out the third variable by knowing any 2 of them.
I can walk
so you can have the angular size before you have the other 2.
Kosho,
you can't. You need the two to get the one.
No. In the case that I told you, I described to you how you can get the angular size without knowing the distance or the size.
No, you didn't. You cannot do it. No matter how many times you people say you can, you can't.
You can.
So do the thing that you say you
method for
cannot
doing
do.
Hey Gregory, I can measure something's actual size without needing its angular size known, right? Like I can just pull out a ruler and actually measure something directly, a direct measurement of its size. That applies. You can measure something's size directly. You can measure something's distance directly with a tape measure, and you can measure something's angular size directly. Each of these things can be approached and understood with direct measurements.
Yeah, you can't. You can't. You just can't. It's impossible. You can't know the size of a.
I can't do it for things I can't reach.
Hang on a second. You
I can't do it to the moon because I can't go there with a.
You can't. Yeah, you can't know the size of a distant vehicle. You don't know the distance. You don't know the size. You can't. You can't.
No, any of those things can be learned through direct experience without any regard for the other two. I can measure something's size through like in all sorts of ways. I can measure something's size. I don't know its angular size. I don't know its distance, but I can.
It's impossible. You will not know that size. It's not possible.
But you're falsely equating, Fundy.
Yeah.
You're falsely equating angular size with actual size and distance.
No,
Angular size is dependent on the actual size and distance. That's the fact. That's how you do it.
I'd lay my life on that. You can't do that. That I'll lay my life on. The fact that you can do that, I will not lay my life on. You can't do that. I'd lay my life that you cannot do that.
Just like you can take a direct measurement of something's distance from you by using a tape measure and dragging it from the object to wherever you want to be a distance from it. You can say, I have measured directly that I am 10 feet away from this thing by sticking out a 10-foot stick and poking it. I know that I'm 10 feet away. That's a direct measurement of distance. You can also just take, through a different method that uses a different type of measuring device, something's angular size through direct measurement.
But you misconceive the use of your protractor. Your protractor is not telling you the angular size when you point it at the object.
A sombrero with 360 chopsticks hanging along the brim, hanging plumb, will tell me that the angle, any circle around you of equal radius with you at its center point with markers will give you a direct observation of something's angular size.
That doesn't inform you of its angular size in your perspective. That is not the way you calculate that. This is informing you of the angle relative to the surface.
That's literally the only thing it does, and it does it very well, actually.
It is not telling you the angular size. It is telling you the angle of the object changes the surface of the ground.
Absolutely killing me. I gotta stop. I really do.
I don't know, man. I don't know if you're not understanding what angular size means or what.
I just read it. From EU.
It can be determined or derived from two other things. Sure, that is correct. However, that same formula can be run in different directions. If you have any of those two things, you can know what the third one is. It doesn't matter.
That's what I've been saying. You're repeating that back to me like I'm the stupid one.
If you have any two of them, you can find out what the third one is.
Repeating that back to me like I wasn't saying that the entire time. Like I'm the stupid one.
I said any two, not just the two that you want, Gregory.
No, not any two. You can't get the angular size without the actual size and distance. Period. You can't.
We've detracted slightly, gentlemen. We've detracted. We want to know how they got the distance and the size of the moon. That's the original point that we were raising here. How would you get the angular size, the actual size of the moon, and the actual distance here on Earth? How did they do that? That's what we're asking you.
It's very simple, Jim. If you know the distance and its angular size.
If you know the distance.
But you don't know the distance, do you, you silly ass? You don't know the size.
Yeah, well, sure we do. Bounce lasers. We bounce lasers off that.
Like, we're asking you, how did you get the distance? If you know the distance. Yeah, so how did you get the distance?
Lasers. Bounce lasers off of it.
Yeah, radio signals is more practical for an individual.
Why do you people think invoking one or two words actually informs anyone
People usually know what those words mean.
Most people
Well, not all the time. So until you finally string together a sentence like a grown man, then that's not an informative answer.
You'd have to
Okay.
allow.
I can just say it again and hope you look up some of it. Radio signals are more practical for an individual to be able to verify the distance to the moon.
So they used radio signals thousands of years ago, did they? Or whenever they found the distance to the
So
moon.
shift the burden of proof to me. You're gonna give me the burden to justify your argument.
Yeah.
It's not a shifting of the burden of proof.
So here's a lazy ass mention of this abstract concept. Now go research it.
It's not an abstract concept. EME bounce is a ham radio operator's known thing they can do.
Yeah, we've heard it all before.
Yeah,
I've never
you can look at it on YouTube. They sit there and talk into the microphone,
never seen it in
and 2
operation.
seconds later, their voice comes back to them.
Yeah, a bit more than 2, but yeah.
No, not the moon anyway. Anyway, how did they know the distance to the moon? What techniques did they use to measure and get the size? That hasn't been answered. It hasn't
You
been
just
answered.
mentioned radio and that's it.
We just
Yeah.
told
No,
It
that's
hasn't
not the
been
only thing that
answered.
was mentioned. EME bounce was
Imagine
also.
if I try to measure my
mentioned
table.
lasers too.
Oh, shooting a laser.
I'm asking you to
Radar.
measure your table, and you ask me how do I do that? I say ruler.
Radar.
Yeah, ruler is a descriptive enough information to measure the length of something. Yes.
Yeah, no, it's not. You're just fucking
Yeah, it
lazy.
definitely is. I'm an adult. Typically, I know what a ruler is used
Lazy
for.
ass pseudoscientist.
Put those words together and use that
After they
to
get the
actually come
size
up
of
with a
the sun.
measurement.
93 million miles away. Ridiculous.
Coming into a forum, you don't actually string together an argument in answering a question asked to you.
Well, it's not very difficult to understand, to be honest.
You can make that subjective opinion all you want. It's not an argument that answers a question.
I'm not even sure what you're arguing at this point.
People don't know how to debate works. You don't know how the conversation works. You don't know how pedagogy works.
Yeah, Gregory, I don't even know what you're arguing at this point.
Yeah. What is the distance to the moon, and what's the size of the moon, and how did you know?
Right.
Okay,
It's curious to me that everybody who is not on the side of the conversation that says do your own research have done their research on EME bounce already, and everybody here
has
already acknowledged, like me, Howard. I think Brenda knows what EME bounce is.
So what?
You guys do your own
I know
research.
what it is. It's still not proving the fact that we know the distance. It's rubbish.
Freaking red herring. You haven't made an argument. You haven't made an argument that answers the question.
EME bounce.
Red herring.
It's a thing you can do.
EME bounce. EME bounce.
Bullshit.
Radar. Laser.
You take this stupid ass method of argumentation to a courtroom, you will be laughed out of the courtroom, and you will lose.
That's just not true.
Absolutely.
You're not presenting anything.
If you stand before the judge and the plaintiff,
Didn't Douglas Burke lose in court twice
and you
already?
just say innocence.
No.
I'm innocent. I'm innocent. That's not going to defend your case.
What if
the
that's
judge
not
an argument to defend your case?
You're going to get
specific
court charges.
A specific operational procedure, EME bounce, was mentioned in this conversation. Yes, you can do that.
Yeah, evoking a term. What is that? What about that answers my question?
No, but everybody who does their own research doesn't know it.
You're an idiot. You're a deliberate idiot. I have to explain to you how to give an answer.
No. You've been described a procedure by which you could determine the distance to the moon called an EME bounce. It's where you point an antenna and you shoot a radio wave at the moon and it comes back to you. And you can measure the amount of time it takes and figure out how far away it is.
Okay, so you measure time distance. Okay.
How does the amount of time it traveled to the moon, or if it really did, how does the amount of time it traveled to the moon inform you of how far away the moon is?
Because we know how fast radio waves travel.
It involves an assumption of thinking you know how fast the thing that you're sending is going to take to travel and get there and come back. Like you have to claim you know the speed of travel.
We do. We know the speed of light.
You can measure that.
What is it?
Well, it's a funny thing. I mean, I don't want to be the guy to be like, well, you only know the two-way, not the one-way. You're only calculating the one-way. But I'm just saying. There's
right, and what you're measuring in this EME bounce is two-way. So if we know the two-way speed of light, and we measure it to come back, that's a two-way distance. So yeah, we're good. We're all fine.
Well, there's an option that the speed of light being measured is only the measurement of the time it takes for it to get to the object, and then the return is immediate, or that it speeds up once it hits and is reflected back. There could be any amount of options where it changes
Okay,
speed.
but the problem is, if we have the two-way speed of light, and we know that what we're doing is a two-way operation, then the two-way speed of light, being accurate as it is still going to get us an accurate distance to the moon, regardless of whether or not one direction goes faster or not.
It could be up to double. It could be up to double.
Yeah, and it would take the same amount of time if it's at the same distance.
Yeah, even in that case, you still know the two-way speed of light, and the measurement you performed was a two-way operation.
My question is,
what is the speed and how do you know it?
But
on
it could
this
also
two-way speed of light, on the two-way speed of light thing, why would you assume that one way was instantaneous? What gives you reason to think that that would be so?
I'm not going to assume anything, but in the realm of not assuming anything, there are many options. There are many viable options. It could go at a faster speed and then slow down when it returns. So there's all sorts of options here.
That still works.
As long as the two-way speed afterwards is the same. So in any case, whether it has sped up in one direction or not, you still end up with the distance being the same.
So what is that speed and how do you know it?
It gives you a range of possibilities, up to double or half of what you
Why are you just arguing the peripheral point and not getting to the central point? What is the speed and how do you know it?
186,000 miles an hour about? Let me
What?
miles a second. Miles a second, yeah.
How do you know that?
I want to use freedom units. Well, in my case, I did it with I did it optically. I did it with a light and an encoder wheel. You could do that with you saw the chocolate bar in the microwave thing. It kind of works.
Wait, so you measure light by putting chocolate in the microwave. Do you have to wear your chopstick?
Well,
you got to wear the chopstick
going
cap?
back, talking
microwave
back to Fundy.
Bro, you guys take this shit serious? Putting chocolate in the microwave, and this is how you get the speed of fucking whatever you think light is?
If you know the frequency and you know the distance between the peaks, you can know the speed of the wave. So yeah, you can.
Yeah, I was wanting to ask Fundy in considering the potential of light going faster one way than the other. Wouldn't that affect like these tape measurers that we use, the laser tapes? If you measure something at 10 feet versus 20 feet, wouldn't you get false readings on that?
I don't know how those work.
Yeah, it's
Can I
in his
add
version of how
something?
light works.
Can I add something to the distance to the moon discussion? So in
Howard at times. Sorry, Bacon.
Yeah, in celestial navigation, there is one extra correction for the moon that we don't make for the sun or for the stars, which is parallax correction, and it's based on the distance that we get from those radar experiments they're referring to. So it matches that distance. So if that alone is not a strong evidence for you guys, then you can also check that against celestial navigation.
So have you guys ever heard that light slows down to 40% its speed through glass or water?
There's water between us and the moon.
Bro, you ever hear that baseball that's moving and you just see, you can see?
I'm just saying that if the moon is something that can be reflected off of with the signals, that if there were anything similar to how light or water or glass affects it, then the distance might seem longer than it truly is, just because the time delay might be lengthened, by some sort of thicker medium that the light is slowed down traveling through. Just saying,
Yeah, keep in mind that the wavelength of the electromagnetic emission that's passing through that medium is important, or at least the frequency. The frequency of that electromagnetic emission that's passing through that medium, if it were significantly lower than visible light, say ham radio, would not have the same kind of slowdown effect through it. So if you want the the visible light to get there at 40% the speed, the radio wave isn't really going to experience that much of a slowdown.
Well, all I have to say is that, NASA claims some funny stuff happens even with time and space itself when you start getting further out into the gravitational field, as they would say, right? And I don't know if that affects light or whatever, right? I'm just saying that when you're talking about bouncing anything off of something so far away, and we know that they claim like distortions in reality happen, I just keep everything on the table at that point.
You're not. There's no bouncing. That's ridiculous. There's no bouncing, right? Balls.
Yeah, the signal that you sent gets back to you. It's bouncing off of something.
So what? Again, so you're using this term that a physical object does. So if I threw a ball against a wall and then caught it, right? That's what you're trying to say you did, but that's not what you're doing.
Okay, what would you call it when a signal that you sent to an object came back to you in its original form?
Okay, did you see anything leave and come back, or did you just get a readout on a display?
No, you speak into a microphone.
Hold on.
No, wait. You speak into the microphone, and a little over 2 seconds later, you hear yourself in the speaker talking back to you.
That's not measuring distance. That's listening. Okay, so you listened. So again,
bounces.
Right the hand, go back and take a nap again. Come on, man.
Yeah. So what did you see bounce, or did you just assume that there's a bounce?
Right the hand.
No, I heard it. It came back to me.
Okay, hold on. Remember when we got down to like what you were actually doing when you measured angular size, that it was you standing around with a hat and chopsticks on it? Now, I think we can get that chopstick hat right now too. I think you've got another chopstick hat you're about to put on how you got this bounce thing. So I want you to let's really go through what you did. You never saw anything bounce, right? You never saw something go and come back. That's not what you saw. You only looked at a readout, right?
I don't think.
No, you heard your original message come back in clear.
But criticizing your hat, buddy.
It could be an induction radio, right? Instead of a bounce.
So you hear yourself again. That's not a bounce. That's hearing the same thing again.
Yeah, it went in one direction and then it returned to me in the opposite direction. So
when you say goes in a direction,
for most normal human adults, when something leaves in one direction and then comes back to you in an opposite direction, it could either have slowly accelerated as it was going away from you to come back to you, or it could have bounced off of something. We'll just say it bounced off of something.
It could have done like a boomerang.
So yeah, and this is the point. When we're talking about we're talking about a ball. You can see the ball leave your hand, hit the wall, and then come back. So you know, or a boomerang. You throw a boomerang, you see it leave, and then you see it come back. So you know there is something leaving and something back because you see it happen. Now you go to the moon. We take this cannon that doesn't shoot anything you see. It goes wee, 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 wee. And then you get a readout on the display. So look, the boomerang.
Oh my God.
And I'm going, no. What you really had was wee, 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 wee.
It's not a readout. It's not a readout.
Or a noise, or what it is. There's never an object that you see go back and forth. That's your assumption.
It does kind of have to be a readout.
The thing that I sent came back to me in the opposite direction. I'll call that a bounce.
What thing? You sent a what? What was it? A baseball? Was it a ball? What was the thing that you sent?
At a minimum, whatever it was that I sent was
you don't even know.
as my voice when it got back to me.
You don't even know. So now all you know is that you heard your voice.
You can claim I don't know.
And then you heard it again. So you never measured a distance. You never measured a distance. You listened. You heard your voice. Then you listened some more, and you heard it again. That's all you did, really, with a chopstick hat
and the
on.
amount of time in between when it was sent and when it came back is informative.
There's no coming back. Again, there's no coming back. There's just you listening.
Nothing you can
left.
say
Nothing
that there's
left.
no coming back. You
But
can
nothing
say
left.
that, but it's not actually true, is it?
But no,
Chris?
it is, because when you're sitting there, you're listening and you hear a noise. That's not something leaving. That's not something coming back. That's hearing a noise. Then you hear another noise. That's not something coming back. That's not something leaving. That's hearing another noise. So you heard two noises. You hear that's reality. You hear two noises in reality. Your opinion.
Yeah, I
would
heard
be
a noise, and I heard that exact same noise come back to me.
No, not to come back. No, when you say come back,
it did. It definitely came back to me.
No, you heard the same noise twice. That's what actually happened in reality. Okay, so
I sent
hearing
it
the
out
same.
in one direction,
Wait.
away
Hearing
from me,
the same.
and then it came back to me.
No. You just said you heard the same
You
noise.
can keep
Hearing the
saying
same
no.
noise.
It definitely went out in one direction, and then it came back in the opposite direction.
But no, that's in reality. You heard the same noise twice, right? We heard the same noise twice.
Right, and if I point my antenna,
Hold on. Do you agree that's what we did?
If I point my directional antenna away from the moon, it doesn't do that anymore.
Okay, but again,
Bandy's trying to get in.
Guys, come on! You're going around in circles. You've got to move on. Seriously.
No. But can we get him to agree?
Definitely not in circles. I'm in the same spot. He's just circling around me.
All right, I want to ask. I want to ask.
You gotta move on.
Let's move on to this question.
Really, hold on. So
talk
you,
about it,
in
talk
fact, you heard
about it. Dun, dun, dun,
in reality,
dun,
you
dun,
heard the
dun,
same
dun.
noise twice. That's what we. The phenomenon. The phenomenon in reality that we're working with, that we're taking. So the empirical data, the thing that happens in reality, was a noise happened twice. That's what we got. Now, any assumption. Any assumptions or personal beliefs you want to extrapolate from hearing the same noise twice, that's on you. But in reality,
now, the amount of time is not a personal belief,
there's no amount of time. You can't show an amount of time. You're trying, and again,
Yes,
you can directly record the amount of time.
It's objective. It's objective. Now let's move on.
Fundy wanted to get in. Fundy wanted to get in. Go, Fundy. Jump in, please.
Ridiculous.
I mean, I do.
Right there.
Since I have the floor, I do want to say that as much as you've given me a hard time tonight, I do agree that like the experiences hearing, the same thing twice or whatever, and I think you can measure the time between the first time you hear it and the second time you hear it. But my question, if we want to move on just a little bit, it's still kind of related, is I would really like to leave tonight. I mean, I have time and all. I'm not in a rush, but if anyone's willing, I'd really love to be taught some fundamentals about like the antenna system, and maybe I don't really understand antennas and radio signals that well, but if anyone wanted to teach me a little bit about like just whatever they feel is most important for a person to understand about antennas, because I find that a very interesting topic, and like how they work and like what purpose they serve mechanically.
I'm just wondering. Does anybody know how bats navigate? Does anybody know? Because that's a mystery to me. I have no idea.
Hold on, because I was trying to. Before we get into the sound topic, I did actually. This helps in some regard to clear up some misconceptions. Fundamental. If you have experience with audio, like speaker systems and whatnot, all that experience is going to serve to interfere with learning how electromagnetic propagation works. So if you have any of that, you can push it out of your head first, because that's not going to help.
Yeah, no problem.
Yeah, speakers are unique in that they are the only things that are far smaller than the wavelengths of the things they produce. Antennas can't do that. They have to have some sort of half the wavelength inside or quarter the wavelength in size in order to function properly. Speakers don't need to do that.
Yeah. Tell me a little bit about that. I just want to know whatever you feel is like really important and like basic about how antennas work for like radio signals and stuff like that. Like my car has this big, long, skinny metal stick on the hood of it, right? But I know that some antennas are shaped like kind of abstract shapes, like things like, is that an antenna? It's like this weird curly Q thing,
Depends on the wavelength that the antenna is built to pick up. So like, your house, well, maybe your parents, I guess, would be better. If they had this big antenna on top of their house, there's a whole bunch of different lengths of metal on it. And each one of those represents a different frequency that it's meant to pick up, because it has to pick up such a wide range of frequencies. So they've put different antenna elements on there in order to capture those different frequencies better, if that helps at all.
Okay, so the longer the stick, the lower the frequency signal it can pick up on?
Exactly. Yes, exactly.
Is that why we can use like 5G signals in our phones and the antennas in our phones are just like an inch wide?
It's kind of a unique case there, because they do a lot of signal processing in cell phones, and that's why you get like these 5G modems. Like my cheapo $280 phone has, I believe it's an X15 from Qualcomm in there. There's so much signal processing going on because of the size of the antenna in order to make it work as well as it does. So it gets a little complicated as you get further up into, because
it
the
has to
wavelengths
intelligently sort things out and disregard certain things it's picking up on. Or...
Right, there's 2 antennas in my case, so it's very processing intensive.
Does anyone else here think that they understand
it makes it weird
antennas?
because in a cell phone you're actually picking up. I'm sorry, but in a cell phone it's a little bit confusing because the frequencies that you can receive on a cell phone are also in a very wide range, but they use the size of the antenna and the processing on there to try and boost the signal to noise ratio because of how small the antennas are, and you're receiving actually a lot of the frequencies that cell phones operate at in rural networks are the same range of frequencies that television antennas are built for too.
What does it mean to boost someone's signal that you're trying to receive? I heard this on a television episode I was watching the other day, where like the transmitter from Earth to like a space station wasn't very strong, so the space station was like, "Hold on, we're going to try to boost your signal." Like, how can they assist in the person trying to communicate with them, like up their ante and like provide a stronger signal? Like, how do they reach their handout?
Well, that sounds like a line from a movie, maybe.
Oh, it's just sci-fi. Okay.
Yeah,
but you just said
it's not precise enough.
Though.
If you changed the path the signal was going, like if it chose a relay somewhere else, the ISS has to do this occasionally. It'll bounce its signal off of something else in order to get a better signal.
Okay. What would you call the 2 ends of radio transmission? Like one's a transmitter and one's an antenna? Is that just like the basic terms?
Receiver.
Well, yeah, you would call anything that has a two-way method of communication, like a cell phone. You'd call that a transceiver. It's just transmitter and receiver in the same word. Yeah, transceiver and antenna.
That's the same thing. Like, why did you say antenna? Doesn't transceiver kind of wrap it all up in one word?
The transceiver is the radio elements that do the transmission and reception of the signal. The antenna is just the hunk of metal that it's attached to. It's like you would say the transceiver, like if you had a ham radio, the box that you have that has all the radio components in it, that would be your transceiver. The antenna is external to the transceiver.
Okay, I see. Well, thank you. Yeah, that definitely answers a lot of my questions about some basics about this. I mean, I could Google it, but hey, I got you guys to like kind of go back and forth with me, and I appreciate that.
Yeah, no problem.
Is there any sort of weird, like, other component, like, I don't know, some sort of like relay system that has like some sort of interesting name where something can like pass along a signal? Does that have its own unique name or anything like that? Like you can hear about these things you can buy for your house to like extend your Wi-Fi range or something, you know?
Well, I don't know about Wi-Fi. It gets a little bit complicated when we get to Wi-Fi. But if you were talking about just plain old radio, like voice communication, you can have the radio, the transceiver itself, and the antenna. In between those, you can also have a power amplifier. And all that's doing is just taking the signal that it's got in and changing the amplitude of the signal that's going back out of it.
Yeah, they call that a repeater.
Well,
a repeater.
If you're doing Wi-Fi, you can have an access point or a repeater.
Yeah, we repeaters are radios in the ambulances and police cars and things. They use repeaters to get down into valleys and hard to reach areas.
You can say that again.
Do you think it's easy to set up a Wi-Fi repeater for your house if you want to say like get better signal in your backyard?
It gets complicated. It gets complicated if you just try to do it with only a repeater, because what a repeater would have to do is it would have to receive the signal in and then it would have to emit it again. Ideally, you want those two things to occur on different channels. And Wi-Fi, typically the channels in 2.4 gigahertz, there's only 3 usable non-overlapping channels, 1, 6, and 11, if I remember correctly. And
where the heck did you learn that?
If you want to increase your Wi-Fi
in this
range,
radio book,
just use a booster, a Wi-Fi booster. I've got one here. Works fantastically.
Right. And if you want it to run most optimally, you want to have what it's receiving and what it's transmitting back out again to be on different channels. That'll give you the most bandwidth. So if you have your router in your house transmitting and receiving on channel 6, then you put this thing on the side of your house to get better yard reception. You want to put it on channel either 1 or 11, and you'll get more bandwidth that way.
I'll get even more. Oh, okay.
Yeah, because then it won't have to compete with the noise that it's having. It won't compete with itself.
If we're gonna disregard like privacy or whatever, do you think that like everyone in my apartment, let's say there's like 10 different units, could just subscribe to one internet plan, but all agree to screw our privacy and just open our connection to each other, but just buy some of these repeaters and save on a couple bucks?
The best way to do that, and I know people love to just make it an open network with no password. I would strongly recommend against that. You want to have, even if it's just WPA2 with a very simple password like
I'm not talking about security. I'm not talking about security. I'm just saying, like, if 10 apartment units were like, yeah, we all trust each other, we're family, pretty much, like, could we all just share the same Wi-Fi if we got some of these repeaters set up around the,
You could do that. The companies that share, or the companies that give you service, they don't like you doing that, but they can't technically tell that you're doing that with enough granularity to know for sure that you have 30 computers on the end of your connection. But these days they don't even go looking, because everybody's got like 6 cell phones in their house at one time. So obviously nobody's looking into it that deeply anymore. But why I was bringing up that password thing is because that offers you actually some isolation in the radio traffic itself from people just passively looking at the stuff that's going on in your neighborhood, looking at people, what pages they're requesting, and so on and so forth. If you just put a bog standard password, even if everybody knows the password, then somebody with a little passive radio listener can't listen in on what people are doing.
That's a whole technology I've never even really heard of, like like infiltrating someone's connection. I've never been interested in doing that. But I guess it's out there.
There are other people that are interested, much to the chagrin of people.
Yeah. Well, I'm satisfied. Anyone else got some questions or topics?
Oh, and as far as that Wi-Fi repeater thing goes, you would be better served and have better bandwidth if instead it was just an access point, but you would have to wired up network, network cable from the router all the way out to the access point. It would be better, but it would be more of a pain in the ass to set up.
Yeah, analog or physical wires is always better, probably. Yeah. There's always gonna be loss when going wireless, right? Or delay.
Yeah, latency for sure.
Yeah, people always recommend, if you're doing like competitive online video games, to buy a wired controller to whatever console you're playing on instead of a wireless controller, because your inputs will take action in the game faster through the cord rather than like a Bluetooth controller or Wi-Fi controller, something like that.
That's not so much the case these days. If you're on a PS5 and you have PS5 controllers or PS4 even, PS4 controllers, they're not using typical Bluetooth to do what they do. What's that?
It's hardly noticeable. I know it's pretty darn snappy nowadays.
Right, because games usually determine what the player is inputting at the rate that they're delivering frames. So if a console game is delivering frames, yeah, they don't always do that.
Oh yeah,
there's some games that shoot for 30 still.
Right. Which is sad.
So whenever they're sampling frames is when they're picking up what the controller is doing, and if the radio can beat that rate, then it doesn't matter. Wired and wireless would be identical in that scenario.
Do you think people can notice a difference in frame rate past 128 frames per second, or that it's just all the same to the human eye after that point?
Anything past 60 is obviously better. Yeah, that's why you specified 120. Yeah, I mean, there are studies out there where there is still a measurable quantity, an improvement from 120 frames per second up to 240 frames per second. It's not much, but it is there. And anything that's there, any serious gamer, I guess if you want to put that in quotes, they'll go for it. It doesn't matter how small the improvement is, it just has to be.
That's great. Does the human eye have a frame rate?
No. The way that the brain responds to inputs from the human eye is completely independent of the notion of frame rate. We do have a rate at which persistence of vision takes over, but that's not really a frame rate. You can have those. The eye is actually detecting photons non-uniformly, but our brain makes up for it because the rate at which we receive those photons is fast enough to where persistent vision kicks in.
I heard once someone say, what AI will never achieve that biology can is the immediacy of experience. And I heard that, but I've always thought, like, well, I mean, we do sort of have a latency ourselves. Like they say it takes like some amount of milliseconds for you to touch something hot to jerk your hand away, not just based on reaction, but just for the signals to travel from your fingertips to your brain. So it's not an immediate experience. There is a sort of delay.
And it depends on the particular reaction you're talking about too, because like if
reflexes are faster, right? Because your spinal cord takes care of that as like some sort of pseudo brain of a lower level or something, like more immediate responses.
Your pressure responses will be the fastest responses that you have. Temperature responses are some of the slowest. So I mean, that right there is what part of the biggest differences are. Like the knee jerk when you get rubber mallet on the knee, like that's one of those examples. You don't control that. That's not you. Right. Your person, your ego. You don't determine what that's doing. Yeah,
that's crazy, yo. I mean, it's great for survival, and I appreciate it being that way. But it's just crazy that we work that way. Biology's a fucking trip, dude.
Well, speaking of survival, in the animal world, there's certain animals that display a movement that actually hinders their prey, hinders the animal that's going after them from seeing them. They'll either jerk in their movements or not fluid, but like lizards and animals like that. Even the chickens, to get their field of view in depth perception, they move their heads back and forward, and some birds do the same.
Well, what we do, I know what you're talking about, and this is really interesting, but I heard that you don't actually sense stimulus straightforward. What you sense is actually like the change in stimulus from one to the other. I've heard that if someone could actually like attach like some like shackles to your eyeballs and make sure you never are able to like rotate your eyeballs in their eyeball socket, and you were forced to look at like an unchanging view, like just like just a wall, you know, that's just going to stay there, that you'd actually just start seeing black and you wouldn't see anything because nothing in your view is changing. But the way we compensate for that is with little micro twitches in our eyeballs to constantly give like a changing stimulus. Even by a little bit, it kind of refreshes it. You know, it kind of relates to that whole thing, like if we stand still, the T-Rex won't see us, sort of Jurassic Park style, right? Like if you don't move, it won't notice you. But the way like humans compensate for that is always like moving their eyeballs around. But I've done it before. Like I've tried my hardest to like just like stare at one single dot for as long as possible, with like trying to keep my eyeballs completely steady, and my vision does start disappearing because there's like
you lose contrast. You lose that first.
That's crazy. And it's like you don't actually feel temperature. You don't actually feel heat. You sense the change in temperature. It's sort of how like if you touch someone's I don't know if I have a good example for this, but you know how like if you have a fever, if you have a fever, everyone else feels cold to you, right? And if you have a fever and you touch something that's the same temperature as you, like you can't tell what temperature it is. Like you can only tell if something's hotter or colder than you, but like you don't actually feel anything if you touch something the same temperature as your skin.
Right. Actually, I said lobster. What I meant was frogs. When they in France, I guess, if you boil a frog, you raise the water temperature slowly, and they don't leave. They just sit in there and cook. But the other thing was about temperature. What you're feeling the heat transfer. So they've done this. There's a video on YouTube on this. I think Veritasium did it, where they have a lump of metal and a block of wood or something like that. Something that's two totally different heat transfer surfaces, but they're actually the same temperature. The metal always feels colder because the heat from your body is leaving your body faster.
So the wood and the metal ingot or whatever, they are legitimately the same temperature, but they're but both of them are, say, like 90 like a 90-degree lump of metal will feel colder to you than a 90-degree piece of wood. Is that what you're saying?
Yeah.
Oh, that's a
both of them are below your body temperature.
Very, very nice, very nice. Yes, that's awesome.
So basically, the more conductive something is, the colder it will feel if you are comparing it to something that is the same temperature as it. Doofus, yeah.
Yeah, it's all about the heat transfer in that case.
Yeah.
I got a question that's been on my mind for years. I feel like I might have met the person or the crowd that can maybe, I don't know, deal with this question. Does something lose heat faster if it's touching something with a larger differential to it? Like, does a 90-degree object lose heat faster to a 60-degree object than it would an 80-degree object if the same like amount of like contact area is like the you know what I mean? Like it's the same amount of contact area for the transfer.
Yeah, this is why if you have like a house in the summer, the difference in temperature is what's driving your energy cost. Not so much the raw temperature itself. Like if you had your AC at 70 degrees and it was 80 degrees outside, it would use the same amount of power if you had it set for 75 and it was 85 outside, because it's the difference in pressure that you're trying to combat, or difference in temperature, I mean.
So heat leaves an object faster even if the contact area is the same to something that's colder on the other side than something that's less cold on the other side. Like the transfer of heat does actually transfer at a faster rate if what you're touching is a colder object.
Right. And that's why you'll see like a nonlinear change. That's why you'll see like a nonlinear change in temperature if you put a temperature sensor on a block of metal, and put that into a room of a different temperature, you'll see that it will change temperature to match the room temperature faster at first and slow down as it gets closer to that temperature.
What would you insulate your house with? Like if you could pick any like on the market sort of thing that won't like rob your bank account, like what's your, if you were to like build a house yourself and say you make like $100,000 a year or something?
Wow, 100. I mean, I'd probably just still stick with whatever's just everybody's been using.
Stuff.
Yeah,
Okay.
$100,000 a year. I'll just put that more toward more fun, more toys.
Okay.
But if I had to choose any insulation material, I might try to get some aerogel. I don't know how good that is.
You're not going to be able to get a bunch of that. That's expensive.
Well, you can make it. Well, you can make it. It's very time consuming. Yeah,
but not.
It's very time consuming.
but not
Requires very
expensive?
specialized chemicals and processes.
Okay.
And
Let
pressure.
me change it then. If you wanted to like harvest from like your surroundings, and you wanted to like play as much of a role as possible in building your own house, what would be your like ghetto like makeshift insulator that you might find around you to build a house out of?
And anything like that would end up being flammable. I don't know if I would be comfortable with that.
Have you ever thought about putting like sealed like empty beer bottles with the caps put back on in between the walls? You know what I'm saying?
There'd be still plenty of space in between those bottles. It would be all right, but I mean, the glass itself would still be a contributing factor there.
Fundy, have you ever heard of an Earthship with rammed earthen walls?
I've heard of them filling like tires for Earthships, like full of dirt or something.
Highly effective. Highly effective.
Is that what you're talking about when they like stack tires on each other?
Yep, and then they ram them full of dirt and everything to keep the thermal properties as close to neutral as they can get it.
What does that mean?
So, have you ever gone down in a cave? Like in the middle of summer, you go down in a cave.
Yeah,
and
it's nice and cool
down there.
Yeah.
And then if it's freezing outside, you go down in the cave and it's nice and warm.
Mm-hmm.
Same exact thing, except we're building it.
Yeah. Basically, what they do, they have three walls that are pretty much pure earth, like the thickness of a tire or two thick, and they ram it full of earth, and then the front wall is pretty much all glass, and that faces the winter sun. So you get the benefit of the winter sun, so you get all the thermal properties during the winter, so it heats your home, and then you get the cooling benefit as well in the summer, because it's not facing the summer sun, but they pretty much maintain a pretty constant temperature all year round from memory, don't they, Kool-Aid?
That's so cool.
If you do it right, you can also make that front glass wall that Bansaw was just talking about into a greenhouse and actually grow a lot of your own food and everything indoors.
Any sort
Have
of
you guys
food, tropical food.
have you guys ever heard that you can't get a sunburn from light passing through glass? That the glass will filter the UV rays, and you might get burned like by the heat, but you won't get sunburned in the way of like UV radiation.
You can, if you're in a car, you can feel that when you roll down the window, your side window, because you can see through that one. It's not terribly tinted, ideally, but your driver's side window, when you roll that down, you can feel the heat difference on your arm. So at least infrared, you can tell is a huge difference. Visible light, not so much. Ultraviolet.
Well,
Ultraviolet is going to reflect off of that surface more readily than it will pass through it.
Right. Yeah, glass will protect you from a lot of the sun's harmful effects on your skin. This is pretty cool. But it's kind of strange though. Like, does that mean like plants won't grow as well, like if the sun is coming through glass?
Well, I guess not as well. It depends on the plant too, because if you're trying to get something that's usually in a like if you're in Florida and it's a plant that normally grows in Wisconsin, it might do well to be behind some glass. But yeah, they use basically everything except what they reflect away, which is mostly green. So anything that's not green, as long as it's hitting the plant, it's using it.
One thing the truther community is talking a lot about lately, not that I've watched a lot of material on it, but just like a sort of fad going on, right, is magenta, and how, you know, they're kind of discussing some of like the well-known aspects of it, but taking it into like a weird rabbit hole perspective too. But magenta is real interesting, right? They say it's like the one color that you can see with your eyes that doesn't actually have its own independent visible light frequency. You know about that?
Well, yeah, it's
like an illusion.
Yeah, pink is also an illusion for basically the same reason.
I don't know, the same reason. I don't know.
Yeah, high pressure sodium lamps are not really mostly like warm color temperature, and that it's kind of an illusion too, because you got the sodium, so you got the yellow for sure, and there's some blue mixed in there. It kind of looks kind of whitish, but when you have like real red objects, they don't look the same under that kind of light than they do off of a much broader spectrum light.
Right. So, there's probably like a straightforward physics answer for this. I don't know if you guys know it, but like, what's the difference between different gases when they're ionized or whatever, and they like you know, certain gases glow blue. I don't know like the one for one thing, but you know, like ionize this gas, it glows blue. Ionize this gas, it glows green, and all the colors of the rainbow, right? Like, what is it? What's different? And I know you could see like their atomic weight or something with their like the amount of electrons they have or something. You know what I mean? But like, well, how would you guys answer that question? Like, what sets apart different gases that directly affects the color that they emit when they're ionized? You know what I'm talking about? There's like neon plasma lamps or whatever.
Yeah,
we
I
all know.
might have to bow out of that one. I think J Ace would be, if you want to, you know, put a pin in that question, J Ace would be able to answer that question best, I believe.
I've never met him, but I'll keep an eye out for that name.
He frequents the server, JAYACE.
It's pretty cool though, you know. It's really cool. Like, how many noble gases are there? Because those are the ones that glow, right? The noble gases.
Any gas properly ionized will glow. I mean, what happens whether or not it's mixed with another gas and it explodes or something? That's, you know, some consideration you have to make.
But it's so cool that the noble gases like go down the colors of the rainbow each, right? Kind of in order, I think. I don't know if it's actually in order. I'm kind of assuming it is. Like, helium glows, I don't know, and then the next one down in the column, you know, goes to the rainbow. I'm just guessing at this point, but it's so cool. You know, it's so cool. You can make any colored gas with those noble gases. Charge it up a little bit. It's just so interesting. You guys have heard the idea that like the sun is ionizing the gases in the atmos and creating that blue, not through light scattering, but through like plasma ionization. You know, is there like a simple retort to that you know of, or is that kind of like on the table to you?
Well, that would require more concentration of noble gases than what we have in our atmosphere. It would. Oh, and the explanation, the meme that I usually see for it is the different gases representing different parts of the day, and that doesn't make any sense because the atmosphere should have the same composition all of the time, and you shouldn't point to different noble gases for their different appearance to make it look like it's or to explain why it looks different throughout the day. That part I don't get.
You know what? That's a really good answer, actually. Like thinking, yeah, that's tough. That's tough. Yeah, that's. Oh damn! I guess that one's out the window, in my opinion. Then, shit. It kind of has to be light scattering, because what do I think? There's a bunch of helium when the sun sets for some reason, making it
I think
orange.
it would have to be neon in that case.
I mean, whatever it may be, yeah. I guess that does kind of fall apart. Damn. I really like that idea. Fuck.
Yeah, that's always struck me as a little bit odd because then it would be it's requiring that the composition of the atmosphere has to change throughout the day, which doesn't really make much sense.
Yeah, it's only a particular gas above me, and that's the one that's blue. But over there above someone else, it's some other gas. But then if I go over there at a certain time of day, now it's helium all of a sudden again.
Yeah.
Yeah. Oh fuck. All right. Yeah. I'll bow out of that one. That's a good point. Oh man, what a fun idea! But no, I can't stand by that at that point. Yeah, thank you.
Yeah, no worries.
Shit, I really, man, it's a fun idea, but that's a big issue.
Oh look,
I bet everyone in this room has heard that idea, though, right?
Yeah, I think I saw a meme on it once where they took different sun pictures. This is what the sky looks like at different times of day, and then they put it next to the gases. Yeah, that's the one I was talking about. That I don't know where that is though. I haven't seen that meme in a long time. Well, Xenon's a good one though. People love their Xenon.
Mm-hmm. Xenon, girl of the 21st century, best Disney movie ever made. Never mind.
Oh, okay. Ironically, use the word defo.
What's ironic about defo?
Because I don't use it.
I don't even know what that word is.
Definitely.
Oh yeah, that's a weird slang. It's not common where I'm at. Defo. I might adopt that. Say, you know anything? It is on my mind. I don't know. The floor is open. Go ahead and take over, anyone, or else I'll just go on random thoughts off the top of my head. Anyone?
I think somebody might jump in if they really wanted to.
Yeah, no one here has an issue with that. So, do you know anything about the tree of life, like Kabbalistic system? You know that's the Sephiro and the 22 connections between them, stuff like that.
Unfortunately, the only exposure I've had to that sort of stuff is through Pete Shea, and that's never a good way to experience anything.
Listen, it's all about the dodo, okay? It's all about the dodo bird.
No, I can't say as I know too much about it. I just know there's a lot of symbolism shared amongst different civilizations about a tree in the middle, all that stuff. I just don't know enough about it to really comment on it.
Yeah, me either. I just think like I started making my own ontology like chart of everything. Right? I know you can have like ontology of like fast food and say, all right, there's like the term fast food at the top, and then I can branch into burger joints, taco joints, sandwich joints, and then you can branch from those categories and like, all right, sandwich, we got Jimmy John's, Five Guys, Firehouse Subs, and like a family tree will branch out into the different incarnations or whatever. Under the umbrella of the one singular term. Also very similar, like the taxonomy chart or like the evolution charts, so like that. There's like kingdoms and genus and species and so on. But I started making my own ontology chart of everything, of like existence itself, trying to break it down to its fundamentals and see what order they relate to each other in. And I ended up making something accidentally extremely similar in, at least in appearance, to the Kabbalah Tree of Life diagram that we've probably all seen. And I don't understand it very well because they use such strange words. And like you said, there's a bunch of symbolism in there. But I always want to ask people like their understanding of it, because I feel like what I did on my own might have just been what they already did like before me. And they've had a lot more time to like work the system out. And if anyone like knew anything about it, I just feel like that might give me like insights on how to improve my system. But yeah, it's kind of hard to come by. You said who? I forgot the name already. You said JA or something? AJ might be my guy.
Well, I was talking about for gases and stuff. Here, I'll type it in the
Oh, that
chat.
was a whole different thing. Yeah, that's a whole different thing. My bad. But yeah, well, if you know any Kabbalists, go ahead and tell me about them. Probably not. Yeah.
I don't.
Yeah, it's too bad.
I will say, and I know this is gonna sound like it's going into dangerous territory, but if there's any group of people that will have taken words, categorized them, assigned numerical meaning and visual representations of, the group of people that comes to mind first are the Jewish people specifically. You'll probably find, I don't even know if it's for reals because I'm just making this up, but I bet you will find something like that in that community.
Yeah.
They assign
that's
numbers to all sorts of things and make, diagrams, all these kinds of things.
Right. Yeah. Kabbalah, I think, means Jewish mysticism. Maybe not etymologically, but that's like one definition of it you'll find usually. And that's exactly what I'm talking about. The Kabbalistic Kabbalah tree of life diagram. Yeah, it's Jewish. And that speaks for itself. They definitely like that sort of stuff. Yeah, that's definitely what I'm talking about. I have a lot of faith, I guess, that it's not just some sort of nonsensical diagram, but that there's actually a lot of thought behind its arrangement and a lot of insights you could draw if you had like a complete understanding of whatever the hell they're like trying to actually describe with it. I think it's probably at the end of the day like a pretty proper science of sorts what they got going on there. I find it very interesting, especially like I said before, and how it so similarly resembles my own creation, based on just my own like independent approach of trying to do something that's kind of similar to what they did. It's like, oh wow, it kind of worked out the same way. Like I reinvented the wheel on my own accidentally.
All right.
That's giving them some credit, though. I don't know if they deserve it, but I hope that they do. I have a sort of faith in that. Do you have an interest in ontology and sort of like trying to like put things in sort of like a relationships to each other. I guess that's a natural human thing. So I guess the answer is like an obvious yes.
Yeah, I typically don't. I just describe things as they are. I'm pretty simple in that regard. This is what I've got. That's what it is. And I don't really try to go any deeper than that. It doesn't serve me to do so, because at the end of the day, when I'm trying to get work done, what it is how I need to use it or how I need to interpret it. All the stuff that I've got is the way it is, and I just do. Unfortunately, that's it.
No, I got you. Maybe in your everyday life, it doesn't show up that often, but I think that like everyone sort of has a sort of ontology that they operate on, like subconsciously, and an understanding I've derived from what I've made myself. One realization I've had is that a lot of the wisdom a person has isn't in understanding things in particular so much, but understanding the relationships between two individual things and how they relate to each other is where like the majority of the wisdom actually lies that you can use in your everyday life. It's like you might know one person and you might know this other person, but like it's going to serve you a lot. Like you can learn so much about this person, but you're actually going to serve yourself a lot better if you know the relationship these two people might have with each other, because then there's so many more options, so many more doors that open themselves to you when you understand, like, oh, this person is the father of this other person, and now you understand this relationship between these two individuals, and there's so much wisdom to be derived by understanding the relationships between two separate things, and not just digging into them or digging into that other person, but understanding these like invisible bonds that different things share, and how they relate to each other. It's just the whole other. That's why the tree of life has like the 10 sephira. They're the nodes, but then there's just as much praise given to the 22 connecting pathways between those nodes. And I think those are just as equally important to focus on as the 10 nodes themselves, the connective bonds that they have with each other. I'm just an ontology nerd, I guess. Sorry.
That's fine. I'm just a weird computer and optics nerd.
A computer system, like whenever I search like ontology explained or like fundamental ontology or high ontology or whatever, all of the results I'm kind of angry about on YouTube and Google is that whenever you search like fundamental ontology, they never apply it to like the universe, which is what I think is most important. But all the search results will actually be fundamental ontology of like programming or software, you know. And because apparently ontology is a big word in the software developing community, which is, it makes sense to me. Like I get it. I just wish that the search results weren't so one-sided when focused on the digital side of things.
Well, I would imagine taxonomy would show up more often than ontology.
Well, I'm just saying when I search ontology on YouTube, all the results will pretty much just be on computer software engineering. And it's like, oh no, I want to talk about metaphysics. I want to talk about the universe in totality. I don't want to, you know. But that's just the nature of search engines. You know, they give you what they feel is going to serve you best within what they're willing to show you.
Right, and if you're searching the word Tesla, your top result's not going to be the scientist or the engineer himself.
The
Usually now it's going to be, because we got this.
Yeah.
I might even test that right now. Let's see what happens.
Well, it's probably going to be a mixed bag probably, but you're definitely not going to get like some list of like the most 100 important things that this brilliant man ever said. You know, the waters are going to be muddied just by, like Ken Wheeler says, what's popular is often untrue, and what's true is often unpopular. And that kind of plays a role in search results on popular search.
Well, in this case, what's popular is what's going to be the top results. So if I search for Tesla, all of the first page is devoted to the company Tesla.
Yep.
And then the next page is Tesla Incorporated and sales for cars. So yeah, I mean,
that's why it's a problem
that's
when people
unfortunately what it is.
say,
You kind of have to know what you're looking for.
yeah.
Where Nikola Tesla finally showed up.
That's why it's kind of a joke when people say, oh, we have the internet, and that means that we have all of humanity's wisdom readily available in one place at our fingertips. Well, it's like, it's not at your fingertips. It's actually buried in a pile of shit. You know, like, it may be out there, but good luck finding it, you know, in this mess. Which is the real issue.
Yeah, I would say the wisdom is all at our fingertips, and the banal, everything that's absolutely brain dead is also at your fingertips, but it's the stuff that comes first. So yeah, it is all at the fingertips, but at the same time, your fingertips are just full of shit first.
Well, yeah, but that's actually what inspires me for my own ontology system, where the fundamentals. I've wanted to give like either some sort of like I've wanted to provide some sort of like tour guide role to the internet, or it doesn't have to involve the internet, but that's one way it could service people. You know, like just you could call it an educational system, or some level of functioning as a tour guide to the internet or to libraries, or just pointing people in the right direction. And I'm not smart enough to really like solidify this as a complete package. Like I'm definitely going to need help, but I want to see how far I can get myself, and that's what I'm working on. That's why I'm so interested in ontology, because I'd really like to organize the most important basic information and then take my time detailing a roadmap from the most simple to the most nuanced, but only to a degree that is worth my time. Because at a certain point, I'll say like, you're on your own from here. I've given you the I've given you the tools, and I've taught you how to use the tools, and now you go ahead and be an adult yourself now, and go off on your own adventure, however you will, and please. But I can't offer that because obviously I'm a dumbass, and I'm gonna need some help even developing myself. Like I'll need the help of others to develop me, in order for me to get to a position that I even feel comfortable giving people sort of like advice on that level. That's difficulty. I gotta kind of become a master before I start taking on students, right? I'm still definitely just a student at this point, but I'd really like for students to team together, become masters by assisting each other, and that would then allow them to take on students and give them advice that they can feel confident in giving, And I feel like ontology. Go ahead.
Well, I hate to reduce it down to something that you're not really saying, but at the same time, it's like you're trying to build a lesson plan.
Yeah, educational system, lesson plan, ontology, whatever. Yeah. Exactly.
Yeah, it's more nuanced than that, but I mean, it's kind of actually. I may just have to nerd out. Unfortunately, here's the computer part of me going into this, but that's kind of like you're describing. You're familiar with JPEG images. The method by which they get to their final result is they iterate over the whole image, or each block, I should say. They iterate over that block as many times as has been directed to them. How much compression they are told they can give to this, or how much time they can give to each block. How many iterations they will go until they've reached whatever that criteria is. They start with the coarse details, then they get more fine as they keep iterating over and over again. It's kind of like the process that you were describing.
Yeah.
That has its parallels. At least you can say I took the JPEG approach.
Yeah. No, I see. I never understood how image compression or file compression works as well as I do now after hearing you say it that way. Yeah, I kind of like you just assign a set of rules to a block, and that can like simplify the transfer of information in a sense. Yeah, compression of file size, it's real interesting. I don't really know how it works, but I think I have a little bit better of an understanding after hearing what you just said. And I do see the relationship it has to what I was saying about giving someone the tools to unpack the mysteries themselves. You know, it's very similar to the whole like give a man a fish versus teach a man how to fish sort of thing.
Mm-hmm.
Yeah, and I'd like to I'd like to develop a system which, you know, probably already exists. It's just not something you're going to get from the public educational system where I'm from. You know, I'd really love to develop the system of like, if there's 10 different fish that need to be approached in 10 different ways of knowing how to fish or using different bait, I just like to tell people like just give it to them straight. Welcome to Earth, you know. First of all, welcome to Earth. I'd like to teach you the 10 most fundamental lessons, which will result in you obtaining the 10 most fundamental tools to then go fish the 10 different types of fish out there, or whatever. You know what I mean? I don't know if there's any book out there that just says like, welcome to Earth. Here's the basic manual. You know, the Bible kind of is similar to that, but it's just not the approach I would take, in a sense. And so is, you know, the educational system in different places. I mean, that's what it kind of claims to be. Like, hey, you graduated high school, you're prepared for life on Earth. But of course, that sounds like a joke because that is a joke for me to say. Oh, you graduated you graduated educational system, you're prepared for life. You're ready to take on the world. I don't think so.
It's like
I learned,
but it's
I
like
learned how to
you're
read,
describing
write,
a
and do
more
math.
hierarchical encyclopedia, a more generalized until
Yeah.
it gets more specific form of like an encyclopedia.
I just don't want to waste people's time, you know.
Right.
I love, like, people have told me my whole life that I should be a teacher, especially when I was younger. People were like, oh, you know, you seem to have this passion, you should really be a teacher, whatever. And of course I would see like the roles my teachers played in my life, and I was like, I don't want to be that, right? But you're saying that not because you're you're not associating me with like the teachers you had. You're just saying, oh, you're just a person with a passion for like sharing what you know with other people. And I think they're right. Like I think they really did see something in me that I have an enjoyment trying to tell people about things. And I think a lot of people on the server also have that same vibe. But I kind of bring that up because I forgot about people telling me that because I hadn't heard in a while. But then I think about what I just found my interest. Like I just happen to have some free time every once in a while, and I've just been working on something just independently, just my own thought. Like I didn't see I didn't even know the word ontology, right? Like I didn't even know of the word ontology before I started working on my ontology chart. I literally just started about 7 years ago saying, man, I've dug deep into so many topics, and I feel like there's like I don't have the skill set to go further than the basics on all sorts of topics. I just keep on getting thrown into the deep end of all this variety of different categories, and there's nothing linking them together. I have no solid foundation, right? I was like, what do I know? What do I think? What do I believe? And that's tough, for everyone when they really think about it, to come to like their ultimate opinion. Just setting down some ground rules of how they philosophize, right? I'm like, well, and then I just tried to assist myself in that sense. Like, how do I set some ground rules about myself, about how I truly feel about my worldview? And so I started making an ontology of that, And that's when I was, in trying to create that, go step by step, I finally came across the word ontology. But it wasn't until then, after I had developed so much, that I was like, oh, there's kind of a word for this. Taxonomy, ontology, that kind of go hand in hand, epistemology, stuff like that, philosophy, metaphysics, cosmology, all that combined together, I kind of call, the fundamentals.
Right, and you had earlier in that, you had mentioned, give me the basics, and we're thrown into something more complicated. Like we want to try to, you wanted to try and get something like a planetary gear set, what its uses are, and all that stuff. And the conversation is currently about a fully functioning jet commercial airliner. It's a bit much at times. We still need to do the basics more.
We saw earlier today, an hour ago, that some people were diving into the deep end of this conversation about angular size, and they just didn't have a solid foundation, of an understanding with like the prerequisites to really participate competently. And I don't mean to insult anyone, but I tried my best, and I'm very confident I was making a lot of sense. That was stated by some other people, that I diligently and expertly demonstrated in like a high level understanding of what I was talking about. But then some people in the conversation would just tell me, "You're wrong and you're stupid," and I'm just like, I'm actually really wise on this subject, and I know exactly what I'm talking about, and I explained it very well. But then I'm dealing with someone that's like, I want to be able to just give you a link or a PDF or something, right? I want to give you everything you need, because I'm noticing like you don't have you've built your castle on quicksand. You know what I mean? And I want to just offer you, because it's just information, it's free, there's no material cost, but I can metaphorically give you, the supplies you need to build a rock solid foundation to what you're trying to build upon here. But as of now, you're building, your perspective on quicksand. It's like, oh man, and I'm not going to fix that in the deep end here. I needed to give you the supplies you need to build back up and fix your foundation. But of course, the optimal situation is just getting it to someone as soon as possible in their life. Like, here's another book title. I could title my ontology system, educational, whatever plan. It would be called "The Most Important Information to Get to Everyone as Soon as Possible." Right? How about that? You can call it an educational system, or we can call it "The Most Important Information to Deliver to Everyone as Soon as Possible." Right?
Right. Do the course stuff and then get in the more fine details later.
Yeah. It's like, how do you lay that? How do you even determine what that information is? And then even if you do come to understand what that information is, how do you order it and deliver it in the right order and with the right type of delivery? Because one of the other things is people learn in different ways. So you're going to have to develop the system, then you have to develop the different ways you think that same information might need to be delivered to different archetypes of individuals, that they learn in different ways, but still get the same essence of wisdom across to them. It's tough, man. I feel like people have already like I said, I think what I did is something that the Jews have already understood for a long time. I think everything I'm doing is something already mastered and developed with esoteric and secretive terms and references in the Kabbalistic system. I just think I'm reinventing Kabbalah. Right? I think that's literally all I'm doing. I think they already did what I'm trying to do, which is why I ask questions.
Some of it may not be one-to-one, because there's not exactly a word for everything, because they'll have categorized it based on their language and their assignment to values for each of those things. that's not shared with the English language. You'll find some concepts don't have an analog in English, and some concepts in English don't have an analog there. So you'll end up.
Yeah.
It's mostly helpful, though. I'll say that at least. Yeah.
I've thought over and over again that because in my ontology chart, I've gone back and forth between trying to choose different words and trying to find the most perfect word. So here's one that was extremely hard for me to come up with. I kind of had to settle like against my complete satisfaction. I just kind of settled on using one word for the second generation of my ontology chart once it branches from the 11 core terms to like the 50 secondary terms of their combination. I was thinking, all right, so one of the fundamental things is like conveyance. And then another one of the fundamental terms is material or corporeal. And I was like, okay, how do I, what word is strictly defined by the conveyance of a physical material, right? Because you could say, oh, I gifted you something, but I can gift you wisdom, but I can also gift you a banana, right? I can trade you something. Well, I can trade you information, right? So what is the word that strictly means the conveyance or trade of physical goods? And I was thinking like supply drop, or just to supply someone with something. But then I was like, damn, you can still supply someone with information. It doesn't strictly mean physical goods. And there was one word that I settled on based on, I think it was either Hammer's or Numpty Noah's recommendation, the word furnish. And when you Google the definition of furnish, one of the definitions is exactly what I'm talking about. I'm like, all right, that's the best I'm gonna get, and I might need to like look into other languages and borrow one of their terms because English just might be failing me at this point. So if I say define furnish, it says supplying someone with something, right? And it's like, well, if that thing is a physical thing, then yes, that's a perfect definition. But you know, a thing can be an abstract thing or a physical thing, a concreto or an abstracta, as Gregor would say. And it's like, damn, is there? Am I going to have to invent my own word that is strictly defined by the conveyance of a physical thing? It's like, is there not a word out there that means that? And that's where I'm having trouble. I run into little troubles in that way, where I'm trying to be as honest and correct with my choice of words as possible. But it's really
you'll
tough
run into issues. Yeah, unfortunately, you run into issues where the common use of a word, even if it had a specific definition, causes it to have its definition vary, the agreed upon definition to vary a little bit. Like toss, you would think, well, you're tossing a physical object, but no, because people toss ideas around. So unfortunately, regardless of how well defined you find a definition for a word that
it won't convey what I
matches
mean.
what you're looking for, it will have some use case where that is used not in agreement with that definition, and people accept it. So I think you're kind of stuck. People are not very precise people or things.
I'm fucked, bro. I'm fucked. Like in certain instances, I'm literally gonna have to invent my own words, I think.
Just use context.
You'd have to use more words than a few, unfortunately. Like so, like you were saying, if you were to give or to supply or to furnish, then you have to specify with more words, unfortunately, to be more precise.
Right. I'm gonna have to have like a glossary at the back of my chart of like how I mean each word I use, which complicates things, but it seems inevitable that it's a necessity to operate that way.
You can preface it like say, here I'm going to I'm going to put an appendix in here for words that I'm going to use in specifically this way from now on. And then they go to the appendix for any
Set
word that
my
you
own
use.
standard.
They know. Yeah. So when you use a specific word in every context, it always has exactly this connotation or this kind of definition.
Uh-huh.
It's
Yeah, and I find that being the case almost half the time for all the choice of words. And trust me, I've spent 7 years just trying to find, as I would say, there's actually 66 that I have so far that I feel very good about, that me alone without assistance from people right now, like I've come to the idea that like I've chosen the 66th most generic terms, but also specific in another sense, that I'm capable of doing with my understanding of languages, which is only like a little bit of Latin, Greek, and English, right? That's all I got to work with. And so I've come up with this. What I think I've done is come up with the 66 most generalized words that exist in my vocabulary, and put them and arrange them in the proper ontological order that I think applies to experiential existence itself, as far as I can tell. Which I'm proud of. I mean, I think this is awesome, and I think that other people have done this, but it just isn't something brought to anyone's attention, and maybe disguised in like esoteric deliveries, like I said, like the Kabbalah or different sort of esoteric systems. And again, that brings me to why I brought up the topic, because I think that this has already been worked out. I don't think I'm the first one to have this idea to try to do this and lay it out in a chart. I just think that it's not something that's going to be like put forward to people. For some reason, people like to keep their secrets to themselves and keep their advantages of wisdom and understanding of the way things operate and relate to each other to keep their advantage over the idiots and be wise themselves or whatever. But yeah, I'm on a quest. I'm on a fucking quest.
Well, I think where if you're worried about reinventing the wheel, I bet what you could do is you could put your own interpretation of how the information should be presented. Like, put your own spin on how the information gets into the brains of the people that you're trying to get it across to. Like, if you weren't worried too much about making
being
the paper book with binding and all that mess, you could design it as something that's meant to be presented in hierarchical form as you're navigating through it.
Yeah,
So,
in
like,
whatever delivery method I want. I might need to give people like a chart or a poster, but then also make like 5-hour lectures, maybe just discussing one word at a time for like an hour at a time. It's like, I want to give you my full understanding and perspective on how I'm using this word, because it's so broad. I want you to know where I draw the line of how I use it, and in all the variety of ways I also use it, but not that way, but in this way, but also this way, but not those other ways.
The thing is, the way that we learn language is very organic. We learn what words mean based off of the way that they're used, their context, and one day we just use them correctly. There's no need to dictionary-wise define every word that you use. That's not how we learn language. We learned how the word was used, the context, and we inferred the meaning when we began speaking and saying mama, papa, or whatever. So people can infer what you mean based off of the way that you use the term and derive a more or less correct dictionary definition that's more or less on the money from there.
I agree with you. It's more of a challenge for myself at this point, because I could just take the time to write out paragraphs of how I'm using each word and how it might not relate to the way you've used it in your life, but just one single perspective, like way you might use that word, like with the words that have multiple applications in different contexts. Like, I understand, I can do that, but the real challenge is me feeling that I've reached the best decision in my choice of words. That's the struggle for me. Just holding myself to my own standards, feeling that I've done the best I can to choose the correct words that I think are most fitting to laying out an ontological chart that really takes on describe and categorizing the universe and all things in the correct fashion.
Yeah, and unfortunately, you're subject to how people typically use words, and then you're also subject to those weird use cases where they're used in a different way than what they're typically used as. And so, of course, there's multiple definitions for one word, and
it's tough.
I feel for you.
It's a pickle,
a problem.
man. It's a pickle. Yeah. Yep. And like I've chosen the word art, and I've used that word in the sense of human output activity, to me, humans input and output. You could call it sensing, right? Is like sort of the input, the action of input being received, right? You could call it sensing, and then you could say like the output is like your behavior, right? So people sense and people behave, but I like to call it measure and art, and so that both of those words would need like this big primer of like what I actually mean by them, in a sense. So yeah, it's tough. It's a pickle for sure. But I'm happy. I'm really happy that it's gone so well, getting a lot of these philosophies I have across to you. I feel very happy just interacting with you and thinking that there's a lot of common sense between you and I that we share on this discussion topic. It's very nice. Thank you. I appreciate it.
Yeah, no worries. I actually got to go, but yeah, good talk.
Good talk, man. See you next time.
Yep.
Earth's flat.
I won't go as far as to say that, but
you get there. Yeah, have a good night, man.
Yeah, cheers.
Well, the Earth is very flat, but it's so hard to define art without a dictionary, I guess. But I think of art as something that makes you want to feel what the artist, felt in the conception of the art. Something that makes you want to see things the way that the artist see the world, the way that the artist has put down on the medium of the film or the canvas or whatever.
I would call that an artwork, right? So I would say art is the action, and an artwork or an art piece is the resulting creation that the art led to the existence of. Like a painting to me isn't art. Painting is an artwork or an art piece, but painting itself, painting is art, and then the painting itself as a thing is the art piece that the art created. But that's just the way I use it. It's like a sculpture, a painting. These are art pieces or artworks, but
well, if you're talking about the execution, if you're talking about artful execution of a task or something, we're talking about something that's flawless, seamless, something that makes you want to participate in the activity itself.
Yeah, I just like to think of art as sort of like a verb rather than a noun. Like people art. And when people art, they create artworks as a result of them arting.
Can art be done poorly? Because normally art appears to be a term that is incredibly positive in that people reserve the term art when they're talking about something that's, wonderful, sublime, something that doesn't have poor execution. If it has poor execution, people tend to think of it as not art. So if we're saying that it's a verb, doesn't that kind of imply that it can be done poorly or well or something like that?
Well, I would say someone slipping on a banana is still art, like even if it's accidental, and most people wouldn't appreciate it, because I would say any sort of like physical, willful movement of your body, like doing some sort of performance, I would call that a dance. I think that humans never stop dancing, that their physical actions their entire life is one continuous dance.
But when we invite something accidental that requires little to no volition, like slipping, into art, could me going to the bathroom be art, or something that requires this little practice, quote unquote, artistry or technique or flawless, execution of technique? I think at that point, you're kind of making the term art sort of meaningless if it doesn't imply technique, execution, and some sort of mastery of the craft.
I think you gotta. I think whether subconsciously or consciously, you're still willing yourself to blink or take a shit, and that would be you arting. It's your behavior, your output into existence, you making your mark, your permanent scar on reality, everything you do. Even just thinking, I would call a mental art.
At that point, you have action and art kind of, fading together. So
yeah, action's a good word. Yeah, behavior.
One or the other term will probably be discarded as unnecessary.
I could choose any of those words and be pretty happy with any of them. And maybe art does deserve a bit more respect, especially the way people normally use it. So I could definitely change it to like behavior, activity instead of the word art. But I kind of just in my mind, they're all synonymous.
Is destroying art like when I burn a painting and do that action similar to slipping on a banana peel? Is that a form of art as well?
Yeah. So one of the things I think about humans is that humans don't create. Humans only rearrange what they have to work with. It's sort of like humans are like before they even have a choice are like given or just they have a hand of cards, and art is the playing of the cards. No matter how skillfully or wisely they play their cards, just the playing of the cards itself is the art. And that might result in something, a beautiful artwork, or something that's not appreciated by many people. But, I try to be as grateful as a person as possible and see the beauty in all things. So no matter how grotesque someone might think someone's actions are, I could still call that to some degree, not completely, but, always to some degree, a beautiful dance. I just want to be as like strict as possible to being as generic as possible, just so that the chart builds appropriately one step at a time. I just don't want to jump the gun at all, and I know I do that in the way it's perceived with the word choice I have, but that's why I'm trying to think of the best words possible. And I could just call it behavior. Maybe that would get me out of a lot of issues with trying to communicate how I feel about things. Maybe I could just call it action or acting or behaving or whatever instead of arting or art. I'm open to changes, and there might even be some like Sanskrit word that just like totally nails it that I just don't even know about. You know, I'm just working with the language that I'm aware of that I was taught as a kid. You know.
Well, art did have a definition implicit or not, as far as I could tell, where the execution was so flawless, it made you want to work on your technique. If me going to the bathroom in any way with any technique is art, that kind of gets rid of that part of the definition. Or the impetus to improve the technique and bring it up to a certain level of high art. If the definition of art doesn't encapsulate that, how are you going to get art? You're just going to get a bunch of actions that are not elevated, that are not refined,
You're right.
that are
You're right. You're right. Maybe you can help me think of a better word and to explain what I'm really after. Like I'm looking for a word that I don't know. That the definition of that word is life's output, a living being's output, and that can be mental output, and like the things that people do that isn't just receiving stimuli, but being a sort of stimulus. You know what I mean? Like thinking, imagining, moving, walking, dancing, painting, speaking, blowing, breathing, any of that, right? Mental or physical. Just that sort of that life form's output. Whether it's contained within their mind, you know, it's still that sort of, it still has a notion of output rather than just like being impressed upon, right? Like that's sort of my definition of like sensing, like the act of being impressed upon, you know.
I don't know, work. I don't know.
It's tough. Yeah, I call it art. I mean, I thought about this for 7 years, and that's the best one I got. Art. Mental art, physical art,
artistry.
Well, you've already explained the issues you have with using that word, so maybe, yeah, maybe something else. And I call what life does, as far as like the being impressed upon, I call that measuring, because I think that like a life form doesn't actually sense unless there's a differential or some sort of ability to some sort of contrast going on. Like if the only color that existed was green, then color itself kind of wouldn't exist in a sense. Like if there is no foreground, there is no background, and without both of them, it takes two to tango. Then there's really nothing going on. If there's always a measuring going on. That's the other side of art. Like people art and people measure. And part of measuring is that a measurement is always a measurement is how I would define it, is a simultaneous awareness of more than two things and a comparison and contrasting of those two things to each other. And I think that's just like this I think that's just that's the power we have to be aware of. It's sort of like, it's kind of like we kind of have no choice in the matter, but what we do is be aware and notice more than one thing, and like distinguish the differences between those two things. And that's what I would call measuring. Because like, as long as you have two things, you can compare them to each other. But without two things, no comparison can take place, and there's like no meaning, because it's sort of that like relativistic sort of thing going on.
The dictionary defines artistry as creative ability or skill. So that might be closer to what you're talking about.
Yeah. Yeah. I would definitely define. I don't appreciate the word creative because I'd rather think of it in the sense that humans don't create. God is the creator, and humans rearrange. So I would, instead of creative ability, I would call it rearrangement ability or arranging ability. You know. That's what I think my will does. I think I don't, my will doesn't create, my will arranges.
The dictionary says art is the expression or application of human creative skill and imagination, typically in the visual forms such as painting or sculpture, producing works to be appreciated primarily for their beauty or emotional power. The art of the Renaissance, great artist concerned with moral imperfections. She studied art in Paris, works produced by human creative skill and imagination. His
Here we
collection
go.
of modern art, an exhibition of Mexican art as a modifier, an art critic, creative activity resulting in the production of paintings, drawings, or sculpture. She's good at art, the arts, the various
You know
branches
what?
of creative activity such as painting, music, literature, and dance, the visual arts. In singular, the art of photography, arts, subjects of study primarily concerned with the processes and products of human creativity and social life, such as languages, literature, and.
You might have helped me out there because I think there's a lot of truth when that you can be aware of when you notice a sort of brother sister relationship of words, and so I think that impress and express might actually be a better choice of words than art and measure. The impress and express, that'd kind of be that input output sort of thing, that I was talking about. That maybe maybe I should rewrite my chart with impress and express instead of measure and art. Expression, impression. I'll have to think about that.
I'm sorry, I didn't get the whole definition. History. Oh, here we go. Subjects of study primarily concerned with the processes and products of human creativity and social life, such as languages, literature, and history, as contrasted with scientific or technical subjects. The belief that the arts and sciences were incompatible. The faculty of arts, a skill at doing a specified thing, typically one acquired through practice. The art of conversation. Phrases, art for art's sake, used to convey the idea that the chief or only aim of a work of art is the self expression of the individual artist who creates it. Art is long, life is short. Proverb. There is so much knowledge or skill to acquire that a lifetime is not sufficient. An art of war, the strategy, tactics, and techniques of combat. Origin Middle English via Old French from Latin ars, art.
I noticed another brother-sister relationship that's very similar to the impress versus express relationship. Those have clearly. It's less obvious, but you just really struck the chord with me of study and practice, right? That it kind of has the same vibe going on as impress and express, express as study and practice. There's like the same, there's the same vibe going on between those two that they share. Yeah, I might be able to work within English and improve on my words without having to explain this whole like weird way I am using these words. There might be some more like straight to the point terms, and but then how do I choose between study and practice versus impress and express? It's like then now I have to think about which one of those is more appropriate as being the more general term. Is one a subcategory of the other? Or do both of those have their own flavor that we're already jumping the gun? Because impress and express almost mean that there is a conveyance going on, like there's another being that I'm impressing upon or being or expressing
Well, it
too.
implies
You know?
something that the thing isn't doing itself. It implies something that something else is doing to another thing. And
Right.
so
So
we're
now there's
talking about
there's
impress or
conveyance going
express
on.
with art, and I'm taking a crap. There's nothing that's being done to anything else or to me. It's just me going through, actions. That's it. Nothing's being impressed or expressed upon anything else. So without that impression or expression
Right.
thing, the artistic element appears to be a little lacking.
Okay, well, I think study and practice is then the more generic term then, because impress and express almost implies a relationship between one being to another, while practice and study doesn't imply two consciousnesses. You can kind of, it's I think that's more generic. But again, I think that I think I already got a better set of words as long as people understand my definition of art and measure. I'm coming back around to thinking I already figured out the best word choice. Man, there are so many people in this room. I can't believe no one's like saying "shut the hell up," fundamental about this crazy shit yet. It's like, how is this going this long with people just tolerating my crazy rant?
Let's reason together.
I'm down. Do you think it's special at all? The first Pythagorean triangle of like 3, 4, 5 adding up to 12. Do you think that there's some sort of universal principle in 12ness that we can relate to other things that come in 12s, like the final Platonic solid having 12 pentagon faces? Is there some sort of syncretism or wisdom you might be able to relate those with?
That's a possibility. I need to see how these numbers work together and see if there's any sort of overarching pattern worth note.
Yeah, that's what I'm interested in that too. Well, just the basics, because the basics are profound. It's very profound that something as simple as you can't have a shape or a polygon with less than 3 sides. That's it's amazing, right? It even has practical purposes where you're like, oh, I want to make a stool. I'm a carpenter. Well, you better have 3 legs to that stool, or else it's not going to work very well. You got to have that completion going on in the geometry. There's just those like fractal and like intimate relationships different concepts have with other topics that on surface or first look you might be like, oh, what do stools have to do with the fundamentals of geometry? Well, it's like, well, it has everything to do with it, and that's why I'm interested in 12. 12 is just this thing you see pop up all over, but like 12 hours in a day, 12 zodiacs, but some of them are so arbitrary seeming. It's like, well, sure, the zodiacs is divided into 12 signs, but that's just some man's random decision. There's no wisdom behind that. It's just some arbitrary decision someone made once upon a time, right? Or maybe there's some very deep, profound understanding to be derived from understanding why someone would choose to, create this system in this way, or whatever. And maybe it has some implications relating, like I said, to the Pythagorean triangle ratio, the simplest one of whole, equal, or real numbers, or whatever, integers, or whatever. There's just, the world's a magical place, in my opinion, and there's a sort of poetry underlying it, like some sort of divine substrate, which a lot of people might call like intelligent design, or God's design, or whatever like that. And the deeper you look into anything, the more it seems like you approach that sort of like perspective. It's hard to avoid.
Yeah, it is a good question. Like, why the 12? Yeah, what are your thoughts on that? Because there is something very potent about the zodiac and the 12, that number, and how that seems to be deeply rooted into the harmonic levels of the sky clock. And it is fascinating to think of why that number 12 seems to be so important for that.
Well, there's one thing. It doesn't answer it definitively or anything, but one way it relates, since the zodiac is a wheel or a circle, of course, and a pendulum is also a circle. So a pendulum has a consistent period length. So the amount of time a pendulum takes to swing from its peak on the left side to the peak on the right side. A pendulum, avoiding the idea of air resistance or friction, just involving like the gravity, the downward acceleration or whatever. A pendulum will have a consistent period that will stay completely consistent the entire way if swung from 30 degrees, or in other sense, in a 12th of a circle's arc, or a 12th of a circle's circumference. And this sort of consistency only applies to a pendulum swinging within 30 degrees. You can start it at 90 degrees or whatever, but once a pendulum begins swinging within a 30-degree range or a 15-degree range from like the plumb point, it'll slow down, of course, its swing, but the slowness of its swing will be equally compensated by the changing distance of the arc it swings within. And like one way to make a clock, which is really interesting when it comes to standardized units, which all have esoteric explanations, and you shouldn't believe what you're told about the origin of the meter or the foot. It's all a bunch of bullshit they told us. A really interesting thing is that the only thing that affects a pendulum's period is not the weight on the end of the rope, but only the length of the rope is the only thing that actually makes a difference in its period length. And so it turns out, probably because of esoteric reasons, that if you want to make a pendulum that swings from its right side to its left side for exactly 1 second, you use a meter length of rope. A rope of 1 meter long will swing for exactly 1 second, period. But that only stays true within a 30-degree range of swing, or a 12th of a circle is where it gets into this like sweet zone. And so that's the only thing I know that has like a universal significance to dividing a circle into 12 parts, and how it relates to time and pendulum, which of course the zodiac also has to do with time. So that's what I'm working with so far, but I can't imagine that's like the end all be all of it. That's just like one correlation that's kind of significant.
Yeah, I posted a video about the Pythagorean theorem and how a lot of things are represented by 12 and 6 because we count from 1 to 9 or something like that. The video explains it better than I ever will. It's 30 minutes.
Well, there is one other thing about 12 and 6. There's a number series, which is, I think, a very important number sequence series called highly composite numbers. And basically what a highly composite number is, a Guinness Book of World Record setter. And as you count up, you realize that 6 can be divided into 6, 1, 3, and 2. But then you go one number up, and all of a sudden there's less divisible numbers. Now you only got 7 and 1 as the only factors. And it turns out that 6 has more divisible factors than anything from 6 to 12. And so 12 is the next number that exceeds the amount of divisible factors than 6. 12 is the next record setter. And so it's a really interesting number sequence called highly composite numbers.
Cool.
And 12
I'll
is one of them.
highly composite numbers.
Yeah. 12 is one of them, but so is 6, and so is 4.
So when you watch this video, Sonic Geometry, they break it down. Things like
I've
distance
seen that.
of the Earth.
Yeah.
I know the moon is. What would you say?
I said I've watched that video about 100 times.
Oh yeah, so excuse all the magical spinning balls, but
right. Yeah.
when they start breaking down the distance of the Earth and the motion of the Earth and the size of the sun and how long it takes for the moon to travel around this and that, and it's like how much of a coincidence can it be? All these numbers are 12 and 6. It's like
our solar system was designed by Freemasons. It's pretty obvious.
Years later you realize they did not think hard about what numbers to slap on these. They're just like, 12 and 6, fuck it. 12 million,
They pick
12,000,
their
who
favorite
cares?
Yeah, you're gonna see the 153s, the 273s, the 108s, the 72s, the 12s.
Yeah, you got it. You already know what I'm getting at. Thank you.
Yeah, the 33s, the 32s. Yeah. When you look into the solar system and the ratios and the speeds and the distances and all that, you're gonna see the same sacred numbers that have been worshipped all throughout history popping up in this new model of describing the universe and how it works, and it's just the same thing.
And this video lays it out great.
Yeah.
That video, Sonic Geometry. Yeah,
it is a beautiful video. There's another beautiful. So there's like 2 documentaries that set me on my path like 10 years ago, and it was Sonic Geometry. I love it, and part 2 is pretty good too. And then there's another one called Secrets Hidden in Plain Sight. Those were like the 2 most impactful documentaries I saw on YouTube that kind of set me on my path and like shaped my worldview very strongly.
What was the second one? I've probably never seen that. What did you say it was called?
Secrets in Plain Sight. It's a 5-hour video, but it's a compilation of like 10 chapters all put into one. But the thumbnail of it should be like a Freemason sort of like art piece where there's like 2 pillars and the sun and the moon in color. But yeah, it's called Secrets in Plain Sight. I forget the author's name, but it's about 5 hours long, and that was like it's just sort of like a one-stop shop for like the most important lessons you need to learn about how the world works. In a sense,
YouTube's hiding it right now.
But yeah, Sonic Geometry and that one were like the most impactful videos on shaping my mental state and how I approach things after watching them. It made a
YouTube is not showing me Secrets.
I'll find it. Yeah, I'll find it.
Right now, man. Yeah, thanks for that. Oh, I found it. 3 hours and 43 minutes. Yeah, I got it now. Oh, I can follow their channel. I'm gonna watch this. Thanks, man.
Yeah, no problem. Wow, they aren't showing it at the top of the search results for some reason.
I'm gonna throw the link up for anybody else.
Okay, so the YouTube channel comes up as the first result for me, so I can.
I had to type in documentary after to get it.
So yeah, the 3 hour, 43 minute, 47 second one is probably what you're gonna want to watch.
I'll probably. Do you think I need to actually stare at the screen, or I could listen to it at work?
You don't have to play. You don't have to pay complete attention, but you're definitely gonna miss out on a lot if you don't watch it. Yeah. But you'll still absorb tons of information just listening. But he did put a.
Yeah, definitely gotta watch. All right.
Yeah.
That's great.
Yeah, it's a must watch. But it's so good, man. And it's going to just touch on a lot of things that you already know at this point in your journey, but it's going to deliver it so well in such an amazing order that just builds upon itself, and just for every different topic he involves, it's so syncretized that it just seamlessly goes on and tackles topic after topic in like a connected sequence. That's just incredibly well done. He has a really nice style of approach to just a whole variety of topics that he really just undeniably shows how easily one thing will lead into the other. You know, when
I'm gonna throw a video up for you.
Cool, man.
I'm gonna watch this 3-hour, 4-hour thing. I'm asked that you just watch this 45-minute one.
Deal.
This is mostly about what they call the land of Tartar and the lost tribes of Israel and Janus or Janos. What do you think they were doing behind walls and behind closed doors? These are the first people perversing human life, I feel like.
Okay, so I see episode 3, 10 lost tribes of Israel found, and the disappearance again circa 1850. That's not the one you just said. Did you post it yet?
I did. You just read the title of the video. Yep.
Oh, I thought you said Janus in the title.
It talks about hold on, there's another video that's 2 hours that's also about Janus. But I don't know.
Janus is interesting,
I'll
man.
send you both. Here. They both talk about Janus, but I'll send you this other one too. It's just they're both very good, so why not?
Yeah, Janus is a god that I'd like to know a lot more about. The only source I've ever seen talk about it is a channel called What the Flock TV, and he's
just
obsessed
put
with
his
Janus.
channel up.
Yeah.
Yeah, he has a 2-hour
Definitely worth
video
looking
breaking down how the character has appeared in history, like the accounts, the artifacts that represent how they represent him, you know.
Mm-hmm. Yep. I got them both saved. I'll listen to them while I'm working tomorrow. Thank you.
Hell yeah, good stuff, man. Thank you too.
Yeah, I think you'll really enjoy that Secrets in Plain Sight Volume 1 or whatever.
And it's
if
crazy
you
to
enjoyed
me. Oh yeah, sorry.
I was just say if you enjoyed Sonic Geometry, then you're definitely the type of person who will enjoy Secrets in Plain Sight.
Yeah, I'm gonna definitely watch that. I definitely have to fucking sleep for at least 5 hours before work. Fuck.
I know. It's coming. It's coming.
So if I watch
Gotta
this
get
right
that.
now, I'm definitely not gonna go to bed. I'm gonna be like staring at my screen.
Sleep is important, everybody. Sleep is fucking hella important.
But yeah, it's
On that
crazy to
note,
me. What's up?
I need
I
to
was
go
gonna
get
say
some
it's crazy
myself.
to me
So go ahead.
It's crazy to me that it took me I don't know. I've been scowling the fucking weird ass rabbit holes of however you get to these places on the internet, right? Trying to find out shit. It took me since 2012 to find out about this Tartary shit. All my stupid ass digging. 12 years? That's kind of like they really are hiding shit. Like really hiding shit. Like, whoa.
Well, don't get carried away because to me, there's something fishy going on, and that doesn't mean the information being provided is like necessarily like all rotten or anything. Because I've learned a lot from the Tartar research, the mud flood research, the Great Reset research, everything like that, the impossible architecture, all that stuff. And I'm not saying it's bad to look into, and I'm not sure what portion of it is meat versus bones. There's definitely a lot of people giving it a bad name by like jumping the gun, being sensationalist and all that, but that's really every category. But I still somehow learn a lot from all of these maybe accidental con artists. I don't know what to really. I have a hard time, necessarily recommending YouTube channels completely. It's like, oh, just go to this YouTube channel. They're not going to mislead you. You don't need to worry about them trying to sensationalize anything or trick you or anything like that. But unfortunately, the honest truth is that like I can't necessarily recommend literally anyone on YouTube or any channel and just be like, listen to everything they say, they're right. It's like, oh well, it seems like I have it always seems like I have one enormous problem at least with literally
so
everyone
true.
who's
Except
ever
for
taught me
one
anything.
character. There's
Yeah.
only one person on YouTube that I feel like he doesn't skip any fucking
Who's that?
He's
Who's that? I'm
Bro
excited.
Sanchez TV.
Oh, come on. Listen, man, he's taught me a lot. Okay, Bro Sanchez has taught me a
What
lot.
don't
But
you like about what he says?
oh, come on, I'm not even gonna answer that.
What's the number one thing? I don't know. What is it?
I don't know that your physical body shrinks the further north you walk.
Did he say that?
Dude, you got such a soft spot for Bro Sanchez because of all the
I
good shit
haven't
he
been
says.
following his channel that long. If he said that, then I disagree with something he said.
He's opened my mind. He's expanded my mind and made me approach things from a whole new perspective. And he's taught me so much. In fact, I've gone so far on the record to say Bro Sanchez might actually be the most has the most output of syncretistic material. Unfortunately, I definitely recommend people to just watch his videos only, where there's like the topic is syncretism and like relating different topics, because I mean those are the ones I gather the most from him from. But no, man, he just goes crazy sometimes, and he knows it. Lately he's been saying, he's like, I know I reach. I'm just having fun, guys. I love reaching. And he says, if you ain't reaching, there's something wrong with you. And that's his defense against him saying his crazy, wild ass shit.
Well, let me just say, maybe he's not 100% correct in everything he states, but I think he's 100% doing what he's supposed to do. Like if it takes reaching to get to the truth, then yes, we need to reach.
Yeah, I'm gonna continue watching him because I know there's gonna be lots of gems and jewels dropped in his presentations for sure.
And trial and error is how you get to the truth, right? So if he messes up here and there, it's done gracefully. I feel like not like stupidly.
He says things all the time though, because I've watched pretty much every single one of his videos for the past 3 months, ever since my buddy Illegal recommended his channel to me. And that it was one of the most obvious lessons I learned about how much YouTube hides people, because I've been into syncretism and literally every topic he talks about for like the past 10 years. And somehow I've searched the word syncretism probably 1,000 times over the past 10 years, right? And somehow none of his videos have ever popped up. You know, he talks about everything I'm interested in. You know,
that's crazy.
He literally, somehow YouTube has never pointed me his direction, even though he's the person who most would deserve being recommended to someone with my search history. So yeah, YouTube's
one of his teachers
hiding him.
Oh man, I don't remember his teacher's name, but he's actually a serious dude from the fucking 30s. Man, that sucks. I can't. He actually was a fucking student to some serious people, though. I gotta look it up. I don't know how.
I got a lot of respect for him. You know, I don't want to tarnish Bro Sanchez's name because, like I said, I'm going to continue watching him because I have expectations based on the past 3 months of me watching him that he's going to continue dropping jewels, dropping bombs.
Let me not say that he's accurate. Yeah, I was saying he doesn't say he gets things wrong here and there, but
I'm saying watch out.
That's my favorite YouTube channel because I think he does it right. If you're supposed to have a forum of honesty.
Yeah, I think he's just a person like anyone else, and I'd like to think that the times where he just says some crazy shit is something he'll grow from, maybe reflect on later, watch his old streams, and maybe not say some things that he isn't thinking through hard enough. But no doubt he's all, even in these short 3 months, he's changed like my life. Like that's how powerful some of the things he says is. I got mad respect for the guy. He's given me so many insights already just in the past 3 months. But I can't say that he's just dropping pure truth, because if you listen and believe everything he says, you're gonna end up being like just one of the craziest people. He's crazy. He's absolutely out of his mind.
Let's just say
he's a mad genius.
He helps me take a step back for myself and better my own perspective, not just subscribe to his.
Uh-huh.
Maybe just see how to gain a new perspective, right? But I'm trying to find his most recent video. He got into a character called Cerabus. You ever hear of this guy?
Is that the bat god?
It's pretty much, this is supposed to be the human embodiment of the serpent with forbidden knowledge, Serapis,
Oh.
or hold on, I don't know.
Oh, that makes sense because of the ser, like serpent. Serapis, snake god. Serapis, serpent.
Yep, that's where's this video?
Some of
Oh, here it is.
so one of the major issues you might want to look out for him is not believing his etymology. He definitely can lay down a lot of truthful etymology, but one thing he doesn't distinguish is between official etymology that's like backed up by, say, like Etymonline, versus when he's doing freestyle etymology, where he's saying this word comes from this word and they share a root, when there's like no one but him making this connection, just because like they both start with an S, and he's like putting like this big focus on like, yeah, they're related words because they both start with S, they come from the same thing, and he'll make a big case on it. And like he pulls etymology out of his ass sometimes, and so that's one thing to watch out for. Not to say it's every time, but yeah, the dude just fucking goes wild and just like states things too certainly, when he should admit he's abandoning an official etymology standard and just going on to his own what's called folk etymology.
Yeah, I've actually been aware of this about Bro Sanchez for a while. He'll make a connection where, you just automatically raise an eyebrow. Like, is that the true origin? Probably not. Is it a coincidence? Is it a funny coincidence? Definitely yes. But I can't say it is the origin. Yeah.
There have been times where he says some etymological connection, and I say bullshit, but then I look it up and he ends up being right. I'm like, oh shit, okay, eggs on my face. God damn,
Like what's an etymology and a fucking whatever? What connection has he made?
I'd like to point out like the most recent one.
Like you just said, the Serapis and the serpent. He said that exact thing actually.
Right, and that's probably legitimate. I don't necessarily remember too strongly the ones that I detect as him bullshitting. Those ones don't stick with me because I kind of try to just use my bandwidth and my memory card of my brain to only retain the things that I think are like worth remembering. I kind of discard the things that he says that seem too crazy to entertain for me. So yeah, sorry, I can't think of one of his bad examples, but I mean, just watch the next episode and you're gonna see probably like 10 examples of him like lying pretty much.
Right. So yeah, who would be the best YouTuber then? Or not, like just I said, YouTuber, just anybody that's
I could name some like 9 out of 10 channels, but I'm always going to have some issue with all of them. So one of them, of course, is Quantum of Conscience. I think the dude is one of the best YouTubers ever, but of course I don't agree with everything he says, but I don't necessarily need to repeat that over and over again. But yeah, so Quantum of Conscience, that dude's awesome. Santos Bonacci has a whole library of really good stuff.
I gotta watch more of his videos.
But again, he'll do the same thing as Bro Sanchez. Bro Sanchez, I'd put them all right up there, like Quantum of Conscience, Mr. Astrotheology, Santos Bonacci, Ken Wheeler, Bro Sanchez. These guys will teach you a lot, but you got to watch out. Also, another one is SGD, Sacred Geometry Decoded. He's the only issue he has is that he believes that the solar system truly is laid out in those divine ratios. He calls it a symphony of coincidence, and because he really does believe that the sun is the distance they tell us and stuff like that. But he's into the whole esoteric ratios and numbers that occur in these things. But he doesn't think it's like something designed by Freemasons. He thinks the Freemasons worship these numbers because of a insight they have as to the solar system. You know what I mean? That like their worshiping of the numbers is derived from their understanding of the solar system, not that the solar system is a creation based on numbers they were already worshiping. But he still got really good information, and he also debunks a lot of the ancient architect, like advanced technology stuff, and shows how
Quantum
primitive people. What's that?
Quantum conscious.
Quantum of conscience. Yep, really great. Also, he's got a website that his friend made for him, where he can speak uncensored, which is awesome. It's called freevoice.io. I promise it's like a safe place to go to. That's where he uploads videos on topics that would get like kicked off of YouTube. Freevoice.io is where you can get some like more personal videos from him. Not personal, just on topics that YouTube won't allow, you know?
Got it. Give me 1 second. I just found a little passage about Serapis from Rose Sanchez. It was actually yesterday. This live was up. All right, here we go. Timestamp is 1 hour, 6 minutes, and 30 seconds. 1 hour, 6 minutes, 30 seconds. I just put it up.
You said 1 hour and what?
Wait a second. That's not the timestamp. 1 hour. I'm at 1 hour and. I'm trying to find once he starts talking about this dude. My bad.
No, you're good. I probably won't watch it tonight. I'm trying to like not use my eyes on my phone tonight, you know? Kind of keep the light down, get ready to sleep.
Good night, bro.
But you can DM me the timestamp. I'll definitely check it out. I was gonna that's his latest video. I was gonna get around to watching it anyways.
Oh
Probably
yeah,
the whole thing.
watch the whole thing. Man, I mean, if you believe in Christianity, he's literally shitting on the whole video.
Oh yeah, I'm not about that. Although I do appreciate what it is.
Yeah, this one is just that's what he's doing this time.
Here's one other channel that's pretty good. It's called CG Dahlin. The letter C, the letter G, and then Dahlin with an H in the middle. DAHLIN. He's pretty good. Does some good videos on singular topics. There's not a lot. He hasn't been at it for a while, but
Doggone spirituality. That's awesome. Thank you for that.
No problem.
Yeah, his channel is fucking loaded. What is this? Wow, cow and bull worship. Yep, that's shit. Thanks, man. Here, wait. Let me. You gotta remember more channels for me later.
Yeah, I know.
All right, man. I'm out of here for now.
All right, man. See you. I guess later today, probably. It's already past midnight.
Yeah, when I wake up later on. Peace, bro.
All right. See you later. Everybody go subscribe to Pete Shea. Best channel out there. It's all about the dodo bird. Let's not forget about Spirit, Science, and Eric Dubay. Whoop whoop. 11 out of 10, guys. 20 out of 10. Nah. Eric DeBay's makes some good videos, though. If anyone wants the history of astronomy laid out, his video called, like, History of Flat Earth. It's really a history of just astronomy and the globe, really, is what it's focused on. But that's a good video right there. Going through Pythagoras, to Copernicus, to Tycho Brahe, to, you know, everyone, Galileo, just all in order, laid out, really well delivered. History of Flat Earth by Eric DeBay. That's a good video if you want to understand where the ball came from.
Bro, who are you talking to, man?
Everyone. I was just giving some recommendations to my buddy Electric, but I felt like just giving one more recommendation to whoever's out there listening, on our conversation now he's gone. You ever seen that video? History of Flat Earth by Eric DeBay? It's really a history of the globe, but it's good information.
Have you seen, there's a series on the history of the flat earth by Jim Panda. You should watch that. It's pretty good.
Oh, yeah.
I don't know if he's still putting out episodes, but let me try find one.
I've never been to his channel before.
Don't go there. Don't go there.
Just this one video?
No, it's a series of videos that he's been putting out.
Okay. Well, I love understanding the whole, timeline of things. If there's one thing I think would be really handy as a tool in educating properly, it'd be some very cleverly designed timelines for people. I think timelines are a great resource if they're like drawn up clearly and properly.
Yeah, that's exactly what Jim Panda does in these videos. So it starts all the way at the beginning. I think there's 4 parts out right now. I don't know if he's gonna put out more, but I tagged you with the first one. And they're pretty short, they're not long, they're concise to the point, like 13 minutes each. Just gives you a brief history of how we got from ancient times to now with regards to the idea of the earth being flat and who the big players were, who the big, names were and what. Yeah. I think you'll enjoy it. And what I love is he doesn't take a side, he's not taking it from the perspective of a globe, but he's just laying out the facts,
That's really nice.
Yeah.
Well, thank you. Say, do you know any insights onto some sort of deep significance of the number 12 and the instances we see it like playing a role in different systems?
No. Or why?
It just pops up, in certain systems that seem arbitrary.
Jesus called
Well, that's one of them. Yeah, that's good, man. Yeah, It's perfectly fine.
What else? Zodiac?
I think that the whole Jesus, the 12 disciples, is a sort of astrotheology in reference to the sun and the 12 constellations he travels with and stuff like that and spends time with. So I think that's kind of the end-all, be-all sort of about that sort of system. But then there's the question, like, why would someone divide the sky into 12 pizza slices? Is there a deeper meaning behind that? Why 12 was chosen? Because it seems arbitrary, but maybe there's a good reason behind it that isn't obvious at face level.
Yeah, maybe.
I have faith in the ancients and the systems we've inherited. I have a lot of faith in them that they weren't just picking numbers out of a hat for all these like long-lasting traditions that we have. I've seen enough poetry and beauty and brilliance that I think I've kind of deduced, or I don't know if that's deduced, from studying astrology and the systems, and like, why is this one a set of scales? Like, what a random choice. Is that just like, oh, fuck it, it's scales because I said so, or is there like a really good reason behind their choice of calling it a set of scales? I think it's actually brilliant. I won't go into it because it's late, but I like I said, I don't think they just picked things out of a hat. I think there's probably some really good insight about universal properties and the way the world works, or at least a sort of perspective that has a lot to back it up when it comes to these things we've inherited, like the alphabet and the design of letters, zodiac, all these different standardized units and systems that we've been kind of just given as children that we don't really think about too often. The meter, the foot, all the standardized units, man. Standardized units, all, in my opinion, have really deep esoteric origins behind them, and the origin stories we're told I think are fictional.
12 inches in a foot, stuff like that.
Well, that's another instance of that 12 right there, yeah. But where did the foot come from? The inch is based on the foot. The foot isn't based on the inch. So how is the foot decided as a unit of length? And
wasn't it literally someone just used their feet to measure stuff? I don't know. That's what someone told.
Yeah. There was a king who wanted a bed made for his queen, and so queen laid down, and he walked beside her and found out, she was a certain amount of his feet long, and then the carpenter was like, "Hey, king, you don't actually have to be here you don't actually have to be a part of the building process. If I can just take a stick and cut it off at the length of your foot, now that we've measured her and the bed dimensions that she needs by your foot, I can just use your foot, this stick, as a reference, as a rube." And but of course, that's just like Benjamin Franklin getting struck by lightning, flying a kite in a storm. These are just stories we're told, The truth of behind a foot. I mean, there's a famous monument in India called the Iron Pillar of Delhi, and it's a solid iron pillar. It's like some I don't know, like 15 feet tall in the middle of some town square, right? And it has a square top to it, and the square top just so happens to be 1 foot by 1 foot in its measurement. And it's like, oh, is that a coincidence that this pillar in a place that should have no knowledge or understanding of what a foot is somehow designed this pillar by the dimensions exactly of a proper foot, And not only that, but this pillar has a story behind it made by a famous alchemist who set it up in the middle of the night and disappeared out of town. And the cool thing about it is that this pillar, it's made of iron, can't be tested to find out it being comprised of anything but iron, but for some reason it's never rusted, even though it's just out in the open air, in the rain and everything. It's a magical iron pillar. I don't mean magic, but you know what I mean? There's some sort of alchemical science in its design. It has the foot in its dimensions, and it doesn't rust, defying all understanding of iron and how something like that could have been created 1,000 years ago. It's just weird, I'm just saying, standardized units, inches, feet, letters, sounds, words, lengths, weights, all of these standards we use, the meter, all this stuff. It's not, the origins of them aren't they aren't the story that Google will tell you, Same with like an acre, you know, or a mile. All this stuff. We're getting fed. We're getting fed a lie as to how they were actually decided upon as a standardized unit of length, weight, brightness, time. You know, the second, the hour, right? Don't believe what you're told.
But I mean, if it works, you know, it doesn't matter where it came from. If we can use these things to accurately, you know, tell the time, determine the lengths and distances of things, doesn't matter where it all came from. If it works,
well, go ahead and use them, for sure. Yeah.
You feel we shouldn't use them?
No, I use them myself. I just know that there's more value to be had through a deeper understanding of what they really are based upon. And that's not something that's going to be offered up to you freely and directly and put in your face, you know, but with maybe a little bit more research, this one thing that you've always known might be a key for you to unlock a whole variety of connected understandings about reality. Like I can tell you this, you might know what a meter is, and you might even know like from your fingertip somewhere up your arm or something, you might know like, oh, like I know that my hand is almost exactly 8 inches long from my wrist to my middle fingertip, right? So I use that. I just like, if I ever need to measure something, you know, I can usually, like, I don't need a tape measure around. I can literally just use my hand. I know my thumb is like an inch wide, and I can measure out I can measure out 1 foot, 12 inches, just my body part. I'll definitely utilize it. However, with a deeper understanding of the meter, I know that if I was ever stranded on an island and I wanted to make a pendulum that swings for exactly 1 second, and I wanted to time something by a second, I know that a pendulum with a rope length of exactly 1 meter will swing for exactly 1 second. So I know how to make a 1 second clock on an island with nothing, but with my own body to use. Yeah. And that's just something, just one way to utilize, you know, and apply a deeper understanding of a meter. I can use a meter to measure time, not just length. And that's just one small thing I've gained from it. There might even be deeper applications to be utilized, you know. The more you know about what these things are really based on. They probably have very deep principles that they're based on that relate to some amazing understanding of how the universe actually works.
Maybe.
I think
that is a possibility.
I think the whole 9.8 meters per second thing is actually like there's references designed in, like, say, the inch or the centimeter or something like that. Like, have you ever heard of the most beautiful mathematical expression ever discovered?
No, what is it?
So, you know what, like, a transcendental number is? Like these, like pi or phi, these like numbers that can't actually be written, like, because no one knows, like we only know the decimal up to a certain point, but it goes on forever. So like no one actually knows the trillion billionth Google placement number of it. We could calculate it if we
irrational numbers.
Well, there's a difference between irrational numbers and transcendental numbers. Irrational numbers just have an ongoing decimal, like 1/3, but the difference between irrational and transcendental numbers is that irrational numbers can be predicted. So when I say 1/3, I know that I can write it down as 0.333 and then put a line underneath it because it'll just keep on being threes forever. However, you can't do that with pi or phi. You're right, because there is no understandable repetition in its decimals. Like, sure,
But wouldn't you say
number,
all transcendental numbers need to be irrational? Like pi,
yeah.
Euler's number, Euler's identity.
Yeah.
Okay. Okay. No, they're only on the same page.
Yeah, all transcendental numbers are irrational because they're ongoing and they can't be written, but transcendental numbers are unpredictable irrational numbers.
Yeah. Yeah. Okay.
But so there's let me Google it because I'd love to just finish the night off with this. Let's see. The most beautiful math equation.
Okay.
Let's see. Okay, here it is. It's called Euler's identity. So e to the
Euler's,
power.
yeah, I said that.
Right. And this was discovered, right? E was invented, I was invented, pi was invented, or just whatever you want to put it, right? And no one knew that these were actually puzzle pieces that fit together to a precisely clear image. All of these were independently discovered, and then it was someone else later on who was like, whoa, if you take e to the power of I times pi plus 1, it equals 0. And they're like, what? Like what the hell? You know what I mean? Like it just, they discovered God within math. You know what I mean? It's just like what the hell? This is like, that's why they call it the most beautiful expression in math, because no one predicted this coming. It was just accidentally figured out, But that's kind of where you kind of come to think where it's like these things aren't invented, they're discovered. Secrets of the universe, But yeah, it's literally ridiculous that that's a thing. Like it's absurd that happened that way. It's unbelievable. But there it is. I mean, you can do it yourself. It makes sense, but it's just crazy. Like, how do you take something like how do you ever take a number like pi, right? How do you even take a number like pi, which you don't even know what it is, right? No one even knows what pi equals. You know what I mean? We understand it as a concept, but we don't know what it numerically actually amounts to. Like, we literally don't know what it is. So how do you involve pi in an equation, right? And make the other side of the equal sign 0 in any other way besides pi minus pi? That's an easy one, right? Pi minus pi equals 0. Oh, wow. Oh, that took a lot of work, right? Well, of course, But no, they're not doing pi minus pi equals 0. They're doing pi plus 1 times I to the power e inverse, you know what I mean? And there's other ways to rearrange this equation that make sense too. That still equals 0. It's like, what? That's all you could say is like, what? How is it possible you can involve pi in an equation and make it balance itself out all on one side? It's ridiculous. And there's other things that are like this. Like the relationship that phi has to 1 is one of the most ridiculous things ever. And you just can't help but understand there's some sort of insight you can draw from phi's relationship to 1 that gives you the most direct analogies you can ever mathematically conceive of to try to relate God to existence, or God to the demiurge, or how God would see himself if he looked in a mirror. It's like no one can see themselves, they can only see the reflection of themselves. It's like if God is 1, phi is God's reflection, or how God sees himself when he looks at himself in the mirror. So, you know what I mean? There's just the insights are crazy, and what you can apply them to philosophically. Do you know about the relationship of phi and 1?
What do you mean? In Eula's identity, or you just asking in
No,
general?
no, yeah. Phi isn't even in Euler's identity. So
It
check
is.
this out. So no. Pi is different than phi. So check this out.
What? Pi? Like pi? Like the ratio of radius
Yeah,
is
add it.
circumference?
Yeah,
Pi?
pi is pi. Phi is phi. They're both Greek letters.
Which one are you?
and-
Which one are you talking about? Pi? Pi?
No, I'm talking about phi.
Oh, okay.
So have you ever heard of the relationship of phi and 1?
Yeah.
Yeah, I mean, it's crazy. Like
The golden
this
ratio.
Yeah, this is one of the craziest ones. So like, you take a number, you take n, and then you square it. And when you square n, think of any number. Like, I could give you to the end of eternity, and you'll never answer this equation. So n squared equals n plus 1. So you literally you square something by itself. I mean, that's what square means, right? You time something by itself, and the resulting number is equal to that number plus 1. So phi times phi equals phi plus 1. And that's just another one of these things. Like, we don't even know what phi equals. No one's ever known phi physically, seen it written down. You literally can't write it down. But somehow we can understand that phi squared equals phi plus 1. And another one is 1 divided by phi equals phi minus 1. There's not a single other two numbers or amounts that relate in this way. It's a one of a kind relationship they have with each other, that nothing even comes close to the intimacy that they share with each other.
Mm-hmm.
And either one in any of the equations can be like substituted for each other, and it usually works the exact same way. Not completely, but especially with the squaring and dividing and stuff like that, like that they become interchangeable in a lot of the equations, and just nothing else works this way. It's crazy what they got going on. And then of course all the ways you see phi and the way it relates to efficiency of organization, the way biology sort of naturally finds like the most efficient way to do things. It's always striving towards being like phi, because phi is somehow some sort of like numerical definition of the concept of efficiency and stuff like that when it comes to motion and arrangement of like around a center goal and self-referencing being all meta and stuff. It's absurd, man. Like, I don't blame a lot of mathematicians for like believing in God the more they learn about numbers and arithmetic and stuff. Like, I get where they're coming from. But I also think that all of these things that I know about, I probably didn't understood from the beginning of time. So that's why I think that you can probably find some of these lessons in the holy texts and stuff like that, and in the designs of the pyramids and the Parthenon and all the ancient structures, and you see phi popping up and pi popping up, and you might get called a conspiracy theorist to say that, you know, these ancients had a much deeper understanding of the universe than we do, and that there's actually been something lost in time that makes us, if you actually understood, like just droopy-eyed, armless children compared to them. Just that we don't even, you know, we look back and like, oh, primitive, we're so advanced now. That I definitely think that you know, a lot of these deep insights about how the universe works have been lost, and we're kind of rediscovering them now to some degree. Not to say we aren't doing our own thing in a special way, perhaps better than anyone else ever done it, but I think we're definitely like just at this point relearning a lot of the same lessons that have already been known in ancient times, and we might feel like we're special, like, oh, we're so advanced and wise. Yeah, no, they knew some stuff back then probably that you never even imagined.
Do you think math is like universal though, or do you think that we just have math plays out the way it does for us because of the axioms and postulates we've set, and maybe it's these axioms and postulates which we see as fundamental that need to be questioned, right? I mean, if you have a set axiom that says 1 + 1 = 2, and from that you build all of your math, why did we decide 1 + 1 is 2?
Right. So here's one thing I can say to that.
Is that something universal, inherent to existence, or is that just dependent on human logic?
Well, I got two things to say about that. So, so maybe we're looking at things completely the wrong way when it comes to understanding numbers and the relationship with each other. Because if the ultimate totality of existence is 1, how do you get 2? If there's no such thing as doubling, then is 2 created by doubling 1, or is 2 created by splitting 1 in half? Right? There's an infinite 1, and then how do you get 2? Well, there's no such thing as doubling. All you have to work with is the 1, and the number 2 refers to the 1 split in half, and we would normally call that 0.5 or 1/2. But maybe the true meaning of 1, is half of, or I'm sorry, maybe the true meaning of 2 is half of 1. Not 2 isn't double 1. 2 is half of 1. You know what I mean? Yeah, maybe we have a whole incorrect philosophy about the relationship numbers have each other, and that how we think numbers apply to reality is functional to a degree, but that, like I said, there might be deeper insights and applications we might come up with if we just kind of reorientated our mindset and the way we're looking at things. Something might click all of a sudden, like, oh boy, well, we're in the Stone Age. If only we understood, we can just fucking smelt this iron and make tough swords. We've been missing out, right? We've been missing out on all these developments if we only just had this fucking simple understanding.
What if I told you that because of these, base axioms that we use in mathematics, such as the idea that 1 + 1 = 2, because of these base axioms, we could never set a complete or consistent set of axioms that proves all mathematics to be true. Do you get what I'm saying? That because of the axioms we've set off with, we can never have a complete theory of mathematics that shows that all maths is true. It's called Gödel's incompleteness theorem. It's basically the idea that
I gotta go. Yeah, I'm sorry, man. I gotta go. I'll talk to you later.
Damn. What, Fundy? We was getting into it. Never mind.
Yeah, I can talk to. I'll show you here.
Yo, what's up, Paid?
Hey, Joe. Hey, thanks for giving me privileges again. Not much. Took me a day to figure out. I forgot how complicated it was to get permissions around here.
Yeah, you gotta type one thing.
Yeah, I know, but it's you gotta go to the right page to do that. It's not horribly complicated. I understand.
I think I saw that. Yeah, you typed it in like I think the voice check-in room
I
or
typed
something.
it in the wrong place. Yeah. So I realized that, and I went back and looked again, saying, "How come it's not working?" Yeah.
Yeah, there's other ways of doing it. Like you can do it with an emoji, where you just click the emoji.
Yeah, I know.
And then but then it can't send you a message that way. Anyways, yeah, there's a lot. When I was looking into all of it, there's like
Yeah, I know.
complications.
Like I said, I went back and said, "Okay, what did I do wrong?" and looked it up. Anyway, it's not horribly complicated. Just complicated. Guess everyone's gone to sleep. I should probably do the same. It's 2 in the morning. What time zone are you in, Gio?
Pacific.
Oh, you're Pacific guy, so it's like what, 2, 1, like 11 there.
It's like 10:45.
Yeah, still early.
Yeah. So you got some knowledge to drop on us?
No, nothing.
You got some knowledge about?
No, it's too late. It's too late to drop any knowledge. 2 in the morning isn't.
How the Pythagorean 3, 4, 5 triangle matches up to 12.
Someone was in here. Someone in here talking about. I think it was Fundamental was in there. I was listening, talking about how we didn't know the value of pi, and I'm going like, that's just wrong.
I was listening to most of it, but I didn't hear. I don't remember him saying that. Is that what he said?
He was upset. He said we don't know the value of pi because we don't know the last digit of pi. You're going like, yeah, that's a really silly argument. I mean, how precise do you need it to be for real life? I mean, I've got it memorized.
Well, it's like an infinite fractal precision that continues to increase.
Well, pi
as
is
it unfolds, but so it is like an infinite type of energy.
Well, pi is both irrational and transcendental. So there's no way to calculate to the last digit. It's just
right. It's cool though. I mean, it's like an indefinitely unfolding process, it seems. And then when you build in like Fibonacci and the golden ratio, now it's happening at like an actual fractal frequency.
No, that's phi now, not pi. That's 2 different values.
Which I think essentially like Mercury, Venus, all of these wandering luminaries are all in their own frequency of the Fibonacci sequence. And pi is pi is worked into that and part of that as well.
Well, guys spent their entire career trying to prove that back a couple hundred years ago and never quite got it to work.
What are you referring to?
Oh, who was the guy that tried to fit all the orbits into spheres?
Copernicus.
No, this guy was trying to fit it into the orbits into the classic shapes. It's 2 in the morning. My brain's.
Well, if the wandering luminaries are all circling the center, And if they're all moving in and out between the tropics, sort of like a general AE map, like the spokes of a wheel coming out from the center over a planar Earth, and those luminaries are all going to be moving in circles, but they're kind of pacing in and out between the tropics and going over the equator, you know, throughout their cycles. So the different like time that it takes Mercury to do it or Jupiter to do it are all different, which of course is what they would call the orbits in the heliocentric model. So like the 88-day of Mercury is actually connected because Mercury phases in front of the sun and then behind the sun in an 88-day cycle. They call that it's going around the sun in the heliocentric model, but really what we see from here is just the lights in different positionings from each other. So one, it goes in front of it, and then it goes the same speed at it, and then it goes behind it, then it picks up speed and goes the same speed as the other one, and then it goes ahead of it. Sort of like if you and your friend were on the highway going down, and you know he goes like 5 miles ahead or whatever, and then eventually you go faster, and then you go a little bit ahead of him, and then that kind of thing. So if they're all doing it in that different frequency, then they're all making a different Fibonacci pi. It's like a pi-based Fibonacci fractal ratio of a circle. But that it's also in a way it's the case in the heliocentric model too, because they're kind of just reconstituting the positionings of them, but they're still making fractal shapes, which like you've probably seen those ones of like Venus where it's like a, you've seen that from above. It's like a geocentric based, basically. It's not
where it makes that nice little pattern you like.
Yeah, it makes like it's like a certain shape. It's like it almost looks like a geometrical 5-pointed, because Venus is connected to the number 5. Its frequency is 5, related to 5, and it makes like a 5-pointed geometric structure. I mean, that what those are is they're like geocentric, but they're still kind of spherical Earth. So the Earth is sort of in the middle, but they're like a geocentric sphere, rather than the actual shape it's making above the actual Earth, which is not quite that, but it's like sphere-based geocentric. Those little designs that you've probably seen, like someone probably posted at some point.
Mm-hmm.
What do you think?
Well, it's interesting.
All right, I just found it. I mean, there's some that have a little bit more of a fancy. There's some that have like a more of a fancy, like, you know, artistry to it. So it's more, you know, but this just shows like the very basic kind of orbital pattern. So if you put a spherical Earth in the middle, and then you have the sun going around it, because the sun sort of, or the Earth's in the middle in this, which is kind of as you, I mean, that's what we see, you know, I mean, on the, even the sphere model, that's, you see the sun doing that, you know, around the thing. Anyways, and then the other one there would be Venus. So it's kind of the dance between the sun and Venus, but it's from like a heliocentric sphere perspective. But yeah, see how it makes that kind of 5-pointed star?
That's a geocentric orbit, right? The Earth is at the center, right?
Pretty much, yeah.
Okay.
Yeah, it's like geocentric sphere based. But that kind of 5-pointed star thing, that does show, because this is like a spirograph basically, and it just shows how it's making that, it's connected to the number 5, like its frequency is a 5. Really on any model you use, it still has that dynamic to it. Connected to the 5, and then that, it's just that it doesn't, like if you took an AE map and you put this thing over an AE map, it wouldn't look like that. Like, because what, like the way that the sun would be going between the tropics and over the equator, Venus would be doing that as well. you know, in that way. So it would look like more like just a different thing. Hey, do you think it? I mean, do you find it just a coincidence that if it is just like a Big Bang and that's what made up this like heliocentric universe, why would Venus, like, why would they have these frequencies? Like, why would they be so timed?
What's the bottom one?
Yeah, I just finally uploaded. Oh, that one's just kind of like it's just sort of a cool little sort of trippy thing, but I think I posted it because at least one part of it sort of shows how the different frequencies are when these things move between the tropics and over the equator. It's not like exactly it, but part of it shows that. And I'm posting another one that kind of shows it as well. Well, that one's just kind of trippy, but it does sort of show how, see, when it's just the circle at the beginning of that last one I just posted, that would be just a circle. And then it sort of fractalizes out from that circle these spirals that come out of each arm. This is why, like, the Foucault's pendulum precesses in the north and the south. There's a field like this. It's all coming out because we were talking about pi before and kind of that ratio. But like, if that at the beginning of that one where it's just a circle, if that was like the equator over an AE map, and then boom, and then that's like, that structure really kind of shows that, because that's like why hurricanes spin the way they do in the north and south of the equator. Foucault's pendulum, all of that's connected to that whole field. And then the luminaries would all be doing their own pulsatings, just like those circles, spirals coming off that circle are showing. Like, they would all be doing their cycles throughout, and they're all different, like the quote unquote orbits. But yeah, I mean, that's what I see is actually happening.
Mm-hmm. I can't even think. It's too late at night. Trying to look for the guy that was trying to spend his lifetime trying to fit the. I don't even know what to Google.
That one's kind of cool too. If you just have these lines that are all interconnected and then rotate these different, you get these different like structures. I love geometry and just like sacred geometrical structures. Hey, do you think you would ever like take peyote?
No. Probably not.
Not even just like just a nice little journey?
I don't think so.
I don't know why I thought of that one in particular, but it just seemed like you would like the wisdom that the peyote spirit would share with you. I'm sure of that. And I feel like you do have some probably Native American roots in you.
I don't think so. Most everything else except for Asian and Native American. Just at least, unless one of the great grandfathers or grandmothers did something with somebody that we don't know about.
Yeah, I mean, it's unfortunate that something like peyote is not just completely legal and able to be used by professionals and things. I mean, it is so gentle and beautiful. I mean, there's so much misinformation about what a lot of these plants and things are and so on. But yeah, I mean, for so many cultures, like all of them would have had at least one journey with something. Like if peyote was in their region, they all have an experience when they're like a teenager, and it helps them go through like a rite of passage, and if they need any additional like support from it, and that's what kept them so healthy and psychologically and physically healthy.
Mm-hmm.
But it's like, I mean, I don't even know if you know anything about it, but I mean, it's like if it was legal and could actually just be used like it is legal in certain areas. Like in Arizona, it's actually legal. And then there's a lot of Native American churches where it is. And then now actually peyote is legal in Washington, D.C., Oakland, California, Santa Cruz, California, Ann Arbor, Michigan, Oregon, and so on, meaning that like the plant-based entheogenic or psychedelic type plants are actually decriminalized, as it were, in all those areas I just mentioned. So, and like the whole state of Arizona as well. So yeah, it already is like getting to that. I mean, it never should have been made illegal in the first place. It's just, I mean, if you don't believe there's a conspiracy, I mean, all you'd have to do is just look at the fact that they took our sacred medicines and literally put them into Schedule 1, at least in the United States. It's like completely absurd and just only based on corruption. Well, yeah, I mean, they want to control people. So yeah, they don't want people healing and connecting with themselves and coming to greater understanding about who they are and how to love others and how to be in harmony with others and how to be in harmony with the earth. They'd much rather have people disconnected so they can control and do all the stuff they do, unfortunately. So yeah, I think things are going to have to shift in a positive way, because I think they'll probably drive us to extinction if they keep genetically modifying us the way they want to. So we're going to have to break free from them at some point.
Ooh, Magisterium Cosmographicum. Sounds really, doesn't that sound cool?
That does sound cool. What's that?
The cosmographic mystery. Also translates the cosmic mystery, the secret of the world, or some variation. Astronomy book written by Kepler. I just like the word Mysterium Cosmographicum. Cosmographicum.
Nice. Yeah. Yep. Well, I mean, that's what it was cosmography. I mean, that's the original.
This is where he tried to explain that the ratio of the 6 planets known at the time were all based on the Platonic solids. And no one could ever quite get it to work. I don't think it was Kepler spent his whole life doing this. It was somebody else. Right.
So what do you really think of these guys? Like, let's just take Kepler. I mean, what is your viewpoint on it? Meaning, like, here would be a couple ideas. Like, was he even a real person or not? And then here's another level. If he was a real person, are the writings and the things that we have from him his actual original ones, or are they altered? And then why do you think so? And whatever in those things.
Well, Kepler only lived. Kepler's 300 years old, 400 years old now. He died almost coming up on 400 years. I think most.
All right, so you think
most
that
of the knowledge from there is authentic?
Okay, so you think it's authentic?
Yeah, I think most of the knowledge from that era is considered to be authentic.
Gotcha. Well, yeah, there's a lot of heliocentric stuff claimed to be attributed to him, so it's definitely
one of
highly
the,
questionable just based on that alone. I mean, the Earth is just not a sphere on any level. It's not moving any of that. So I mean, some of the stuff that he was claimed to be connected to were basically a following of what's claimed to be this whole sort of Copernican revolution, Copernican principle system, or the Copernican system as well, that is claimed to be this lineage of, you know, these guys that apparently just discovered the truth 500 years ago, even though humans have been around for eons.
Well, you know,
they just blew our noggins. Like, it's not even that they had rockets or shit to go out there and be like, oh my God, it's a sphere. This is claimed that these just dudes on the Earth, same as you and me, paid NASA show. You, me, Kosho, all of us, you know, it literally like.
Well, they've known the Earth is a sphere long before.
Chilling. They don't have rockets and going out there. They don't have satellites out there. They're just dudes chilling. And they just happen to fucking just strike gold of this idea that the Earth is actually a sphere and all these other things. I mean, come on. What is that really a believable story?
Yeah, they've known the Earth is a sphere for 2,000
and then
years.
it just happens to be that after World War I, where they do genocide and do all that shit, sinking of the Titanic, and then the establishment of the Federal Reserve, Einstein, the Great Depression, World War II.
What's this had to do with the shape of the Earth?
And then finally they claim to get rockets out there, so then they could start to try to, and go to the fucking moon, to where then they could convince people, hey, it's real. That's how long it took. But in your viewpoint, like, these guys were fucking just geniuses and absolutely just discovered Earth's a sphere. If you believe in that whole Copernican revolution, and you believe that's true.
Copernicus didn't have any much to do with the shape of the Earth. He knew the Earth was a sphere. We've known the Earth is a sphere since about 500 BC or so, somewhere in that general area. So that's not new knowledge. I mean, the fact that the Earth is not at the center of the universe, that's what they started discovering.
Well, these are claims. These are claims. They are claims. And I know you may believe them as true, but of course it is a secondary or tertiary level of direct anything that you have.
Oh, no. I've got first level knowledge that the Earth is not flat. You can do that. You can do it a couple different ways. I mean, this is not high-tech stuff anymore. So with a cell phone and an airplane, you can definitely show the Earth is not flat.
So, okay, so I'm just saying the story that you're told. Okay, so when you say we believed the Earth was a sphere, I mean, you were trying to go back to like even for a claim of even before Copernicus. I mean, obviously in today's day and age, like it's referred to in terms of the Copernican revolution and all of that. Now there are the claims that even earlier, people were had this idea. I mean, I think the kind of mainstream story of Pythagoras, who was like had this little cult, like a sun worship cult. And then he basically started saying the Earth was a sphere, and then he got these other people involved. And, and then that idea would be that group sort of has continued on through the Freemasons and through all kinds of different, Jesuits and so on. So there is that idea, but I mean, then to even put that into context, you have to then believe the whole story of what humanity was at that time. You just have to take that on face value. Then you just have to kind of believe it. But yeah, I understand that's an idea. But even when you say we, what does that mean? 10 people, 30 people? And why? Because they saw boats that would be visually obscured from the bottom?
Yes,
no way.
That started, yeah.
I mean, if they were doing that, they were absolutely like in a state of schizophrenic cosmographical disassociation.
That and the fact that when they went south, when they started traveling, across the Med, they would see different stars than they saw on the other side of the Med. And they start going into Africa, and different stars start coming out.
Yeah, but those have been mapped for centuries, eons before that, on a planar Earth surface as the foundation for all navigation.
Right, but that was no.
I mean, how could they have done it if they were just if they were that off, and it just what I mean? That already was established.
Your history is slightly off. I don't
Because it's
think
not
they
hard
were.
to do. Anyone can do it. It's circle of equal. I mean, it's not like the easiest thing in the whole world to do, but I mean, you do have to have an ability to do it. But I mean, it's just very basic in terms of mapping the star systems and GPs. So they never needed any spherical anything for that.
Let's not get into that today because I don't want cell nav is another issue, which actually comes a little bit later.
Nice one, dude.
Well, no, I don't want to get into that tonight. I really don't, because we're talking. I mean, they knew that the Earth was. I mean, they suspected the Earth was a sphere based on the boats going over the horizon and the hull disappearing before the sails. And when they returned, they appeared the sails first. That's why they put people up in the crow's nest of ships so you can see further. And then it wasn't until.
Well, I see how that idea could be attributed later and be like, oh, they thought that. But
no, they noticed it.
There wouldn't be any reason to. I mean, okay, I do understand the explanation of why that could be Earth curve. Like, I would say I agree that it's fair. Like, I agree that it works that way at long distance, the way you're describing. Yes, well, it depends on the ratios, the atmospheric conditions, depends on a lot of things. But you can definitely get an arrangement where the ship will. Yeah, it will, like the water level will look like it's obscuring or cutting off, however you want to describe it, but visually it's doing it. So even if you want to call it cutting off visually, or if you want to call it obscuration, which is I think more of an accurate term, and that will occur, like the meeting place of the water and the boat will shift to where the ratios are such that the water will start to rise from the hull of the boat and then all the way up to the mast and all that. So I understand the idea that why it would do that on a sphere. That's cool. We can hold that one possibility. But I also completely understand how that's perspective, and that could be recreated on small scales in a whole variety of different ways. And that's like the way the whole, like everything merges at the convergence point of all the perspective lines and so on. So it all makes sense in terms of that as well. However, you're claiming that in this time, these 500 BC or whatever you were saying, that these guys, even though it had been interpreted that was perspective over a planar Earth for eons, since the dawn of humanity, you're just claiming that these guys in 500 BC just all of a sudden their minds were blown, just like you're saying Copernicus. But you're saying these guys were just so high above everyone else, and they were so their infinite wisdom that they said, no, I think that cutting off of the boat from the bottom up is because the Earth is curving, and that somehow they were just striking gold with this incredible idea. Is that the story you're trying to say? And that's all they had?
That's basically it.
And sticks in the ground?
Well, the sticks in the ground came later. Sticks in the ground came later. Sticks in the ground was the proof.
All right, so you're telling me in 500 BC, these guys are like...
these six.
First, they're like, "Oh, dude,
these guys were smarter than you in 500 BC." And
so first, in 500 BC,
actually measured the Earth. They knew that the Earth was a sphere, and
so before 500. Okay, let me just get this straight. Before 500 BC, all humans had been navigating planar Earth, the sky above. Let me just finish speaking. I'm just saying that a stationary planar Earth with the heavens above has been the default of all of humanity, and then the cutting off of things on the water from the bottom up is due to perspective. So you're telling me that was the baseline. Everyone knew that. And then in 500 BC, you're saying that these dudes were like, you know what? I actually think that cutting thing off of the boat from the bottom up is because Earth's a sphere. And if I put these sticks in the ground and I assume the sun's really far away, the Earth's a sphere. And you're telling me that right at that moment, those guys were actually striking gold and striking on the first truth that the Earth was a sphere ever in humanity?
Well, probably. I mean, the first guys actually write it down, at least, let's put it that way. First guys to make sense of it. But the sticks in the ground came after he knew the Earth was a sphere for a while. And he was the guy who actually measured it.
So can I contribute a little bit here?
Yeah, I gotta step away for 5 or 10, so I'm gonna be listening. This has been a fun, it's a fun convo. I want to hear you guys take care.
Yeah, it's 2:15 in the morning. I should probably go too.
Well,
go ahead,
just a quick one, mate. So in 500 BC, right, they discovered Earth was a sphere. Yeah.
Well, they suspected it, at least.
Well, suspected it, yeah, because they saw, say, boats going into the horizon and potentially sailing off the edge of the Earth. We've all seen the classic cartoon, boats sailing off the edge of the Earth. So then
the Earth would have an edge. The Earth would have an edge if it was flat, right?
Well, let's not just quite go. Well, we're talking 500 BC, so this may be what they were thinking about, right? Because that is the common kind of thing that is spouted around, like boats sailing off the edge. So then, in 500 BC, they
Plus or minus one.
Yeah, they set out to sail, and now they discover that they're on a ball. Okay, then. So
Or at least the Earth is curved as far as they can tell.
well, curved, or at least curved. So they're going down, right? They're going down a hill. Okay,
let's not go there because that gets into some different concepts.
No, well, no, it's all the same concept, because I know why you don't say it goes down, because of gravity and all that sort of stuff, right? Because this is where I'm going, all right? But back then, in 500 BC, they had no notion of gravity, because gravity wasn't
Well,
even.
they knew.
Well,
no, don't give me that. They know about gravity. They knew that things fell in the direction we call down.
No, they had no idea of
Oh,
gravity.
fuck
because
off! Do you think that gravity didn't exist until somebody finally said something about it?
No, gravity. They didn't even think about gravity until
they knew
1665.
but they knew
1665.
They knew that when you drop something, it went in the direction called down. Little kids, when they're 2 years old, knew then, as they know now, that when they trip, they fall on their bottom, they fall in the direction called down. Now, they may have a different word for it because they spoke a different language, but the concept was the same.
So in 500 BC, like, they had the concept of down being towards their feet. So as long as down is down. So what in 500 BC was this mystical, magical force that kept them from going over
I don't know if they thought that
curve?
way. I don't know.
They must have thought something, because
No, I don't think so.
Well, if they were that primitive, right, and
No,
they thought that
extremely
boats, if they thought boats sailed off the edge of the Earth on a flat Earth.
Well,
right,
then again, the boats usually returned. Like the sailing off the edge of the Earth was if you went too far away, which the Mediterranean was not known for.
Yeah, but the theory is
they didn't sail out of the Med very much.
No, but the theory is that they discovered the spherical Earth 2,500 years ago. It's been known for 2,500 years that Earth is a sphere.
Yep.
Right. So now I'm on the bottom of a sphere. I haven't even discovered gravity until 1665. So when I'm on the bottom of a sphere, what has stopped me from falling off? Why aren't I petrified?
They didn't discover that.
What do you mean? They had
They didn't go that far. They didn't sail outside the Med. Because if you look at the times, then nobody sailed outside the Med. Very few people. Occasionally, people would sail on the Atlantic, but they stayed close to land. The deep sea, the age of sailing across the oceans is a couple thousand years.
Okay, so they're sailing over a curve. So sailing over a curve, they naturally think to themselves, because they can study water now on land, and they know that water goes from a higher elevation to a lower elevation, right, and flows down.
I don't know if they got that far yet.
Well, they must have. They must have thought these things if they were smart enough to work out that.
Well, maybe they knew that water fell from the. Maybe then again, the only part of the Earth they know is this section around the Mediterranean.
Well, I don't know. If they're smart
they probably recognize the water flows downhill. I'll give you that, because that
exactly right. So what in 500 BC stopped all the water from pouring off the top of this curve?
I don't know.
Exactly. Right. So it doesn't really make much sense.
I don't think they were concerned about it. I don't think they were concerned about it, though.
I don't think the stories kind of marry up there.
Yeah, I don't think they were concerned about it.
Mixed up. Well, they must. I'd be concerned about it.
No, you're a modern person, though. You can't. I don't think you're putting yourself back in there. They basically say how about they say we don't know, and we'll have to figure that out later.
No. That's exactly what I'm thinking, because I'm putting myself back then. I believe in gods, and I believe in woo-woo.
Well, then the gods
did it. I believe in all this sort of stuff, right? And now, right? And then when I go over this curve, why don't I get
who's the god of the ocean? Was that Uranus? Was he the god of the ocean? Poseidon?
No, that was.
Or some similar guy.
Neptune or something. Wasn't
Neptune, right?
Yeah, it might have been. Was that
so guy? Neptune was in charge of the water.
Yeah, exactly. So how did he
So
stop it
he kept control of it.
How? With his pitchfork? He put his pitchfork
Yeah, I
into
mean
the
he's
ground.
he's in charge of the oceans. Zeus is in charge of I don't know.
The dates don't nowhere near marry up. They don't know
I don't
near.
know.
Like they're 2,000 years from discovering gravity, and that on the bottom of the ball,
Well, no,
they're
they
actually up.
but no, I mean they're 2,000 years from understanding gravity. Perhaps they knew gravity. They knew that there was something pulling stuff down.
Like what, magnetism? So then why could they
I don't know.
jump? Why could they
I don't know.
jump on the bottom of a ball?
I don't know.
Because if stuff is
Speaking of
pulling
living
it
on the
down.
bottom, you're the guy living at the bottom of the ball. You tell me how it works.
No, well, apparently I'm not on the bottom.
You're
Apparently
on the
I'm
bottom
on
of the
the
ball. How are you standing your head right now?
Well, no, apparently I'm on the side of the ball, not quite on the bottom.
Well, you see,
A
that's
bit
the
more on
thing.
the side.
I don't people like you. I mean, although I like you more, I have to say you're one of my favorite flat earthers. I think that you and I could out and have a beer.
Yep.
As long as I'm buying, I think.
Exactly right. And have deep pockets.
Yeah. That's what I'm saying. I know more than to pay. I know not to pay in Aussie's full bar bill because that'll bankrupt you.
Yeah,
But
exactly.
where was I going with this? It's 2 a.m.
Keeping water from flowing off the top of a ball.
Well, I was going to. I think that Southern Hemisphere or outer band, however you want, Australian flat earthers amuse me because you can go outside and see that the things aren't as Nathan Thomas tells you they should be.
What's Nathan Thomas? What's he tell me they should be?
Well, you shouldn't be able to see you shouldn't be able to see a second rotation point. You shouldn't be able to see.
Who's Nathan?
Nathan Oakley, Nathan Oakley, Thompson. Who's the other Nathan? There's Nathan Thompson. I mean,
I don't
you shouldn't be able to. Wow, you go look outside and things aren't the way they say they're. If you look in the sky, the sun sky.
I don't know. I reckon if you walked out your back door and I walked out my back door, we'd probably see similar things. See land, would see sky, and would see sea.
Yeah, but I see different stars than you do. Actually, right now it's daytime there, which is interesting.
I know. Amazing.
Can I intercept for a second?
Yeah, go, Carlos. Go, buddy.
It's a slightly off topic, but I mean, you don't have to continue with it. I saw there was a NASA article saying that they've measured accurately the perimeter of Antarctica, and it actually ends up it's bigger than the circumference of the globe.
What?
Yeah, do you have the link to that?
Yeah, I'll find it now.
Okay, thank you.
NASA. The circumference of Antarctica is bigger than the circumference of the globe.
Well, it depends how precisely they measure the coastline. I mean, the coastline of the United States, the coastline of Australia, if you measure like every nook and cranny and go around every inlet and every little bay, it's huge too. I mean, as I saw the East Coast of the United States,
it sounds a bit too big.
Well, no, because you measure like every little bay and every little inlet, and
That's a lot of bays.
Yeah. You have to
Yeah,
measure
it's
around
like the sorry, it's like the second half of that video I just posted that it starts talking about that.
banjo. Oh God, I got some of the banjo. How long is it?
You get through about the first half and it's stuck. I don't know the timestamp, but yeah, the perimeter of Antarctica. It's
I don't know if I can
crazy.
take banjo at 2:20 in the morning. Let me right to sleep.
Well, it's actually not him. It's him posting someone else's
I
material.
know, but
on
he's
his
reading
channel.
it.
Yeah. He's narrating over top. Yeah, but it's just going over the article that was from NASA.
Oh, hold on, let me see what he says. Maybe I can stay awake for a bit.
And that yeah, fucking hell. I live near like St. John's Ambulance, a major police hub and a major police fire station. So yeah, I'm about 2 kilometers surrounded by these guys all day long. It's crazy. You'd think you're in a war zone living here. Yeah, but they're all actually going to the other side of town, so that makes me feel better.
So Western Australia is mostly desert and relatively flat. Well, I can vouch for that. It is relatively flat.
Oh, it's the first half, not the second half.
A flat sea.
Hey, you know what they mean by a flat sea. Come on. You guys are Aussies.
There we go.
Paige, so go ahead.
No, go, Joe. Jump in, buddy. Jump in.
Just real quick, I was just gonna ask Paige, like, Paige, if you did see like absolute measurements that the Earth doesn't have curvature, and or if that happens on a larger scale, you know, in the coming years and so on, to where it's absolutely for sure that it doesn't have the curvature and so on, how will you look back on this time, and how will you kind of try to figure out what happened if that was the case?
Do you have the data, or are you just posting a hypothetical?
At the moment, I'm just posing it to you. If you want to call it a hypothetical, that's cool. Let's just go with that.
I'm sorry. It's 2:25 in the evening. In the morning, I'm not in the mood for hypotheticals. Sorry. Well, however, if you come up with the science, I'll admit that the science is correct. You would come up with the science first.
We've just established, that they discovered that Earth was a sphere in 500 BC, but because they didn't discover gravity until the late 1600s, they had magnetic boots to keep them from falling off the bottom of the sphere and the water from falling.
Oh, come on. You're not that stupid, Bandy. Don't give it to me. Bandy, you're not that dumb.
They knew nothing about gravity back then. Absolutely nothing. They should have correlated the dates a little bit better.
All right.
Like how could they have said the Earth was a sphere and then had not had some thing, a force that, because everyone knows everything would fall off the sphere. So how when you're saying they knew it was, you're saying all these people believed it with absolutely no logical reason as to why there would be a physics that sticks things to a ball?
Well, I don't know. The gods were in charge. I don't know. I don't know there. Maybe they weren't worried about it.
Like, they were very primitive people. Water flowed downhill. It was on top of a mountain. It flowed down a mountain. Like, I would have been worried if I was in a boat sailing over a sphere. I'd be worried that I'd be falling off the side of a sphere myself, let alone off the edge.
I always thought that the first sphere they produced was a flat stationary Earth, geocentric, with a celestial sphere around it. So the stars would go around this realm that we live in, and that was the first globe. Was actually just based on the stars alone. And then somehow they decided to wrap the water around it as well.
NASA's saying they discovered the sphere in 500 BC. Pretty conclusively.
Well, they discovered it was at least, somewhere around there.
Yeah.
I don't think they were concerned about the gravity part yet.
Oh, I would have been. I would have been petrified.
Of course, I know, you're going back. I don't know. Whoever the god of gravity was controlled it.
God of gravity.
Think about how frightening that would be. Like, if you just, like, all your family lineage for eons of time, like the Earth is like a plane of existence. We're in a realm, there's the heavens above, all of that, which always was connected to a creator as well. And you just came along and said, hey, you know what? You're actually on a huge sphere. We have no idea how you're stuck to this sphere. We have no idea how that's happening, but you just are. And get this, you're moving at millions of miles an hour through a huge unknown galaxy. And we have no idea what this thing is. We don't even know what this thing is. We don't know if there's just asteroids that might hit us tomorrow. We don't know if there's aliens. Oh my God, that would just wipe the floor out from some underneath.
I'm saying you that they knew the Earth was a sphere, and you started into everything else that they didn't know for thousands of years later. But okay, go ahead, go for it.
I would never have come out of my cave. I would have been too petrified myself.
See, well, the Greeks lived in an age of reason, where you didn't have to worry about this, apparently.
Well, they were very smart. They discovered the sphere, but they could, but they had no idea what kept the water on the from
I don't know.
just
I don't think
pouring
they were
off it.
concerned about that. Obviously, it didn't
Well,
pour off, so they weren't worried about it.
well, I would have done a few experiments myself. I would have got myself a rock. I would have chiseled it into a ball, poured water on it.
No, see,
I
they
would
weren't
have
that
been
dumb.
petrified. They
They
were
weren't
that
Well,
that dumb.
dumb.
I'd say before microscopes, right? I'd say they probably would have just surmised by looking at a housefly on the ceiling and supposing the ceiling is really big, so the fly can walk upside down. So the Earth is really big. That means we can walk upside down because they had no microscopes to check how that fly was sticking to the ceiling. Yeah.
So now we've got fly feet that stick to
Yeah.
ceilings.
Oh, God.
I don't know. Maybe they thought they didn't. All right, this thing about the coastline, all they're doing is measuring the coastline very precisely, measuring every inlet, every bay. So it's not surprising. If you know anything about coastlines, they curve a lot. They're not flat.
Oh yeah, it definitely looks.
So that's all they're doing here. It's not a big deal.
But it kind of matches up to the flat Earth map, doesn't it? As
No, not really.
Antarctica being the perimeter of the southern region.
No, not really, because you could still sail around it in a whole lot less time than that.
Maybe time's different down there.
I don't know.
Oh, now we're getting into time relativity. Really? You want to go there at 2:30 in the morning?
Might
You want
just
to go
be.
into relativity?
Well, it might not be that complex. It might just be simple as portals. There might be a big series of
Pac-Man?
portals down
We can
there.
go Pac-Man now too. So you get the one side edge of the flat Earth, you Pac-Man over the other side.
No, not necessarily that, but more just that there's actually portal regions on the Earth that, depending on the electromagnetic charge and so on, to where if you enter into it in the physical world, you can and will transition through time and space to a complete other dimension, other realm.
Okay. I want to know how they describe this.
Which actually plays into what they use as the black hole story.
So what did they say about this phenomena before the Pac-Man was invented? How did they describe this? I mean, because saying Pac-Man is such a great way, everybody knows what you're talking about.
No, that's something where you exit one side of the map and then you just arrive on the other side. Yeah, I'm not referring to that. Well, there's a portion of that. What I'm referring to, believe it or not, I mean, everyone always likes to bring up Narnia. I mean, it's that type of concept where you're in the physical world and you are who you are at your age and everything else. And if you enter into these areas, you literally can like shift into a complete other state of consciousness. And then you can come, and then some of these legends.
The rabbit hole into Wonderland or Ellen?
No, I mean it would depend on. Well, there's different things. I mean, for example, like
he went to the closet to get to Narnia. He went down the rabbit hole to get to Wonderland.
Well, like Hyperborea. So there's the idea that when you go to the center of the Earth, there's multiple portals in multiple regions and areas, and so if you're at a particular awareness, vibration, intention, etc., and you go with a group of people, you can all enter into another realm together. And then you can come back into this one. And you could call it another realm, but it's physically at the center, if you want to call it that. But it's like you can get into like time, space, warping, even bring some of those ideas in, that at these points, it shifts to where your consciousness completely shifts and it can be into what seems like another dimension. So it's like another world at the center, but that world is huge. Like imagine something like Lord of the Rings or something, just this huge, huge, huge landscape. What if that was all in the center? But it's not that it's physically in the center the way that we know physical land. It's that the center is a vortex of the entire magnetic field. And it's like you can get into the idea of time and space are all, and at that point, and that's kind of like the black hole thing as well. But you can enter areas and regions to where you literally will enter into another realm or dimension. And then when you come back into this one, it's like you're in the, it's like no time passed. So when you come back, you could live like eons in another one. And then you come back here, and once you come back here, you're right back where you were when you left. We got to get it into a full screenplay in a movie. That'd be sweet. But I mean, that's what a lot of those ancient legends were, like the Hyperborea and of these like sacred lands at the center where they would go to have like healing ceremonies and downloads from higher levels. Of course, now the Dark Ones are using it for their channeling, and that they're doing it from the center. So it's kind of where they're controlling the whole plane from right now, in my viewpoint. They're basically like blocking those portals, keeping them from us, and then kind of controlling the center right now. So, Paige, I mean, isn't that sort of similar to what the mainstream story claims? What happens if you go through a black hole?
I'm not totally up on black. I don't think you can go through a black hole and live. I don't think you can get out of a black hole.
All right. So, what happens in your model? Let's say that we had, like, you know, whoever you want to say invented some great new spaceship or whatever, and we can go to a black hole, and you and I are in the ship, and we're going through it, dude. We're gonna just full speed ahead as fast as we can go. We're just gonna launch into this thing. What do you think could happen?
We'll get spaghettified.
It just turns our body into spaghetti shreds.
Yeah, basically.
Just dematerializes and deatomizes your entire body into just a.
No, about that, but
It swallows you whole. Is that so? You're just saying you would die?
Yeah, basically. Oh, would you or not? Because time slows too. There's some question as to whether you would die or not, or whether you...
Yeah, that's deep. That's intense to think about. Yeah. That's kind of what I'm saying with like the idea. I'm kind of using a little bit of that in the idea of like where you can portal into like a whole nother realm where it could feel like 1,000 years in that realm, and then you come back here and it's like a minute, the same minute you left. It's like just entire lifetimes within.
It's like when I left my hometown, I went overseas stayed in China for 7 years, came back, and nothing had changed.
That's pretty sad. That's pretty sad. If you live in this little bitty old town or something.
Yeah.
Talked to somebody that lived in a town of like 15 people, and something similar happened. They left for like 6 years, went back, and nothing had changed. I go back to my town after 6 months. I don't recognize the place.
There was a guy who wrote a book. Basically, he was like, you know, I don't know his exact age when this happened, but, you know, like a 30-year-old, 35, something in that range, I think. And he got into an accident and he went into a coma. So he was in a coma for quite a long time. I forget the exact amount of time, but like months and months and months, just straight in a coma. And then he came out of the coma. And when he came out of it, he said that when he was in the coma, he went to the future. So it was on Earth, but it was the future. And he said it was like 2,500 years in the future. So pretty far, like considering, you know. And he said that the whole time he was in the coma, that, you know, we here in the physical world could validate, like, yeah, this guy's in a coma. He claims that during that whole time, he was in the future and he was living a life, a whole lifetime there. And for many years, he was living there. And he, of course, in his book, like writes about all of what, you know, things were like then, 2,500 years from now. And so that's an interesting part of it as he's describing that. But that's what he claims. And he like lived like a lifetime in the future. And then when he came back from the coma, he came back into this life. So it's like not a past life, it's a future life. But it's not only a future life like memory or like an emotion.
Do you remember it all? Could he make some money off of it or not?
Well, yeah, I mean that. Yeah, he's shared his. I mean, I guess like if you're going to look at it from a super materialistic type perspective, you could say it's just his experience, right? You could say it's like a dream, but then there's the question of, is it actually real? I mean, in that case, like he wasn't just experiencing like an emotion or a memory from a past life, because that's sometimes when people do like therapy, like past life therapy, they're connecting with, like, let's say they have like, you know, pains in their body, like in their back or something, and then they want to find the root of it, and then they go to a past life where they were like stabbed in the back or something like that. So there's that thing. But in what I'm saying with him, he actually claims that he actually went to the future and was living the life the way you and I are living our lives right now, you know, day in, day out. That's what he claims, is that he actually like, I think he didn't say he was born in that time. He said he just popped into someone's body that was like, you know, like a 21-year-old man or whatever. He just like woke up one day, basically, or woke up like, well, when he went into the coma in this life, in this reality, he claims that he just literally, right when he went into the coma, he woke up in that person's life, and he was actually like living the whole life. So it wasn't just like a faint memory or like some idea. It was like that's what his claim was, is that he actually was living the whole life the way that like that you and I are living our lives now. And then what if, like, I'm not trying to say I think that it's going to work this way or something, but what if like we just went to sleep one night and then woke up in someone else's body in a different time? I mean, that's kind of a trippy idea in and of itself, but. So what do you think of that? Do you think that's even possible in your worldview, Paige?
I don't know. I haven't even heard this story before. Seems like a weird one. At least he wasn't bored while he was asleep, huh?
Yeah. Do you think it's possible you've lived a past life, Paige?
I have no knowledge thereof. I can't comment on it.
But it sounds like you think it may be possible.
I have no knowledge of it.
Well, do you think it's possible that you have amnesia? Like you don't have like a form of amnesia, meaning you don't have like memory of that layer of, but that it actually could be there in your mind?
I have no idea, since I can't access it. I definitely can't access it at 2:41 in the morning. I can barely access my own brain at 2:41 in the morning.
I think some folks, like even like in terms of believing the globe and that whole model, I think some will still say that like they think reincarnation could be possible. But I think one of the ways they describe it is like, oh, through the genes, like they try to make it more material that way. Like if a child like instantly is like a genius piano player, right, when they're just like, you know, like 3 years old or whatever, like how could they have already be like, you know, a master of piano?
We really don't understand savants at all.
Yeah, like what's up with that? That's profound.
I knew a guy who was a numerical savant. He could multiply 5-digit numbers faster than you could punch them in a calculator.
Damn.
Yeah, that stuff's incredible. I remember a guy, it was like a form of savant autism, and I'm sure we all heard of this kind of thing, but where you could give him any date and he would tell you the day of the week it was.
Yeah, that's a calculation.
I know, and it's not even like it's kind of on the savant thing. It's like it's on a certain part of that. Yeah, but
yeah, I don't know if that's really a savant thing, because there is a calculation that can be done. I don't. But this one guy.
So you're saying that the guy, when he does that, those people. I remember there's a guy at my school who could do that. And you could go up to him. You know, he was in like the special ed part of the school or whatever. But like at lunchtime, you know, he would be like around the area and whatnot, and people would go up to him and just ask, you know, say like, you know, September 13th, 1989, you know, and then he would be like, and then he would repeat it. He would say September 13th, 1989. That was a Tuesday. Like he would do it that quick. It was he would definitely repeat the day because he needed that in his head or whatever. But it was very quick. So if he was doing an actual calculation, that obviously is impressive. I'd have to see what that calculation is. I hear what you're saying though. There probably is one because it is all cyclical.
Yeah.
But if he's getting it, but then otherwise, how is he doing it? I mean, it's pretty intense. It's pretty interesting.
Here, I've got it here.
If it is a calculation, it's a pretty cool party trick.
Yeah, it's a party. I mean, the fact you can do it fast is interesting, but here's one of them at least.
Oh, there you go.
I mean, I guess the guy, is like the musical savants is the one who really don't understand guys like Mozart and that just
Yeah, dude. Have you heard that Beethoven, like when he wrote his music, he basically would just close his eyes and he would.
He was deaf for the last 10 years of his life.
But he would he would basically like hear the notes,
Mhm.
and then he would just write them down.
Yeah, like I said, he was deaf for like the last 20 years of his life. He wrote some of his greatest works when he was totally deaf.
Look, that's pretty interesting that he's literally hearing the song and then he's just like, you could call it channeling it. Like he's literally just copying it from something else, like the ether. I mean, there's
They said that Mozart would write stuff down without error, first time.
Yeah, that's incredible too.
I don't know. Anyway, well, it's 2:45. I'm falling asleep. I'm going to bed. Have a good one, guys.
All right, Nessa.
There's some savants that are really good singers too. Like, have you seen any of those bands? Like this one guy that was on, I forget if it was Britain's Got Talent or America's Got Talent. America's Got Talent? Have you seen one of those?
Oh, I've seen the shows, but I can't actually recall seeing any sort of savant performer there. No, I've definitely seen the show. But it is interesting with people that can. Some people, I don't know what it is, but
Check that one. Oh, just because.
Yeah. Actually, no, I saw him. Yes.
Yeah, he's incredible.
Yeah, he went viral. Yeah, I actually did see him on a clip.
Yeah, sorry, I didn't mean to interrupt you. I just posted it. So yeah, because that's the one I was thinking of. I mean, it's amazing. It's like he has. I don't know all of his condition, but I mean, you can tell the way that he's like acting, and his. I think it's his mother. But I mean, he definitely is impaired, and then when he sings, it's incredible. He's like he's already been doing it for 80 years.
Yeah, no, he was incredible, but he just seemed to be in a zone. That kid, didn't he? Like, he was quite incredible. Like, when he wasn't playing the piano, he was totally just reliant on his mum there. But then all of a sudden, he sat in front of the piano, and this whole world just opened up in front of him. It was quite incredible.
Yeah, I don't know if he won the whole thing, or I think he did get like far into it, because I mean, I didn't really follow it, but I think I did see that he definitely got into further rounds, and then I don't know whether he won it or came in second or something, but yeah, that's profound. I mean, it's just, I mean, he had like style and soul, like it wasn't just it's not that he just hit the notes. It's like it was like soulful and had like
Yeah, after I actually saw him, I can't remember what I saw on YouTube or whatever, but I actually saw it, and then I actually YouTubed him, because I thought, gee, this kid's got an incredible gift. And I actually YouTubed him, and he's got his own YouTube page and everything. And I watched a few of his songs, and it was quite extraordinary to see that young fellow perform the way he did.
Yeah, I just looked here. I just Googled his name, and then he's got a whole website, pretty fancy looking website with bookings, and looks like there's some band that he's in, and so there's the whole website here. So it looks like Yeah, he's doing it.
Yeah. Which is really cool. It's really cool to see that someone with a severe disability like that has really carved a path for himself that that quote unquote normal people just look at awe in him.
So why do you think the creator creates all something like that? Like, what is it? Does it just want to have every different possible experience and every one is unique?
Yeah, look, I've got a nephew that has Down syndrome and quite severe. And like when you get into the whole conversation in regards to God or a creator and these sorts of things, you ask yourself, like, if I was that creator, why would I do something like that? Like, why would you be like so cruel to inflict some people with these things? And I know with Damien, he is the happiest fellow. Whenever you are around him, Gio, you you just feel happy. There's nothing but happiness around him, and he's a joy to be around, and you feel uplifted. And maybe that is, the reason. These things are the reason. Um, and you don't know why. Like I was telling this, I think, to Carlos maybe a month ago, but my wife and I, when we went to down town, we're in the shopping centre and we were in one of those little food courts, and we're having a coffee, and then anyway, walking through the door, um, there was a this mother and father were pushing a hospital bed with what appeared to be their daughter. Now, she would have been maybe in her mid-20s, and she had all these contraptions hooked up to her, like, and she was severely disabled, like mentally, physically, the whole 9 yards. And they were pushing her through the door, and anyway, um, Sharon and I, looked at her, and you see this young woman, and she is just, she had this shake in her head, which was, this, I think, a natural shake to her anyway. But her eyes were just going everywhere, just seeing everything, and she had this smile on her face, and it was so uplifting to actually see, this smile on her face, and her parents had this smile on her face, and you think to yourself, the extraordinary effort it would have been to actually just to get her there, to get her out of the home, into the car, out of the car, through the shopping centre, back into the car, back out of the car, back into the home, would have been a monumental job in itself. But everyone just looks so happy, as sad as what it was, right? And I'm sure their life is just nothing but a struggle, absolutely nothing but a struggle. But they had this motivation, it seemed, within them to give their child every opportunity to experience, absolutely everything that they could get her to experience. And why? What is the reason? I've got no idea, but maybe the reason is to put a smile on other people's faces to see things like that, because it definitely, even as sad as what it was, it put a smile on my wife's and I face. To see her happy, to see her parents happy, and kind of live that little moment with them. Yeah, it was very moving, and like I said, with Damien, he has such this positive energy about him. But why it happens, I don't know. But the best answer I've got is maybe for experiences like that. maybe for experiences like that. Who knows?
There's the idea that the creator has a impulse in a sense to create everything that it isn't, meaning that if it's infinite, it wants to create finite. If it's infinite like bliss, it wants to experience limitation or suffering or separation or pain. If it's infinite joy, then it wants to, it seeks something different than itself. And then those of us that are in the state of separation from it, that we crave the other side. We want to be whole and we want to just be in love and bliss. And that there's like some sort of dynamic between these states of consciousness that is being desired to be had. Like it's intending to do it all so that it can experience all of the different parts of itself.
Okay. Hold on, I'm just getting a phone call. I'll be back.
Yeah.
Sorry about that, mate.
Yeah, no, all good. I wanted to hear your thoughts on that. Yeah, just the idea that if that the creator, all of those things, infinite bliss, infinite knowledge, infinite awareness. There's actually a term in Sanskrit called Sat Chit Ananda, and it's a 3-part word that actually represents this. It's like infinite love, infinite awareness, infinite knowledge, peace. And then if it's in that state, like that idea that it's actually craving what it isn't. So it's creating like limitation and suffering, dying. Like if it never dies, it wants to create death because it never dies. So, well, maybe it'd be interesting to see what it's like to feel like you're dying or have that be a thing.
So it wants to experience every possible emotion.
Yeah.
From every possible. That's an interesting way to think of it, actually. And yeah, I've never heard that, but that is definitely a possibility. Every possible emotion, from both the person itself, but also to other people that have to interact with with people, with anything. Yeah, actually, that's pretty powerful, Gio, to be quite honest with you. And that is that's a. I think you can look at it one or two ways. Too, like, is that a selfish way to create things? I want to I want to experience suffering or hardship, so I'm going to create suffering and hardship just to see what it's like.
Yeah, like almost like an experiment in a way.
Yeah.
To see what I like. When I think about just all the different varieties of things in life, like, oh, it's just infinite. Like just even in human interactions alone, the different, like, just take even like sex, for example, not to go on a whole conversation on sex, but just what people, that whole realm, that whole realm of humanity. And it's like, and then people with different partners and different, energies. And then even like their astrological charts and how those are all interacting. But it just makes me think that whatever this principle that's creating, it really wants to experience, like, it's like, what is that Skittles thing? Like, taste the rainbow?
Yes.
I mean, I'm joking in a way, but at the same time, it does seem built into it. It's like a spectrum.
Yeah, a flavour for all occasions. Definitely.
And that goes into like even painful stuff too, like, car accidents or, it's like, wow, like, the creator, like all the different types of car accidents as well that happen. And I mean, a lot of those are like blink of an eye and, or, something happens, some kind of event happens. And that's kind of a frightening realm of consciousness when I think about that. Cause I mean, when I just think about all the people that have gotten in absolutely horrible crashes and all the rest of it, like plane crashes, all that stuff, like, wow. I mean, but I mean, in my viewpoint, like if the creator created everything, then certainly it created that. So it must have wanted to have that experience as well.
That's why I actually turned away from God, the creator, or religion, per se. But when my brother was killed at an early age in a car accident, and my brother was born with quite a few problems. He had a hole in his heart. He had fairly severe facial deformities, severely crooked teeth, a cleft palate, a hole in the roof of his mouth, like the worst crooked nose you've ever seen in your whole life, and his eyes were offset, like they were bug eyes. That was quite pronounced, and he had a lot of, because of his heart and the hole in the roof of his mouth and stuff. He had a lot of dramas early on in life, lots of operations and things like that, and then because of his facial abnormalities, it was extremely bullied at school, extremely bullied, and it was heartbreaking to see, but. And he was a puny little weed of a kid. He was a dweeb. There was nothing at him, of him. He was 3 pounds, sopping wet. There was absolutely nothing of him. And then it was when the very first Rocky came out, and he fell in love with that movie, Rocky. And you know how all that primitive training Rocky used to do with like chin ups in the doorway and push ups and boxing lumps of bloody meat in the abattoir and running and whatnot. Well, my brother just emulated him and did everything that he did. And over a period of 12 months, my brother went from 3 pounds sopping wet to like Arnold Schwarzenegger. He was an absolute beast. Um, and he took himself to production music school and became a DJ and whatnot. And then all of a sudden, like overnight, from a kid that was so isolated and so bullied and had no friends, um, he had about 8 months of pure bliss where he was the popular kid. Everyone wanted to be around him and all that sort of stuff. And then he was tragically killed. And it's just like, why would you do that to someone? And then, that's when I turned away from the whole God thing and whatnot. Like, you put all this pain and suffering and whatnot, and they get out of it, and then you take them away. Like, what sort of prick are you, type of thing. Which I'm sure many people have similar sort of experiences with a God or a creator or whatever. Tragedy sort of happens, or they see tragedies and they just go, yeah, nah, it ain't so. And it actually took a few years actually, for myself, and because I was convinced there was nothing. Like, you're in the ground, and basically, your life was now just getting eaten up by witchetty grubs and cockroaches, and I think from a selfish point of view, for purely for myself, thinking of that, him being nowhere, I then turned back to a creator, right? Because I wanted to think that his soul was at peace, resting, somewhere safe, and so that gave me comfort then to once again not turn to religion at all, but to believe in a creator of everything and whatnot. So that's when I developed my relationship with my creator. That we all sort of have different paths and whatnot, and different experiences with a creator or a god or a religion, and that's a bit of a brief in look to what I went through. But yeah, no, you do definitely ask yourself why sometimes. Why do they? Why would he, or why would it or she do such things? And the way you kind of worded it there, so the creator can experience everything, like it puts a bit of a selfish twist on it. But then again, like I said,
Yeah, it's like a heat. It's like a. Oh, thank you for sharing all that. By the way, that was beautiful and that was awesome. But I was just thinking, it's sort of like a hedonist for experiences. Like the idea of a hedonist that wants to, sort of like craves experience and all kinds of different types of realities just that.
But maybe it's not for his experiences. Maybe it's for our experiences. Like I said, when we were sitting in the food court and we looked up and we saw this, the parents and the young girl getting pushed through, and it literally put a smile of joy on our face to see what was happening, right? So maybe what he wanted to do was give us that experience, give us that moment, not necessarily himself, but us as individuals.
Well, like I hear what you're saying there, but I guess the way I see it is that what I would refer to as the creator is sort of like almost the idea of like the mainframe of the computer, like it's at the center of the whole thing. So I think that it's experiencing these realities through itself all the time. And then also the part of ourselves that feels separate from it, it can be like, it's like a partitioned part of it. It's like a partitioned away section of it. So like that's the way I see it. Like I'm experiencing it, feeling like me, but on like a holographic level, that's actually the creator experiencing this part of it.
Do you, because I've heard people say that God or the creator is all knowing, right? They know what is going to happen before it even happens. They know your destiny already. Do you think the creator or a God or whatever it is actually knows what is coming, or or it too experiences what is coming because they don't know?
I think in my viewpoint, it's already created the whole thing.
Right.
Because it has to be outside of time because it created time. So by definition, in my viewpoint, well, I mean, not the word doesn't have to be definition, but just by default, in a sense, if it created everything, if it created time, then it was coming from a place where there wasn't time. And so if there isn't time in that other place, then that means that the past, present, and future are all one. And so in that sense, it would have in some way the full conscious access of like the entire time strip, and perhaps it, however it made it. I mean, that's a whole nother thing. Like, did it make it in an instant, or did it always exist? I mean, that's an interesting idea too. But basically, like that the whole lifetime, or let's say human lifetime for this example, that the whole thing it's already happened because it was created outside of time, and then we are just experiencing it through time. And then from our perspective, it's like it hasn't happened yet. So it's like playing it out. But from that other level, yes, I would say that it's all, in a sense, predetermined. Like we can have the experience of free will, but the thing actually is predetermined ultimately. But the experience of free will can feel very real, kind of like that idea of, the creator wanted to have all these different experiences, so it could feel unique and real to have free will. Like, oh, I'm going to go do this, but really on the larger scale, it's all in that infinite field.
Yeah, I would think if we want to take the path where everything was created so the creator can experience absolutely every possible gamut of things that are happening, then it'd want to experience actually what it was like to happen, so it wouldn't know what is going to happen. It's put these things in place, and now it is going to experience everything in place for the purity of what it actually is in that moment, and wouldn't know.
Well, is that okay? I see what you're saying there. Yeah, no, that does seem to be like the impetus to creation is to kind of experience things as like new and yeah, like as very authentic. It's like making it very believable. It's almost like a movie, and making the movie, like I like the analogy of a movie because like let's say the movie, it's already been made, it's already been filmed, and they got the actors and they did all that, and then you just watch the movie. That's like the analogy of like living a human life. It's like if the movie's already been made by the creator in some infinite realm, and then whenever the bandsaw program went into the matrix, through the ether and the egg and the sperm, the whole deal. The bandsaw was manifested, and then boom, like that played. It started playing. And then you're watching the whole movie year by year. You don't know what's going to happen. You feel like free will. You're doing your thing. It's like you're playing the game, but you do have certain boundaries. Like you can't fly, unless you get in an airplane. I mean, you have to eat food, drink water, some of these basics. Yeah, and it's all it's all playing out. It like so in this sense, it's authentic. But has the movie already been made in a sense, and then we're just experiencing it in the moment, just like you do when you watch a movie and you've never seen it before.
Yeah, well, obviously the movie set was made, so he made the movie set, right, being where we are, and now he's just put the moving pieces in there and let them move as they move, and he's just sitting back on the couch with his soda and his popcorn, just seeing what's gonna happen. Probably face palming a few times along the way. But yeah, I think if I was the creator, right, and I wanted to experience everything, I'd actually want to experience everything. Like I know that I have created that soul, right? So that spark of life, bang, Geo's created, right? Bang, with that little spark. So I've created you, bang, there's your soul. Now it's up to you to do with it as you will. And I'm just gonna sit back for the ride. And see what manifests. I think that's how I'd want to do it. you know, I've got a hand in it. I've got a hand in it, like you say. You put yourself or me into the action, but you don't know what the action is going to be. Like it's not predetermined at all. But he has put that piece in play at the very beginning.
Yeah, I got you. Yeah, that's I do think that state, like that whole thing does exist. I mean, it does for me for sure. Like I definitely have gone through my journey as well. Okay, so let me think about that. Okay, if it created the soul and it created the body and all the material matter and stuff to make you and then the whole process and how that happens, then the core thing is the soul, right? Because the body is just the body, but the soul would be like your consciousness or that part. So when that separated, like if the creator is just there and then it created this other thing, like another that's why I like the idea of like that word partitioning. It's like if it partitions a part of itself away from itself, and then now it's like a separate type thing or it feels separate. Wouldn't it have the sort of bat code to the whole thing? Like, because if it created it, wouldn't it have like in the like code of it, wouldn't it have the memories of all the time of what that, because it would have to like create the time for that life to even happen. And if that was created from a timeless area of consciousness, then wouldn't it from that level, like it's kind of like the mainframe, like it's like in my mind, like it already has all of the movies of our lives on its hard drive, to use those analogies. Like it's got them all, like my life right here from age born to when I die, your life born to me. My thought is that those are all, it's like the idea of the Akashic records and, this sort of region of consciousness where there's sort of almost like this massive library where like all of the memories of everything that's ever happened exist. So do you think that's the case, that it has like all of the movies, in that sense, and that we're just living them in a way, like a new way? Or do you think that the movie of my life has not even existed yet until the creator creates time and then creates the material and the soul, and then this is like real deal on that level? I mean, the other one's real deal too, but I'm saying that that the future actually is not written. I guess that's the ultimate age-old question.
I don't think the future is written. Like, I can get on board definitely with the creator wanting to experience every possible gamut of every possible emotion, every possible situation. Okay. But if it is already written, he already knows the situation and every single experience. So it's a self-defeating purpose. Like it already knows, right? So now he's just watching a rerun of it to maybe remind himself, but he already knows anyway. He ain't gonna forget it. So I don't think it is predetermined at all. I think the only part of it that is predetermined is that initial placement of the soul, right? That initial spark, right? Bang, there is now life. Here is your soul, right? Hopefully you get to enjoy it, but we're going to sit back, like I said, for the ride, and we're going to see what happens, and I am going to experience your life through your eyes. And through other people's eyes too, because other people that I have given life to, I will also experience your life through their eyes as well. So I'll have the whole gamut of experiences and emotions with that, and it will play out. So I don't think it is all predetermined in a mainframe or on a movie reel or anything like that, and it's just just playing out for the sake of it. Because what's the point, if it if you want to put it in the realms of a experiment, and what's the point of doing the experiment if you already know the outcome? If you already know if the outcome is already predetermined, there's no point doing the experiment in the first place.
Well, but isn't it an experience each time you experience the experiment? So like if some part of me created, let's say like my whole lifetime, and it's all already happened, and it's just like the whole thing, like from birth to death, the material world, the earth, these humans, like in this whole mode, whatever this thing is, I was born in the year I was born, and then these years have been going by, and then you were born in your year, and then here we are, talking, etc. Like this whole thing, and I don't think this is even all that exists, but let's just say this whole thing that's occurring.
Yep.
If it already has the whole thing somewhere deep in consciousness, my thought would be that it would want to experience that creation more or less it is experiencing it indefinitely in that viewpoint, but it also might want to, like, I guess it's like the way you would watch, like rewatch a movie, let's say, the creator, Steven Spielberg, rewatches his own movie almost, like in that idea, something like that.
Yeah. I don't know if because there's too many movies to watch as well, isn't there?
Well, it's like you would just fire up, like, all right, let's start it here, and this is 2000, 2001, 2002. I mean, whatever those, like, whatever that even means, but I mean, there's clearly like a time thing of consciousness that seems to be unfolding that we're in, and like what our true history is. But I mean, this like time is moving quite consistently for a lot of us. So the creation is clearly like synced up right now to create this particular one. But what if it's just one of many as well?
Well, that's definitely a possibility, and that's a realm that my wife is into. Like, this isn't the only place. So maybe that there are. And maybe there are many creators. Maybe there's not just one. Maybe there's a family of them or a whole world of them, and they all have their own little experiment. And you get to go from one experiment or one realm to the other. And each time you are experiencing different things. But it all start off with the initial placement in whatever realm that you were put in, first off. But maybe I'm just thinking it from a human point of view too. But I think if I wanted to experience something in its purity, and get the most benefit out of it, I think the only way that I could do that would be experience it in the moment. And because it is timeless, I get to experience all those moments at the same time. Like, we've got 7.5 billion people on the face of the earth at the moment, but I'm experiencing all those moments all at the same time, because to me, it's not all mixed up and jumbled. I can separate them all very distinctly and all very clearly.
Right. It would have to be able to do that to create this.
Exactly right. But I think I can do that, but I am still experiencing every single moment in the moment, because I am in a timeless world. Because there's no time in my world whatsoever. There's only time in our world. But because there's no time in my world, I can experience every single moment in the moment, because I live in timeless. Yeah.
Wow, that's deep.
Yeah.
Because it would have to do that. Yeah, if it was simultaneously connected with, and that's not even getting to the idea of whether the future has been written or not. That's just into the idea of a creator or consciousness that could create something like this entire earth, whatever the earth is. We'll just leave that aside for the moment. But the whole earth with all these humans on it, all living their lives synced up to the sun and the stars and the weather and in these cities and areas. And then you build in, the financial, all these other social, political, and all this stuff going on in the world as well. But they're all living their lives, waking up, sleeping. They all have their biological bodies, all of that. And something is powering the whole thing in a sense.
Yes, exactly. Exactly.
And like you were saying, it would have to sort of be in some almost timeless type realm to be able to like coordinate all of those all those different consciousnesses that are seemingly separate and living those realities within a particular time cycle.
Yep. Exactly. Exactly.
And then
And I'll jump in late here, boys. How are you? I heard someone explain the other day that when you get down to the quantum level, where they say basically everything is just what do they call it, a probability distribution or something. So everything that seems real to us or solid to us, or what we consider matter, is just a collection of probability distributions of electrons and other things that I don't fully grasp. But there must be something holding it all together, because it can't be random. If it's just a random probability distribution, then things wouldn't exist. Am I explaining that properly? Like an electron isn't in any one place; it just kind of pops in and out. So it's not as we thought at school, where it was buzzing around in a circular or an elliptical, pattern around the nucleus of an atom. It just pops in and out, apparently. So if that's random, then how can things actually hold together? I don't know. The way he explained it blew my mind.
Okay.
Yeah, like that idea. That is deep. Yeah. Kind of something like entering and exiting.
Something must be holding it together. In an orderly fashion. Because the vast majority of any atom is just empty space. So, assuming atomic theory is correct, but there must be some cohesive, binding, orderly force that makes everything be what it is. Otherwise, it would just be random chaos.
Right, because there's like order in the system, but there is seemingly chaos, but even the chaos seems ordered.
Is ordered, yeah, exactly.
That's it's amazing. I know, you're right. Like, it's not just a jumbled mess. I mean, that's kind of what they try to claim with their Big Bang thing. Like, in a way, and then they try to just say that out of that jumbled mess came all of this. It's a kind of a strange place to start. Instead of the brilliance came, I mean, if this is an expression of this level of, like you're talking about, almost like a force, I mean, the brilliance of nature, of the way animals, I mean, all of the insects, I mean, it's endless, the water cycle, I mean, all of these things. And it seems to have such like a perfect design to it that one would think that if it did this design, then this is likely not even its best work. Like this is just at one level of it, and there's so much more beyond.
Exactly. Because see, that whole atomic theory or whatever it was probably sound 100 years ago, in its basic sense. But now that we're now delving into the quantum level, where things aren't a nucleus with electrons spinning around it, covalent bonds, where they share an electron field or whatever, but electrons pop in and out, and quarks and quasars, they're there and then they're not there, and if you look at them, they behave differently. Like, all of that doesn't fit in with that previous, basic atomic understanding. Here's another thing that spun me out. I'm just going to digress to somewhere else, but the other night at 2 o'clock in the morning, I heard this magpie. Do you know what a magpie is, Gio? You got those in America?
Yeah, the birds.
Yeah, this magpie was warbling outside my bedroom window, and I was listening to it, and it seemed to be repeating the same thing over and over, to my ear anyway. And I thought, he's probably calling out something to his mate or his family or something. And then my brain started whizzing at 2 o'clock in the morning, and I thought, I wonder if I bought a magpie from 500 miles from my house. I wonder if those two magpies could talk to one another. And I've asked a bunch of people, and everyone said, well, yeah, they probably could. Would you agree with that? I am going somewhere with this. So do you think all magpies can probably talk to one another?
Can magpies talk to one another?
Yeah, like all magpies. Vandy, if I brought a magpie over from Moe in Victoria to your place, do you think he could talk to the magpie in your front tree? I think he could.
Definitely. Yeah, they talk the same
Okay.
language. Yeah.
Excellent. All right. So now think about this, because I never had. Maybe you have. Okay. That means that magpie language somehow is in the DNA of a magpie when it's born. Whereas you and me, we don't have any intrinsic language. It's taught to us by our parents. Mm-hmm. Our language is taught to us by whoever raises us. We don't have, as a human baby, we don't have any language. Whereas every animal in the animal kingdom intrinsically has language in its DNA. Like the papa magpie doesn't teach the baby one how to speak magpie. It just knows how to, because they can all talk to one another. So where that common language exists, you know what I mean? Like that freaks me out.
But if you see, well, maybe they also too do learn it from their parents, because baby magpies make completely different noises to adult magpies. Right. So, and then they go, they grow up and they go through their adolescence, and then they become their little adult magpie, and they also too go through a learning process as well. You know what
so
I
the
mean?
Curiosity would be, if there's a magpie, if we brought a magpie in from New York, would it be able to speak to the Australian magpie, or would they not understand one another, having been separated by 10,000 miles of ocean?
Well,
assuming that there is just one magpie language in all of Australia.
Well, I would say a magpie a magpie can speak to another magpie, but can a galah speak to a magpie?
No, I don't think so.
There you go. So can a German person speak to an Australian person? Can they speak German and we speak English and we understand each other? No, not at all.
No,
so
correct.
Exactly.
Because our language is forced.
Exactly.
That's the crux of my curiosity. To get a magpie, I see what you're saying. If we bring one from Victoria, okay, maybe every magpie in Australia speaks the same language. But if we got one from overseas and they could seemingly communicate, that would be bizarre. That would speak to a higher power.
Well, there's definitely a higher power anyway. There's no doubt about that. But could a German magpie speak to an Australian magpie? That's the question.
Does a German magpie have an accent,
man? Exactly. So does a little German magpie walk around, raising one little wing, doing its little.
Careful, you get the channel shut down.
Yeah, no, I'm not going to go any further. But anyway, but yeah, no, but
sidetrack the conversation. Sorry.
Yeah, no, definitely. The same animals can speak to same animals because they're speaking the same language, just like people. But I do think.
And can a German Shepherd speak to a Staffordshire Bull Terrier? I think so.
Well, yes, because they're in the canine family. Okay.
They're all dogs, aren't they? Yeah.
Exactly right. But can a dog speak to a cat? Dogs can interact with cats. Dogs and cats can learn to interact with each other. I've seen that. But can they? But then, do they just learn how to behave with one another and interact with each other?
Basic cues, sort of thing.
Exactly right. Interesting thoughts, but I'm definitely not into your bloody atoms and your electrons and stuff. I don't think we're made up of atoms at all.
Yeah, I kind of don't either, mate. But I'm just going
no.
with the narrative, for the
Yeah,
conversation.
no.
But
I think we're just flesh and blood, and that's as far as it gets, to be quite honest with you. I heard someone say that we are made up of these electrons and neutrons and protons and all this sort of stuff, and in actual fact none of them actually touch each other. I heard actually someone tell me once that when I squeeze my fingers together really, really tightly, as hard as I can, if I was to have the most powerful microscope in the world, there is actually space between my two fingers that are
that's right.
pressed. Exactly. That's ludicrous. That is absolutely ludicrous.
Utterly ludicrous.
Yeah, it is ludicrous.
See,
I'm
I had the
sorry.
scale explained. I think I've gone here before on this channel, but it was something like size of the nucleus of a so-called atom is 10 to the minus 8 centimeters or something, or 10 to the minus 15, and the size of the electron field is 10 to the minus 6 or something like that. So it's like 10 to the 9th power of empty space, and they visualize it. So that if you've got a golf ball and put it in the middle of a football field and call that the nucleus, the outer edge of the electron field would be 8 miles away. But that's the amount of empty space between the nucleus and the electron field. I think they're the numbers that I remember. So a golf ball is the nucleus. The electron field was 8 miles away. And everywhere in the middle of that 8 miles is empty space. Right? So how can that form solid matter? It just makes no sense at all.
No, none of their
But we're 99.9999999% empty space.
No, not at all. Not at all.
Between my ears there is, but generally not.
I think I've got a black hole between mine.
Yeah. Time dilation.
Time dilation. We had
Between my ears.
we had NASA in here before telling us that the sphere was discovered 2,500 years ago. They knew it was a sphere, right? And how did they know this?
Oh, yeah.
Right? Because boats sailing off the edge, right? So the Earth is flat apparently, right? It's going to sail off the edge, right? So now we have a ball, right? 2,500 years ago, FE, we have a ball, right? So we're very primitive people back then, and he confirmed it. 2,500 years ago, we discovered a sphere, and I said, okay, then. So then, how does that then work with their understanding of water 2,500 years ago, NASA? All right, because I've got water and I put it on top of a mountain and it flows down the side of a mountain, or I put it on a hill and it flows down the side of a hill. I put water from high and it always flows down to low. So now you're telling me that 2,500 years ago that they're living on this sphere and they're standing on top of it, right? Because they're not on the bottom of it, they're standing on the top of it. Right? Why would they think they're standing on the bottom of it? Because they'd be falling off the bottom of the sphere, right? And the water would be pouring off the bottom of it because it doesn't quite marry up with your theory of when gravity was discovered in the late 1600s. So you've got a 2,000-year gap then where water is pouring off this sphere that they discovered in 500 BC. Absolutely ludicrous. Absolutely ludicrous.
Yep.
But what would I know?
Well, that's right. What would you know?
He said they believed in gods back then. I said what they believed in gods and magnetic bloody shoes and kept them from falling off. Did they? The water was magnetic, was it back then? But sorry, did I know what?
It's interesting. Like if you go back to whether it's ancient biblical type text or Sumerian writings or Mesopotamian history or whatever you like every one of those cultures speaks of some kind of interaction with fallen angels, giants, Nephilim, whatever you want to call them, who taught them all sorts of things. And yet you reckon they might have mentioned that the place was a big ball, but that doesn't seem to appear in any of those ancient texts or ancient writings. All sorts of other stuff does, but they taught them all sorts of things about technologies, and there's evidence that there were other technologies around back then. But there's no evidence anywhere, going back 4,000 or 5,000 years of those interdimensional beings or advanced beings or space travelers or whatever they were in the writings that they mentioned to anyone that it was the ball we were living on. Because all the ancient texts, apparently, like the really ancient texts, all refer to, flat earths and backs of turtles and whatever else. So there's a bit of a disconnect there.
Seems to be a little bit.
Maybe these aliens didn't know, or the Anunnaki or Nephilim or whatever you want to call them, maybe they didn't know it was a ball either.
They still don't know it's a ball.
Yeah. Maybe not. What do you think of that, Gio? Are you still floating around, or have you gone to bed?
I'm still here. I'm listening. Yeah, it's a great combo. I'm enjoying it.
What do you think of that? Like, in those ancient writings, like I said, Sumerian, Mesopotamian, whatever, none of them contain anything. They refer to lots of other things that, certainly outside of our current day-to-day experience. But none of them mention anything about the Earth being anything other than to contradict what the other ancient writings claimed it to be.
Yeah, exactly, and that's why, like we were talking with Pate earlier, he's claiming that all of a sudden 500 BC, these guys just the boat's over the horizon, must be a sphere. But yeah, you're right. I mean, it's not. I mean, of course, it's hard to know exactly what all the history was, So I mean, that's a whole story. That's a whole thing in and of itself. However, from everything we do have, there's an origin story of this globe thing. So, like you're saying, yeah, it's not in all of this. Basically humanity up until this very recent time.
Yeah, like the really ancient writings that are way before 500 years BC. And a lot of those ancient cultures all corroborate one another's stories, to some degree. And they all, and I don't even mean about the shape of the earth, I mean about just ancient history generally. But none of them make any reference. Whoever these so-called other beings were that they interacted with, from other realms or other worlds or aliens or other dimensions or fallen angels or that, they've all got their own story of essentially the same event. You would have thought that, all those ancient cultures thought it was a flat plane with a dome or a back of a turtle or a whatever. Some of these more advanced creatures might have said, hang on, boys, you've got that bit wrong.
Yeah. Yeah. I mean, exactly. Yeah. I mean, I guess they claim in their story, at least from their belief, that it was just sort of, all of a sudden, basically out of the blue, these humans just, and the only thing they were, I mean, like Paige was saying earlier, sticks in the ground and boats that, or, you know, objects on the ocean that have that, you know, that perspective optical sort of process going, you know, in terms of the looking like they're being sort of cut off or obscured from the bottom going up to the mast. So yeah, I mean, humans since the dawn of time have had that, the stationary Earth with this, you know, sun, moon, and stars above, and the planar geometry just being the just the basics of just physics and how level works and all of that. And then, you know, this idea that these guys just, you know what, these shadows in the ground over here and these things, these boats cutting up, I think we're on a huge sphere. And then they're claiming that all those guys just agreed with it, or a bunch of people did, or whatever, even though they didn't have any explanation of gravity or any of this other stuff. And then, you know, they just came upon this, you know, groundbreaking idea. Apparently, that's the story.
Yeah, and it makes me laugh that in 2022 we still refer back to the sticks in the ground story, and and give it enormous weight and credibility. You know, in a day and age when we evidently have this particle accelerator that's colliding quasars and whatever the hell else we're doing. And yet sticks in the ground, that's still a solid argument, you know. So you'd think something better would be rested upon by now.
Yeah, especially when sundials have been known how they work since the dawn of time as well. And sundials showing over a planar disc type of a surface, like the way the sundial works, sort of like the face of a watch, and the sun or the shadows that are made from the sun. And that is how the understanding of how the sun is moving above that region of the Earth. And it's a miniature version. So it has like a flat disc of sorts. And then it has that the little rod, the little gnomon it's called. And the gnomon basically shows that shadow of light. So that geometry, and then also going along with, you know, level and horizontal, all of that geometry has been the basic for the shadows. So for someone, when that was established and known that in these different regions, you're going to get those shadows from that close and local sun coming into your local planar region and then leaving. And then the idea that these guys would come along and just say, you know what, I think these two sticks and, you know, these two sundials, essentially a stick, but I mean, but they're not claiming they're sundials. They're trying to take it at a certain snapshot. But basically these two shadows that you get from a stick now all of a sudden mean that the Earth is curved and that the sun is an infinite distance away. Like the thought that would just come in to be some kind of breakthrough. It's amazing they've gotten people to believe that in a strange way, or to even, you know, back that idea.
Yeah, I think it's fanciful to say the least, but
I mean, I guess you could say it has a little teeth to it, only because if you do make the sun 93 million bajillion miles away, and then you all of a sudden claim this thing of these parallel light rays, that does like twist the geometry, where they're making those things so far away to then allow for a very real ratio to then be attributed to a radius. So I mean, I guess in a way it does, like it links in a way, like they're not just totally off their rocker to believe it. I mean, there is some way that it links up, but you have to just make that assumption of the sun being that far away. And the inverse square law and the way that infrared heat works as well to the inverse square law already shows that the sun is not 93 million, that it's doing those ratios in relation to a close and local type of object, like the heat, you know, the heat that comes and the light.
yeah. In my opinion, the inverse square law, it's something they really can't. They just can't explain that. I can't get with even moonlight, sunlight, the size of the stuff. I just, nobody's been able to satisfy me of that. And you're right, like their argument, it has some compelling points to it. It's not that everything they say is just stupid, but I don't know how anybody can be utterly fixated on one or the other, because in my opinion, both sides have, you know, some things that can't be explained away, and they both sides have some things that don't quite make sense. That's my view on it.
Yeah.
Yeah, someone in here like NASA, I mean, you know, if I had to choose one side of the line, I think we know which side I stand on. But am I 100% sure? No, to be honest. Like, I don't think I can be. I don't think anybody can be.
Oh, I am.
Oh, Mr. Contrarian.
Well, you're talking to the guy who has the future already written, and he already knows it.
Exactly.
There is no future, is there, Bandy? There's only the now.
Exactly. Right in the
Yeah, I
now.
agree with you on that. It's only the present.
Well, I suppose like a level of sureness could come through, like, in terms of logic. I mean, if you're in a world like a realm where level is level and water is level and the way water flows and just the very basics of physics, just the XYZ axis of real physics, like no pseudo physics, none of the like theories of outer space. I'm talking about actual real physics, the way that, you know, things, when you throw something, the way they drop, the way that the things are moving above us, just the way even the human body works, where we, you know, when we're standing up is up and down is down. And even just going off that, and then especially if you were to like be like, you know, even doing measurements on local water, I think it is sound to logically conclude that the rest of the surface is a continuation of that the physics in your local region are the same physics, like the physics I have here are the same that you guys have there, and so on. And we are on some kind of surface. But of course, I mean, the argument could be made the other way as well, that, you know, you can't assume anything out of your local region in that sense. And, you know, it could be curved over there, but it's level over here, you know, so you could get into that. But at the same time, I could see the logical of just being able to evaluate the reality in your local region and basically have that awareness that it continues with those same dynamics.
Yeah. Yeah, I agree. Now, I'm just going to go and put myself in financial peril, boys. I've got to fill my car up with fuel.
Oh,
so I
my
might
God.
need it. Yeah, I know.
Oh boy, it's always an adventure these days. Like, how high can you go?
Yeah, I'm just going to take an extension on my mortgage, and I'll be back with you shortly.
All right.
Well, it's about, wow, in US dollars, it's about $9 a gallon here in Australia.
Oh my gosh, really?
Yeah. Yeah.
Okay, that's higher than here.
Outrageous.
We're at like 6 to 7 in California.
Oh God. Yeah, I think Canada is pretty close to us. I was speaking to someone yesterday, but it's out of control. It really is, and stuff is. You're actually seeing just in your goods down at the supermarket. They're starting to slowly increase. Like the price of meat and fruit and vegetables have slowly been going up over the last couple of months.
Yeah, I suspect that trend's going to continue. I think kind of into the financial reset. They're going to kind of try to. It sounds kind of dark to even say, but just trying to separate the financial classes, I suppose, just divide and conquer.
Oh, yeah. There is definitely going to be a greater divide between people. That is for sure. I was reading the other day that China and Russia have just created a new trading currency that is actually backed by minerals. So their trading currency is actually going to be backed by gold, copper, silver, titanium, these sorts of things. Apparently going back to what money was supposed to be backed by, gold. And the thing that I was watching was basically saying that the states stepped away from that in the mid 70s, thereabouts, the late 70s. The US dollar has no longer been backed by the gold standard, and it's backed basically by by debt. And what was the debt that he said it was? I think it was $30 trillion.
Yeah, I mean, it's so stupid. It's like, who are we in debt to? Just the controllers? I mean, come on. It's like stuff ridiculous. I mean, yeah, you could be in debt to each other. I get that idea. Like, oh, if someone lends someone what they can call money, whatever, and then you have that debt or whatever, that's fine. I understand that idea, but the idea that we're just all in debt, just the whole country's in debt by trillions. It's like, okay, what does that even mean?
Crazy.
In debt to who? It's ridiculous.
It's absolutely crazy. And
it's just made up. Basically, it's just that it's so they can do the control mechanism. They need the inflation and then to blame us for it so that they can. That's kind of how they're doing their trick.
And look, I don't know if it's true or not, but apparently the amount of debt that China owns of the US, that at a click of a finger, China could instantly turn America bankrupt instantly overnight.
Right? They could just say, "Oh, we had to pay China, this many trillion. Sorry."
Yep.
They just they were going to repo our car, so.
Exactly.
The repo man was driving up, and they're like, we got to cough up the money here.
Yeah.
That's ridiculous. I know it's just such a scam that they're doing. It's ridiculous. Trying to make it seem like these countries are all separate, and it's just a joke. But yeah, I know they might do, like in the financial reset, they might do something like that, like try to do some kind of scenario where like some other country threatened us that they were going to go to war with us if we didn't pay them these trillions. So now we're inflation just goes off the roof, off the charts. Who knows what they're going to do? But yeah, those things are possible.
Well, there's definitely a reset coming. That is for sure. Nothing is more certain.
I think they're going to lose, though. Like as we were talking earlier, I do come from the perspective that the future has been written on a certain level of consciousness, and my sense of what that is coming, what's coming, is that they're not going to succeed in the end, and actually are going to lose their power within the next, like, if I just had to put a long stretch of time, I would say the next 1 to 2 decades, like next 10 to 20 years.
Yeah.
Let's give it some time.
Some time.
I mean, it'd be nice to get free a little bit earlier than 20. Like, let's say in the next 5, it'd be nice to see some movement, but it might take a while. I mean, that's my sense truly of what's coming. Like, I know there's so much doom and gloom, and there is a lot of pain and suffering, and there will be continued, unfortunately, because I think that idea that the creator wants to experience kind of, everything. But I think the overall flow is actually going towards getting free from these kind of certain controllers that are doing their thing, versus going deeper into that.
You can only hope there's enough pushback, don't you? You just hope that people will just open up their eyes and see what's going on and say, no, enough is enough.
Yeah. At the end of the day, that's what it's going to take.
Oh, exactly. Exactly. But it seems like the culture that's ingrained in many is like, the government will save us. Right? That's our safety net. They're going to do what's best for us. Please save us, Mr. Government. Yet they don't realise that the very people that they pray to are the very people that are doing this to them.
Right. The true, like, wolf in sheep's clothing, where they, the sheep think that the other wolves are just, they're the good wolves, they're helping us get out or whatever, but they're really just leading them to slaughter.
That's right.
That's the deception right there. It's like people think that they think that authority is not what it actually is. It's like they've been catfished almost. That catfishing where
I had a mate that got done by that. I can't remember what app he was on, some dating app, and he went out and it was like this complete stranger just walks up to him and says, "Oh, hey Phil, how you going?" And he looks at this person, "Who the fuck are you?" "Oh, it's Kerry." It's fucking Kerry. Pulls out his phone and checks a photo and told her to fuck off.
That's funny.
Yeah, the story, yeah. He said he was a little bit more direct than that, actually, but so I don't blame him, actually, to be perfectly honest. I think someone's just going to be completely deceiving you like that. Why would you want to get involved with them in the first place?
Yeah, I guess that's like a con man that can do that, where they can just completely put off something that they're not, and then get people. So yeah, like these people in power, they've somehow convinced people that, like these companies, like Johnson and Johnson, that they have like your best interest in heart for you and your kids. I was actually at the store today, and I was looking at the water, and there was like it's like gallon of water that's kind of made for like for like infants or whatever. Like it's like distilled water probably made for infants, and it said with added minerals. Like who knows what that really is. And then there was the one that said with fluoride, and one that says without fluoride. I'm just like, and the one that said with fluoride had a little picture of a little child's face, and it looked all happy, and it had rainbows and colors. Oh gosh, it's just like, so it's like that idea that like, oh yeah, that they have your best interest. And it's like somehow people like the WHO and all this stuff, like it's just classic wolf in sheep's clothing.
Isn't it absolutely crazy? Funny you should mention that, but we discussed this a few days ago too in regards to food, like whether it's meat or fruit and vegetables. You go down to the supermarket and there's a particular part of the fruit and veg aisle or the meat aisle where it's like totally organic. Grown without pesticides, without herbicides, all this sort of stuff. This is real fruit, like fresh from farm to you. You don't need to be worried about any chemicals or anything like that. If you want the good stuff, like here it is, and you have these big organic stickers over everything. Isn't it funny the stuff that's all treated with chemicals, right, has all hormone injected, that there's no warning labels on any of these things at all? Absolutely none.
Yeah, I know. They just have these colorful labels, and yeah, it's unbelievable.
Yeah. I know, it's crazy. All right, cool.
It'll be like factory farmed, like factory farmed, like grain-fed factory cow milk, and on the cover it has this cow, roaming the green fields, and
Daisy the cow, right?
Yeah.
You don't see a chicken in a battery hen farm like
I
on the
know.
cover of your eggs or anything like that. It sees these chickens that are roaming around in a free or in a field.
The reason I
Full of,
reckon,
like, very real chemicals that are just so bad for you.
Yeah, the carrot would say this was grown in a field sprayed with glyphosate.
Exactly. It's quite backwards. It is definitely backwards the way they've got that all.
I really think a lot of the organic stuff is honestly, it's just a marketing strategy thing for those people out there that they know they can convince that that the regular products are all really bad for you, when I don't really think that's the case. There's advertising and marketing people, mate, always trying to come up with some sort of more expensive version of anything, and justify some reason to sell it to people.
I personally don't think that hormone injected chicken and meat is good for you. I would much rather organic meat.
Well, what's actually bad about it? Like,
what's bad about it? I'll tell you what's bad about it. You can see, I think of the way children are reaching puberty far earlier than what they once were. I think that's a direct result of the hormone injected meats that they are ingesting. Personally.
Okay, but is there any actual science behind that? Or because I mean that's a story you can tell, and yeah, a lot of people might say, well, yeah, well that sounds like it might be true, like it makes sense, but is it actually? Because yeah, maybe it's not. Like
I know. Without being crass, back when I went to primary school in the 70s, 10-year-old girls didn't have tits, right? And as a 10-year-old boy, I was looking for them. Now, 10-year-old girls and 11-year-old girls now quite often have some level of development. So I think there is a fair argument to be made that in a fairly short amount of time, puberty and onset of that kind of thing is certainly more advanced than it was 30, 40 years ago.
I agree that fact is true, but it could be for other reasons, like social reasons. The fact that young children around those ages are exposed to so much more sexualization than they ever were back in those days. Like it might be that rather than actually the diet or the food itself. Because they're thinking about sexuality and they're exposed to sexuality and all that stuff at such a younger age. Maybe that's what.
Are you arguing that not the stuff in their food is having like a chemical reaction? It's because they heard the word, sex at school and that's making their boobs grow? I mean, I don't get it. Is that what you said?
Well, in a way, yeah, because they're thinking about their sexuality and they think that it's, an important thing these days. They're seeing it everywhere all the time. And maybe that's what it is. Maybe it's a psychosomatic sort of thing, more so than the actual foods. Because if it is the foods, then how are the foods actually, making girls have tits earlier, is it actual estrogen or is it estrogen in the food? And
estrogen. There's a lot of xenoestrogen in our food now, and just in our lifestyle, hairspray and deodorant, and all those things that probably weren't there back then.
Yeah, Rams. I mean, I would say to what you had said about the difference between organic and all that, I would say my thought to that is yes and no. I think that there definitely is parts of the organic thing that has some scammy qualities to it, especially when it comes to the USDA in America, that makes it very high cost for farms to get certified in an absurd way. Now they claim that it's under being rigid and strict, and I think there is some good strict and rigidity in there, but it's the cost part of it. They make it so expensive to where it anyway. So I mean that's a whole problem in and of itself. But in America, let's say like with USDA organic certifications, there's a lot of different kinds as well. But let's just say with the USDA with America, it is pretty good in terms of like that. If you buy organic, you won't be getting, I mean, hopefully, obviously it's probably not 100%, but you're not going to be getting glyphosate, Roundup Ready glyphosate, which virtually anything that's not certified organic will have glyphosate in it. And glyphosate is very toxic in a multitude of ways. So if you buy organic, you're not getting glyphosate, hopefully. And then there's the whole genetic modification, which is a huge topic in and of itself. But you're definitely not getting like at least one part of genetically modified. I think they've modified corn in a lot more ways than one, but they just go with GMO, non-GMO. But there is something different to those as well. And of course, there's all kinds of stuff that slips through, and it's not always 100%, but there's that part. And then there's like the growth hormone part as well, that they can't use. At least they can't use the synthetic hormones in that sense, which is a huge factor. And then, of course, there also is the
cut out.
I got a phone call or something.
Oh, I jumped out. Oh, the last one was the difference between Yeah, I hit my mute by mistake. Synthetic pesticides versus okay, there's fertilizers and herbicides and pesticides. In the non-organic, they can use synthetic versions of all of those, including the Roundup Ready and all that. Whereas in organic and USDA organic, they can't use the synthetic ones. So they can't use like synthetic pesticides. They can only use what would be considered organic pesticides made from organic compounds. But then, of course, there's a lot of particularities. But yeah, like the fertilizers and the usage of those as well. So it is different. Like there is. I do think there's a difference in terms of what you're getting with that.
That's why we get a lot of our produce from the local farmers markets. You can't beat it.
Yep. I mean, like if you just walk into like a mainstream grocery store, like in the United States, and you just buy whatever milk, just non-organic milk off the shelf, yeah, that's going to have glyphosate, GMOs, all kinds of pesticides, Roundup Ready in it, and all kinds of who knows what funky hormones and chemicals and all kinds of stuff they can put in it. Whereas if you were to go to a store and buy one that's certified organic, it still could have various things in it, but it's definitely going to be better, and it's not going to have. I think USDA is pretty darn good. I mean, I'm sensitive enough that I can tell when there's glyphosate in food, and I have gotten some glyphosate in organic foods, but I would say it's pretty good of them keeping it out. Like it's actually pretty solid.
Pretty.
Yeah, I mean, if you eat all organic, like you're not going to get much glyphosate, I would say, but you'll get a little, but not nearly like what you get with the non-organic.
The taste difference between the farmers market fruit and veg, and even some of the meat, we get there. If they've got a butcher there, try and get the stuff there. It's chalk and cheese, really. Like you bite into an apple, and it's the crunch of the apple. It's like, damn, this is an apple. You bite into one of those supermarket apples and they're floury, they've got no texture to them, they just disintegrate. They last about 2 days if they're lucky. They're absolutely dreadful, in my opinion. All the fruit.
The only thing with some of those farmers markets, Bandsaw, is that you get some of those. A lot of the times, like the markets I go to, a lot of the people that are selling fruit and veg are like Asians or something like that, and often they're just doing it in their backyard or something like that. But you don't know what they're using. They might be using chemicals and stuff, but you just don't know. But I agree. Like if you do get something that is, like I got some ladyfinger bananas the other day from the markets, and tasting one of them, it was like I'd never tasted a banana before, like in terms of flavor compared to the regular ones. The regular ones just taste bland as shit, man.
Yeah. And look, the farmers markets and whatnot that are in town, I'd be more dubious of personally myself. But where I am, Rams, is basically in the middle of nowhere. I live in a little seaside town, surrounded by dairy farms and orchards and all that sort of stuff. So, the markets
nice.
are fairly legit, I suppose. But yeah, if they're more in town, I can definitely see where you're coming from there too. Like, where is it coming from? Have they too just gone to the wholesaler and bought the stuff, or are they growing it in their backyard, fertilizing it with their own feces, or fucking whatever the case may be? You might ask yourself a few questions about that sort of stuff.
So I've always wondered, like, when it comes to food, like, I wonder how much of the placebo or nocebo plays into food in terms of, like, if you're eating maybe not the best food all the time, but your attitude towards the food and towards eating it is one of just pure appreciation And you know what I mean? Like, I wonder how much that plays into it, you know, because some people can sort of eat maybe not the best food all the time, but because of their attitude towards the food and towards eating it and all that sort of thing is just, I don't know if that sort of plays into it at all.
Look, I think there's a lot to be said for the placebo effect of anything, to be honest with you. You know,
yeah, because if you're told, okay, look, this piece of fruit is organic and it's pure and it's not got anything in it, and you eat it and you feel, oh yeah, that's good, that's nourishing, that's great, and then you get another piece of fruit and you say, oh, this has been used pesticides and all sorts of shit on it, and so your attitude towards it is that, oh, you know, I'm eating this and it tastes okay, but it's got all these bad things in it. Is that thought of oh, there's all this bad stuff in it, could that possibly be affecting our health? I would argue maybe.
Yeah, look,
And
I could definitely say too, maybe, because you know there are definitely scientific studies on the placebo effect that it does work.
yeah. So if I went to someone who eats only organic food all the time, they're obsessed about it, and I was to just buy them a bunch of GMO fruit and veg and just give it to them and just tell them that it's organic, then, like, health-wise, would it be the same as them just